with large volume generated. And this voluminous data which is being generated, how to process that data, how to store that data, how to protect the data from different areas and different variations and different, particularly many software companies, many companies, their storage of data is very important, and cloud storage is one of the area where actually even hacking of the data information is also been possible. This area is very important nowadays, how to protect them, and how valueless data has to be avoided, and how useful information has to be included and protected, and how this accumulated data has to be protected. And these are very important, particularly. And apart from this data generation, data storage, data elimination, and data protection, and this particular security of the data, the cyber security is one of the important area. How this particular cyber security is very important. And as you know that blockchain technology, which is coming up in banks and other areas where hacking of the passwords and hacking of the several things are actually been taking place. Blockchain technology is one of the area where they are actually been using this particular technology for protecting the software and blockchain. What is the main advantage of blockchain technology? Is that the software which is being used for protecting the software will be changing every few minutes, and it is not going to be a fixed pakka software technology, so that it happens that nobody can hack that particular password. This is what actually blockchain technology is been protected, and also it is being used. And similarly, now the digital imaging and digital learning are one of the important area, and how, and particularly you can have healthcare treatment is one of the area where because in several countries actually not having any medical facilities, and this particular medical facilities actually not been available. They are now providing from the various countries where the health facilities are very important. They are now able to provide the digital imaging of the particular patient and patient internal organs and everything, and how it has been problems are being used, and that particular problems are there that can be viewed by artificial intelligence, and they are now able to give guidance for the treatment of the particular patient. This is one of the area. Now it is coming up very important development in the data science, particularly in artificial intelligence area. So these are very important areas, and many scientists actually working in this area, particularly in computer science and in computer engineering also, they are not aware of the developments which are actually been coming up. These developments has to be taught to the teachers who are actually going to deliver these goods again to the student. So students should be aware of at least the important developments of the technology and important development of the data science and artificial intelligence and cyber security, how it is going to be useful and how it is going to be, at least that background, if it is generated, the students will have some kind of interest for learning that, and the students will have a exposure for the advanced learning technology. This is very important that the faculty development program, which has been emphasized on this particular data science and artificial intelligence, will be having a lot of importance for particularly for training of the teachers. And these teachers who are actually need to be understanding that they are not really been self-contained and self-sustained in knowledge. They need to update their knowledge regularly, and they need to learn the recent things. Though I'm a biology man, I'm trying to learn the various advanced subjects in data science and even big data analytics. I'm trying to learn myself. So this is one of the important aspect that any person, even though he is a science man or even though he is non-science man, commerce, economics, statistics, and management, and all the people actually are now included in this particular area of data science management. This is one of the important area now for all the subjects. Is a very important topic. People should understand that they need to upgrade their skills and knowledge and development regularly. This is very important. The teachers should not be self-contained and self-sustained. This is what actually they need to be always learners and upgradation of the knowledge and subject. And they can in turn cater the needs of the students, and they can discharge their duties responsibly to the student. This is one of the important objectives of the FDP program. So I congratulate all the mathematics department and particularly Professor Jamal Hussain, head of the department, and other faculty members for choosing one of the important area of the present day scenario. and developing this particular FDP program. Thank you very much for giving me an opportunity.
Thank you so much, sir, for your enlightening speech. I'd like to mention, sir, I'm really happy that participants from various countries like Pakistan, Oman, Uzbekistan, Afghanistan, Ethiopia, Philippines, Nigeria, and Algeria have registered, sir.
Oh, very good, very good. That's one of the wonderful FDP program that you have included many other countries people also. It is wonderful, and it is very nice that. So this all the participants, for the benefit of participants, realizing the importance of these courses, we have Mizoram University have started these courses recently, MBA Big Data Analytics, and we have started MSc Artificial Intelligence and Machine Learning, Cyber Security, IoT, and app development. These are the courses we have initiated in the recent past, and many students are enrolled in that particular courses. We are wonderfully doing our Mizoram University in this area, particularly. Mathematics department is also now involved in development of, I think IoT is in Jayaprakash, you have given with IoT, no, Internet of Things, I think.
Yeah, yes, sir. Yes, sir.
Yes. Okay, and thank you.
Thank you so much, sir. It is all due to your leadership, sir. Thank you so much.
Thank you.
May I now request the chairman of the organizing committee and the Dean School of Physical Sciences, Professor Diwakar Tiwari, to address the gathering.
Thank you.
With your permission, Diwakar sir, I can go?
Yes, sir. Yes, sir.
Thank you.
Other programs.
Thank you.
Thank you, sir. Thank you, Professor Jamal Hussain. And the chief guest of this inaugural program, Professor KRS Sambasiva Rao, despite of his tight schedule. So we have requested and he made available for a few minutes in this inaugural program. And then the guest of honors, Honorable Dr. Jai Narayan Nayak, the Registrar of Northeastern Hill University, Shillong, and Professor Syamanta M. Hazarika, Department of Mechanical Engineering, IIT Guwahati. The head of the department, Dr. Jaiprakash Singh, the honorable, the distinguished speakers from the different country, different places, the different institutions, participants, ladies and gentlemen. First of all, good morning to all of you, but different time zones are there. I do not know. Good morning, good afternoon, or good evening. So I welcome all of you in this the International Faculty Development Program. I'm very happy to see that the different countries are being involved in this important, I'll say, the faculty development program, which is on the data analytics and machine learning, which is one of the, as VC sir already mentioned about these are the emerging area where a lot of research, a lot of studies. And as Professor Jamal Hussain, he already mentioned that it is one of the integral part, I will say, even at the UG level, the digital learning and all that, this has been included, and this is a compulsory or the mandatory component of the NEP. So this is a very important aspect or an important area which has been chosen. And I'll say that the Mizoram University is taking on lead in such type of the courses to introduce or the programs to introduce in Mizoram University, or the faculty development program or workshop and all that. So it's a great pleasure that to see such kind of the initiatives has been taken by the Department of Mathematics in our school. And I'm very happy to see that the linkages how he has made with the different institutions like the Northeastern Hill University or the IIT Guwahati. And when I was looking into the speakers, the resource persons, there are the different places they will be joining and delivering the lectures. I can see here that from the USA, Sweden, Bangladesh, Singapore, and so on. So they will be joining. And it's very happy to see that this is one of the FDP program in which the academia as well as the industries are being involved. And I was looking into the Hawaii is associated, or from the Singapore, that is R&D manager at Fort Media, they will be joining. So it will be a great, I will say that there's a great opportunity to the participants. They will be interacting not only with the academia, but at the same time with the industry people also. So they will be, they will be having the better understanding about this in the emerging area. So I hope that this will be a grand success of the program. So with these few words, thank you very much. Thanks a lot. Thank you, sir.
Thank you so much, sir, for your address. And it is so informative. And may I now request one of the distinguished speakers of our FDP, this program. And he is one of the guests of honor for today's function. Professor Shyamanta M. Hazarika is a professor in the Department of Mechanical Engineering, Indian Institute of Technology, Guwahati. May I now request him to deliver and interact with the participants.
Thank you very much, Professor Jamal. Good morning to all of you. It's a great pleasure to be here this morning, particularly talking to young people working on data analytics and machine learning. Now, we need to realize data analytics is not a new development. From the beginning of business intelligence, analytics has been a key aspect of tools employees use to better understand and interact with the data. However, today the scale, the scope of data analytics has drastically evolved because of ubiquitous computing, because of use of computers in every sphere of life. Now, traditional data analytics platform would typically revolve around dashboards that would be constructed of visualizations and pivot tables that would illustrate trends, for example. And in most terms, most of this work would involve technical team members. What has changed over the years is the coming of machine learning. Machine learning analytics is an entirely different process. Machine learning automates the entire data analytics workflow to provide deeper, faster, and more comprehensive insights. Now, as many of you may be aware, machine learning is a subset of AI, and it leverages algorithms to analyze vast amounts of data. Now, these algorithms operate without human bias or time constraints, computing every data combination to understand the data holistically. And machine learning analytics understands boundaries of important information. In other words, machine learning not only tests out hypotheses to answer key questions, but it can test all of them in a much shorter time span. And finally, when you are dealing with data, huge amount of data, and using machine learning, which I refer to as machine learning analytics, it is then able to tell a data story that's accurate, exhaustive, and relevant to the person asking questions. Now, this is where we need to understand that coming together of data analytics and machine learning is of vital importance. The amount of data thank you very much. So the amount of data that companies have access to is much greater now than it has ever been before. And this data is gold mine for businesses, as it can inform decision-making processes. Not only business organizations, it is a gold mine for every aspect of life. The amount of data that you have, if you can process that and understand what type of information is the data giving you, you could have better decision-making process. And that is where we need to look at. Now, in tandem with growth in data is a growth in computational processing power. Cloud computing, the technology that ultimately supports this data, is becoming more advanced, and machines have more processing power than they have previously. After all, the intersection between the expansion of data and the computational power that we are obtaining, we need to exploit through what we call machine learning algorithms. So machine learning is essentially what you do with these resources, the data and our better computational power that we have today at hand, to leverage them as assets. Without machine learning, all we will have is possibly a sea of disparate information. With machine learning, we could create hierarchical structure of information that's more specific, relevant, and important to the role and function that we need to take a decision about. So the potential gains from machine learning have enormous appeal. And worldwide, institutions, companies, organizations are looking to invest in advanced analytic solutions. Within this perspective, I think this faculty development program is a brilliant call. I thank Professor Jamal and Professor Iftikhar for organizing one on data analytics and machine learning, and thank them also for giving me an opportunity to be part of it. Thank you very much. I look forward to talking to you in another 10 minutes or so. Thank you very much.
Thank you so much, sir, for your very nice and informative speech. May I now request one of our guest of honor, Professor J.N. Nayak, Registrar, Northeastern Hill University. Sir, please deliver your speech.
Thank you. Thank you. Thank you, Professor Jamal. Can you hear me?
Yes, sir. I think there may be two devices, sir, logged in, I think.
I just switched it off.
Yes, sir.
Yeah.
Yes. Please go ahead, sir.
Yeah. Good morning to all. Honorable Chairman of this program, Professor Divakar Tiwari, Vice Chancellor, Professor Sambasiv Rao, Professor Syamanta Hajarika, Professor Jamal Hussain, Professor Iftikhar, Dr. Jayaprakash Singh, other deans, faculty members, research scholars, and students. In fact, this is a proud privilege on my part to be associated with all of you at this stage. Thank you very much for inviting me to such kind of program. In fact, in our university, we do conduct such kind of programs, and perhaps in the series, this is third or fourth program that we are having in collaboration with other universities and central universities. And it is nice that Mizoram University came forward and NEHU could also make a program in collaboration with them. Coming back to the issue of machine learning, we have been every day finding this little difficult to digest, that the kind of data we are receiving from every corner. In the higher education system, we will find that the data analysis has become an important source, though it is more or less concerned with industries, because industries, they need such kind of things, because to predict the future, the requirements and to find out the kind of analysis that we need on the market as well as on the society. And education is not lagging behind. When in Indian context we are going through NEP 2020, the concept of higher education is moving towards the skill development, skill upliftment. And when we are moving towards the skill development, we do find that all of us need to have certain skills. And in such kind of thing, when we talk about the machine learning, cloud computing, it is not a new subject to anyone, be it from social science, be it from engineering background, be it from general sciences. So here we find that the field of study that we gather from various data, how to interpret it in a proper form so that it is useful for the larger body and to decide what kind of information is more relevant to the system, to our needs. And it is nothing but a system of processing. We know there are a lot of hiccups, but how to deal with this big data, how to deal with cloud computing, how to move with algorithm, and to give a proper output. And all of us are well aware that this has come into existence for a common man during the time of COVID. The whole big data of the world is being analyzed. And now again, there are certain kinds of predictions. Whether it will come out or true, that time will be the answer. But as far as technology is concerned, it has tested over its time. And I am pretty sure that things will evolve to different levels, and such kind of programs will help all the scientists, industrialists, educationists to come forward to have a meaningful deliberations and to learn how to make use of these kind of technologies for the betterment of human being with proper results. Thank you. Thank you, one and all.
Thank you so much, sir, for your very good and informative speech. Our inaugural speech by the chief guest is already done. So I'd like to mention that this program is also sponsored by the Department of Information and Communication Technology, Government of Mizoram. With this word, I thank everyone, and may I now invite Dr. Jaiprakash Singh, Head, Department of Mathematics and Computer Science, to propose vote of thanks.
Thank you, sir. Honorable Vice Chancellor, Professor KRS Samba Sivrao, sir, Chief Guest of this program. Professor Diwakar Tiwari, sir, Chairman of this program, Dean School of Physical Sciences. Guest of honor, Professor Syamanta M. Hazarika, Department of Mechanical Engineering, IIT Guwahati. Another guest of honor, Professor Jain Narayan Nayak, Registrar, Northeastern Hill University. Colleagues, distinguished speakers, participants, students, very good morning all of you. It gives me immense pleasure to deliver vote of thanks on behalf of Department of Mathematics and Computer Science in the inaugural function of International Faculty Development Programs on Data Analytics and Machine Learning. My sincere vote of thanks goes to Honorable Vice Chancellor, sir. Despite of his busy schedule, he grace the function, and he has highlighted data analytics as an emerging field, and he has encouraged with his encouraging word. He wishes for the successful of the this program. So thank you very much, sir. Now my sincere vote of thanks goes to respected guest of honor, Professor Samantha M. Hazarika, sir. So he speaks about machine learning, and he highlighted how it will be very applicable to the researcher, and it is very good for the young researcher. Thank you, sir, for your encouraging speech. Now I would like to thank Professor Jai Narayan Nayak, Honorable Registrar Nehu. So he also speak about machine learning, artificial intelligence, and also so how it is very much applicable to research, and what is the use application. So thank you, sir, for your speech. I would like to thanks the chairman of this program, Professor Diwakar Tiwari, sir, Dean, School of Physical Sciences. So he is always motivating us for doing such type of programs. He is always available for any kind of suggestion, always motivating us to bring projects to the department and excel in our academics. So we are very much thankful, sir, for all of your advices and encouragement. Now I would like to thank all the participants, colleagues, and speakers. So for joining this faculty development program, I hope great success of this program. Now I would like to thank the sponsoring agency. So Department of Information and Communication Technology, Government of Mizoram, for providing fund for holding this international faculty development program. So thank you all. So with this word, I would like to hand over to Professor Jamal. Sorry, I just forgot to the main organizer, actually Professor Jamal Hussain, sir. He is our ex-HOD. So he always busy with this type of programs, and always bringing the greater height for our department. So thank you, sir, for organizing this program, and hopefully you will do next time also. Okay, thank you, sir. Now over to you, sir.
Thank you so much, Dr. Jaiprakash Singh. Now, dear participants, let us move straight away to our scheduled lectures. And let me introduce, and it is my proud privilege to introduce Professor Samantha M. Hazarika. He is a professor in the Department of Mechanical Engineering, IIT Guwahati, where he leads the Biomimetic Robotics and Artificial Intelligence Lab. His primary research interest in robotic neurorehabilitation. This translates into interest in machine learning, artificial intelligence, and rehabilitation robotics. Prior to his joining IIT Guwahati, he was with the Department of Computer Science and Engineering, Tezpur University. He had been a full professor of cognitive systems and neuroinformatics, University of Bremen, Germany. He holds a BE degree in mechanical engineering from Assam Engineering College, Guwahati. and he holds MTech in robotics from Center for Robotics, Indian Institute of Technology, Kanpur, and a PhD from School of Computing, University of Leeds, England. And I know Professor Shyamantamani Hazarika for a long time. Though I'm not a direct student of his, but I remember his teaching in Tezpur University. It was so interesting, like students from, in fact, other departments also will join the class, keep standing from behind and attending his classes. He delivers excellent lectures. So with these words, I welcome Professor Shyamantamani Hazarika. Sir, please go ahead and interact with the participants.
Thank you very much, Professor Jamal, for your kind words. I will now share my screen. Let me know if the screen is visible. So is the screen visible to people?
Yes, sir. Yes.
Attending the talk?
Right. Yes.
Great. So let me straight away begin my talk. I shall be talking on machine learning. But then almost we have 180 participants here. And everybody has a different perspective of machine learning. So it's very difficult for someone to just talk of machine learning per se. What I would rather do is look at what machine learning has done over the years. If you see machine learning today, it's everywhere, right? From drones to Alexa. More interestingly, which is not obvious to us, hidden from us, is the very fact that machine learning started, I will go on to that in later slide. Machine learning started as an exercise to understand the very idea of how to create machines that could learn. And people look at the brain to emulate these systems. But then we have come a long distance. Today, machine learning is used to understand the functioning of the brain. And therefore, or because of its all-pervasive nature, it's used in everywhere. Talking of machine learning is really, really difficult. And when it comes to a number of different fields being involved, right from statistics to information theory, evolutionary models from biology to databases from computer science, symbolic logic, which is one of the proponents of artificial intelligence, whatever that means. We'll come to that later. Neuroscience, as I was telling you the story, that people wanted to recreate the systems of the brain or how human cognition works, including in psychological models, to decision theory and control theory, networks, data mining. So machine learning means different things to different people from different fields. And to talk of machine learning, which is an all-pervasive idea within this, is really a very difficult option. Therefore, I would give you an overview of the area, really pushing many of these intricacies under the carpet, but a good enough 1 hour or so that I have for me, talk on what are the trends and prospects of these ideas that we club together as machine learning. And all of these we will try to understand from an AI or artificial intelligence perspective. So let's begin by understanding what is AI. Now, whenever you want to do a task, which possibly was usually done by a human being, and you want to do it by a machine, that machine will require the ability to learn. And not only learning, it will need to have the ability to reason and solve the problem. So we say AI is demonstrated whenever a task which is formally performed by a human requires the ability to learn, reason, and solve can be done by a machine. And that brings us to the very idea that any form of intelligence that we are talking of is the ability to solve problems. Now think of this. You solve problems yourself many a times. How do you do it? In fact, there are two different strands of solving problems, or two different strands of AI activity. One, which tries to understand how our intelligent behavior arises, and then recreate this ability to solve problems. That's the cognitive approach. Another approach to really creating intelligence is not to look at how intelligent behavior arises, but somehow create intelligent machines. So that's an engineering approach where the goal is to construct intelligent machines without getting into the philosophy of what intelligence is. So when you look at these two strands of AI activity, one thing remains common. The commonality being that any form of intelligence will require knowledge. When do I say I have knowledge? Actually, a lot of data is there. I process that data to generate certain information. And then, given that information, I figure out which information to use under which circumstances. That's when I have gathered knowledge. And that's when I'm supposed to be rational or intelligent. So intelligence requires knowledge. But then this knowledge only can come through a process of learning. And that makes machine learning very, very important. Because if you really want to create intelligent systems, you need knowledge. And that knowledge comes through learning. Learning is nothing but the ability to explore the world and then gather that knowledge. And when it's done by a machine, we can think of automating the process. So machines would need the ability to explore the world and acquire the knowledge if you really want to create intelligent systems. And this makes machine learning a subset of artificial intelligence. Because if I can create machines which have the ability to really learn for themselves, here when I say learn, I mean they should be able to adjust their algorithms, change if they really want to change the algorithms. But they gather information. And that information is the basis of knowledge. That's what machine learning is. And that makes it a subset of AI. So herein, I would take a breather and just let you dwell on understanding what is learning. According to Herbert Simon, if I make some changes in a system and those changes allows me to really do the same task efficiently the next time, I have learned something. Like, for example, you are drawing and you are drawing with a pen. You make a mistake, you want to rub it out, you realize rubbing is difficult when it's done with a pen. That's very obvious to you. But think of a child doing it. The child has now learned that it's not good to draw with a pen for the first time if it's a draft. Rather, draw with a pencil because you can erase it with an eraser. And therefore, the next time he tries to draw, he changes his system. That system enables him to not pick up the pen, but the pencil. We say he has learned. So learning is also about not only understanding what changes in his system needs to be done so that the same task can be done efficiently next time. It's also about constructing or modifying representations of our experience. Like in your kindergarten, you must have been told by your kindergarten school teacher that apples are red. And that's something that you have really gathered from the data given to you that apples are red. You have this knowledge that apples are red until you go to a supermarket and see brilliant green apples there. So then you have to really modify your representation that apples are red with this new experience that you have gained, that apples can be green as well. And that's learning. So learning is not only changing the system to enable a system to do the same task efficiently next time, but also constructing or modifying representations as we experience. And that we want to recreate in an artificial system. And then that system would be called a machine learning system. So we need to understand the architecture of a learning system in order to really understand how machine learning works in a very fundamental level. So as I was telling you, learning is the capability of autonomous acquisition. That is, you try to really acquire new knowledge or new information and somehow process that information and integrate into your knowledge base. So typically, a learning system would be constructed of 4 elements. I would have a learning element, which would really understand how to make changes so that performance goes higher. And if it goes higher, it will record what changes it has made, like drawing with a pencil rather than with a pen, and that knowledge would be stored. In order to really learn certain things, new problems need to be generated, and that's done by the problem generator. Finally, how much of learning has happened given the performance element, given the performance and based on actions on the environment? You really compare with certain performance standards, and that's the critic which gives you a feedback. Most of us, when we fail to learn certain things, our critic gives us solace by saying, oh, don't worry, this is too difficult to learn. That's fine for 1 or 2 failures. But every time if our critic says, don't worry, the feedback is this is too difficult, we will never learn anything. So it's very important that we have a critic that gives us really critical evaluation vis-a-vis the performance standards and our actions to enable us to learn. So let's look at these 4 elements very quickly. So we have the learning element, which is really looking at making it possible for us to make improvements. And how do we do this? We do this by getting feedback to improve our performance from the critic. And that feedback allows us to make changes. And that changes, if they are really on the right direction, is stored as knowledge for us. Who tells us whether our changes are right or wrong is the performance element, which selects external actions and drives the learning element. So the learning element is driven by the performance, and that element and decides on what actions to be taken. Now, learning can only happen if you have new experiences. If you are not experiencing anything new and if you're always in your comfort zone, you can never learn. Similar is the truth for even a automated system. So you suggest actions that would lead to new experiences. And that would ensure that you explore and you really come up with better actions. So problem generation is a very, very important element. Now, just to give you some perspective from cognitive sciences, as we grow old, our problem generator becomes compromised. We do not want to really do a lot of exploration. But think of a child. He's trying to get any number of problems generated, really to gather new knowledge is based on his actions. And that's what I meant when I said the problem generator ensures exploration so that better actions are discovered for anything that you want to do. And finally, as I was telling you, you fix a standard of performance, and that is giving feedback to the learning element. So all of these four elements are very important for a learning system. And when I say machine learning, I'm trying to really understand this, or I'm trying to really create this system into an automated process. So it will involve programming computers somehow to optimize a performance criteria. And how do I generate these is knowledge by using example data or by past experience. Now, one needs to understand that machine learning, that is using data or experience or past experience to really make sense of what is happening. That's what I called data analytics in my short talk in the beginning today morning. This has changed now with machine learning. So machine learning, if we are allowed to really look at it that way, is a natural outgrowth of the intersection of computer science and statistics. I would now just point to you that machine learning is not new. Machine learning is a field of study that gives computers the ability to learn without being explicitly programmed. Was written by Arthur Samuel in his very interesting paper published in 1959. That paper was called Some Studies in Machine Learning Using Game of Checkers, and published in the IBM Journal of Research and Development. What you see on your screens here is Arthur Samuel playing a checkers playing program with an IBM P500 machine. IBM shares were depleting. IBM was losing. Nobody knew what to do with computers. Arthur came up with this brilliant idea of making programs play games. And he made this checker playing program and went live on television playing against a computer. He won a couple of times, the computer won a couple of times, but the end result is that people know what computers could be used for. Okay, jokes apart, this idea that some form of programming, not to be done explicitly, would give the ability to the computers to really understand these learning elements was path-breaking. So I'll take a minute from you to really read the abstract of that paper, because that paper is something that's so path-breaking that if you read that paper, the very idea that machine learning is grounded in 50 years of history makes sense to us. So his paper called Some Studies in Machine Learning Using the Game of Checkers, he describes two machine learning algorithms. And he says that these algorithms allow a computer to play a game of checkers. They learn the rules in a relatively short period of time. And he then goes on to say that they are able to play even better game of checker than the person who programmed the computer in the first place. So learning must have happened. And if you look at the very definition of machine learning as put up by Tom Mitchell years later, this is the first formal definition of machine learning. It says a computer program is said to learn from certain experience E with respect to a class of task T. So with a certain class of task T given an experience, if my performance measure goes up, then I am supposed to have learned my task. So given that idea, authors checker playing program, the task is about playing checkers. Performance could be measured as percentage of games won against opponents. And E is playing practice games against itself. So you could see that as the computer program played games against itself, its performance of games won against opponent improved. And the task was about playing checkers. So we had our first machine learning program. Given that history, and given that idea that it was way back in 1959, now many of you may be aware, it was 56 in the Dartmouth conference that McCarthy had just introduced the term AI. Just 3 years later, the term machine learning was introduced. So it's almost a parallel history that we are looking at. The idea here is slightly different in the sense that I'm trying to build a model which is a good and useful approximation to the data that's being brought to me. And I am trying to optimize the parameters of the model in order to really improve my performance as I experience new data. So in terms of the philosophy that it's based on statistical ideas, we need to take a short look at it. In statistics, we are also doing similar things, trying to understand data and what's the structure in that data. But statistics is limited to low dimensional data. Machine learning, by nature, we are interested in high dimensional data. Noise in the data is a problem. We enjoy noise. So machine learning algorithms, noise should not be a hindrance to obscure the structure in the data. In statistics, structure of the data can be fairly a simple model. Here, it's too complicated to be grasped by a simple model. But then, here's a caveat, here's a warning. You should not take it for granted that you cannot understand machine learning models. You need to understand what your model is saying. But that's a different story. The main problem is distinguishing the two structure from noise in statistics. Whereas here, the main problem is about representing the structure so that you can have learning. And learning, by this time, you should be clear, is about improving performance given experience for a task T. So the philosophy of machine learning is to automate the creation of analytical models so that algorithms can make continuous change. And those models that I'm talking of, they can be either predictive models, that's models that can predict what will happen in the future given these experiences, or they could be descriptive in the sense that they could capture the amount of knowledge hidden in the data, or they could be both. So now, one thing that comes to my mind, and this is something that usually happens for everybody and anybody starting machine learning, is that they tend to look at traditional programming vis-a-vis machine learning as watertight compartments. Now, many of you are aware what traditional programming is. You have data, you have a program, and given this program and the data, you are looking at what's the output. In machine learning, you are given the data and you are told what that data is about. So you know the output. All you are looking for is a model. The model in a computing in parlance is nothing but the program that describes this data given this output. So given this idea of traditional programming and machine learning, I would emphasize that you need to look at that as one driving the other, in the sense that if you get a program from a machine learning effort, that program can be used to understand data and the output and get newer outputs. This new output and the data that you have used recently can be then fed into the machine learning to get a better model. So traditional programming and machine learning can be made to run interactively, okay, so that you have this idea of driving one from the other. Now, taking this discussion further, you can see that machine learning is about a method of data analysis that somehow automates this analytical model building. And when we are talking of machine learning, almost many of you here are aware that we are talking of three different types of algorithms or approaches. One is called the supervised learning, the other, the unsupervised learning, and the third, the reinforcement learning. I'm sure many of you would be aware of this. For many, this would be covered in more detail in the other sections as well, other lectures. But let me just give you a brief idea of what is these three different approaches to machine learning. So supervised learning is about when you have raw data and you really want to understand what this data is about. But then there is a supervisor. It's like the kindergarten school teacher telling you apples are red and mangoes are yellow, or things like that. So you have an input vector, but you learn to predict the output given the input vector. So that's where the supervisor comes in. So prediction of future cases is to predict output for novel instances in the future. And the knowledge extraction here is to really get an explanation for the process underlying the data. Supervised learning is usually either classification or regression. Classification is about having certain labeled data and our algorithm trying to draw boundaries between these labeled data, so that as you see an unlabeled data here, which is roughly a triangle, maybe white, but that doesn't matter for us because it's a triangle. We classify it as a triangle. Okay? So that's classification. Having labeled data, trying to draw boundaries, and then the unlabeled data put in the correct boundary, within the correct boundary. Regression, on the other hand, is about modeling relationship between dependent variable and some explanatory variable, or what we call independent variable. So it could be classification as boundaries between different objects, regression being explanation of one in terms of the other. So here is an example. If I had two types of genes, the blues are healthy genes, the red are the disease genes. A classification model would be more interested in drawing a boundary between them. Whereas a regression model would be about finding out, given the healthy genes, what would be the survival in numbers of years. So it would be like, given this gene, I would love to explain the number of years the patient would survive. So that's a regression model. Coming to unsupervised learning, you are interested in creating an internal representation. Here you are not given an input vector. You are not told what your input is. So there is nobody telling us that apples are green or red or mangoes are yellow. So you have no idea of a supervisor telling you anything. You need to create an internal representation of the input. That is, you need to really extract features and try to understand which groups falls into what. So most of the unsupervised learning is about learning relationships. So it's about understanding relationship between data components, or it is about forming groupings of similar input variables or clusters as they are commonly called. And finally, we would love to determine the distribution of the data within the input space. Unsupervised learning, the most common is clustering, where you really put things in the correct cluster or group. And the other unsupervised learning approach is about dimensionality reduction, basically used for concepts such as feature elicitation or big data visualization. So here is a number of points. I don't even know what these points are until I tell you that it's about certain spending in the European Union. And then given a clustering, you could see that different clusters coming up. Okay. Now, when I started here, I didn't know what the structure is. I had no idea about the underlying structure, but somehow using some form of distance between points and the number of clusters available, I had figured out what are the different groupings. And that's clustering for you, where you have unlabeled data, yet you would try to really draw boundaries and give meaning to these categories of data or clusters as they are called. Now, the final form of learning that I wanted to talk of to you is the idea of reinforcement learning. Learning that requires an agent to be there. And that agent tries to somehow maximize his payoff. That action is picked up that will maximize his payoff. Like, think of a monkey being taught how to ride a bicycle. The monkey takes around in his cycle, and if it does it properly, you present a banana to the monkey. Now, the monkey is not trying to ride the bicycle for the fun of it. It's trying to do this best action of riding the bicycle to get the banana, to maximize the payoff. But in the process to get the banana, the monkey is somehow learning to ride the bicycle. So that's reinforcement learning for you. When you have an agent and the agent selects the best way to do a certain thing because it wants to maximize its payoff or reward, and in the process learns how to do that thing. So reinforcement learning is concerned with finding suitable actions, maximizing reward, and it's about learning from past good action sequences to really generate a policy that would maximize the reward. Reinforcement learning is used widely in controller design, in navigation, real-time decision, skill acquisition, and so on and so forth. Now, that was a 10 or 5 minutes primer on machine learning. But all of these machine learning algorithms, all of these machine learning techniques, whatever they were, you could see that underlying them are these 5 machine learning algorithms, which is about finding trends. That is, we are interested in how is a sensor performing over time. Is the process going out of control? Or we are interested in finding out the lifespan of a component. What is the run to failure or time to failure? So we are interested in trends. We are interested in relations. What are the main influences? Let's say for machine breakdown or asset lifetime of a particular item. We are also interested in finding out segments or groups in the data, associations or correlations. Like if someone is buying bread from the supermarket, he's also buying butter together. So we are interested in finding out such correlations. And of course, anomalies, unusual data or errors or certain change in sensor behavior which was not expected. So machine learning is about really finding out, or as I call it, machine learning analytics, is really finding out trends, relations, segments, associations, and anomalies. How I do it is using the 3 machine learning paradigms that I have shown you a little while ago. Underlying them is these 5 machine learning algorithms. So any machine learning system would therefore fall in a very interesting 5-element architecture. The first of them is about data acquisition. You need to have data. So data could come from your ERP databases. It could be the mainframe computers being used. It could be IoT devices, whatever. You need to really acquire that data. The most important and possibly the most interesting step comes next, which is feature engineering. Many call it data processing. The data processing is really looking at it like the data analytics vis-a-vis business informatics, where I was telling you in the morning, we are interested in creating dashboards. That's when we say data processing. Here we are more interested in features engineering. That is some form of transformation, some form of normalization, some form of encoding, so that some clean features are visible to us, so that the data that we have collected could be used to really drive our next step, which is called the model engineering, or getting the machine learning algorithms in place. That can only come quickly and effortlessly if we have done feature engineering well. So here is a simile that I love. If you were asked to cut a tree with an X in 6 days, I would rather sharpen the X for up to the 4th day and make an attempt to cut it on the next 2 days. This simile runs also for machine learning. After data acquisition, feature engineering is where most of the time needs to be spent to really do model engineering better. Once you have the models, you go to execution and deployment. So that's the machine learning architecture. And given this small primer, let us now look at where are we heading for the future. Everybody tells us that machine learning is going to go out, make an impact, or machine learning is already making an impact. But the question is, where are we heading? This is where Elon Musk says Model S is something that I take it as a standard. Model S, according to Elon Musk himself, is not a car, but a sophisticated computer on wheels. Why? Because it has forward-looking camera mounted in front of the rear view mirror. It has a radar that sits below the nose cone. It has 12 ultrasonic sensors providing with 360-degree vision for about 16 feet range. It has information from camera supplemented by information from GPS and many other sensors, whatnot. Now, all of these integrated so as the car performs better. And this is where we need to really understand what Timothy Chow calls precision engineering. So according to him, the machine of the future, it is going to be still assembly of parts, gears, electronics. But the machine of the future is going to be integrated collections of sensors and actuators connected by software. And that would really lead to what is today fancifully called the Internet of Things. So the Internet of Things is just a outgrowth for me of the idea of coming together of data analytics, big data, machine learning, and the ability of embedded computing. So in Timothy Chow's book called Precision, Principle, Practice, and Solutions for the Internet of Things, he gives a number of very interesting case studies where all of these has come together and machine learning has been the principle moving this ahead. So one of them is about automated patient monitoring. So if you look at an automated patient monitoring system, okay, machine learning is giving a huge prospect here. You have the Internet of Things, which is identification, which is sensing, which is communication, then computation, services, and finally semantics. So Sensium Vitals is the world leader, where they have sensors which they can put on patients, and all vitals can be sensed, identified where it is coming from, communicated, and you then compute and give the services necessary. After that, you make meaning out of this. That meaning, don't forget, is the knowledge. And that knowledge would drive intelligence, so that the next time similar signals come or similar data come, I can make sense of what services to provide. So this is what Timothy Chow called precision engineering. And this is made possible by machine learning algorithms that I have just now discussed. Other areas where machine learning has come in a big way is computer-assisted surgery. Traditional surgery would require 3D mental reconstruction for diagnosis and planning, image acquisition, and that image he needs to carry to really recreate the operation in his brain and do it functionally there. Today, you have multimodal 3D visualization, planning in the virtual environment possible with augmented reality systems and multimodal data integration, playing for him the complete operation online as it is performed physically. So that's where we are moving. One area very close to my heart is because of the very fact that the world leader, the world leader in computer-assisted surgery or robotic surgery is Da Vinci robots. The world leader in digital twins today is an Indian company, a Tata company called Voltas, which makes chillers for refineries worldwide. Now, these chillers, they create what are called digital twins, which are digital representation of the real world objects. Now, these digital twins are not only just CAD models, the finite element analysis models, the physics-based models, the statistical models. They are machine learning and AI models. So all of these together, they are able to really recreate the operational history, the maintenance history, the aggregate fleet data history, so that without even operating the machine, they have all of these histories with them. Together with the operational data, they could really think of controlling these systems, maintaining these systems in the best possible way. Now, let me tell you, this is not predictive maintenance as we have understood years ago. This is really trying to figure out how that particular real world chiller or object would behave by creating its digital twin, okay, or digital representation. These things have pushed, as I have shown you in the couple of slides, have not only pushed further the idea of healthcare, the idea of really creating factories of the future. They have brought together these huge data, possibility of generating huge data that we have created for ourselves by our improvements or advancement in sensor technology, together with our ability to really compute with the improvements in computing power via these simple ideas of supervised, unsupervised, or reinforcement learning. Now, just to give you some idea of what I do in my own lab for a living is I take data from the human body, like the EMG signals that comes to your muscles from the brain, and try to understand how a particular person is trying to grasp an object, so that when we create prosthetics, these prosthetics are controlled by the human body rather than just being in prosthetics that are more or to do with being cosmetic. We are also trying to look at how to really get the sensors on the prosthetic hand, collect the tactile information, and using machine learning algorithms, give it to the peripheral nervous system, so that then the nerves of the human body carry it to the CNS. That is, we are recreating a prosthetic feedback system, which would be at par with a biological feedback system. So we are also looking at electroencephalogram, the signals from the brain to do brain-computer interface, which is where we drive systems using signals from the brain, and either we drive prosthetic hands or wheelchairs. So this is something that's made possible only because of some advancement in machine learning. Now, just to wind it up all, if you look at artificial intelligence vis-a-vis machine learning, and another term, deep learning, that I have not even touched, AI is the superset. Machine learning is within that idea, and brain-inspired systems create what are called neural networks. The ability to really create these networks with a large number of layers in between leads to what we today call deep learning. But there are other interesting ideas called spiking neural nets. which are artificial neural networks, but they more closely mimic the natural neural networks. In fact, in addition to the neuronal and synaptic state, spiking neural networks incorporate the concept of time into the operating model and are better approximations than artificial neural nets. Now, deep learning, which uses either deep architectures of learning or hierarchical learning approach, is again a class of ML, which have really changed the machine learning future. As I was telling you, machine learning also has a long history. But by 2010, a subset of machine learning, which used multiple layer neural networks, was made feasible, leading to deep learning, which has pushed the boundaries. But that's a different story. I don't want to get into that today. Rather, in the 10 minutes or so, after I finish within 2 or 3 minutes, we will have a discussion. And I can see a number of questions on the Q&A, which I would love to take. So let me finish off with a warning. AI started with the idea of creating machines that are truly intelligent. And we had this big picture of really getting things as close to the human as possible. Somewhere in our journey, our idea of AI narrowed down, and leaving aside this general AI question, we fall back on this idea of just understanding data to really understand some process of or structure of the data so that we could gather knowledge and say we are learning. When would we have this general AI back? Nobody can tell us that. But then that's a long story, which I would emphasize you people to really take this surge of machine learning with very cautious, because I don't want you to get carried away with the hype. So it's very important that you are able to really separate out the hope that machine learning holds from the hype and create the fundamentals first. Then go to your own area and try to look at its implications. For any starters, these books may not be important for anybody that has already started machine learning. But any starters in this 220 participants here, if you're interested to start machine learning, then the first book that you should pick up is Machine Learning by Tom Mitchell, which is the single source introduction to the field. And the best thing about this book is it requires no prior background in AI or statistics to make you understand machine learning. The next book is The Elements of Statistical Learning. Now, this is a very interesting book. But here you would really feel that the approach is statistical. So the emphasis is on concepts rather than mathematics, which models to pick up for what type of data, for what type of prediction. But the book's coverage is very wide, from supervised learning to unsupervised learning. And therefore, anybody interested in really statistical learning, this is the book to pick up. I would rather prefer these last two books, Introduction to Machine Learning by Alpedin, which is a nice blending of the topical coverage with also probabilistic foundations. And the other book by Alpedin again, which is called Machine Learning, the New AI. This is a concise overview of ML, which underlies applications like recommendation systems, driverless cars, face recognition, and whatnot. So many of you may be teachers in engineering colleges and institutions. For you, the first book by Tom Mitchell, and the last book, Machine Learning, the New AI, is what should drive any course that you are teaching on ML. Thank you very much for your kind attention. And I would love now to take the question and answers if Jamal allows, or I can just stop.
Sir, thank you so much for your excellent speech and this really valuable lecture. And as always, you made the things very easy, the difficult concepts through real life examples, which anyone can easily relate. It's really excellent. Thank you so much, sir.
Thank you very much.
I now request sir to respond to the queries. Shall I read out the questions?
Yeah, you can.
It's Madan Nagar. He says, does machine learning means dynamically change the actual coding or just infer output from the input data?
Okay, so machine learning, if you see, is not only about inferring output from input data. It is inferring output from input data, yes, but in the process, rearrange its own dynamics so as to better infer next time. So it's like not only dynamically changing the actual coding. Dynamically changing the actual coding, we have other forms of coding that are there. That's not what exactly here I meant when I said it changes the way it looks at the data. It is about really changing parameters and trying to figure out the data in the next phase more interesting. The second questions, I can see the answers now. I can see the questions now. Yeah. What is the difference between clustering and classification? Okay, that's something I had shown a slide about. In classification, you are given the input vector. So you know you have red triangles, you have purple rectangles, and you have white circles. You know that. But in clustering, you are not given the input vector. So you have no idea what these points are about. And you try to figure out their closeness by really finding out characteristics of these points. Like 2 points are very close to each other. You may say, oh, they are of the same group. Okay? So clustering is completely unsupervised, whereas classification is supervised. In machine learning, who control flow program, the programmer itself or the algorithm? In machine learning, if you have written a very nice machine learning program, the program or the algorithm is supposed to take the control flow rather than the programmer. The programmer has very little role to play once you explore this data and how these data are going, how this data is going to really bring this learning to a steady state. How machine learning is different from evolutionary computing techniques. Now, this is something that needs a little bit of more discussion. Machine learning and evolutionary computing techniques. I have not talked of evolutionary computing techniques. Evolutionary computing techniques like genetic algorithms, or you could say simulated annealing, are biological processes that you really want to recreate in the machine. Like you want to create a population and you want to create, bring up the best two variants from that population, give it in a mating pool to really create a third element and of the population. So you recreate what is happening in the biological system and expect that the best things survive because of like if I'm recreating generations, I would have survival of the fittest and the best would emerge as the result. Whereas machine learning is about finding out the structure in the data. It's not about really copying things as happening in nature. Okay, biomimetics, the area of my lab, is about copying in natural phenomena into robotics so that I am guaranteed to have an optimal solution. because nature has optimized it. That's what evolutionary computing techniques are also trying to really work on. Whereas machine learning is about finding out the underlying structure of the data using any form of tricks that will make you understand the structure of the data, not necessarily copying things from nature. How digital twins are different from simulations. Digital twins, simulations are one part of the digital twin. The digital twin, if you see, is not only the finite element model, it's not the physics model, not only the simulation model, it is a real digital representation of the real world object, in the sense that it is an avatar in the real world, real sense of the world. It's an avatar of the real thing. So that avatar simulation is only about numerically looking at how the system will work over 10 cycles. When then I'm creating an avatar, the avatar's actions and reactions to different elements in the environment would come because of its physics model, because of its finite element model, because of its AI ML model, everything. Okay? Can data acquisition be sometimes a problem in machine learning? Of course, data acquisition is not easy. Even if we say we are generating data, today the Vice Chancellor was emphasizing how much of it is data that you don't want, data that's erroneous, or data that is anomalous. So you don't know that. Okay, so the only thing that I can say is that if you are a starter in machine learning, you need not bother about data acquisition. You could get data sets from different places and work on the machine learning problem itself. The moment you want to implement this in a real world scenario, like we implementing it by taking data from the human brain or data from the muscles, problem becomes tenfold. Data acquisition then leads us to this huge idea of how best you can acquire data or how you can process data to understand the real structure. What type of infrastructure is needed to pursue research in this area? You do not need much of infrastructure today to pursue research in machine learning. You can take computing power from the cloud on rent. All you need is a fire in your belly to really understand what are the things that you want to really solve. So you should have a problem in hand first. And you should be an expert, or you should be able to talk to the experts of that fundamental area rather than talking to an expert of machine learning. Once you understand the problem and the expert's idea of the problem, then you can think of machine learning algorithms on your own or looking at certain machine learning in courses or websites. And as for infrastructure, you can take on rent computing power from the cloud. Is there any relation with finite element method with ML? Madan Nagre, finite element methods allow us to really look at how things will behave. Like, let's take an example. If I have a beam, I can do loading and I can understand and what is the bending moment or what are the stresses is using a finite element method. That can then be my data to really understand the behavior of that beam without a constitutive model. That's machine learning. So machine FEM can really push forward the machine learning agenda, where you will not even be talking of constitutive models, and all you will have is data-driven mechanics. I think I have covered all the questions now. Jamal?
Yes, sir.
Thank you very much.
Thank you. Thank you so much, sir. I think all the queries are answered. And thank you for your excellent response to those queries. And I once again thank you on behalf of our organizing committee. Thank you for your time and support and excellent lecture. I hope everyone got benefited, particularly the new young researchers and then faculty members. Thank you so much, sir.
Thank you very much, Jamal. It was nice being here. Aizawl is a very beautiful place. Hope to be there physically sometime soon.
Yes, sir. It's our pleasure, sir. Do visit sometime.
Thank you very much.
Okay.
See you then.
Thank you, sir. Thank you. To all the participants, I think these resources it is recorded and it will be put in our university YouTube channel. And with the permission of the speakers, we'll try and share with you also.
Can I leave this webinar, Jamal, now?
Yes, sir. Yes, sir. Yes,
Thank
sir.
you very much.
Thank you, sir. Thank you. And the participants can join back at 2:30 sharp. We'll have a hands-on demonstration related to machine learning. Thank you so much. We can stop and go for lunch. Thank you. The coding is integral part of machine learning process. So let me introduce the speaker for this session. He will show some hands-on demonstrations on machine learning. Mr. Vanlal Ruata Namte completed his Bachelor of Computer Application in 2009 from Makhanlal Chaturvedi National University for Journalism and Communication, Bhopal, India. Thereafter, he completed his master degree in computer application in 2011 from Annamalai University. Currently, he is working in intrusion detection system using deep learning techniques in our Department of Mathematics and Computer Science, Mizoram University. Currently, he is working with software-defined networks and already published 5 papers in international journals of repute. And his areas of interest include network security, deep learning applications, and machine learning. So with these words, I welcome Vanlal Ruata and request him to deliver his lecture.
Thank you very much, sir. VC Sir MZU and MZU Registrar and the organizing team and rest of the participants who are with us here today. I hope my screen is visible.
Yes, go ahead.
Okay, thank you very much, sir. So thank you very much for giving me a chance, sir. Today I will be talking about the programming language, particularly hands-on, while working with machine learning and deep learning. First, I would like to talk a small introduction on machine learning and deep learning, and we'll go straight to hands-on demonstration. We'll talk about Python language and the tools, the IDE which we can use, and we will be doing practically some of the work. And as artificial intelligence, we already know that it is first coined by McCarthy John in 1956 in the conference of Dartmouth conference. And the science and engineering of making intelligence machine, especially intelligent computer, the AI is a simulation of how computer brains work, how it learns, how it decides and work, and it aims in improving the daily work, day-to-day works. So artificial intelligence is basically an approach to make a computer or robot or a product to think how smart human thinks. AI is actually the study of how human brains decide to do with data, to work with the data, and when trying to solve the problems. And there are some intangibles, intelligence, which is composed of reasoning, learning, problem solving, perception, linguistic intelligence. So the objective of AI researchers are to find and realize the ability of the computing device. So let's come to the field of machine learning. Machine learning, as it is a subfield of artificial intelligence. The goal of machine learning generally is to understand the structure of data and fit those data into models that can be understood and utilized by people or maybe a computer system itself. Although machine learning is a field within computer science, it differs from traditional computational approach like simple artificial network. And in traditional computing, algorithms are sets of explicitly programmed instruction, like maybe application program or maybe a system program used by computer to calculate or problem to solve the problem. And machine learning algorithms instead allows computer to train on data input and use statistical analysis in order to output values that falls within a specific range. And because of this, machine learning facilitates computers in building models from sample data sets in order to automate decision-making process based on data input. Any technology user today has benefited from machine learning. Face recognition technology allows social media platforms like Facebook, Twitter, and many others, social media, other social networking, to help user tags or friends, tagging and share photos of friends. And we can also take an example of optical character recognition technology, converts image to text to movable type like animation. And we can also see a self-driving cars that rely on machine learning to navigate on the road, may also be soon available in many common customers. And we can also say that there are three types of learning in machine learning: supervised learning, unsupervised learning, reinforcement learning. We'll not be able to explain each and every details on this hands-on, since we are going to mostly demonstrate on machine learning techniques. And coming to deep learning, Bengal University in 2015 stated that deep learning is part of broader family of machine learning methods. And deep learning is obviously a branch of machine learning, which is completely based on artificial neural network. As neural network is going to mimic the human brain, so deep learning is also a kind of mimic of human brain. So in deep learning, we don't need to explicitly write the code or code language, program everything. The concept of deep learning is not new, but gained its popularity recently, and it's been a couple of years now. It's on hypes nowadays, and it's a hot topic in almost all the research area of artificial intelligence. We did not have much processing power earlier, so nowadays computing powers are also available in the market in a cheaper rate. So as the processing power increased exponentially, deep learning and machine learning comes into the picture. The question is like, what type of architecture we may use in deep learning. So first, as we can see here on the slide, we have an input layer, and hidden layers can be 3, 4, or 5. So here in the example, we have a 3 hidden layer. It is not necessarily that we have only 3 hidden layer. We may have hundreds of hidden layer as well, but the more hidden layer we have, the more complex it becomes. So basically, we have 3 parts: input layer parts, hidden layer, and output layer. So we may have several architecture in this type of form. Deep neural network can be formed in this type of neural network. It is a neural network. What we are in deep neural network, we have a certain level of complexity, having multiple hidden layers between the input and output layers, as we can see here on the slide. They are capable of modeling and processing nonlinear relationship. And we also have deep belief network, DBN, which is of a class of deep neural network itself, but it has multi-layer belief network. So learning layers, features from visible units, contractive divergence algorithm, and activation functions. Finally, the whole Debian network can be trained from several hidden, including several hidden layers in between. And we also do have recurring neural network, RNN, which allows for parallel and sequential computation, similar to the human brain, such as large feedback network to connect neurons. They are able to remember important things about the input they receive, and hence also enables them to be more precise. So why choosing deep learning in most of the case nowadays? Because when working with traditional algorithms like in machine learning, the more data we have, the more data we feed as an input, the result is not improving much. Whereas in deep learning, the more data we feed, the more better performance we get, and accuracy also. So the reason that deep learning has taken off successfully is because it performed very well at supervised learning as well. So recently we do have some work with deep learning methods. We already published these 3 papers, and another 2 papers are also there, which is based on some machine learning techniques. And we will go straight away into hands-on training. We can use the language whichever we are comfortable with. So R language, Python language, JavaScript, C++, Java, or MATLAB. That depends on us. Most of the people choose R and Python. And some people are also working on Java language and C++ language. And MATLAB is also very popular since the application is quite light, and it gives very powerful computation. So I will suggest using Anaconda, or if we want to have little bit lighter version of Anaconda, we can use Miniconda as well. MATLAB can be downloaded from their official website, and we can also use Google Colab. It is available free, of course. And if we want to go with higher computational processing, then we can go with Google Colab Pro Professional Edition, professional version. And we can also use IBM Watson Studio. And there are many other tools with which we can work with while doing with machine learning or deep learning. So first, I would like to highlight Python language. So Python language use Unicode, which is very much understandable when writing the program. It is not like C++. We can use some already built-in function, which are Python is having very much rich features when it comes to machine learning. So I promise that whoever is working on machine learning or deep learning project or doing research, it is very fruitful to work with Python language, because as I mentioned earlier, it has a very rich features on data science. So why Python is most popular language for machine learning? So it is very easy to learn and very simple and very much efficient. It does not take much time to compile on whatever program, whatever code we write down there, diverse libraries and frameworks. And it is very much versatile as well. And the developer community is big enough to support you when we work on Python language. And it is very much portable code, and whether it is compiled on Linux system or Windows system, the same can be used on another platform, or maybe when we port to Google Colab, we can still use the same code. So it is very much flexible, and it also has very much rich documentation. So I will be mentioning about the documentation later in the demonstration. So let's move on. So I will open up my Chrome browser. So first, let me stop this sharing, then I will share the screen. Okay, well, here I am using Google Colab. So we are going to start on hands-on programming, the Python language. So Colab, obviously it is free, as I mentioned earlier. We can get this Colab right in the colab.research.google.com, or we can even start with our Google Drive, creating a folder and creating a file as a Google Colab project. So here, the environment is quite simple. On the top, we have menus, files, edit, views. These are the menus we have. It's quite simple enough. Just next to that, whenever we want to add a block of code, we can simply click on this code block button. And whenever we want to add some text in the block below or between this block, then we can use this text cell button. So in this cell, in this block, let me mention it as a block, I have some codes already written here, because if I type line by line, it is going to take so much time. So I will break down this, and I will be explaining this as much as simple I can. And first, directly let's dive into the Python code. Here in the first line, we see that import pandas as PD. So whenever we want to work with some files or some document, we can process the CSV file, convert it to CSV file, or from text to CSV, something like that. We have to import the pandas library. So when I import the pandas library, whenever I want to use that panda, I assign it as a PD object here. And also whenever I want to fetch a file from my local drive, or maybe from Google Drive online, or maybe from a URL, we can use get file. Then we have to import the get file libraries from the TensorFlow Keras utilities, exactly the same way I am writing here. So once we assign these pandas and get file, we import here, then we can write get file. From this URL, we have to pass these two parameters in the get file function. So I will download this file from this URL. Then once it is downloaded, it will be saved as this file. So that is done using the get file function. Once it downloads, it will be assigned to the path variable. If this file is not found from this URL, or maybe I have mistakenly typed some URL here, something like 0 or something like that. Suppose it is an invalid URL, then it will show me error downloading. So if there is nothing wrong, then it will go ahead with that. This error downloading will not be shown. So it is taking from this URL, and then when it is getting into my system or into the Google Colab drive, so sorry, program, it will be saved as kddcup.data 10%.gunzip, ZZ is the gunzip. So it will be taken as this. Then I will be reading it as a CSV, and there is no header defined here. So I have to define later on. That's why I am putting here header equal none. If there is a header, then you can define the header here itself, or just remove this header parameters, and you can only put the path here. So the df is a variable, the data frame variable, where when I download this file, it will read it as a CSV, then it will be kept in a data frame variable. So I will be reading from the data frame how much row are there, how many rows are there in that data, and once it print out that how many rows are there, then I want to filter out the not applicable null value or NA value from the data, which are not important for us to go ahead with that. So it will clean the data. So here I define the column from the data frame. I will be using this column. So whenever we use any type of data set from any website, or maybe it's a cancer data sets, or maybe it's a network intrusion detection related data sets, or maybe it's a image data set. So some of the data set may have the headers already, but some does not have. So when the data set doesn't have any headers, we have to define the columns this way. So we are defining the column here. Once we define the column, then we will display the data frame, only the first 5 rows again. So let me try to run here. Once we finish typing our program, I can even run in a small portions of cell, but whatever I have within this cell can be run from this small button here. You can see on the left hand side. Once I click this, it will show me some green color here. So that indicates me that I am running this program. So now I will be trying to run this first program. So if I have any error, I will be getting error downloading. So let's have a look. So now it is running. In the meantime, you can also work with another chunk of cell. So nothing is displayed yet here. We will be getting the output down here, just below this cell. Yes, now it is executing. Okay, now the downloading is from the URL which we had given. So it is downloading. It's already finished to download, and it's stored the downloaded folder in the root folder, Keras dataset. Then this is the file name which we had assigned earlier. There, that is the file name which assigned. So it came exactly as that. Then we have totally 4,94,021 rows that was displayed in this line. So we displayed the whole, how many rows are there. And after displaying that, we dropped the null value and a value. And after that, we assign the column. Columns are assigned. All the columns are not visible right here. So we displayed the first 5 rows, as I stated earlier. So that is what it does with this cell of line. So I want to write some more code. In that case, I can simply click on the add code buttons here, and we can write our code here. So I will be working with the next line of code. Here we have to import the NumPy because we want to work with statistic problems. So when we want to work with those such problem, then we can use NumPy library. And also when we want to use some matrix or sklearn, from sklearn, we can import that matrix library. And Z-Score, we can import from the SciPy stat library. So I defined here a function which will expand the categories. So we can have 2 types of class whenever we use any type of data. Like suppose I have animal data set which has cat and dog. So when I want to classify, either cat or dog will be placed as an animal. And if we have any other image like sheep or maybe a building, it will be non-animal category. So I want to categorize into 2 parts. Then I can have binary classification there. So I can categorize it into 2 groups. So in that way, we are defining a function which will count the value and expand the categories. And also I define the analysis function here. So which will print the columns values, which will assign the columns values in the calls variable and put the length of the data frame into total variables, as we can see here on the screen. And we will print the format, the total, and it will format into integer value, and we will be printing out the value, and all the unique column, unique count will be displayed. So this is just the function. So once I click here, this function will not be run yet. So I have to call from some other cells. In these cells, we will not have any further output. It is just to define means to execute this function that we can call later on. Now, in this block, we are having a print function to print the length of data frame. And once it is printed, we will also print the shape of the first feature data point. Then the features will be available here, and the outcome, as I assigned here as into output variables, the outcome values will be assigned there. And once it is assigned, then again label value will be set from that output variables which we assigned. Then once we run this, we will see something like this. So the total row is 4,94,021 rows, and number of data points are 4,94,021, and number of features we have there is 42, and types of outputs are guess password, phishing, rootkit, smart, teardrops, nmap, etc. So this way we are going to analyze the data sets whichever we feed. Okay, this is not that very much complicated yet. So we are still just walking around with the data sets to see further what's there in the data set. Now comes the data cleaning part. Once we want to clean the data, null value can be cleaned from the first section here. In this line, I could have cleaned it, but it may take some seconds to clean the data. That's why I removed that line before I executed this. So if we are not cleaning the line, so we usually have some noise in some most of the data sets. So we have to clean null values so that we will get more accurate values. And if there are any duplicate values, then also we have to clean those duplicate values. That's what exactly we do in this line. First, in this line, we remove the null value. Then we remove the duplicate value. Then again, we drop the NA value. Then we will print out the length of the data frame. So let's try it out. Let me clean the data. Then let's see. Yes, after cleaning the data, we can see the difference. Previously, we have 4,94,021 rows. After cleaning the data, null value and NA value and duplicate value, we have now 1,45,586 rows, because the data sets which I am using right here is having duplicate values, null values, and NA values. So that will give me, if I do not cleanse those things, it will give me not very much accurate result later on when I want to further train my models with this data set. That is the reason why we have to clean the null values and duplicate values and NA values. Now let's analyze our DF. So we already analyzed here somehow. We already analyzed here, and we can see how many rows we have, what are the columns type we have, what are the features we have, and also many other things can be done here. So analyzing can be done in sort function. As we can see here, we can use analyze function, and then we just pass that data frame. And let's see, text only, yes. So as I told, after cleaning, I am running this program. We still have the same rows. As we can see here, we have 1,45,586 rows, and we have duration features, 2,495 entries, and protocol types. These many entries are there. We can see the whole analysis of the data sets which we have right here. Then after this, I want to work with a graph, because this type of data, when we are displaying data in this kind of format, it is not very easy to read. So I want to further work with graph. In that case, I will need matplot libraries and so on, so that I can display this whole data in a graph format. So let's do it. We will import pilot from the matplotlib library as a PLT. I give it a plot, so I can work with the figures. And after importing that, we are getting all the functions under this library zone again, matplotlib.pilot. We take everything from there. And as I already assigned the pilot as PLT, so PLT.figures, figure size, you can mention if you want a big figures, then you can change around these values. If you want small chart, then you can make it less. So it's up to us how big we want to be, how big the figures should be, can be assigned from here. And the class to distribution should comes from the outcomes. We have an outcomes here. After the analysis of the DF, I have an outcome here. So outcome will be my class distribution. Values count will be there, and class distribution plot will be bar type. Bar. You can use pie chart, bar chart, histogram, and so on. So I'll be using a bar chart type, and the axis will be labeled as class. The y label will be labeled as y-axis will be labeled as data point per class, and the title of my plot will be distribution of clean training data, and it will show as a grid, and we can run this program now. As I mentioned earlier, now we have a bar type, bar chart. Then the outcomes are given here. Here, normals, Neptune, right? Normal, Neptune, peg, teardrops, Saturn, and so on. So that comes in the class x-axis as a class. So that is how we display this whole analysis into simple graph. So it's quite simple. And next we have to clean some more further data in the class. So we can also classify this whole thing, this whole class, into two groups as a normal and attack class in this case, in this data set. So this is a multi-class right away. And if we want to work in simple machine learning technique, then we can simply classify this, categorize this into two category. Otherwise, we can go with multi-class so that we can have more precise result. Then once we clean, we can still run check whether there is any point data, the duplicate points in those class. And after that, we can print out the say, we can print the values along with the class. Here, number of data point in class normal, we have this many entries, and it is of 60.33% from the whole data set. So we can do that, print that number of data class. So it is not important. So I just highlight this point to verify along with this. So in that case, you can compare both the scenarios. Then we come to the encoding Z-Score. So I want to execute two more functions here. I want to encode the score in numerical form. So I define one function that is encode numerical Z-Score, and I pass 4 parameters, data frame parameters, name of the columns, and the mean to none, set mean to none, and SD to none. And that this is the formula I use to get the encoded numeric Z-score. And also we can define, we can encode the values other than numeric to text dummy. So for that, I put a function, I declare function here, then dummies with the file name. So we have only 2 parameters right here, Previously, we have 4 parameters, so we don't need to calculate any kind of statistical means or standard deviation or anything. So that's why we put only 2 parameters here. So let's execute this. So nothing, no output will be shown. Just we are just defining the functions here. Once we define the function, then we can decode each of those columns values to either numeric, Z-score, or text dummy, because duration is in numeric format. If I go back there, I can see that duration is in numerical format. And prototype, this is not non-numeric format. That's why we are using text dummy. As we can see here, protocol type is a text dummy, service also text dummy, and so on. So we have to work on this encoding by looking the previous examination of our data sets actually. So we can expand this and then we can see what's going on out there. And let me just encode it. And this encoding, sometimes if your data set is big enough, then it will take time. In this case, my data set, whatever I use here is not big enough. So it does not take much time to encode all the rows. And then here the outcomes are stored in the X column variable. Then the value counts is in the text values will be stored in the dummies variable, and the outcomes of the dummies column is stored in the outcomes variables once again. Then here comes the modeling part. So until here, we are just analyzing and reshuffling the data. Now we are going to create a model. So before creating this model, we have to be very clear with what type of data we are using and which one we want to analyze, which features we want to take and work with, and which features are not required. If some features are not required, then we can simply drop them, drop out of our data frame. And in my case, let me go back. In my case, here I have around 40. Okay, just 1 second. I have 42 features here. So if I need only 10 features from here, then I can drop whatever features I don't need to further input in my models. So that way, we need to analyze the data set first. Once we get the full details of the data sets, we can walk around, so we can even drop or not dropping any of the features, then feed into our model. So let's go into the model. As I already demonstrated in the slide, we have 3 hidden layers in the slide. So one layer was the first layer was the input, and in the hidden layers we have 3 hidden layers, and also another layer was there, that was the output layer. So here we obviously need to split our data into trained and test data set. So once we split that one, then we can either train the model first. After that, we can test whether the training is great or not. So for that, we will be using this library from sklearn model selection. We will be importing the train, test, split library, and we will also import the matrix library from sklearn, because we want to see whether the accuracy rate is needed to be displayed or not. If we don't need to display the accuracy rate, then we don't need this library at all. But in my case, with my model training, I want to see the accuracy rate. That's why I will be importing this matrix library as well. And since I am going to work with some NumPy, if we do not already assign there, then we can assign here. If you reassign here also, it's not a problem. It doesn't create any other it does not change anything. So also I need some sequential modeling in my model. That's why I import sequential library from TensorFlow.keras.model. So I will be assigning my model to sequential we can use any other modeling also that we can work out later on. And we need activation function, and we need to define the dense function in our model. So I import them from tensorflow.keras.layers. So from the layers, we can have dense and activation. And also, we don't need to train so much longer time. Suppose if the data set is very big, then we can always use this early stop. In case of the training is very much successful, it will stop early. Otherwise, the training time will take maybe even a whole night or maybe a full month also. So in that case, I usually use this early stop library so that I can my testing time will take lesser time. From we can import this early stop from tensorflow.keras.callbacks. Then, as I already said, train and test split library was used. So I want to split them, split the data, the x and y into xtrain and xtest, as well as also assigned to ytrain and ytest. So we assign the test size to 25%. If you want to use 30%, you can put here 0.30. If you want to put the test size as 10, then you can use 0.1 or 0.10. It's up to you. But usually we split the data into train and test size to 25% most of the time. And we assigned here the random state to 42, and we can walk around here. If your data set is big enough, then you can also assign a bigger amount. If your data set is not big enough, then the random state can be set to 10, 12, or somewhere there in below 50. That does not matter much. So it's up to you what random states you want to use there. So we go into the modeling. So we assign the model variable to sequential. We already import the sequential library here, and we add a model dense of 92. So the first hidden layer will have 92 several weights, and then in dimension we are taking the first except and activation function as a ReLU function. So we can use other activation function. We have several activation function like sigmoid, penH, softmax, alu, soft plus, and so on. But we will be using here a ReLU activation, and we have a 3 hidden layer, and the hidden size, whatever dense size you want to assign, you can assign here. And in this case, we assign it to 92, 46, 92, and also we are assigning one more layers with a kernel initializer to normal type, and the output layers will have an activation function of a softmax. Then we will be compiling the model, and the loss function will be categorical cross entropy, and optimizer we will be using Adam, and the learning rate is default. We are not changing any learning rate, or we do not optimize any learning rate out here. We will use the default. And also we want to see the accuracy rate. That's why we assign the matrix, which we import earlier, the library of matrix, import earlier here as to accuracy. We want to see the accuracy, and we want to monitor it so that if we can stop early, then we will stop early. We do not need any the whole training. So I assign the model fitting epoch parameters to 1000 here instead of training all the 1000 epochs. So if the training is going good, then we can even stop somewhere in 100 or maybe 50 epochs also. So this early stop will help us save times. So let's train the model. It's going on. It's take the first epoch. Out of 1000, we have 1 epoch. This will take sometimes, but it is not since my data set is not very big, so it will finish soon. In the first epoch, as we can see here, it takes 8 seconds, and the loss is 0.3509, and accuracy is 90%. Here we see in small point, this accuracy range between 0 and 1. So here we can say that it is 90.91% accuracy, and the loss is 0.1220, and validation accuracy is 97.06. And in the second epoch, the improvement is there. Accuracy goes up to 97.44, and validation accuracy is going up to 97.78. And it goes on, it keeps improving when we train the model. So here is the 9 epochs. In the 9 epochs, we already get 98.73% accuracy, and validation accuracy is 98.88%. So if we compare from the first epoch, on the 10 epoch also, we already see that it is so much improving already. So it goes on. I think this model training will stop somewhere around 15 or 20. So it won't take much time. As it goes on, we can see it is improving. Somewhere it is dropping. Here it is dropping. Somewhere it is going up. So somewhere here, the early pods will stop. So let's wait for a few moments. It will finish soon. And as we can also see that it takes mostly 8 seconds, 7 seconds for training each epoch. So in some case, if our data set is quite big enough, then for a single epoch also, it may take up to 20 hours. So if you are assigning very large epoch for your model, then it will really take some time. Otherwise, if you are assigning to 5 or 10 epochs, you may not get very accurate result as well. So as I said earlier, our epoch stop when it is 20 out of 1000. It does not go 21, 22, and so on up to 1000, because it's already defined that yes, this accuracy rate is dropping, coming, and then it is no point of going further. So it stops somewhere here. So it concludes that the accuracy rate is 99.18%, and validation accuracy score is 99.15%. So that's how we train the model. And this model is quite simple. This is only a simple deep neural network. And after training the model, we can have several score we can display here, because it is not very much easy to get from here. We cannot simply complete from here. So we have a function libraries here: accuracy score, confusion matrix, precision score, recall score, F1 score, ROC score. We can import them from sklearn matrix, and also we can pre-process if we want one more time. So predict models is there. So we are predicting the X test, and we are testing whether it is displaying, testing accuracy is given properly or not. So once let's run again, then I will explain these functions one by one again. This will take some seconds. It will not take much time. In the meantime, we want to evaluate the X test with a batch size of 32. And also we want to see the NumPy argument with X test and exists to 1. And we want to see the score and the recall score and the precision score and the F1 score. Yes, now it's finished to run. Then we can conclude that our validation score is 99.17%. This range between 0 and 1. So since we get there, I avoid this part. And evaluation score is okay, 99.17. That is quite good. Recall score 99.17. That's fine. Precision score to 98.69. Yes, that's fine. F1 score 98.89. ROC score, I think this is not very much fine, because the data sets which we are using is having very much disparate values. which is not very much good for this processing. So anyway, we'll move on. This is just a demonstration. We do not feed or we do not remove much features. So there are some features which we don't really need, but we do not remove such. That's why we are getting some wrong things here. That's anyway, we can move on. And I want to display in a plot whatever we get here. So from the training, I stored the model's outcome into a history. So from this history, I can take it out again, history variable. So from that history, the history is taken to history dictionary variable, and from the history dictionary variables, lost will be kept in the lost values, and history from the history dictionary loss validation loss will be kept in the val loss values variable, and accuracy will be kept in the accuracy variable, and validation accuracy will be kept in the val accuracy. So let me just run. We will not get any output here, and I want to plot whatever value we get from here into a graph. So we can use any kind of graph. So here we will have a good graph. Yes, this is the training accuracy, the blue color, and the orange yellow color is the validation accuracy. So here is a 98%. So it is more than 98%. It goes up. This is how we demonstrate the outcome. And we want to see the loss. Loss is also already assigned here. And here we are working with the accuracy and validation accuracy. So let me see the loss as well. Yes, here is our loss function. Training loss goes here with the blue line, and with this orange yellow line, we have a validation loss. So it is very much low. So this is very good result as well. Then we can see the high accuracy in the lower right with different type of picture other than this. If we want to display in other form, we can always walk around with this plot. So it does not matter whichever way you want to display, you can always display, and you can also change this type of colors. I hope that we will be working on some more demonstration, and I will show one more example. Okay, in this case, with the same data, after downloading not only 10%, full data set has been assigned from the local disk, and it is not required to download from the URL, and straight away we can load the CSV from the local disk. And once loading from the local disk, header assigning, everything is still the same here. And if you want to work with a Google Colab, this will not work. You have to either upload your data sets to your Google Drive and load from your Google Drive. So if you are working with Anaconda or Miniconda, you can straight away use this code. And I will share the link if anyone wants to get these files, I can share them. Then once we load the full data, the results what we get here is different. The numbers of rows are different, features are same, and also the output of the data set is different. And also when we clean the data, it will be almost the same. And let's go in the training part. Yes, the output is also different. Previous data set was KDD cup data 10%, and right now here, which we see on the screen, is KDD cup data without any filtering. It's a full data set. So if I train the model with that on DNN, I get above 99%. So in the previous case, we got 98 point something%, but if the data is data sets is large enough, then the accuracy rate is improving, the performance is improving. So this proof, it is the same program with the previous demonstration. It is totally same. Only difference was the data sets which we used, though it is KDD Cup data, the previous one was 10% extracted data sets, and here there is no such compression. So we do not compress the data. So we use the data as it is, the full data, and with the same program, we get different output in the training. The same, we also use the same models, the same model here, and we get different output. So this conclude that the bigger data we have with deep learning, the better results we get. So let me go back here. If anyone wants this file, kindly drop an email. I will be displaying my email soon. Okay, so I'll come to the conclusion because I think the time is also going too fast. Okay, artificial intelligence has reached the high peak, and news outlets reports that companies have replaced workers with IBM Watson, especially in healthcare. The IBM Watson has been used a lot in the field of finance, in the field of healthcare, in the field of military, and in social media, face verification, facial features, and friend checking, as I mentioned earlier, and in Twitter to identify the hate speech and terrorism, and also a fake account and the related cyber crimes were detected using the artificial intelligence program. And the new AI application pop up every day as in the customer device like Alexa, Google Assistant, and Siri, etc. We can see that artificial intelligence are used in our daily customer device as well. So it is very common nowadays. Like we can simply ask the Google Assistant to search some particular news, weather status, and we can also search songs, biography of a person, and so on. So instead of typing in the search engine manually, we can simply ask all these Alexa, Google Assistant, Siri to search for us. And when we use a machine learning algorithm, we can use several algorithms. It is not only that we will be sticking with one algorithm. There are lots of algorithms that we can choose based on the dimensionality, complexity, and depending on our data sets as well. So we can choose whether we will be training our data on a supervised algorithm or unsupervised algorithm to get the most performing outcome. Or we can also use some reinforcement algorithm in some case, but there, as we already mentioned, deep learning already outperforms many traditional machine learning algorithm. So we can work back and forth with deep learning and machine learning depending on the needs, the outcome we need. And neural network, as we already mentioned before, the futures of neural network are not just deep. So just deep is not enough, but they will be processed further, might process information in a progressive way in the near future as well. So it is already in progressive way, but it will be improved. It's in every day again, and with proper design of the network, both efficiency of learning and interpretation are improved significantly. So once nowadays we have a very big data available in many places like universities, or maybe from some business server, and maybe from social networking platform as well. So we can have very much better accuracy when working with the deep with neural networks. anyway. So if anyone wants the code or further deep learning work which we already had, so I can share with you. You can contact me on this email. Then I'll be very happy to share the code with you. If there are anything other than the code, if you want to ask also, I am very much happy to help. Thank you very much.
Balanlata, thank you so much.
Thank you, sir.
For your nice presentation and demonstration of various problems using Python.
Thank you, sir.
I think we have a few questions.
Okay, sir.
Q&A, do you see?
Yes, I can see now. Yes, sir.
You can respond to them one by one.
Okay, sir, one by one. The first question I can see here is Python good for neural network? How to create a simple neural network in Python? Okay, this is from Venkata Subramania Ganapati. Okay, so Python is very good. We cannot simply give that Java is the best language for machine learning or working with neural network. It is depending on the libraries. Python is having very much wide variety of libraries, as I mentioned in the slides also. So that was the reason that for me personally, I choose Python, and I also work with MATLAB and JavaScript to do this machine learning and deep learning techniques. So I found that Python is short with short code, and it actually perform better comparing to JavaScript and MATLAB in some case. MATLAB. So MATLAB in some case it perform better, but in most of my research experience, Python language is giving me very good results for when working with neural networks. And your second question on how to create a simple neural network in Python, I have demonstrated a very simple deep neural network that is coded with Python. And if you want that, I can share the code, the whole code with you. So I think I answered your question. And the second question is from Brinda Senthil Kumar. There are many output labels. Is it a multi-class classification problem? Okay, the answer to this is yes. It is a multi-class classification. So when working with binary class classification, we usually get very good result. But in the real world, whenever we deep down into big data, so it is not only to work with the binary class classification. So we need to sometimes, most of the time, we need to think about the multi-class classification so that to get several varieties of performance. And if one have to work only with, on a binary classification, though it is easy, we may get very good result, but it may not be very much applicable in real life. For example, if antivirus company is working only on one signature, say this is virus and this is not a signature of a virus, then it will be difficult to detect a new type of attacks, like ransomware will be there every day. Some other some other techniques comes out. So in that case, if we are not working in multi-class classification, I think in the real world, our model will not be very much fruitful in some case. So that is the answer. And the next question is, do we calculate Z-score to see the data distribution? No, not at all. Z-score is calculated to see to convert the values, assigned values into statistical problem. It is not necessary that each and every features the values which are in data sets to be converted in Z-score. And my example also, we converted into text dummy and one into Z-Score. So it's depend on how you frame the output. The way you frame the output, that way only you have to convert the data values to see that to work with that data sets. So that is the answer. And another question from Brenda Setil Kumar: how to decide the number of hidden layers? In this presented example, 92, 46, 92 neurons in 3 hidden layers. Why we have to reduce the number of neurons in the second hidden layer? Is there any standard formula to decide the number of neurons in the hidden layers? So this, the answer is, it's depend on the experiment. In some case, I even use very very big neurons, say 256, maybe 512, and it is not necessarily that when you use 3 hidden layers, the middle one is going to be half of the other 2 hidden layers. It is nothing like that. We can even go from 100 to 50 and to 25. We can even decrease. We can even go increasing order. That depends on how we model how we want to model the learning. So it depends on that. So it is not fixed on any numbers here. So we have to work around. In some case, when you work with small numbers of neurons in a hidden layer, you will get better result. And in some case, if your data is big enough, then you have to use larger neurons in each of the hidden layers. That also will boost the output. So that is the reason in my presented code, I use 92, 46, and 92 neurons in those 3 hidden layers. So it is not fixed. Even if I change the middle one to 92 again, so I have 92, 92, and 92 neurons in the 3 hidden layers. So the output is still the same. That's why for the performance, I just simply reduce the middle one. Still, I get the same result. So I keep as it is just for the demonstration purpose. That is my answer. And the next question from Linda Setil Kumar: the data set is an imbalanced data set. Can accuracy be a good metric to validate the model? This is very important question. My answer is, whatever data sets we choose, we must see whether it is balanced or very imbalanced data set. So if we work with very much imbalanced data set, we are bound to get very different, unacceptable results in most of the case. So if we work with balanced data set, the output accuracy is also perfect. It is always perfect. But in that case, in my example, I use a very much imbalanced data set that is accepted. So I accept it. And that is the reason that even if I use deep neural network, the accuracy rate stuck somewhere in 98% only. So if I use balanced data set, my validation and my testing also will be much better than the demonstration. And here is another question from Avik Mitra. For a neural network, is there any way to logically or mathematically determine how many layers and what number of neurons we need at each layer, or it is completely an empirical determination? So my answer is, if we are designing simple neural network, 3 or 4 hidden layer is more than enough. In that case, if you are working to get simple result, or if you don't want to make your model complex enough, then minimal hidden layer is more than enough. And the size of the neuron is depending on the numbers of features. Actually, suppose you have 100 features and you are assigning only 20 neurons, so you are going to get lots of bias in your layers or in your output as well. So it is always better to use large neuron whenever it is possible. And as I mentioned, it depends on the features. Suppose you have only 5 features and using hundreds of neurons is of no point in some case. So if you have only 5 features and you want to go for around, let's say 20 neurons, that is perfectly fine. And it is not required that you will be using hundreds of neurons in that case. So it depends on the features and the class you want to categorize. So if you are going to get a good accuracy, obviously higher neuron is recommended. And you can decide on that. You can work around and then you will get in a result. So whether to use higher neurons. So you have to experiment at least 2 or 3 times, changing the number of neurons on your code. So the next question is from Dr. G. Om Prakasam. Is the code execute ML? Okay, I think I did not get that exact question. I understand it as whether the code is executed as machine learning. Obviously, this is also a part of machine learning since the model is not very much complex, but I use a deep neural network, which is having 3 hidden layers at least. When we have 3 hidden layers or more, then it is considered as deep neural network. In most of the research experiment, I use 5 hidden layers for all of my papers. At least 5 are given, and I usually work with the optimizer. I used to optimize the learning rate and also use several optimizer like SGD, RMS Prom, and ADA Delta, and then underground ADA Max, and also we can use NADAM optimizer. So we can work around on that. So obviously that is also a machine learning as well as a deep learning. So that I would conclude that your question answer to be it is also ML, but it is deep learning code, actually deep learning. So that is my answer. Thank you very much. Okay, one more question is there, sir, from Raju Bodla. Which parameter is used to differentiate encrypted packets and compressed packet? Okay, so we can say that Python is very much rich in libraries, and there are several libraries which will differentiate this type of encrypted package and compressed packet. But when we acquire the data sets, the problem is in which format we acquire it. So if we acquire the data sets in the format of CSV or text, then obviously it is somehow it is already decrypted or maybe still encrypted. So when we want to feed the packets into variables or maybe into a model directly, that parameters, I think the differentiation between encrypted packets and compressed packets should be in the pre-processing. So in the pre-processing, that is the best place to do. So I think parameter wise, whatever you want to use, it can be created. I mean, you can define the function yourself using some available libraries. Otherwise, you have to write our own code. You have to write your own code to differentiate between the encrypted packets and the compressed packets. So I think I answered your question.
Okay, there are many questions, and that reflects the lecture was quite good, and the participants could understand and got benefited. I once again thank Valal Ruata for your excellent presentation.
Thank you very much, sir.
And I would like to inform the participants that a link will be shared for your feedback on this second session. So please provide your feedback.
And tomorrow the session will start at 10:30. So we look forward to seeing you again. So we'll start sharp 10:30. See you tomorrow. We can stop now.
In terms of communication and networking field, we will also see different machine learning techniques initially, and also how they've been used or how they will be more suitable in designing a next generation networks. Moreover, some research challenges of the next generation network, and how some existing approaches are there, including some of the approaches which we solve, and also we'll discuss some remaining issues and challenges. Finally, we'll conclude the talks by mentioning some of the future works. Okay, maybe it's better to start with a problem that currently we are facing in the existing network. So ultimately, I think, like as you have, all of us know about, like different technologies, like those we know about, like self-driving networks or everything like drones and all, automation, most importantly automation. We talk about smart home automation. We like there's the IoTs and all are there, like sensors, actuators, communications. So a network should also, in a smart way, it should be a self-configuring, self-managing, and self-optimizing one, which is a very difficult task, very challenging, but especially in case of networks. But that is what the current trend of networking shows, communication networking shows that the future network should be a self-configuring, self-managing, and self-optimizing one. So the problem here in the current network is that so we know that the size is growing, the complexity, like like we deploy multiple networks, communication networks together. We I mean, so many complexities are there in the network, communication network, when you talk about in the practical network scenarios. So also the security issues, one of the very important concerns. So along with this, the current network still separates many services from it, which actually we don't want. So we want everything should be service oriented. For example, it may be a network of video oriented network, your application oriented, your service oriented. What you require based on the net, it should be based on it. Like what the automation application generally it is automated based on the context, based on the intent. So that is how a network should be. And another challenge is that a vast majority of network parameters are manually configured. So so it's the reason is like there are so many vendors, there are so many approaches, organizations working different in their different ways to defining different network problems, solving network solutions. So the complexities in those network are also increases. So therefore, configurations is a big problem network, because majority of the parameters is manually configured. We use our network engineer, network administrator to manually configure those network to finally try to make it automation, but it doesn't work generally. So that's the reason configuration failure is still inevitable. Is there any questions? Like, I heard your voice. Okay.
Go ahead. I think it was by mistake, probably. From
okay. So I'll go ahead. Okay. So let's start with how the network size, how the network is growing. So if you see the diagram on the right side, so you can see the trend of number of devices in connected device. It means you can mostly internet connected devices. So So you can see till like it's already over 2021, 36 billions. Now, if you try to see just next of 3 to 4 years, like if you see the 2025 figure, like it is 75 billions. So if you compare with the number of peoples in the world, like human population, so by 2025 it will be 8.1 billions. So if you divide 75 with 8.1, it means almost 9 devices per person. So so that is obvious. So if you see now also, like we use our mobile devices, we have set of wearable devices connected to the internet, we have a laptop, we have a mobile phones, and especially if you look at the developing countries, they have so many devices, like in terms of keeping number of devices at home, number of devices at offices as well. So second important problem is like they use heterogeneous networks, protocols, technologies for communication. So it's not that all devices are connecting to a similar, same type of communication infrastructure. So it is also varies. So that is another big issues. So the existing pool of human expert is not big enough and will not grow fast enough to tackle this type of challenge, how to connect this heterogeneous communication with large scale size of networks. So there comes the issues like network planning, one of the biggest issues now, fault predictions. This is some of the example of the issues which are growing exponentially as well. Coexistence with previous generation of networks, because when you talk about 5G, we also need to think about 4G, 3G. That is another issues we have. So at a scale and every many more spectrum bands than ever. So people are trying license-free, license-based approach for communication channels and all. So those also create so many problems. These are some of the problems only. So if you think of a real practical scenario nowadays in communication and networking, there are so many issues which cannot be solved like traditionally human experts. One of the example can be network management. So we generally, traditionally, there are network administrator, network engineers. They try to configure those devices to make a network connect. Just to connect to the internet, maybe we also give so many efforts. So there are some more problem is like network devices and complex and distributed control software. So typically close and proprietary, and in terms like when you talk about end devices, like we have maybe some IoT devices or some maybe our mobile phones or desktops. So, and those end devices connect to the gateway from different vendors or running different softwares, typically of close property again. Routers also from different of different heterogeneous types or a switch as well. So it is not so a network administrator need to go to manually to those devices, access those devices using different configuration interfaces if it is available. So there also the problem, like so individual configuration through individual interfaces. Then configuration interface may also differ across vendor, like specification, protocol, and standard can be defined as well. Even the interface of different protocols, like belonging to a specific vendor. I see like so many, maybe Cisco devices, we see like so many interfaces are there to configure their device as well. So this type of challenges are there in the network management, which is currently facing. So it's a big issue, like in current network scenarios. So this scale, the way network deployed or network being used, communication network being used for connecting such number of devices. So there are vast majority of, again, like as I said, like majority of network parameters manually configured. So when I say network parameter is not only the configurable, so not only the available configurations we have, there the possibility is that like a network might be able to configure all the type, should be able to configure all the type of configuration who's decide the network functionalities. So what is the best option is like is the automation. So how to make this network is a automation, like so we think like this is what the new future networks will be like. So there will be the ultimate goal of future network is to move towards the full automation with fully autonomous networks that configures, optimize, run and heal themselves with no human interventions. So if you see the trend of some automation in networking by some existing mobile network operators, there is a trend we can see like 2018 to 2025. So we see it's a good thing that there after 2020 only, but it's slid, but it started on the automation thing. The blue line, blue bar here is for automation. Yeah, that is the fully automation, but there are like there we see some good figure of like 80 to 90% of automation, that the purple color bar one. So yeah, so just in 2020 it started. There's a good sign, and this is what we can see the next coming years of networking and solving the problems of networks. So what obviously we think that AI, artificial intelligence, is the best suitable solution, which can monitor the network, current network parameters and data, and make some suitable decisions for making the network automated. Before going to the different other approaches in making a network automations, want to see somehow like AI-based AI index report, like in terms of R&D sectors, what is the number of publications? If you see this trend were plotted by Stanford. Like, so if you see in the first graph, there is the number of AI publications in thousands. We see there is a growth after 2000. There is a significant growth almost. So after 2018, and in terms of region-wise, if you see, United States have been using very in a large manner, like for example, what I can see here as well in Dartmouth, like most of the research are like machine learning or AI oriented. So I think that shows like the importance of AI and ML in solving many problems like this could not be solved earlier. In case of networking as well, it's more important because network is very complex, and especially when it run by different vendors or different organizations, so it became more complex. So ML will be more helpful here. So let's see. Let's try to understand what is future network. How should be the future networks in more way? Like what are the different solutions it solving? Like so obviously when you think about the next generation networks, recently 5G and 5G, one of the mobile cellular network that has been discussed, and even many developing countries already they deploy the 5G in US also. In here also I see 5G is available. But at the same time, there is a research especially in research, we see the 6th generation mobile networks. So it's interesting because 6th generation networks, it considers like it's a different environment like of communication. For example, underwater network, it combining all type of networks in a same platform. For example, underwater network, terrestrial network, aerial networks, and space networks. So all are connected to the same network. So this is what this next generation type of next generation network it is, like all type of communication networks are connected to the same networks. And of course, like when you talk about 5G, 6G, the most important parameter that we think about is like data rate is very high. In 6G, it's more than Gbps. And also like latency. So mostly we measure with this parameter, data rate is very high, and latency is ultra low latency when we it measured like that. So here, like if you see, some of the main challenges will be like interoperability, how the networks from different areas can be connected to a single platforms, networks, devices, services, and environments are different for them. So controlling such networks, again, like it should be self-configurable. It should be like decision should be based on the aggregations, opportunistic setup, context awareness should be there. Communication systems should be reconfigurable as much as possible. Otherwise, it is not possible to apply the dynamic rules to the network for making it more automation. Some more techniques like software-defined radio, cognitive wireless networks, dynamic spectrum elections in terms of in a physical layer process will be used. This type of technology will be used. So as I said, an example, 6G mobile network expected to support applications like 3D communication, maybe like holographic teleportation, we know, like making a video conference like a real conference meeting, tactile internet, fully autonomous driving. So they require huge the size. So their requirement is like high data rate and extremely low latency. Another example may be V2X application, vehicular to everything. The popular application which has been recently aligned with 5G based communication networks. So it basically talks like we have a vehicle. That vehicle can be connected to another vehicle. That same vehicle will be connected to a person or a roadside unit or a network again, like for backbone connectivity. So it requires cooperative sensing and maneuvering, high density platonings, teleoperated driving, there have been some work I saw in IISc Bangalore where this type of work are going on. For example, they try to control a car from remote control. Remote control car driving type of. So it's required. The requirement will be like, especially in terms of ultra low latency and high reliability. So it should be below 10 milliseconds, high reliability near 100%. So there have been some technologies, some approaches like ultra low latency and high reliability solutions. So those are the requirements for this type of applications. So high data rate in order of Gbps communications. So, but when you talk about a next generation network, which is more automated, I think this type of network is still not talk about solving the complexities and making it automations based on the challenges as I mentioned above. So even if it is a 5G or 6G network, so those type of challenges is still there. So we can summarize like next generation networking should be a self-configured network, as I said. So it should configure itself automatically. It should be self-managed network management for controlling the routing of traffic or different type of operations like firewall management and all access control policies. So that those should be automated, and self-optimize. So this is one of the work which has been previously also been trying, mostly uses machine learning based a process to improve the network performance. When I said network performance, mostly we see like throughput, delays, jitter, and all. So in that case, in this case as well, the optimization should be a self-optimized network. So when I said self, it's like automation. It means there is a feedback line from the output to the input again. So in that case, again, but when so what we see in the existing solutions and techniques, we can divide mostly three type of approaches which are helpful for making network automations automated. One is the basic partialization and softwareization. So that enables network design and infrastructure to be abstracted in software implemented by underlining software across hardware platform and devices. So there have been effort of defining the network hardware resources in the software, partializing the physical network in softwares, which is very helpful in controlling and looking into the problems of networks from a central point of view. I mean, like from a centralized location. So controlling the network, viewing the problem, and solving issues. So that type of approach has been very suitable. Then, yeah, of course, another thing is like if we have the physical network more configurable, we have more capacity to make changes to the network, like as per the requirement. Second, of course, the massive artificial intelligence and machine learning. So that is like for performance monitoring, maintenance, healing, cyber attack detection. It's already been using, and now that will be used for in a fast way. So another approach that has been discussed is whether it should be centralized or distributed. So how the decision should be made, like it should be a centralized one or distributed one. I think like it's better like if we say it is a collaborative one. So as per the recent literature, so there have been so many approaches like where collaborative approaches have been used. For example, the brain of entire network is equivalent to the network master brain. So considering this in mind, so a router can be because recently there have been so many devices from Intel or other organization. They're making like a device AI embedded or capable of doing edge intelligence. So in that case, so network collaboration on those devices is finally making the master brain for. In case of especially routing, also it's a good solutions. Some important terms. One is, as I said, I think we have to mention it. One is the software-defined network. So recently it's been very popular. So it enables dynamic and programmatically efficient network configurations for controlling your networks. Then software-defined parameters is one of the approaches we try to hide the internet-connected infrastructure, like different resources, server resources, in fact, a device as well. IoT device as well. So it can hide for security purposes. So anything, if any third party wants to access those devices, it should go through the perimeter, like which is defined by software-defined SDP perimeters. So it's not a replacement to the existing solution, but it's an architecture that can be built upon existing solutions. For example, SDN can be a suitable solution for SDP. Another approach is the network function virtualizations, NFV, which is very important features of 5G and 6G communications. So it basically talks about decoupling the network functions from the hardware appliances and programming them in a software, like in a control software. So and then those are program to deliver equivalent network functionalities. So rather than network functionality programmed in the real the hardware, those functionality can be programmed through a network function, can be virtualized in a locations, and centrally can be control those hardware resources from the central controller. So and cloud, so as we know, it abstracts, combine and share virtual resources over a network. It's basically an environment, we can say. And virtual, along with cloud, we also need to mention about another technology that is called virtualization. So it is a technology that allows to create multiple simulated images. So for example, we host a cloud, we host a web service in a cloud, and that I mean, for a better example will be like how this Amazon AWS and all works. So they basically use the same cloud server hardware for and create virtual simulated environment, and they can allocate to multiple users for their use. So it is not basically the physical hardware we are using, but it is in one of the simulated environment which is created by AWS and then given to us. Two important factors. One is abstraction and flexibility are very important for network autonomous network support. So abstraction is basically like hardware is decoupled from the software, and most functionality is pushed to the software. So as I said already, so if we want to define the CT as the abstractions, then it's best. It is a function of current abstract view, that is AT, where AT is the global physical view, that is VT. Is a function of global physical view, that is VT. Another parameter is the flexibility, which talks about how how many parameters that can be dynamically changed so that it can adapt itself with the goal that we want for better performance. So it is the number of sense requests that can be supported within the time constant T is divided by the number of sense requests, which is like FT equal to senses in supported request within the time, and then total sense requests. So so it's a dynamic parameter because because network is like it's very dynamic, it senses at the time. So how many senses it can be supported within a time against the request. So the target would be like making it more flexible by keeping more parameters to be programmable. So in terms of networking, software-defined network has been a good in approach, which has been currently considered for next generation network networking. So I think it's better to understand a bit about it. So let's see some of the concept of software-defined network and how it is helpful in making a next generation networks. So SDN is a new approach of networking. It's not about architecture like what you talk about, like IP, TCP. Those are for especially to architect the network, but it's about the design of network. For example, routing, traffic engineering. So the concept is basically it separates the control from data plane. There is a control plane and data plane in there. So the device, generally the device we know having two planes. One is the data plane and control plane. So the idea is bringing all the control logic from the devices to a centralized location and keeping only the data plane, which is having only limited functionalities, maybe just for forwarding the traffic in the data plane. And also it provides an open API which can be helpful to access those data plane and make changes to the data plane as per the requirement of the network, what the network wants. Although I would say a very simple logic, simple idea here, like just simply separating these logics, but it enables a lot of like possibility of making more network more like flexible in terms of making it more autonomous. Maybe from this figure, it will be more clear about what is the SDN if you compare the traditional network. So basically, in traditionally, there were the devices individually. They used to have like control plane and data plane. To track the topology sensors, compute routes, install forwarding, individual device should do these operations. And control plane also responsible for like this running this is required to run distributed algorithms, establish state in there, so that they need to maintain state in the device as well. But in case of software-defined network, so as I said, like control plane are kept in a centralized, logically centralized controller. The problem there is it is very smart because it has the network overview. It can view the network issues and take the decisions from central point. But sometimes it may be slow because every time it need for a new type of flow, it need to communicate to the controller. And there are some API who's actually used by this controller to communicate with this dumb but fast data plane devices that can be a switch or router. Some applications can be like seamless mobility and migrations, as controller has the most of the parameter, most of the information about the devices, or about the data plane devices. So mobility and migration will be easier. Improve security in network through global visibility. Dynamic access control using multiple wireless access point can be connected to connected for taking like different decisions. For example, maybe monitoring the channel conditions, or maybe the handoff decisions, or maybe other solutions can be improved through this software-defined network process. Energy efficient networking, and as it knows about the network overview, it can control more on the network. It can monitor the uses or not uses in the network, and accordingly, energy can be efficiently can be utilized in the network. Adaptive traffic monitoring, similar as I said, like traffic can be adaptively monitored in as per the requirement. So that can be like, as I said, it has the global overview of the network. Some of the very important issues like denial of service attack or some other security attacks can be detected in real time. For example, in simple local area network, there can be like ARP. There are some issues like ARP spoofing issues, or those can be easily solved by software-defined network by simply directing those traffic to a, not directing some of the traffic which is creating like some floods or some chances of making those type of attacks. So as controller can, controller can make decisions based on whether to drop, whether to forward the packet. So it can efficiently control those communications, which creates problems like DDoS attacks, DOS or DDoS attacks. Network virtualizations also is a very good application in software-defined network. So that is been used to in many other process like network slicing or defining different type of network functions for making a network smarter. And also the server load balancing is one of the problems which is especially useful for data center network. Coming to the So protocols for software-defined network, there are OpenFlow and other southbound APIs. For example, if we talk about software-defined network with OpenFlow protocol, it's basically this is the data plane where the communication interface are done through OpenFlow channels. There can be multiple tables or basically this is the communication protocol. So it helps to abstract through match action policies in OpenFlow. So if you see the header of a OpenFlow, so if you see the table, OpenFlow table, which is supposed to be in the data plane devices, it basically has three fields. One is the match. So it can be different type of like source, destination, or port addresses for matching a particular traffic which is incoming to the data plane devices. And accordingly, actions can be taken like forward to the port, drop, or modify different type of actions we have. So also some additional important parameters which are more helpful in defined cases. For example, if you can keep the record of packet counts or byte counts, which may be further helpful for resolving security and other solutions. So additionally, one important important data plane programming language and one API I have to mention, that is called P4. So like, as I said, in this type of like OpenFlow based communication, generally the data plane is like fixed functions. So the table or whatever, those are fixed functions. Only a dedicated fixed set of configuration can be changed through this OpenFlow protocol. But P4 is a language which provide more flexibility in programming the data plane structure. I'm saying structure. So the programmer can write maybe a header or maybe a filter in for a data plane devices. So and that can be compiled in a compiler. So and that same compiler can also generate one generate an schema, like, so that basically can be used to create a P4 runtime API. So instead of OpenFlow API, P4 runtime API uses program as per the code which is programmed for these particular devices for a new logic. So in that case, that is been more flexible way to program the data plane devices. So how the problem again, like here, yeah, flexibility of course is one of the very important improvement in this type of software defined network, that now other than the fixed function programmability, you have the power to define your own programmable parameter for that type of device, and you can now control as far like what we want to be run on the data plane devices. But in this case, like different problems like runtime bugs, faults in the codes, which may cause serious network outages and security threats. So network verification is very crucial, especially in data plane devices. So having said data plane devices, the P4 is not only for data plane devices, it can be used for any type of device. It can be a programming a control plane as well. So that is the advantage of P4. So coming to the point is how ML in networking is helpful. So as we know, mostly the artificial intelligence, when we talk, we basically, it consists of machine learning algorithms as well as like some rule-based intelligence or some expert learning based intelligence as well. But our approach will be mostly on looking into the different machine learning process. So in networking, traffic-oriented have been widely used. For example, classifying the traffic, because like there are challenges of identifying the traffic when you talk about only port or the packet inspection based process. So there are a process like machine learning. A process can be helpful for identifying the traffic based on the host behaviors or considering different features of a flow. Routing, in routing as well, like in many traffic can be studied, traffic data can be analyzed to make better routing decisions. Centralized, decentralized functions can be designed. Also in different prediction approaches, prediction-based analysis can be done through machine learning as well. Congestion control is one of the problem, very important problem in networks. So there, different type of data can be like analyzed, like so packet loss, queue size, congestion window, or interference can be monitored and take better optimized decisions from using machine learning. Resource management, like admission control, resource allocations, are some of the areas where machine learning is being used. Fault management, predict, detect fault, anomaly detections, find root cause of the anomaly or fault can be in this case as well, like ML are used. Quality of service and quality of everything, like correlations, prediction of QAs, etc., are helpful for providing better QAs in different network applications. Network security, of course, intrusion detections is one of the popular approaches have been used in networking. In terms of analytics, there are different analytics models are developed for networking. For example, there can be descriptive type, which are responsible for improving network performance, maybe with a subscriber perspective or radio access network perspective as well. Mobility pattern can be monitored, traffic profile can be developed for better control on the network and use of network resources accordingly. Then diagnostic, as I said, like network anomalies can be, so this type of analytical module can be used for anomaly detection and finding the root cause. Network impairment, faulty and network element find faulty and network elements, faulty elements in the networks. So that type of diagnostic analytic modules are there. Predictive analytical module also helpful for like for improve decisions before like different problem happens, like some attacks happen or some congestion problem happens. So that type of analysis is helpful for damage or some sort of harm to the network. Okay, so then prescriptive analytics also have been done. Network expansion plan, for example, decision option or planning of slicing, like so, and then or virtualization or edge computing. Some of the network expansion plan can be done through the prescriptive type of analytics. And resource utilization plan also, like suggestion or corrective actions can be done through this type of prescriptive type of analytics. Coming to the machine learning techniques, I think all of I know about, like mainly we divide machine learning algorithms into three types. One is the supervised learning that basically talk about like labeled set of data. So this type of algorithm works on data which are labeled, and unsupervised learning is like so it's like the levels are hidden, like so without having the levels, so it try to find the pattern in the data set. So and then most importantly, like the clustering process, so it tries to cluster the similar type of data in a group while making the distance between cluster higher. Now, the important learning algorithm called reinforcement learning is very suitable in making intelligent decision in networking, because network basically is like data are very complex here, and and then mostly the data are not available. So in case when data are not available, this type of learning approach is very helpful, which basically works in a feedback error and trial process. So we'll discuss more about this type of learning algorithm in detail. So while talking about supervised learning, just to mention that so there are two types of supervised learning. One is classification and regression analysis. So there are different examples of that type of algorithm. You can see here, I think one was. So coming to that technique, so in terms of networks, so supervised learning can be used in some of the problem, like as already mentioned, the traffic classifications. So as I said, port-based and deep packet inspection-based process are not suitable for application dealing with like new traffic characteristics. For example, it can be an encrypted one or of unknown types, which is not defined in the controller or in the analyzer. So there can be some features like packet count, byte count, or duration features can be helpful for detecting an anomaly in there. So the anomaly type can be detected. So that is one of the anomaly type of traffic which are not also identifiable through traditional port or deep learning based approach. So a machine learning can identify those using considered like some of the advanced features. In case of unsupervised learning, some examples may be like customized slicing of different services with different QoS and resource requirement. So I think in slicing, it's very important to define some set of users clusters, some users having similar type of QoS and resource requirements in a group and allocating resource according to their requirement. Coming to the reinforcement learning technique, so it doesn't require any training data. So wrong decisions are not correctly corrected explicitly. Issue with other technique. So basically, the other technique, there is no mechanism to correct the wrong decisions. So that is why it's so here basically. So it's called like learn from the error. So reinforcement learning follows that approach. So agents learn by interacting with their environment. So and one of the example may be like future location can be predicted for proactive flow placement. So in software defined network, flow placement is a issues like, but if we know the future locations and which is very dynamic, and so accordingly a mobile user's anticipated role and interest role can be placed to the future location, I mean future devices which supports that mobile user should move. So we'll see some more example of this type of learning algorithms. Maybe for better understanding, we can think of, for example, in figure this one. So there is the agent and then there is the environment. So agent based on some actions on the environment. So environment responds with some feedback. That is one is the reward. So if action is based on the actions, if it is a so like based on the correctness of the actions, so there can be reward, loss, or gain, and also it suggests a new state to the agent. So this is how it talks. So I think this type of learning is very suitable when you talk about automation type of application, especially in case of the network that we are talking about, next generation networks. There are some examples. So I think some key important component of this type of learning we'll discuss later as well. So the learning which is mostly used here is called Q learning, quality learning. So here basically the approach is basically agent stores a perceived value for each action state pair, which then inform the policy of next actions. Based on this, there are more QNet learning approach called deep Q network, which is like based on the deep learning again. So it basically simply applies a neural network in the learning approach. So that is more powerful in making better decisions. Components which are basic components which can be helpful for solving RL problems are, there is an environment, as I mentioned, which is a physical world, which is where the agent operates. State is the current situation of the agent. A reward is the feedback, as I mentioned. And then policy is the method to map agent state to the action. So, and then value is the where the Q in the value where the Q learning and other learning approaches works. So it's the future reward that an agent would receive by taking an action in a particular state. While defining a RL problem, mostly so this is a like a sequence problem. So in that case, Markov decisions is one of the suitable way to define the RL environment. For example, moving from one state to another state. So that is mostly used, but not only a Markov decision problem. There are some other approaches are there which are defined for defining RL environment. Q learning for taking a suitable actions, as I said. So how useful a given actions. So that is what the target is like. So the future. So the target of Q learning is mostly to make the future actions a positive way, or positively. That is, the future action should be rewarded as a positive way, not the negative, not the loss. Actually, the main problem here is like exploration or and versus exploitation trade-off. It should be a versus. So it's like agents should collect more information to make best decision in future. So basically, so the problem is like so number of the making a better decisions always the agent needs more number of action to be taken, but it's better if more information if it takes initially and take a better decision in future. Some example of RL in networking can be in different field. For example, there can be most optimizing the performance of networks as it can continuously automatically evaluate the network status. So the required policy for dynamic network optimization can be executed on this. There can be appropriate parameter values for minimum transmission power. So transmission power can be minimized by appropriately finding the parameter values and optimizing the distribution of network resources such as transmission power and channels. So these are the problems which are currently faced by the existing wireless or mostly wireless communication networks, can be solved through reinforcement learning by monitoring through the feedback mechanisms. In case of management as well, adaptive network models with effective strategies like there can be environmental disturbances over the varieties of network areas. So accordingly, the network management can be also dynamically changed for different strategies. Design verification, as I mentioned, verification is one of the very important issues in network programming, especially when you talk about a complete network, programmable network. So when a remote device is programmed with a code, so that code, there can be bugs in the codes or logical errors in the code. So that type of verification in there also as well, we see like RL is very suitable. Then another approach, as I said, distributed and centralized approach of learning. So there is what we have to think in terms of a network. We see basically the architecture is like traditional, generally like there are edge devices, or there are which are distributed in different regions, and there are some central devices which may be a centralized controller or maybe a cloud. So in many cases where backhaul on a wireless network is very congested, or it's like backhaul network, if somehow it like there can be a disconnection in the backhaul network if it is a wireless. So we don't want to move the data over it. So in that case, the localize, keeping the data in the local or global is a trade-off, which is an open issue. So however, a collaborative approach for learning has advantages, of course. So there is another learning approach called federated learning, which allows collaborative training of a single global model by multiple local learners without accessing or transporting data anywhere. The advantages are like data security. So we are keeping training data set locally, so it was not exposed much to the external networks. Then diversity is another advantage. Like basically, when we have heterogeneous data in different location collected in different data sources, if required, those data can be specifically concerning that these are heterogeneous data can be accessed from the whenever required. So in case of data privacy as well, so there also like it's not a problem of local or global, but in many cases like keeping data locally, the privacy problem can be less because we are not exposing this data to the outside network. But it's all about like again trust issues. But when you talk about data set for external use, third-party use, and making different models, there comes the issues of data privacy. So in that case, maybe there are approaches like differential privacies, machine unlearning approaches. So it talks about like right to forget of data. Hardware efficiency is another important advantage of federated learning. No need for one complex central server to analyze the data. So as we are distributing the like data computation, so that requirement is not required anymore. The working principle of federated learning is very simple. Like it's basically you can look into the 4 steps. One, in the first step, it basically there are local data which is collected locally. Each local learner trains a local version of ML model on its local data. So whatever the data available to it, so it creates a model from the local data. In second case, only the local model parameters update are sent to the model parameters. Means the calculated maybe accuracy or weight, or there are different parameters which can be used to measure a model, machine learning model. So those are sent to the federated learning controller. So the controller performs the weighted average of the parameter updates, and it gets a new set of parameters for global model. So having a global model by the controller, so it again, the controller then send the new global model back to the each local learner. So again, so it can initialize to local model for the next round of training. So this is how the federated learning works. In case of use of network, federated learning in networking, as we see, like in a globalized IoT or other network application scenario, so there have been a approach of globalizing everything, like for mobility or for remote control. So in that case, federated learning solution will be used in a use way. For example, there are different upcoming talks, maybe in terms of distributed intelligence for next generation networks, orchestration and management. In as intelligence case, there as well, federated learning can be used to support efficient network management. Secure trust of the operation on management, for that is also one of the important factors need to be covered in next generation network. Mobile access, then routing, switching as well, architecting the next generation routing there as well, like collaborative, this type of collaborative learning will be suitable. Federated learning, then in case of circuit and packet switching as well, federated learning will be suitable. Having said about this federated learning and reinforcement learning, I think we should not forget about deep learning. So this is one of the strong learning techniques which have been used for solving different complex problems, including in communication networks, especially when the data are unstructured or and it's very complex in nature. So DL techniques are like very good when you do not need to worry about features in engineering, because feature engineering is one of the key challenges in machine learning. So the feature engineering problem can be solved through DL techniques. So DL, so it can work on big data sets, but in most of the problem, what is for DL is like solving the data problem itself. Like, so when you talk about finding the final output, so there, like traditional machine learning are preferable, but finding the better data and maybe a feature extraction or maybe data, working on the data. So there, like deep learning has been used. Like, so complex problem like image already been used, like image classification, natural language processing, specification and recognition has been used. In terms of next generation networking, there have been complex issues like unstructured data, natural language for automation. So this is one of the important things that need to be considered in a network automation. Like now, as we are removing a network administrator, a network engineer from the network, so it should be like from the context, or from the maybe someone just simply say that this is my requirement, that network should automatically program the network as per maintaining all type of like the requirement which actually required in a particular time. So and also IoT traffics are very complex in nature because it's heterogeneous. So in that case, deep learning, of course, it will be used in a huge way. There are many approaches. So basically the idea of deep learning is to keeping several hidden layers, multiple hidden layers between the input and output layers. So many approaches are being developed on deep learning techniques, especially like the classic neural network is the so-called artificial neural networks. So it's basically like inputs are processed only to the forward directions. Some other process like convolutional neural networks, it can be used for feature extraction, recurrent connection to the hidden states. So there are process, and those are used in many applications of mostly analyzing the data. One of the important approach is generative adversarial networks. This is very important, been recently used, especially as it can generate new data. So for example, there have been issues of having data like trustworthy data, or maybe privacy related data. So this type of learning can be helpful in that case to generate a new data of which can be reliable or trustworthy. Some more approach there. So in case of deep learning, there can be like again supervised and unsupervised learning. So this type of other approaches like autoencoders, backpropagation, these are some of the unsupervised deep learning. Gradient descent. So again, like deep reinforcement learning. So again, so it is like use of deep learning in place of Q learning. So like this is like reinforcement learning powered by deep learning. So again, deep learning for federated learning. So recently I see one paper where they talk about deep learning use in federated learning approach as well. So having this shows more advantages in learning a process. So not only this, like there are approaches like deep learning as well. So in case of autonomous networks, this type of learning, mostly the network autonomicity or autonomous vehicle network, like there we see deep reinforcement learning, and recently the deep federated learning based approaches have been used. Machine learning for automation, I talked about, but how generally the automation works, as I mentioned that. So basically, the network management operation on the network are managed through the data collected from the network and taking some important decisions what that can be where different techniques can be used. And then finally, the network configuration can be automated from here, and for better. So that basically, like we are removing the human work here. So the machine automatically can take decisions. The main components are data management. This collects, clean, filter, correlate, and relevant the data. Then data analysis part analyzes different depth level of data. So it's analyzes the data. So it tries to find the different network elements, user, location, time, etc. features especially. And in analytics, understand the network performance using machine learning, quality of everything, identify the network anomalies, optimization, etc. And finally, in the action, automate the network control operations. So one of the effort of this type of, when I talk about complete automated network, is this intent-based network. So, or also called intent-driven network. So it basically tries to, as initially I said that how to connect service to the network, like so how to remove the gap between service and network. So this is one of the approaches where they try to decouples the network control logics from like, so they try to integrate the logic, like what is the business requirement and how the network will be as per the business requirement. And it's basically a closed loop orchestration. So it works based on the feedback. So like as I said about the automation thing. So automate intent, application intent. So if there's an application, we will give some, which will send some intent to the system, and the system will translate the intent to network configurations, and then again there will be some validations on the feedback from the deployed network, and that step is called assurance. So this automation, this control loop technique goes on for such type of intent-based networking. So mostly some big vendors like Gartner, they also propose IBM. They are mostly based on translating intent to a network configurations, validating intent or implementation. So Intent translation can be like, in simple example, can be can be a voice to a network configuration. So so when you say like we have a meeting tomorrow at 10 p.m. So we have a meeting 10:30 p.m. a.m. So so the network should understand the requirement immediately that there should be a VoIP call at 10 p.m. tomorrow, and that VoIP requirement is like it should be 150 milliseconds. The minimum latency should be maximum latency should be 150 milliseconds. So such type of QoS criteria should be known to the network, and automatically that enables the communication more smooth or more suitable for the conference. Cisco also been trying mostly works on translation, activation, and assurance module. Even Hawaii also have been working identify the user intent, realize end-to-end automatic configurations. But when you talk about end-to-end intent-based networks, so they have been mostly working on separate module. So, but in case of considering final deployment and starting from the intent or context, so there have been so many integration and so many intelligence required, which is not yet been done. Some research challenges and future works, like network management wise, there are dynamic network configurations which need to be enabled for end-to-end automation, reliability, security, efficient, and autonomous solutions should be developed. Cooperative and distributed management solution can be some of the approaches which is suitable for this type of network management. Intelligence, of course, some orgs might be continued for like making self-configurable slices, self-optimization, self-healing of network functions. And there also future orgs need to be carried. Closed loop verification is another open issues. Interoperability, unified management and orchestral function, challenges from industry and standard, because they are doing their type of autonomous network individually. Even in terms of communication configuration interface protocols, also they are not unified. So fine and real-time access to the network information. So not only the data traffic sufficient for making a real-time access network information, but also some different other parameters also need to be considered. For example, pattern, behavioral locations, or power and SDN and ML for IoT have been some of the previous works we have done. So SDN has few advantages in IoT, especially making a flexible IoT gateway, designing security policies at the SDN controller, enforcing the network switches and IoT devices. I'm talking about the security policies, as it has network domain view, so it can take the better decisions. Flexible northbound APIs, which makes enable to develop secure applications. And ML can be useful for identify heterogeneous flows. So considering one of the important issues, like we need to identify flow for because there are large attack services in a network. We need to go software-defined network in IoT especially. We can look into the duration, packet length, packet interval, some of as a features of network traffic classes. Machine learning algorithm can be used to determine the pattern in the network data which is captured. So, but at the same time, this solution should be done in the real time, automated, and it should be done in a real time, like in automation network, next generation network solutions. One of the approach that we develop is intelligent flow identification. So it basically like it's a collaborative approach. We try to keep the classifier. So we train using a few classifier modules, mostly supervised learning process. And we try to keep the classifier module. So in SDN, basically one of the biggest issues is how to remove the control overhead. But when IoT data is heterogeneous, so there will be huge control overhead. I mean, communication between switch and controller. So this particular paper work was mostly to reduce the latency in communication from the edge to the end device, and as also reducing the control overhead. The approach is like so basically features and data are and so a classifier are requested from the SDN controller for a specific switch based on dedicated features and data, and only a dedicated classifier is deployed to the here. So when we have a classifier in the local node, the traffic filtering can be done locally. So the improvement are, so the proposed scheme is compared with some deep packet based and port based approaches, and it found that it reduces latency up to 34% on an overhead up to 23.4%. You can see here as well. So this is the network overhead. So we see the other approaches, there is increase in network overhead, but in proposed scheme that's very low. There is another approach, as I said, analytical modules are programmed to the edge node. So why not if you can make a programmable analytical module? So this particular approach is to take decisions for industrial automation and control by specifically programming different execution policies or analytical module in the edge node, which can significantly reduce the downtime. So in industry, downtime is very important factor because it depends on the productions output. There is another approach we develop is uses machine learning in two ways. One is predicting the criticality of a packet flow and then predicting the location of a user, mobile user. So based on the, for example, especially in healthcare case, some heart disease maybe someone has. So the criticality level, if you can predict, and the location, if you can predict, so there can be the flow placement can be improved by dynamically placing a required rule without further negotiating with the controller for a new rule. So that is more suitable for increasing latency as well as overhead and energy consumption, reducing energy consumption. We also develop RL-based MAC protocol for underwater acoustic network. So underwater network is mostly considered to be very highly unreliable due to high error probability, propagation delays, floating node mobility, low data rate. So in that case, the finding a suitable channel, when I say channel means in its channel there is a frame. So we consider a hybrid mechanism there as well to, but reinforcement learning, Q-learning is used to identify a particular channel and slot for a for transmission. So because the uncertainty, so reinforcement learning could help for finding a better frame for communications. So it improves the success transmission for a given frame. Yeah, so lastly, we also work in a reliable routing attack detection. As I mentioned, there is a the approach called generatory adversarial network. So that is the deep learning approach. So SVM is a supervised learning used mostly to classify, suitable to classify traffic. So even, for example, detecting a intrusion. But with a generalized adversary network, so we try to work on the data set initially so that the data the training process, the learning process can be made more reliable and trustworthy. So there are some approaches in basically in GN, it works like it uses two deep learning algorithm. One is called generator and another is called discriminator. So there is a also it also considers some other approaches like for feedback it uses backpropagation and also basically a max min approach to detect a data it training is properly done or not, ensures to properly done or not. So once it ensures that it is properly done, so then the SBM can be used to classify for different, in this particular row, we mostly consider the RPL routing and sort of attacks in RPL routing attacks like black hole detection or person number and hello flat type of attacks. Finally, so it is expected that the next generation networks, as I said, it should be autonomous. Having said like different applications like covering all type of platforms, global coverage, autonomous driving, AR, VR, smart healthcare are some of the next generation applications where autonomousity is very important. End-to-end automation is still need to be done where intent translation, dynamic network configurations, online feedback, closed loop verification are some of the different work need to be done. Intent to network code translation. So not only configurations, why not we can, I mean, completely change the network structures, like why not codes? So that can some of the works. Then collaborative deep reinforcement learning or combination of all or some of them are suitable for complex network scenarios. As an embedded intelligence, nowadays devices are having inbuilt and as intelligence capabilities or embedded capabilities, so it's more will be suitable for collaborative learning. There have been little effort have been devoted to understanding and characterizing a full and detailed analysis. So we basically try to get a real and some data set and do the experimentation for optimizing or some enhancement to the network. But I think it's better like in a wide box of approach if we do it. I think because network is very dynamic, so even it can varies in different location. Problem can be varies based on different parameters, a huge number of parameters. So in that case, it's better always consider a wide box approach to work on the data from the network. Through programmability in all planes, not only data planes, network intelligence could be implemented directly on programmable device with the network core. At the same time, sensory information and even emotional information may be collected and applied to AI. So in that case, privacy security is the biggest challenge now. So in that case, a process are there, but still many works need to be done for like right to forget effort. With this, I like to thanks everyone. Thanks for the fashion. If anything, please let me know, or yeah, I have my mail address here as well. I see some questions. Is there?
Dr. Nurjaman, thank you so much for this nice presentation. And it is really excellent, and it is as per the objective of this program also, to help out the beginners and young researchers in this field. All the slides I could see are, various aspects you touched, and then references were there wherever it is required. That is really helpful for the participants. And so let us go and take up the questions. Some of the questions are what you can see. The first question is from Avik Mitra. What is 3D communication? I think we respond to it.
Yeah, so 3D communication, like it's like holographic teleportation. Holography, if you know, like holo means like the the three-dimensional plotting of maybe a human being as well. Like so 3D communication will be like so instead of going physically to a meeting, it's like our version of one will go to the meeting, and like it's like a real communication, holographic teleportation it calls actually. I hope you understood. Like
Yes, yes. Then next one is from Venkata Subramanian. How beamforming helps in next generation communication networks?
Okay, so there are approaches like I think like I mentioned again here as well, like as intelligence. So I think it's defined further as or extreme as position. So intelligence at the edge is one of the important aspects should be considered in next generation network, including IoT. So of course, like fog or edge is like initially came for taking immediate or low latency decisions. So when you have an intelligent low latency decisions, that is more preferable. So in that way, and also along with federated learning approaches, those can be further helpful in case of next generation network. I hope.
Yeah. Next question is from again from Venkata Subramanian. Shall we use Onyx, Rootflow, Veriflow, OmniNet, these softwares for SDN?
So there are so many tools for experimentation on SDN. I basically prefer MiniNet because if you work on the MiniNet, I think like it can work in any type of hardware, like mostly available hardwares. Yeah, so it's not a problem of working with other platforms or tools. I basically prefer MiniNet, which is mostly used widely, having latest updates on it.
Again from Venkata Subramaniam, is P4 really device independent?
P4 is device independent. Only thing is it should be some specific architecture. For example, it should be a FPGA or ASIC type of architecture. And another important is so yeah. So when I talk about FPGA or architecture, and there is no other dependencies. So that is the only thing you should consider.
Then Babul Sarkar asks, in network collaboration, which tool is more effective, Slack or EMR?
It is, I am not aware about Slack, right? Is it Slack? I'm sorry, I'm not aware about Slack.
Okay.
Slack, right?
He has written Slack.
Okay.
So next question is, how does federal learning differ from classical disrupted learning in data center environments?
I know about federated learning. Maybe I have to explore the other type of learning he mentioned, because I'm not able to make the differentiation once I don't know that other one.
Oh. Avik Mitra asked, only thanking myself. Then another, I think the last question here is is real-time traffic classification possible in next generation networks?
Yeah, so that is what I mentioned, I think. So that is a challenging, but I think a process like reinforcement learning can be used in different ways. Like there can be some approaches. I see some approaches for identifying real-time classification, monitoring the previous patterns or some other features of those type of traffic. And I mean, there are so many parameters that can be helpful for identifying real-time traffics.
Okay, that was the last question. And I once again thank
you, Professor.
Yes, and yes, it is really, because it is a very odd time out there in your place, but still you agreed and took the pain to
I'm
prepare
delighted.
and
Thank you so much.
interact with the participant. And I'm sure it is very helpful for the participants, for the beginners.
Yeah, oh, yeah, thank you for that. I was wishing that. If required, I can share my slide as well if any participant.
Yeah, sure. That some are inquiring also. So we'll collect all the, with permission from the speakers, and then try to share to the participants.
Yeah, sure. Thank you so much.
Thank you, Dr. Mizoram, for your time.
Bye. Take
Time.
care.
Thank
Bye.
you. Thank you. I would like to we have a small announcement here for the participants. The next session today, that is usual timing is from 2:30 Indian time, but then for second session today, it will be from 15:30, that is 3:30, because of the time difference. The next session will be, the topic is deep learning based cyber attacks behavior analysis for cloud systems by Manohar Bhuya. Okay, so it's from Umeå University, Sweden. So I request all of you to join us back after lunch, but this will be at 3:30. Please note that. And next day also, that is Wednesday, 23rd. The timing will be different. I have circulated this program schedule once again in all the groups. Please note that. And accordingly, we'll start from 1:15 tomorrow. That is 13:15. Okay, and the 2 classes tomorrow will be continuous classes up to 5 p.m. Okay, with this, I think if Iftikhar can add anything. Iftikhar, are you there?
No, thank you so much. It was a very nice session, and it was handled very nicely by you. There were so many questions. All the questions are answered very nicely. Yes. So I hope it will be really helpful for the researchers in particular.
That's true, yes.
Yeah. Thank you.
Okay, thank you all. We can log out now, and see you soon at 3:30 today.
And the journey that I have. But with that, I think it's really great. Thanks both Professor Jamal and Iftikhar for inviting me. And even though that, as I mentioned before, like a bit of like time constraints, so it was a bit hard. But I said like it's really great opportunity to talk to like a lot of like larger community. Yeah. So with that, I think. I just like to start what I will be talking today. So basically like deep learning based cyber attacks behavior analysis for cloud systems. It's mostly I mean today's if you see in this world that the advancement of machine learning, and then people are like use quite a lot that the word deep. But of course, the machine learning is not grown by today, but it might be like quite long back. People have been working on it. But the theories behind this could be used for both cases or like both aspects, like how you in cybersecurity, and then especially for cloud systems. So. One way is that you make the attackers more smarter and more stronger. The other way is that how you defend them in better way to protect the larger scale systems. Because these days cloud is not exactly the cloud only the data centers, but it's like cloud has like the continuum of like multiple kind of like it's basically like closer to the users, like services, trying to provide the services closer to the users. So the other way you can say that the large scale or like distant data centers will have like fog, and then you come into the edge computing or like edge servers. Yeah, but so let's a bit of like go further. So yeah, so this is like a bit of outline. So where I'll be talking about a bit of background motivation. So a little bit I mentioned, and then this two works is basically like deep ensemble learning for detecting anomalies in IoT devices, and then one DCNN for detecting BSI DDoS attacks in IoT applications. And then we'll conclude with the open issues and challenges. But the reason, I mean, these two works actually have made or like done by one of my PhD students who works at Nara Institute of Science and Technology, and she recently graduated in February, and the both of this paper like published in very good venue. So probably I will giving very high level view of these two work, and then of course the fundamentals, like what exactly was it like, you know, in cloud systems that happens. And with that, and then again, like at the end, like we'll see like what are the challenges that still exist in these areas. So deep learning in physical world. So I think it's everywhere. If you go, like you can see kind of like, I would say like autonomous driving, and you have been hearing from quite a long. And then it's the healthcare, smart city, malware classifications, fraud detections, and biometric recognition. So, I mean, most of the places like these days, you have like, even though if you go to the news reading, then also like people are doing there like deep learning for things make automations, or like to where with like more perfections and more clears things to presence, rather than some make mistakes in during that. Yeah, so I would be I would be like happy to hear any kind of questions that you will be coming out in during this lecture. So if you like, you can stop me to at any point and to ask the questions, or otherwise we can take the questions towards the end of the lectures. So anyway, it's fine for me. Yeah, so then coming to the security and privacy, so very specific that there are several security incidents, I think now and then happens where like either hackers did like some sort of like creates specific problems, make down of specific servers for certain hours. For example, it was happening in 2018, I think. The GitHub server was down for about an hour, I think, or two. So it was like the problem of the now question is that what happened like if a server is down for a certain period of hours, and then it's a huge loss for the company that who is kind of like running particular services over in a cloud systems. So so for that, I think it's always good to have that kind of make always availability is the one of the things I think what we need. But the if you see the community that are developing in both ends, like the attackers and the defenders in parallel, and in that cases like whatever I mean, doing by one community, the another community is trying for defense, or like another community make more smarter way to enter into the systems. And that's, I think, in both cases that happens in security and privacy. So how often like your data, like for example, your cell phone data, like is tracking by someone, like how you stop doing that. For example, you are using that a lot of Google apps, like you feel that you are getting like help out of it. Of course, the Google is taking the data, your all data from your cell phone, or like kind of tracking you where you are. So which is like mostly personal data, and is it allowed? No, so that's not allowed to do that. But but they Google always ask that they do like a smarter way, that they always ask you that, would you like to provide this data, or like somewhere that kind of agreements would you accept? Like once you accept the agreements, that means you are giving everything. So no one read the agreement either. So just have a look, and then you say, okay, I need this app, and then it immediately said I accept it, and then finally you're done. That means you are accepting that, or sending, or like sharing the data with the Google. So there are a lot of like such incidents that happens, but one is that unknowingly, but some of them knowingly, but you must have to do, because without, there is no alternate way. And these are the kind of infrastructures where basically like is critical infrastructure, especially where the problems mainly occurs. Now coming to that, as I mentioned, that this is the problems that mostly I talked about Internet of Things. Now there are two ways. Like if you see here, there are several different kind of like this kind of attacks, or like different kind of things so far developed. Now what is basically happened, that the IoT devices that is developing in super faster way, and then like millions to billion devices very soon, and a lot of like already having like billion devices. But this problem is that the one is that the how to protect those devices that you are using either at home or like at office or in a larger context. And the other aspect is that the applications that the devices that used, like the applications primarily they deployed in the cloud, either at cloud edge servers, or in the like in the fog servers, or in cloud data centers. But the issues always, it happens in both cases, like how you make a solutions that integrates both, like that can provide solutions for device, that can provide solutions for applications at the same time. But which is like a bit of like tricky to make both together in like a kind of like solutions when you develop. Now coming to a bit of like what are system anomalies, or like basically, I mean, what I mean here, like cyber like attacks, or like considered as an anomalous, which we don't know what kind of attack it is. And in that cases, so typically what happened that it's very common that if you see there is some non-conforming observations in the systems. Now, what exactly happens? So that can be like deviating from normality or expectations. That could be like decided based on the threshold, rules, correlations. So there are a lot of things you can use for saying that they are like anomalous and they are not anomalous, and which is like can get from the runtime metric data or like log files. But is that enough for just using like manual tuning, or like manually fix some set of like boundaries between them, or not? Yeah. So if you see the nature of system anomalies, then it could be like symptomatic, like which is like typically precede like some sort of incidents after some time. And then the actionable, like what kind of actions that you can like, it could be like it says that there are security breaches, workload change, like service level agreement, like violations, or like it's reduce or degrades the quality of service, and or like bad experience of user, like quality of experience. So there are a lot of things can be done in that aspects, and in complex in the sense that it is very hard that to find out what is the root cause of it, like because cause is not same for everywhere, because its cause is always like different and in every aspects. So this is like just an example of like when you CPU, like because in kind of like in cloud systems, that is like you you borrow resources for a certain period of time, and then usually it says that the resources are kind of unlimited, but of course there is a limitations at the end, who is the kind of either as a infrastructure provider, or it's, if you see, it's somewhere the what the applications owner borrowed out from the infrastructure provider. Now, is the CPUs like normally had happened? They in different aspects. Like normally it used like very used for a certain period of time, and then it's a reduced very normal uses. But it's hard to say that where exactly the problem it is, and when it is started, and where to put the defense systems in for kind of integrated solutions. Now, if you see the detection pipeline, so I think it's Google use quite a lot of such systems like SRE, site reliability engineers, like who like basically like one call engineers, and where you have a dashboard, and then you have kind of a lot of thresholds that you can make, and then you can manual tuning, and then the problem will be solved for certain reasons. So one way is that what you will be monitoring from the infrastructures. So of course there are multiple layers. You have the infrastructures, you have virtualizations, and then you come into the services, what kind of services that you are running. Now, one case is that if you monitor, after monitoring, you have like detections mechanisms, and then you have kind of run the diagnosis. Now, question is that would you like to use some human in the loop, or it will make automatic decisions by the system itself? But that is like hard questions to say, because if you do like both have like trade-off in between. If you go for like this just use the automated decisions, then it could be like be a problems with the at certain point that it doesn't work actually. So what is supposed to work, because the system takes sometimes decisions which is based on the knowledge or informations that gained over time, but human knowledge is in different way that will affect the systems or impact the decisions from the experience point of view, from the knowledge, or like from the different like the situations where what kind of decisions need to be taken in that time. So the basically like resolutions, or like kind of solving the problems, that is a bit like tricky, because of one is that if you do some sort of like protection at the like resolution, or like at the initial level when you monitor, and then if you protect something, or like kind of make some sort of reducing the, for example, reducing the number of traffics that is running through it, and if suddenly it is increased, and then you just reduce it, that is quite easy to do that, but that will affect the services that you are providing from the systems. So there are other, I mean, one side, if you do something, and then the other side, there will be impacted a lot, but that is hard to say because in large systems. Now, the question is that what decisions you'll be taking should be vital. So it should be very clear and correct decisions, and otherwise it will be a kind of major issues that can arise in the whole systems, from infrastructure to services. So this is about, I think everyone knows this, NIST, like this is like cloud reference architectures. We have like cloud consumer, cloud provider, and cloud broker. So like around the security issues, like there are several places. It's not only one of them, but what I mentioned is that the availability, user experience, kind of like what kind of protocol that we're using. Is there anyone like legitimate users that is taking like availing the services for a certain point of time? Now, it's basically like because after all, an attacker can avail the services from the any cloud provider. So it could be like Amazon, it could be Microsoft, it could be Google. But that needs to be taken care by the security itself, that this is not a real users, or is basically a kind of, it could be a bot, or like could be a kind of malicious users. So that should be analyzed by the system itself at very early stage, before damaging the, or like, you know, creating the problems in the large infrastructures. Yeah, so this is kind of, I mean, it's more or less towards the IoT devices and applications. So why I say that it's in cloud systems, but this is, of course, that you must have a larger scale IoT devices. For example, for industries, they use a lot the IoT devices, and then for different operations or different tasks. But the problem is that how the applications is controlled over the kind of millions, or like thousands of devices together, and which is a bit trickier for handling. And then in that cases, like applications typically deploy in larger systems, you know, in cloud. And then the questions comes that the lot of security holes could be like resource constraints, there are a lot of resource. I mean, IoT device, of course, itself is a resource constrained device, but the how to make the device, or like, I mean, the low cost, insecure, heterogeneity, more like critical, or like insecure interface. There are a lot of security holes is still there, and that needs to be like kind of solved. So yeah, so there is a question, how the cloud computing can be applied in accounting. Yeah, I mean, it's I don't know, it seems a bit more generic questions. So accounting, in the sense that if you if you have an like applications that developed for, I don't know, it's for salary, or like for something like computers or tax calculations, for example. So that could be deployed in the cloud system. Now the question is that why I should deploy my applications to the cloud. And now that is like infrastructure owner is different, and then the application owner is different. And then in that case, it's like who will provide the actual like protections on it. Now that is a kind of the application owner, like why kind of moving your stuff to, because there are a lot of benefits. I mean, if you go like just the advantages, or like features of cloud, then probably you can see the huge benefits of, you know, when you move your applications to cloud infrastructures. So these days, I think people use mostly cloud natives, but this, I think, is the reason also that when you move your applications, then those benefits you need or you don't need. So if you don't need, then why you are moving your applications to the cloud? I hope that it's somehow a bit of, I answer your questions, but we'll take more if you have more clarifications or needed at the end. Yeah, so I mean, deep learning here, like, I mean, it's not new or for everyone. That's the community. There are huge, like, as I said, like the small part, it's basically like deep learning, and where of course, like advancement of different machine learning algorithms, especially like multi-layer perceptron, or like neural multiple neurons in different way you organized, and then you have like multiple architectures that you want. Yeah, so a role of RL. Okay, yeah, this is if I am correct, then it is reinforcement learning. Yeah, I mean, this is so there are like huge, I mean, these days, I mean, if you see a little bit of kind of like quite a bit of maybe 2-3 years back, that people doesn't use much more like reinforcement learning for multiple applications, but typically like it was used only for robotics, knowledge representation, or like some sort of like those kind of applications. It's not exactly in the real world like other applications. But these days, I think I would say that the reinforcement learning or deep reinforcement learning is used in real-time environment where like a lot of automation. I mean, if you have like probably you heard like this federated learning, so it's quite of like similar concepts, but it's here I think you have multiple agents. If you just consider multi-agents reinforcement learning, or like if you just a single agents you can consider. But in that cases, I think it's always makes sense to because it's learning by experience. So if you put a learn for like without learn, just then build an agent, software agents, I would say, because to better understanding, to learn from the data that you have, because you don't know, because that could be like online and then that could be offline. So if it is online, then you don't have much more knowledge about the data. So what will be coming over time, and then is over time it will be learn, the model will learn in different aspects. But if you just consider like offline, then you have like the broader pictures of the data that you have, and that the learning could be like, better way can be arranged. So that's why people says that this online learning is more tricky than offline learning. Yeah, but yeah, it's about that actually. I mean, in cloud systems, I would say it's a huge role, and or like even though if in IoT context, because if you wanted to like deploy detection systems where you need some sort of like automated actions that you need to take, like if you have multiple agents for multiple one application, multiple aspects, because these days applications are like multi-component. It's not like single component, because of why that is basically known as microservices. So where the applications has like individual components works for individual or like individual task. Now, if one component is down, then the other component is still active. So it still can like provide the services as usual. But which is not the case in case of, if you see the monolithic applications, not microservice one. Because if it is down, means down, like some server is down and this down. So nothing happened or nothing you can do in that moment. So it's always good to have that. Yeah, so I will come if you need more clarifications on this. So this is like back to the presentation. So here, if you see that, I think it's very normal pipeline where like AI driven or like ML deep learning driven cybersecurity. So you have to have best data, have representations learning, and because data is not like could be anything. So these days most data are like multimodal in the sense that, for example, if you have multimedia data, like for, I would say the reading a news, that is the video is one kind of data, audio is one other kind, there is the text that is coming out on the screen, that is another kind of data, and then you have some other like system representations. So all together, if you consider, those are like multimodal, because one is affecting or like connecting with or like has a correlations with others at the same time. Now, once you have like better representation, I think it's, I mean, basically the learning. So if you can do that, and then I think it's much more easier the rest of the steps. Or so that's why actually, I mean, in machine learning, people says that you spend 85% of time on the like data and preparing for model training, and rest 15% is the overall all of them. So because data is like purely vital here, but data is quite a lot, I would say. So it's a huge amount of data. But these days, what is happening that you don't know which data is important for you. You are recording everything. for example, if you have a train, like a smart train that you are building, like in Netherlands, so they are trying for building a smart train, but the question is that they are collecting the data, every bit of data into the storage or into the cloud storage, but they don't know which data would be useful. So my point is that here, that's what data that is really useful for your specific task, I think that is much more important than recording all of them. And because storing data is not free, so it's also like cost a lot. And in that case, yes, I think it's always makes sense the data that you have like that is like useful in some sense, that for either for providing some sort of decisions, or for like you better understand the data to convert it to a particular knowledge from that. Yeah, so this is like the kind of like basic pipeline. And yeah, so now coming to this work, and this is like one of the outcome, like Internet of Things journal Elsevier in 2021, I think. So it was published so it's last year. So what are the like problems here? So what we are trying to say here, this deep ensemble learning. So ensemble learning is basically like you just try to combine multiple weak learners to make or to build a model that is more stronger. And this is built for especially for IoT devices, not for specific for applications. Now the challenges is like complex dynamic, what I just like mentioned a few minutes back. It could be like anything can happen, and then the addressing these challenges like by using, so here I think it's typically like we are trying to use better representations of data. So you have like better future representations or better futures, then it is much more easier, as I mentioned, that for the model, actual models to learn it and then provide the better decisions at the end. So the here I think it's primarily used deep autoencoder, and then like we have used like probabilistic neural networks, and then the ensemble learning. So we integrate it like together, and then there is uses in the system level, that is software defined networking, to route the traffic in different way. And then we use the long-term, short-term memory. But here, what I would like to point out that this is like mostly the applications of deep learning. So it's not exactly, we have not developed a model that is specific to this task, but we also like do some other kind of task, or like where we purely develop learning models where could be like or learning model that makes more generalized for multiple tasks. So here actually the main contributions to where like we are trying mainly the detecting anomalies in IoT devices, and that could be like controlled through software defined networks. Somewhere to balance it in the devices like can survive longer. So, and then here I think another problem considered the data imbalance, I think, which is more common in any kind of security problems, because when imbalance in the sense that you can say that always you have more normal data or like legitimate data than abnormal. So abnormal data is rare, because if it's just opposite, and then I don't think that you need to have a smarter techniques to detect it, because it will be much more easier. And the deployment, and because it's also like the problem is that how you, I mean, after development of the model, like how you deploy it, where to deploy, how to deploy, and then is it like reliable when you deploy it? Like no one can, exploit the models. Now here they at the end, like as predictions, like how to forecast that, like a device is probably, you can take like preventive measures before interrupting a device. So if you have like a lot of, probably just consider like 10 devices, and then you are kind of some way easier to say that these are the devices is going to be problems, and then we'll have like before it's going down, have some sort of like preventive measures for them. And it's evaluated with different measures, like especially like MCC's Matthews correlation coefficient, which is basically for when you have like analyzing data imbalance issues. So here is the kind of like system architectures, where you have like the training data, we have learning model, detection models, and then you have kind of like managing like flow managements in an SDN, and then kind of you have, we generate a action or like kind of a status table, and this status table will be used later for predictions purpose. So a status table is that the every time point when a device is, what is the status of that, like is it good, or like is it bad, or is it attacked, or like is it something malicious that happens into the devices. Now so how we validate that is in learning model is basically like if you see in the left side of the screen, and then you have the test bed setup, so where we have like multiple IoT devices which is connected with the SDN switch, and then we have like kind of a edge router or like switch. So we use typically like edge routers that is connected with the internet, and we have like multiple physical servers, but here it shows like because of to control environment, so we use 2 servers, and then multiple like open kind of like open suites, where like we have made like virtual infrastructures with Zen hypervisors, and deployed multiple VMs, and then at the end we have like multiple IoT applications that control, either there's the control or the like kind of specific services that is like providing for like, for example, if you say that's for the IP camera, so that what you will do like IP camera with, or like smart plugs. So these are the kind of like devices that you use for kind of during the experiments, or like generating, especially the generating the data, the test bed. Yeah, sorry. Yeah, so there is another questions. Yeah, so it's very good questions. I think it's how to determine the hyperparameters. It's really kind of, I think it's a challenge that, so typically I would say that's an heuristic approach that for small systems it's quite easy, like by heuristic approach. So you like, you know, just try and then, you know, say what works better, so you just stop there. But for that you need to work a lot to identify the best hyperparameters for the models. Yeah, so here I think it's consider like multiple data sets or multiple data, like of course we consider like test bed and as well as like in benchmark data set. So in test bed I think it's considered in different way, in considering multiple generating actually multi-scale distributed denial of service, or like denial of service attacks, and then other side will check that the will have like a specific target of the device. I mean, either it's like physical level or it's virtual level or it's an application. So one targets of in each layer, and then the generates the like attackers. We like simulate the attack, emulate the attackers in similar way, and the other end. And we use benchmark data sets. I think it's pretty common. That's the and popular, like I would say, and BIoT data sets. So which has like the use to kind of like attack tools, Mirai and Basslight. But they have like quite large data sets produced like based on the requirements. You can select like single attacks or multiple attacks in from that. Yeah, so there are some more questions. Yeah. It's how to overcome the botnet and DDoS threats that have been observed on IoT networks in recent times. Yeah, so that is, I think it's the very good idea to go for blocking the, like, especially the botnet and this. So if you have a model that is a pre-trained model, I would say, pre-trained model with the different kind of botnets data that you have, like, I mean, if you have more and more varieties of botnet data, and then your model is pre-trained, and then you deploy it in real systems, then I think it's more or less you can, at least the existing bots can be easily detected, but cannot give guarantees of any new bots will be detected by using that. So it's I mean, detecting new attacks is always hard. So it's not like, you know, with this detecting new attacks is easy all the way. So here I think it's these two architectures for the deep autoencoder and stack autoencoders. So I think I don't want to like go in detail of like how many layers and then what kind of layers and what kind of works it is done. But this, as I think mentions that I borrowed these slides from my students. So perhaps like I'm not saying that you will explain, but it's the probably the time that will if I go in details. But the reason here mostly use the autoencoder is better representation of features. And until unless if you have, like, we use like one side the encoder, not the decoder parts. So we encode it and then we put into the learning models for kind of like basically the detection models, and what gives like better performance than usually if we see the without that. Now coming to like probabilistic neural networks, and this is basically a multi-layered feed-forward networks, and primarily have like 4 layers: input layer, and then the pattern layer, summation, and output layers. So input layers basically like the features, like the data points that you are going to classify. And then the what pattern layers do like is basically it says pattern is like hidden layers, and for each class like calculate the similarity between classes. So if you see that here that the I don't know my cursor is visible or not, but it's it belongs to like compute the similarity, and then it goes to like individual classes. And then at the end, like you will get perform the sum operations by summation layer, and then towards the end, like you have the kind of voting of specific classes, which class that is maximum. And this is the architecture, so where we have like diff encoder, and then you put like multiple PNNs, so not a single PNN, and with multiple layers. Now, question that may come, that this is like why the multiple PNN is used and why use multiple layers instead. So it's typically like it's more and more so the concept of deep learning is also like is very similar way that you need to have like more tuned information you need to extract from individual layers. And then if you go more and more depth, and then you have like more and more fine-tuned informations that can be used for classifications, and which is like typically like if you don't use that, then probably you'll reduce the number of information extractions that out of it. So here it is same. So use like trying more and more layers and then to have like the better and better results. But so there is a limitations that somewhere you have either model overfit. So if you do more extremely in terms of the what is not required, and the other aspect is that if you have pretty little layers, then kind of underfit the models. So there is a both way having kind of you need to have a balance that what you are expected out of it. Yeah, so coming to like flow management. So here actually we use if you see in the left side there is an kind of like the architectures and which is like reactive flow managements, and where like you have like so we use like POX controller, so which is a bit old now. So now if you see there are several of them, like Onion is one of them. So there are several of them like this that can be used in as a controller or to control it. And then here basically like use so the reason is to do that. So we will have like much of more rules and then actions and what kind of like counters that it's considered for especially for decisions making. Now either like devices that is sending malicious traffic, you just to stop that. That is the like statewide solutions. But the other way is also that if you don't know some sort of traffic that is malicious, then could be like marked as for like accumulate them for further analysis, and then see then later can have more actions on it. So here I think it's more makes sense to use the reinforcement learning. So because it's basically a loop, so you learn and then you take actions, learn and actions. So here about the data, so it's kind of imbalance. So this is like 1, 2, 5, and 9, which is basically an imbalance ratio. And then these are the number of instances. So if you see, so it's a kind of like differentiate between them. It's pretty much clear, but this is the case like where we have found maximum difference. But if you go down, and then probably sometimes it happens that this is close to the normal, and then it creates the problem, because then it's a modeling dilemma, that's which is what is normal and what is attacks at the end. And the characterization, so this is basically just the distribution plot, and where it's like normal or like legitimate, or and then the other side is the attack flows. Yeah, so and then coming to if you see this one of the parameters that is in PNN, like probabilistic neural networks, that is the sigma, so which is kind of like it depends like how it performs, like it's analyzed the dependencies, and also like we'll see if you go and increase the number of layers and how the performance will either it degrades or like either it's or it increase the performance. Yeah, so the performance variation of detection rate, like with respect to number of PNNs, that's like basically used in the 1% imbalance data set. So the imbalanceness is 1% is that if you are more and more lower the imbalance ratio, then I think it's there is a problem, or there is a risk to have model fail, because it's a very minimal number of instances are anomalous or like attacks, you could say. But in that cases, it's always better that, I mean, the model can perform very well if you have like very close to like in both classes is normal and anomalous classes, but which is not the case always. So as I said before, this is for like single attacks and where the like multiple devices and consider, and then these are the kind of number of instances and then the results out of it. Yeah, so where here the MCC scores, like as I mentioned before, that's this MCC is basically used for kind of like imbalance ratio, and then when the like if you increase the imbalance ratios, that how your model will survive. And here it is, I think for single attacks is quite good performance if you see towards the like especially when you consider this like SE ensemble, that is PNN, or like the DAE ensemble PNN. So basically like the deep autoencoder ensemble PNN works much more better in both cases. Now coming to the forecasting of devices, like flow management. So here used basically like is nothing changed in the LSTM model, and where just we try to take the status table and then we consider trying to predict where the problem starts. Now, if you see the difference in the left, the figure like 16 here, and on the left side, that's you have the legitimate traffic, and then you have the attacks, like in terms of like based on the status table, and then you can easily predict that from where the attacks is started. So similarly in outside, so this is like the second diagram. So here I think it's just an representation of throughputs, but it's the device status can be predicted over time, like that's what is actually when the attacks is started. So if you see in the diagram in the right side, and which is I think really important for the devices that's going to be problems very shortly, and then it is easy that have something can be taken care of before device going down. Yeah, so that's what about the deep ensemble learning for detecting anomalies in IoT devices. Now moving to 1D CNN, which is basically for detecting BSI DDoS attacks in IoT applications. Now here is basically considering very short intermittent distributed denial of service attacks. Now IoT application, as I mentioned, that it's typically deployed in cloud infrastructures or like large scale infrastructures, where the applications are either is for maybe like for controlling the weather, for example. So there is a device in a house, maybe like 100 house, and then having a device that control the weather, like weather in the sense that there is a sensor inside, and then sensor gives the data, and then based on that it decides that what temperature should maintain all the time. So the country like in Sweden, so it's really important that to maintain the weather inside, like I mean weather in the sense that I mean mainly I'm talking about temperature. So if you have like temperatures outside is very, very low, and then it should like need more heating inside the house, and then temperature is like outside is very hot, and then need more cooler, like the opposite side of that, like no need heating, but rather need like air conditions, run the air condition instead of heating. So if the application is deployed, such applications in the cloud or like in the edge server, then how you kind of give the protections, especially for against this very short intermittent DDoS attacks. So this works is like also published in last year, which is one of the conferences. Now here, if you like security challenges, like I think it's every year, like Kaspersky, like they reports like number of or like percentage of DDoS attacks that comes, you know, over the years or like over quarters, I think, and it's quite a lot every year, because the problem is that if you are having a detection systems that cannot, I mean, of course that can protect, because there are a lot of providers or a lot of providers, they give protections, especially for the different kind of attacks. But there are a lot of providers also, they give like, you know, the attacker services, like they use like those services used for attacks to other systems. So both end, as I said, like both end has a very strong, you know, capability to make that more kind of like parallelly grow situations that where it is whatever. I mean, no one can give guarantees by today that my system is fully secure. No one can give guarantees that. So can say that some extent it is secure because you have something, as I mentioned, that, I mean, all of us, we use like antivirus software, but do you think that your system is secure even if you have that antivirus software? No, I said totally no, you are not. Now, because it's quite easy when you are connected with the internet. Now, problem is that, and that was the reason, I think, if you see the defense infrastructures, they use different networks rather the same networks over what other people are using, because that is much more easier to exploit or like, you know, to use them or like to damage them or create problems on it. Sorry. So this BSI DDoS attacks, especially, it was introduced in, I think, by Sam et al. Like in 2-3 years back, or like maybe around 3 to 4 years back. But when the problem comes that, as I mentioned, that there are several mission critical applications. For example, if I say there is a robotic surgery and which is happening kind of, you know, overthrow an applications that robot will make a surgery. And then now in that cases, if something happen, which could be a very minor things happen, like in terms of like surviving the applications, but rather even it is very low problems, but the impact is quite high into this overall, what I would say, sorry, the specific task that you are like doing by deploying that applications. Now, what this attacks does, and it's try to mimic which is not different than low rate or slow rate attacks, but here mostly try to degrade the quality of service or like quality of experience of the users. Now, question is that how can it is possible to do it? And there are several ways, but here I think this the very little summaries of the contributions, but I'm skipping that. So here, if you see, there are like number of attack requests, or like this is kind of the period of attacks, and then this is like between the attacks. Now, question is that if the bots are not from the same source, and if it is on multiple times, multiple bot is activated. Now, question is that it will run for maybe some sort of like 10 milliseconds or maybe less than that, and then it is like stopped. so not doing anything. And now at the beginning, there is no problem, or it won't be any problem. So, but it goes for longer and longer, then it will have somewhere, there will be a problems that the problem will start, because that user will experience in different way. That's the user have like bad impressions, I would say. So in cloud, basically like how to hold your customers. So if your customer experience bad, then probably customers never be with you. So they try to move, because after all, they are paying for it. So if they are using for 10 minutes service, but yeah, they are paying for 10 minutes, or like the whatever, like it's cost actually. So users should be satisfied at the end of the day, like that is the main goal. But in reality, it is not like in that's like somewhere it's a problem at sometimes, that if users cannot achieve that, then the loss of the industries, or like the cloud industries, or like software industries, where the huge amount of loss that will happen, not in day one, but in maybe in a year, they count, and then there will be huge financial loss. And that is not good for any company, or like any kind of industries that who run this like such kind of applications. Now, if you see here, that's what we kind of like simulated or emulated in the testbed environments. Here we have like multiple bots that we used, and then we have like kind of like without attacks, and then also see the how does it works in certain sense, that we kind of like when you're deploying the multiple applications. Now here we used basically like deploy an IoT application at the edge server, and then we try to see that how it mimics the behavior of like legitimate users. So which is basically like the as I said, like it's very short, and but it is for very longer time, maybe year or maybe couple of months, that's doing that continuously. This is the like proposed kind of architecture. I think it's this is very popular, like 1D CNN, which is basically used for analyzing time series data for different kind of task. So here is also like the reason is that to use it like better future representations, and at the end you have like have a well, the good like performance, basically like how you can classify attacks and normal. So that is the main goal, and then you can reduce or like the problems of like quality of service. Yeah, so that is another questions. So it's BSI is basically like very short intermittent. So that is BSI, distributed denial of service. Yeah, so this is a convolution layer. So I believe that everyone like who actually works in deep learning, and I think it's very normal like architectures of, or like fundamental architecture, I would say, where you have like multiple kind of inputs, and then at the end what you are going to like select out of it at the end, out of these whole inputs. Now there is a like pooling, max pooling and average pooling. So here I think you just use like sigmoid functions, and then we have like future map, and at the end like you have select and the maximum values out of it, or there's a kind of max pooling. And basically like to find out like dominant feature set, so to in multiple way, that's or rotational like positional invariance, and which is like really important for model training. And it's very fast. I think that is one thing, is that 1D CNN works very well for such situations. because this the representation, if you see why I said for very good for time series. So time series is basically you have like one side you have time, and the another side you have like this kind of the events that happens. So which is like could be like if you see I don't know, the ECG signal, and also like kind of analyze by using 1D and it's quite easier way and quite faster way. So here I think it's two layers like fully connected and then softmax layer, which is like the part of like so how you assign the weights, and then at the end like what you get out of it. Now coming to the applications that what we have deployed. So it is what we tried like to deploy basically a track simulations, or like a track has like need fuel, track how speed is running, how many time driver sends, and then the how it is like affecting so into the kind of evaluating when the aids or like specific services from that. Now we have like set of legitimate users, and then and another side you have like the attackers at the same time, and then we'll provide like when availing the services, then how kind of interrupt the services over time in this like when the either like track is running or like track is stopped. And these applications, I think it's available, and we just did a benchmarking for our task, especially for detecting BSI DDoS detection. So here also like we use both like testbed and benchmark data. So as I said that it's difficult to finding the data. Like I mean, finding the data means in the sense that what exactly you are, what kind of tasks that you are, what kind of models that you are going to develop and then validate. So based on that, data should be like based on the problems, you must have the data very similar kind, or like data should carry similar characteristics or behavior. If it is not, then I think it will be doesn't make sense to have those data in like for testing or evaluation of your model. Yeah, so it's in like, as I mentioned, like the application servers, and like here, what is like used that create like kind of like different kind of queries to retrieve the real-time locations of like 1000 tracks when you create this data set, and then wow, and the execution time 100 like queries is around like 50 milliseconds. Now question is that if you every 2 seconds you send this created queries to the IT application server, and then you see the like what's command, that what is happening there at the end, and you have like very I'm not saying that it's a fine-tuned data, but you will get some large data that you can use for training 1D CNN models. Now here also like you used because of here, as I mentioned, like non-availability of benchmark for such tasks, especially when you consider IoT applications. But there are several data sets available for IoT devices, but not for applications. And this is like that's why actually we considered, I mean, as like benchmark, what you could say, the device data sets, which is not actually correct in a sense, because they are not applications data. But there are some instances that was like considered where they created in a way that can be used for models to validate, such models to validate. And primarily I could focus on testbed data that we have created, or like we have developed. This is mostly like the applications, how it is run, and then mimic the VSI DDoS characteristics in the data. in very similar way, that is data characterizations, where you have like kind of legitimate and the instances, attack instances variations. And this is like a bit of like hyperparameters, like how kind of like it's tuned the model like in optimal parameters, because it's difficult without, if you're not following the heuristic approach, then probably it is really difficult that where the model performs the best. And that is like that's why actually I think it's important that always have multiple variations. But here I can say one thing, that what kind of like experiments you do. So there is a like Gartner quadrant of experiments. So it's basically like, if you have like 1,000 experiments you need to do, and what you like to choose out of it to carry out. I think that is like once you have that the carrying out these experiments like a specific set, and then you can at least get like up to certain level of like performance. Yeah, so then at the end, like we like say, use the baseline models, like where you have like LSTM, support vector machine, and naive-Bayes classifier. And then we also like observe that this is like one decision and performs very, very well in especially in the kind of like benchmark data sets, and also like in testbed. So when it runs. Yeah, so coming towards the last or like towards the end. So here what I am trying to say, that is about like open issues and challenges. I think there are a lot of challenges still exist and open the problems. But what I'm sharing here in two parts. One part is more specific to models, and the another part is more specific to the systems. And in terms of models, I can say that it is always important to have like faster model adaptations, and like in diverse environment. Like you develop, say for example, like the model we developed, like the framework we developed, does it work for another environments? Like it could be thousands of devices, and then you have the different cloud settings and everything, but in reality it is not. And then that is, I think, is a still challenge to make like one model, and basically like you made more generalizations or more general overall, like when you develop such kind of models for specific or multiple tasks together. And the reduced time, cost, and increased safety of training process. Now, how can you protect when the model is training at online, then can you like make the training, reduce the training time? And then also like how about the cost? So where you are doing the training. So if you are doing the training without a GPU, or like you just in the local machines, then the cost will be less, could be. But if you are running a cloud infrastructure, then you need to pay for it. Now, in that case, it's like how the cost-effective solution, cost-effective training that you can make. Then increase the safety. So safety in the sense that can your training can be manipulated by either manipulating the data or in manipulating any kind of parameters that is really needed for training process. That is still open. I think there are a lot of people working on it. But then survival of models in adversarial environment. Now, the environment is like changing over time, like it's adversarial in the sense that there will be anything can happen at any time. In that scenarios, that your model survive with those problems, or maybe like you can consider in disaster situations this model will survive or not. And then the clean and useful data for model training. Now it is hard actually. Clean, useful, like, I mean, you have ample number of data. So what you are going to clean first, and then how to select which data is useful for your task. So that is like very, very tricky to do that. And once I think anyone can do that, I do think that rest part is quite simple and easy. And then fairness in decision making. So typically what happened, like, fairness in the sense like you have 5 classes of how to provide like fair decisions to all of the classes, and which is, I think, a bit tricky to maintain the fairness. So I mean, I'm talking about the model perspective fairness. And then come into the system perspectives, the challenges is test or verify models with multiple threat models, like threat models that you consider like the attackers like very stealthy, slow, and then in that cases what will happen? The dynamic, which is, I think, very common, that's the attacker's always dynamic. Then collateral damage, probably not damaging, suppose targeting an applications, but not exactly targeting that applications, but rather targeting in another applications because of impact. Like, for example, if I say we are running one mission critical application, another very normal applications. Now, one applications is targeted by the attackers, but that impact will happen the other one easily. So that is basically like collateral damage. Or it could be like, for example, in clouds, it's resource management. It happens that how you scheduling, how you kind of orchestrate, and then each task is interrelated or like interdependent with other tasks. Now, once you do one task and then is an attack like one task, then effect will be happening in the overall the other task as well in parallel. And then coming to defense overloading, like how to overload the defense. Like, of course, there is a defense system is there, but it is possible, like easily possible to overload them. And once you overload that, the CAN system survive still. And the last is that integrated method to protect like IoT devices and applications together. So typically not happen like the most of the method either develop for IoT devices or develop for applications, not people like combine them together. But there could be like several reasons why, because it's devices could be kind of, one is that the devices is thus the use, I mean, ample number of devices for there is no specific applications they use. Now, other reason is could be like there are huge number of like applications is typically like deployed because of its large, and then applications deployed in the cloud infrastructures, and then it is not reachable in that way that each and every devices. So there will be multiple reasons that's the why that is not happen. But then in that cases, like when you bring together device and applications, that because the task could be different, and then the protection at the same times is not easy. Because in device it's possible like you blocked a particular device, and then the applications what will happen in that devices is running or like availing in that time, and which is might be like vital for to be stopping the devices. Okay, so with that, I think I'm just like concluding. So it is kind of a bit like the summary. That's what I tried to say is brief overview of like deep learning, how especially like these two methods like deep ensemble learning and then 1D CNN, how it works, and then how especially like how we try to solve like two different kind of problems, or and then observe the different kind of challenges, open challenges at this moment that can be like solved in or like they can be like picked up to work on right way for providing solutions. So the multiple aspects either you can design like security by design, or like security like in developing, or like deploying, and then for especially for cloud systems. So it's not only for large data centers, but it's also for fog and edge servers, and including like the diverse of applications and multiple of them. Yeah, so these are some references, and so I'm just like taking 1 or 2 minutes about where I am actually. So here the groups. So I think it's now over like around 20 people, but there are like so if you see where the groups people ended up at the end. So there are very nice places, like, you know, the recent one was in Carnegie Mellon University. So you then like as a postdoc there for 2 years. So it's like quite good kind of environments here. So we have like quite a lot of people like as a senior researchers, and then like number of PhD students in the groups. So we have now like a lot of open positions. So we have 15 positions and fellowships within the lab. So 2 assistant professor, 9 postdoc, and 4 PhD students. Why I'm sharing this, I think it's better that you can have like a look at it into it, and then could be anyone is interested to have like or grab on positions here. Yeah, so with that, I would like to say thank you all, and for having your like patience to listen me, and yeah, so if you have any questions, so you have still some time, then I can take.
I think thank you so much, Dr. Manwar. I think there is one additional question is posted there. Can you see?
Okay. Yeah, now I can see. Yeah. Relations, yeah, ML, RL, IoT. Yeah, that's a good question. Yes. I mean, the 2 aspects that we can see here, that is, one aspect is basically I can say that make the attacks more smarter, and then the other side you just say that you make smarter defense at the same time. So I believe that both end it is important. So either you make the attacks smarter, or you the defense solutions, or like solutions that you make, you know, more smarter. So I think it's for this both tasks. So AI plays quite a like good role in several aspects, because smartness, you know, giving like automation. So now you can give like automations. For example, if you say I need like 1 million bots, and which is not, I think is possible, that if you use individual like AI kind of like agents that is learned for kind of a specific attack behavior, and then you just like put them like, for example, sending thousands of requests every like 1 million specific one-time intervals, then I think it's like makes that's for 1 year, but you don't need to track 1 year, and you know, once you make that. But if you don't have those, I mean, if I just go back to the classical machine learning context, then one thing is that was lacking, that we always we have been always doing that the future extractions, because we don't know which future is relevant for a particular class of attacks. Now I think that is automated by especially like better future representations by using like different deep learning models. So that is like kind of makes the task more easier, I would say. Yeah, I believe that I don't know, it's I answered your questions, but somehow I tried.
Yes. Once again, thank you so much, Dr. Manwar, for sparing your valuable time and giving an excellent speech. And the presentation was like, I can say it included diverse aspect of security from IoT and overall network security. And it is so important, because we are into this from on day-to-day basis. We are using all these devices and of course the transactions that we do on daily basis. So security is actually very relevant and very important. And thank you so much for a nice presentation. And Iftikhar, if you...
It's really great. I think great talk to all of you, even in virtually, but I'm hoping that in sometimes we'll be end up in the university.
Yeah, sure. Yeah, you're most welcome and invited to this beautiful state of Mizoram. It's pollution free and green. So yeah, do visit sometime.
Definitely.
We'll be happy to take you around. So,
yeah, sorry, last questions. I think I just saw one or two questions. So
some are there. Yes.
Yeah. So which parameter useful to differentiate malicious packets from other in real-time classifications? So it's, if I say only the packet, so the packet has like a lot of features. Now question is that which features you are considering. Now that's the reason actually you don't know, or I don't know that which feature is more relevant for particular class of attacks. And in that cases, it's always better to have this, better representation of features, and then you put the like represented features into the model for better classifications. So very specifically, I can't say the specific parameters, but rather, better future representations. And then the last question is, can you please describe a bit more about deep ensemble network? Yeah, so it's very similar to ensemble learning. So where if you have, like, if you say there are several weaker models, or maybe one weaker, one strong. Now problem is that when you combine them together, so the problem is that sometimes it happens that the performance is degrades quite a lot. Now in that case, it's like how you revive, or like how you get the excellent performance that you are expected from it. Now in that cases, you can do like one, as I said, that you add like multiple layers of either at the same set of or same set of number of layers neural networks, or it could be different set of number of layers in neural networks. So, but the question is that if you have more and more layers and then you combine, I mean, the main reason is that to extract the best informations out of it. Now, until and unless you are extracting the informations, I think it's really doesn't make sense that to stop maybe one layer, two layer, or like multiple layers. So it's always good to have that you combine them, like to get the best out of it. And then, you have like for every neural networks, like PNNs, I consider like probabilistic neural networks, like 5, if I say considers 5. So 5 of them, like they will investigate the same data, and then will check it, says that giving the voting or to find the best highest voting to get the best results out of it. But that's one way. So you have considered like same data. But the another way is that you can consider multiple different model as well. So not same model, but we use same model. So the reasons, like one, if you change the data, so if you you can change also the data, and you can like kind of samples I'm talking about. So if you have a multiple samples, and then model is properly trained, and then it is much more easier to detect the actually the task that you are built for, the model is built for. Yeah, so
I think a couple of more questions are there, if you can see.
Okay, so yeah, I can see. Let's check that. So
from Vaigasri, I think.
If any threads there is a network failure, and then how it will be solved. Now the cause of network failure, I mean, I don't know, it's full failure, or like you are just talking about this network failure in the sense that you don't have internet. that is not only the network failure. So so it is two ways we can consider. So here, the one is that the how you build the overall architecture. So I think I mentioned one challenge is that security by design. So once you have the like how your design is strong, so is there any weakness? Is there any flaws in your design? So if your design is like there is a flaws in the design or like holes in the design, then of course it is much more possibility to fail easily. But my question is here is that the to primarily investigate the how that device is connected with the network. I mean, in physical connections, one could be like physical failures. So another could be a kind of damage your kind of your networks or the overload the networks. So there are several reasons it could be, but that is like, I think, as I mentioned, the overall, you see the both aspects. One is that the you continuously monitor the systems where you deployed them, and then easily, I think I could recognize that what is what is typically happening in the kind of long run once you are continuously monitoring them. Yeah, but this is the one more questions that okay, do you have like proper control over the data in cloud systems? Yeah, I mean, it's control. I don't know what do you mean about the control over the data. So like data in the sense that in cloud, that's why I say that it's a huge data that you can collect, but what you need, you probably don't know for your task. So it's always the controlling in the sense that data, I mean, it could be like data leakage problem. So the data can be leaked or data can be like exploited by anyone. Yeah, your data is possible to do that. But I think it's the solutions for this, like one side is that as an application owner, there could be one type of solutions. Then another kind be like cloud provider, it could be another kind of solution that could be. So the controlling data, not, I would say not controlling the data, rather you get the data, better data to have better decisions on it. Because more or less we are, either you are going to make your system more smarter, or other side you are going to reduce or kind of like, you know, more make your defense system more smarter. So it's a kind of like trade-off, like what you are going to do actually at the end. So the another last questions, I think we'll just stop with.
Yes. Yes.
Can we say that in a deep learning is analogous to neural networks and which nodes being replaced by DL model? It doesn't mean that actually you should use neural networks. So you can use any classical machine learning models. For example, you use KNN, Bayesian learning, and then another one, random forest. So you can combine them and you can do that, build that, because it's primarily here is that how you voting mechanism is developed and how you or like not voting. So there are several mechanisms to combine. So what is expected out of it? So it is based on your problem. And if you are considering just the fundamental machine learning problems, then in case of like deep ensemble learning, now in that case, it's like how you combine the like deep layers. So so how many deep layers that you're using? Either like they are separate or like they are what your mentions like with every what I would say every round which model you will be replacing. So that is based on your problems, but it is not restricted to neural networks. So that I can say. So it could be used any kind of like models or like classical learning models. So which is kind of possible to build and deep ensemble. I mean, main reason is that more and more better information extractions, or kind of other way you can say representations, and that is useful for decision making. So that I try to say. So because this is here, it's a vital role when you're taking the decisions. Yeah.
Okay.
So yeah, after all, it's a security systems. So decision. Why I'm saying that decision is more vital, because it's you say that someone you allowed, someone you don't allow. So you say that in airports, the security is checking and then by machine. So you don't need to like someone says that yeah, you are allowed to go, but that means it's a huge kind of problems if something wrong with that guy. So the decision is always like vital for security systems, any security systems. I'm not talking about only compute kind of it's specific to this problem, but any security systems. Yeah. So with that, I think I like conclude that was the last questions. And again, thank you very much to all of you, and quite nice questions. I'm like kind of really happy. I don't know I answered all of them or not, but I tried in my way.
Dr. Manohar, once again, thank you so much. The number of questions, reflects the impact of your lecture. I think there may be many more questions, and the participants can reach by email to him also. And with the permission of the speaker, we may share the slides. And anyway, these lectures are recorded and it will be in our university YouTube channel, so anyone can visit. And thank you, Dr. Manohar, and look forward to future collaboration. And see you soon when you visit India, Assam.
Sure.
Okay, Iftikhar.
Thank you very much.
Yeah, welcome. Iftikhar.
Yeah, thank you, Dr. Manohar, for this nice speech. And it was a nice presentation. In fact, it was a very nice amalgamation of security issues with machine learning. So I also learned a lot, and I'm sure the participants must have been benefited from this. So thank you. Keep on joining us with some more collaborations. It will be really helpful. Thank you so much.
Yeah, great. Thank you very much, all of you.
Thank you. And for the participant, I want to reiterate that tomorrow the lecture will start from 1:15 in the afternoon. Because of some unavoidable circumstances, we have to do like that. And there will be the two lectures will be consecutive from 1:15 to 2:30 and 2:30 to 5. Okay, so all of us be there with us tomorrow. Thank you so much. Thank you, everyone. We can leave now. Good. So, dear participants, ladies and gentlemen, we have a distinguished resource person today. Let me introduce. I have the privilege to introduce Dr. Nazrul Haq. He has been working as an assistant professor in Manipur University. He has also worked as an assistant professor in Kaziranga University, Tezpur University, and Rongya College. His research interests include network security, machine learning, and IoT. He has done his MTech and PhD from Tezpur University. He has published several journal papers and conference papers with more than 1,000 citations. He is also a reviewer of several reputed international journals. Today, he is going to speak Today, his topic is network traffic analysis using machine learning. So with these words, I welcome Dr. Nazrul and request him to deliver his speech. Dr. Nazrul.
Thank you so much, Dr. Jamal sir. I'm very much thankful to you for giving me this opportunity to deliver a talk here in this faculty development program organized by the Mizoram University. Today, without any more delay, I'm just going to start my presentation. As sir has already mentioned, that I will be talking on a very important topic, that is network traffic analysis using machine learning. So let me share my screen first. Okay, my share is visible to all of you, dear participants.
Yes, please go ahead.
Okay.
You can enlarge this.
Yeah.
Yes, fine. Yeah.
So very good afternoon, my dear participants. So today I am going to deliver a lecture on the topic network traffic analysis using machine learning. So this is not only the theoretical presentation. I will try to show you how can you analyze network traffic using some tools, or I will show you my hands-on experience to analyze network traffic using machine learning. But before directly starting the hands-on, I would like to give you an overview, theoretical overview about what is network traffic, or how can you get the network traffic, or how can you generate the network traffic, and after generating the network traffic, how you can apply the machine learning. So that is the overview of my today's presentation. This is a very simple topic, but nowadays people are using very sophisticated network. Sophisticated network in the sense people use Internet of Things networks, people are using software-defined networking, people are using cloud networking. In addition, that means apart from that traditional TCP/IP network. Okay, so my presentation will be related. It's based on the traditional TCP/IP network that we are using from last 30-40 years, and that type of network I am considering. But the same concept you can use for Internet of Things networks or software-defined network or whatever may be. Basically, when we say a network, and that is a collection of some component in entities, and from those entities you will get the traffic. The traffic may be from normal traditional network, or it may be from IoT network, or it may be from cloud network, or whatever may be. But basically, that is a collection of some network traffic. So once you get the network traffic, then you can analyze the network traffic by using machine learning, because the machine learning is very useful nowadays. Or subfields of machine learning you can also use, like deep learning. But people are using some other techniques also, like statistical learning. Okay, so some statistical methods also you can apply for analyzing network traffic. All right. So the main outline of today's presentation is that first you should know how to get network traffic, or how can you generate network traffic. That is most important. Okay, so I'll try to give you an overview, basic overview about generating the network traffic in your own network. Okay, then once you get the network, that will be raw data. Okay, and you are going to apply machine learning or deep learning for analyzing network traffic. But the thing is that, so if you have developed one machine learning model, in that machine learning model, you have to use some structured form of data. But raw network traffic that you have generated from your own network or from your own network testbed, that data may be unstructured in nature. So if the data is unstructured in nature, then machine learning model will not get the correct information from the data. That's why there will be some pre-processing step will be required. And one such pre-processing step is called feature extraction from network traffic. So you can extract some informative features from network traffic. All right. So after extracting some informative features from the network traffic, your next step will be the same pre-processing step, you can say, the feature selection. Okay, both feature selection and feature extraction, you can say as a pre-processing step before providing the whole network traffic to the machine learning model. Okay, so after extraction, you have to select the features. So I'll explain what is feature extraction and what is feature selection, and what type of tools you can use for feature extraction as well as feature selection. Okay, there are some freely available tools by which you can extract features or you can select features. All right. After performing the pre-processing steps, then you will get some structured data from the raw network traffic. So original traffic was raw. You have performed some pre-processing steps, and after pre-processing, what you have done, you will get the structured form of data. And once you get the structured form of data, then on that structured data, that basically very frequently we call it as a data set. On that structured data set, you can apply any machine learning technique or deep learning techniques or any learning model. And you can classify or whatever you like, you can do. And once you apply some machine learning model, or you have developed some machine learning model, then you can validate whether your machine learning model is good or bad. There are some validation measures also by which you can say whether your result is good or not, whether your classification or analysis is acceptable or not. And finally, I'll give you some research issues. So now I'm coming to how can we get network data. Let me just a minute. Okay. How can you get the network data? First thing. So to get the network data, there are three approaches. One approach is generate your own data. That means suppose you are working in a network laboratory, your own institute have some network laboratory. From that laboratory, you can generate your own data. That means to get your own data, first requirement is that you should have a laboratory test bed. So that test bed may be very simple, but connecting some desktop or laptop or some server, okay, that way you have configured one laboratory test bed, and in that test bed you are using some scripts to generate traffic. Very simply, I'm telling you are using some scripts or tools by which you can generate that means you can pass different traffic flows in the network, and once you have simulate those tools, then due to that simulation you will get some data, and that data you can capture and you can store. So that way you are generating your own data. I will show you one test bed, very simple test bed, and how you can generate your own data I will explain very clearly. So next approach is access from public repository. That means there are so many publicly available repositories, and from those repositories you can freely access some network traffic data. Okay, so some publicly available repositories are Kaggle, already you have heard about it. Then UCI machine learning repository or UNSW repository or Stanford large network data collection repository. This is the second approach. Okay, from these repositories you can freely download the data. And third approach is that somehow you came to know that this organization has their own data or this laboratory has their own data, but those data are not publicly available. You cannot get those data freely. So what you can do, you can send a request by mail, okay, to the concerned laboratory or the concerned person, and you can request them to share the data. If the person wins, then he or she can send you the link to download their own data for experiment, educational purpose or experimental purpose. So these are the 3 ways by which you can get the data. So I'm giving you some freely available network traffic data sets that you can use for experiment. Suppose if somebody is interested to analyze network traffic by using machine learning or deep learning, they can use this type of data sets. These are the publicly available data sets like CAIDA 2007, DARPA 98, 99, 2000, then KDD CUP 99, UNSW NB15, BOT IoT data set, and BA IoT data set, CIC IDS 2017, 18, 19 data sets, and TU IDS data sets. So these data sets you can use for your experimental purpose. Now, as I have mentioned, how to generate your own data set. So already I mentioned that if you want to generate your own data set, then there should be a test bed. So here in this slide, I'm showing you a very basic test bed, network test bed. This is very fundamental. Nothing is there, only one switch and 2 machines, computers connected to the internet, and that way I'm showing. But this network test bed may be very large or it may be very complex also, no issue. That means for your simple understanding, what I am doing here, suppose these are the 2 machines, PC1 and PC2. These 2 PCs are connected to one switch, and that switch is connected to the internet. Okay. And now what you can do, out of these 2 PCs, you can configure one PC, suppose the PC1 as your server, and suppose PC2 is one client. Okay, or you may have some PC3, PC4, PC5. So all those other PCs except PC1 are working as a client. And suppose all these things are connected in the same network or in one local area network, and for your experimental purpose only, you keep all these machines in one LAN, and then give the access of your server to others, other clients, and clients are accessing those that particular server. Now, suppose initially, since all these machines are connected in a local area network, so whatever communication is going among these machines connected in the same network, local area network, so the switch will know only through the switch you are supposed communicating. And when any traffic, any packet is transmitting from one machine to another machine via that switch, then in this switch you can capture your traffic. From this switch you can capture your traffic. All right. So your traffic may be of 2 types. One may be normal network traffic and another is attack traffic. So this is most important point. So how can you generate normal network traffic and how can you generate attack traffic? So attack traffic is okay. I have used some attacking tool, or I have installed some attack scripts, attack tool in my client machine, and that client is trying to launch an attack to the server, and whatever traffic it is communicating, those traffic you can say as an attack traffic. But how can you define the normal? That is a very important point to understand. How can you define something as normal? Because suppose normal means no malicious or that means no unusual activities should be there. Okay, so that means that traffic is attack free. But how can we ensure that that traffic is attack free? This point is very important to understand. Okay, so to ensure something that traffic is attack free, first you have to configure your network in such a way that your all PCs are not working as an attacker. Okay, there is no any attack event or attack activities is there. First you have to ensure that. And second important point is that your network, suppose this switch or router should not be connected to the outside world, or it should not be connected to the internet. So if it is connected to the internet, then definitely the outside world can communicate to your network, and outside world, that some traffic from the outside world can come to your network, and that traffic may have some malicious events, malicious activities may be there in those traffics. So first you have to ensure that your network is not connected, your own network, your test bed is not connected to the internet. And whatever, without connecting to the outside world, you try to generate some traffic without any malicious activities present in your own network, and that traffic you can mark as a normal network traffic. But you have to ensure that all PCs are performing normal activities. No malicious activities are being performed. Okay, so suppose your network is not connected to the outside world, and you are only communicating in your local traffic, local area network, or in your own network, then suppose that communication is performed for 1 day, and that 1 day traffic you can capture, and that traffic you can label as normal. Okay, so label as normal means you assume that your traffic is attack free. So next is that you are going to generate some attack traffic. So how can you generate attack traffic? Suppose your PC1 is marked as a server. You have configured that PC1 as a server, and PC2, PC3, PC4, PCN, n numbers of PCs you are using as a client. Now, the PC2, in PC2, you install manually you can install one attacking tool. There are lots of attacking tools. I'll give you a list of attacking tools, but don't use those attacking tools to launch an attack in some public servers. That is not ethical. Okay, that is a crime, cyber crime, you can say. So don't be part of any cyber crime. Intentionally, you should not launch any attack on public server, because there are so many public servers. We are getting services from many public servers in our everyday life. But intentionally, if you launch an attack on some public server so that the server becomes unable to provide services to the legitimate users like us, then somehow if you are identified that your PC is launching that particular attack, then cybercrime will be imposed on you. So you should be very careful. That's why I'm telling everything should be performed only on your own network, and that network should not harm your. That means your attack traffic should not harm to others. For your experimental purpose, locally in your own test bed you are doing everything, that's fine, no issue. Okay, right? So you can test. That means you can test whether attack is launching or not in your network. Those things you can do, no problem. But publicly or in public server, you should not launch the attack. Now, manually, if you install some attack tools in this PC2, PC3, PC4, they can access the server, and when they access the server, instead of some legitimate traffic, they are executing the attack tool, and as a result, so many attack traffic is passed to the server. And if the number of client is very high, then in a very short period of time, the server will get a huge amount of attack traffic sent by PC2, PC3, PC4 like that. And as a result, the resources of the server will be exhausted, and it will die. Basically, it will die. Die means it will not be able to provide services to the other users, other clients. So that type of traffic you can mark as an attack traffic. All right. And or there may be some in between, there may be some normal network traffic also. That's fine, no problem. But the thing is that you can capture all that traffic, attack traffic from the switch. Now, how can you capture the traffic? There is some packet or traffic capturing tool, or you can say packet capturing tools. I'll give you a list of tools by which you can capture network traffic. So is it clear? How can you generate your own network traffic? So there are some freely available scripts or tools by which you can generate the attack. And if you can launch your own attack, and the attack traffic, whatever attack traffic is communicating inside your own network, that traffic you can capture by using some packet capturing or traffic capturing tools. Okay, so next, tools for attack generation. As I have mentioned, there are so many attack generation tools available. Some of them you can use freely. But again, I am repeating, you should use these tools only for experimental purpose. That means educational purpose you can use. Intentionally, never use this type of tool. If somebody using these tools to launch some attack, and if the victim identifies that you are the attacker, he may give some cybercrime case, and in that case, you will be the victimized. Cybercrime laws will be imposed on you. So you should be very careful. I'm repeating again. Only for your knowledge, I'm sharing what are the tools that you can use. So in my experiment, I use LOIC, low orbit ion cannon. It's like a cannon, traffic cannon. It can launch DDoS attack, distributed denial of service attack. And nowadays, distributed denial of service attack is one of the very challenging. Not nowadays, from the last 10, 20 years, it is very challenging. Earlier, this distributed denial of service attack was very common in normal network. But nowadays, people are using Internet of Things networks. So you know, in yesterday's talk, Dr. Bhuya sir has explained about the distributed denial of service attack using botnet like Mirai botnet. They have performed very good experiments. Okay, so that botnet means you are compromising. Suppose I am an attacker, I can compromise many things, many devices of an IoT network. The devices may be your mobile phones, your CCTV camera, your refrigerator, okay, your sensors, any devices I can compromise if I am an attacker. I have that skills, I have that type of scripts by which I can compromise your devices, your smartwatch, everything I can compromise. So if your device is compromised, then what will happen? The control of your device will be done by me, not without your knowledge. You don't know that you are compromised. Your mobile phone is compromised. Your refrigerator is compromised. Your CCTV camera is compromised. If everything is compromised without your knowledge, then you will not aware that you are that means somebody has controlling your device also. And in that case, the attacker may instruct the devices. The attacker may silently instruct your mobile phone to send some attack traffic to some victim. Okay, and if the attacker can compromise your mobile phone, your refrigerator, your CCTV camera, your smartwatch, or whatever may be, and the attacker can form a botnet. Bot means once you have compromised the machine, it becomes a bot. And if the number of such devices is very high, they can form a network, and that network is called botnet network. And if you are a part of a botnet network, then according to the instruction of the attacker, original attacker, who is the mastermind, he can instruct your mobile phone to send some attack traffic to the victim. So that way, some distributed denial of service attacks are also launched. So one such tool is LOIC. Okay, or you can use Trin also, or HYC, Targa, Jolt, anything you can use. So as I have already mentioned, for attack launching, first configure one server. In our test bed, PC1 is configured as a server. Then use some clients and access the server. PC2, PC3, PC4, any number of PCs can or machines can work as a client and they can access the server. Then third step, one or more clients will work as an attackers. So PC2 will work as an attacker when you manually install attack tool on the client. If you install any tool like this LOYC, you just install LOYC on that particular machine, and you manually, if you execute that tool, then that tool will send attack traffic by using the IP address of your PC where you have installed that particular tool. All right. So use the server IP address during attack period. That means the client will set the ID or IP of the victim. So victim will be the server for your case. You are sending this, that means you have put the server IP address as a victim IP. And your client will send all the traffic, attack traffic to that particular server IP address. And finally, if all the clients send attack traffic to that particular IP address of the server, then the server will die. So after launching the attack, as I have mentioned here, you can launch the attack in PC1 by using PC2, PC3, PC4, or n numbers of PC. Then whatever traffic is communicating in your own network, that traffic you can capture from the switch. Or there may be some so many other techniques. There may be some mirror port options also. So mirror port options means whatever communication is going inside the local area network, you have mirrored all the traffic in a particular port. And that port is configured as a mirror port, and all the communication, all the traffic that is passed through the network, you can capture from that particular mirror port. So for capturing, what you can do, you can use some network traffic capturing tools. I can show you one such tool. Let me show you one tool. Warsaw. Yeah. So this tool I can show you. One very commonly used tool for network traffic capturing as well as analysis. Okay. So using Warsaw tool, you can capture network traffic. So here, only thing is that you have to specify from which interface. Suppose your PC is connected to some local area network by some Ethernet card, and you have to specify only that particular Ethernet, and after selecting that particular Ethernet, you can go for capturing. Okay, so suppose I have selected some Ethernet, and there are so many local area connection 8, 7, 6, like that. So many Ethernet things are that means interfaces are there. I have selected Ethernet 1, and once that is selected, then all the traffics that is communicating to in my network or in my that means in my own setup, that communicated traffics are being captured by this capturing tool called Warsaw. So all the communicating traffics it is capturing. All right, now you go to capture. Here in this Warsaw GUI, there is some file, edit, view, go, capture. So you can stop the capture at any time. Suppose I want to stop now. No packet is captured at this moment. Okay, because I have stopped capturing. So whatever data or whatever traffic this tool has captured, now what you can do, you can save the file, captured file in some storage. Okay, you can store it as a pk file. Okay, you can store it as a pk in this format, WordSec format. Any name you can give. Okay, suppose test data. So I can store it in the form of some test data. Suppose this is my file. I am storing it desktop. The packet is stored now in the form of .pk file. Okay, now you can analyze that traffic. Whatever data you have captured, you can analyze. Okay, so similarly, you can use Ethereal, TCP-dump, Net2PCAP, Snow. So many other tools are also available. You can use any tool. Out of this tool, you can use any one to capture your network traffic. Fine. So network traffic capturing means it is sniffing. It's also called sniffing. Okay. So use sniffing tools like TCP-dump, libpcap, or WordSec to capture real network traffic, either from a particular host or from the whole network. All right. So port mirroring, as I have already mentioned, port mirroring can be used to capture traffic from the whole network, and the captured network traffic will be stored as in the form of .pk file or .tcp dump file. Okay. So up to this point, I have mentioned how can you generate your data, or how can you capture your data and you can store it. So after getting your traffic data, next is that you have to process the captured data. You have to pre-process some by using some pre-processing techniques. You have to pre-process your captured data. So without pre-processing, that data is become raw. So raw data means it contains the header field, TCP header, IP header, Ethernet header, all the header fields information will be there along with some payload field, actual data field. If you know the structure of the TCP IP header or IP header or Ethernet header, in every layer there will be some header information as well as payload information. So all those information will be in the raw structure. So you cannot use the raw data directly in the machine. That means you cannot provide those raw data to the machine learning model. You have to pre-process. Okay, so for pre-processing, there are two steps actually. One is called feature extraction and another is called feature selection. So feature extraction means, suppose just now I have shown you using WordSec tool, you have captured some raw network data and you have stored it in some storage like trace-data.pk. Now that traffic, from that traffic, you can extract some features. Okay, so for feature extract, that means when you are going to extract the features can be extracted either from flow level or from packet level. So you know what is flow? Do you know what is network flow? So network flow means, suppose this is your machine. You have machine 1. Okay, and this is another machine, M2. These are the two machines with some IP address, IP1, IP2. So in these two machines, suppose machine 1 is using one port number P1, another machine 2 is using another port number P2, and in between these two IP address, there is some communication with specific protocol, like suppose TCP protocol. So whatever traffic is communicating from this IP1 to IP2 in forward direction as well as from backward direction, okay, from IP1 to IP2 using one particular protocol called TCP or HTTP or whatever, maybe some specific protocol in port number P1 and P2. Only this port number, no other port number. Only for this port number and for these two IP, with this protocol, whatever communication is going on, that becomes a flow. That traffic will be considered as a flow. Okay. So from each flow, you can extract some features. That is called flow level feature extraction. Okay. So for flow level feature extraction, you can use a very good tool that is called CIC flow meter. Those who are interested for network traffic analysis, they can use CIC flow meter tool. This is freely available. You just download this tool. I will show you how to operate this tool. And remember, this tool is used only to extract features from flow. It will compute flows, and from each flow, it will generate the packet. Features. And there is another approach by which you can extract features, that is called packet level features. So packet level features means, let me explain. Suppose you have a packet, network packet. You have a network packet. All right. So a network packet may have some TCP header information like source IP, SIP, destination IP, TTL field, then checksum, then suppose protocol. Okay. Then suppose Ethernet header information. So that way, these informations will be available in each packet. Suppose if I say this is my packet number 1, then for this packet, this information, header information is available. Similarly, for packet number 2, if I say packet number 2, just a minute, for packet number 2 also same type of information will be there. Source IP, destination IP, TTL, like that. Now the thing is that many times this information, SIP, DIP, this information will be very common, okay, for each packet. So if you consider only the header information available in each packet, then that is not very suitable for analysis. So for that reason, what you can do, you can combine multiple packets. Suppose you are combining packet 1, packet 2, packet 3, like that. Suppose hundreds of packets, continuous hundreds of packets, you are considering as one batch of packets, and that batch of packet is called one window. Suppose this is window 1. Similarly, from 100, packet number 101 to packet number 200. Suppose this is 101 to 200, this is suppose window 2. So that way, suppose this window size, or it may be instead of number of packets, what you can do, window size in time. Suppose 5-second time window, 5-second time window. This window size is 5 seconds. And in 5 seconds, it may be hundreds of packets or more than hundreds of packets. Suppose in window 2, that is also again same 5-second window. So in 5-second window here, it may be 150 packets. That way also you can split the whole trace. That means what I am telling, as I have already mentioned, you have captured a file, test data .pkf, and this is 12-hour duration. For you have executed your attack, that means you have captured the traffic for 12 hours, suppose. And now this whole test data.pkf, you can, from this whole trace, you can extract flow level features. You can extract flow level features by using CIC flow meter, one approach. This will give you only flow level features. But if you want to extract packet level features, try to understand, if you want to extract packet level features, what you have to do, you split or divide the test data.pkf file, the captured pkf file. This is your captured pkf file. Now you divide the whole pkf file into 5-second or 10-second or whatever, maybe some time based splitting is required. So if you divide your test.pkf file into 5-second time window, then in 12 hours, how many total window you will get? So 5 seconds in one minute, how many windows will be there? 12 windows in 1 minute. Okay. So in 60 minutes or 1 hour, how many windows? 12 into 60. Okay. In 1 minute, that means 5 seconds is 5 seconds you are considering as a one window. If 5 second time is considered as a one window, then in 1 minute you will get 12 window. All right. If it is 12 window in 1 minute, then 60 minutes, yeah, 12 into this 60. So that many windows you will get. Now for each window is nothing but some collection of packets. These are the packets. So from this window you can extract some features. And for these things, what you can do, you can write very simple program to extract the features. Okay, that's why. So what may be the window-based features? Okay, time window-based feature extraction. What type of features you can get from time window? I'll show you. Now let me explain the feature extraction using CIC flow meter. Let me show you the demo of the CIC flow meter. Okay, so I request all of you to download. That means later on you can download this CIC flow meter. Just that is available in the web. You just download that thing and you can use. All right. So I have for after downloading, you just extract that CIC flow meter. Then you will get that CIC flow meter folder. Inside the folder there is a bin field. So inside the bin folder, the CIC flow meter.bat, one batch file is available. You need to execute this batch file using your command prompt. Okay, so let's open the command prompt. As administrator, go to that particular bin folder. Go to that particular bin folder, E drive, then CIC flow meter, then again CIC flow meter, then bin. So now I am here, E drive, CIC flow meter 4.0, then bin. So inside this folder you have that CIC flow meter.bat file. You just execute this CIC flow meter.bat. So if the execution is successful, then you will get the interface. So this tool interface is shown here. Now using this tool, you can extract features. All right. So for feature extraction, there are two options. Go to the network. Here, file, network, and help. Go to network. There is offline options and real-time options. Suppose if you want to extract features from your real-time network, that means you are considering current network traffic, and that traffic you can use for feature extraction. That is also okay, or you can perform offline. Suppose somehow, as I have already stored some network traffic by Wireshark, I have captured some network traffic. That network traffic trace file testdata.pcap, that file is already stored, and you can use that file also. So whatever may be, you can select, suppose offline data. Then go to browse. Here only thing is that pcap directory. See, in the pcap directory, that means your file should be in pcap format. So let me say whether I have stored my file in pcap or not. If it is in pcap file, then that's fine. Otherwise, you have to change the file format to pcap. Okay. So this pcap png. Okay. Let me rename it as pcap. Where is the rename option? So I'll rename it as pcap only. All right. So now, the action cannot be called because the file is open. Okay, I have to close the Wireshark first because that is already open. So fine. So go to again the tool. So here what I'll do, I'll upload that file. Which file? Test that pcap. Go to my desktop, all files. Okay, so I have loaded recently captured test that.pcap. Oh, that is not png, this is not png, it should be pcap. Let me rename it again. It should not be png, it should be pcap. Okay, you remember it. The file name should be only pcap. Just a minute. Okay, so okay, and select the browser. Suppose I am storing in the desktop. Okay. Oh, just a minute. My file name is not correct. That's why it is not working. Okay, or I can install. I can give some pcap file directly. Just my file name is not changed, so I can give direct pcap files. No, not here. Somewhere I have stored some pcap file. Okay, just a minute. Where is my pcap file? Not okay. Let me do one thing. Why it's not renamed? I don't know why it's not renamed. Okay. So go to network, offline, desktop. Okay, suppose I want to store in desktop. Okay, so if you see here, so I have loaded the test.pcap file. You remember the file name should be only pcap. And once you have upload the pcap file, then from that pcap file, the tool can extract some flow features. The status of that file is given here. Packet status total 8086 flows. Total 8086 flows are there. All are out of 8086, 8031 is valid, and some flows are discarded. Okay, now that extracted features are stored in a CSV file. You can see the CSV file here. These are the extracted features. So interestingly, see, you have given the pcap file. Pcap file you have given to the tool, and tool, after getting that pcap file, it extracts so many features: flow ID, source IP, source port, destination IP, destination port, protocol, timestamp. This is timestamp. Flow duration, for how many second, for how many times the flow is performed. Then total forwarding packet. That way, so many features have been extracted. And can you imagine how many features have been extracted? It is more than 80. More than 80 features have been extracted from more than 8,000 flows, and in a very short period of time. But the thing is that if you look at the last field, the label field. So the label field is that no label. This is one of the drawback of this tool. No label information is available here. That's why at the very beginning, I told you that when you generate attack traffic, when you generate any traffic, you can first generate normal traffic. So if you know that the traffic is normal, then you can label all this flow as normal. And then with reference to the normal traffic, you can analyze other traffic also. So normal is most important. And if something is not normal, initially you can say that is attack. Okay, so this way you can extract more than 80 features by using CIC flow meter. This is called flow level feature extraction. In addition to flow level feature extraction, there is another approach called packet level feature extraction. So feature extraction using CIC flow meter, I am just summarizing, used to extract features from network flow. As I have already mentioned, you have uploaded only the test.png file to that CIC flow meter. It has extracted more than 80, here I am writing more than 50 features, but in general it can extract more than 80 features. It supports only PCAP or TCP dump file. If the file name is something else, or if the file type is something else, you have to convert it to PCAP or TCP dump. But the thing is that no label information of the flow. The tool cannot perform the labeling itself. So manual labeling is required. That is the main drawback. Okay, and all the extracted features are not required during analysis. But just you look at here, all the features that you have extracted, it's not equally important. It's not equally important. Only some of the features will be important. Although you have extracted more than 80 features, to identify whether that flow is attack flow or normal flow, all the 80 features are not equally important. So you need to perform another pre-processing task that is called feature selection. Then feature extraction from time window. As I have mentioned, you can extract features from flow or as well as from time window. So split the whole traffic trace into small time window of size maybe 1 to 5 seconds. Okay, from each window, small window, you can extract some features like total number of packets in a window. For these things, you can write small Python programming scripts or some C programming scripts. By using that way, you can extract some features. Then after feature selection, as you have seen, all the features are not important. You have to select some features. So how can you select features? By using some feature selection tool. So very briefly, the feature selection means you have a large number of features, and from that large number of features pool, you are selecting some informative features only. Okay, so how can you find out that feature is informative or not? For that, some objective function is required, and with the help of the objective function, you can compute the score for that particular feature, whether it is good or not, or whether it is relevant or not for that particular application, or for that particular network traffic flow, or for that window. Okay, so you have to evaluate each and every feature, and after evaluation, by using some objective function, you can decide whether that features will be useful for analysis or not, and that is called feature selection. There are different techniques for feature selection. Here you can see in this step, suppose you are giving some training data. Now for the first time I'm mentioning the training data. Training data, for the time being, you just assume that data is some kind of structured data, and training means there will be some label information also. And the feature selection approach, this approach will use some searching techniques with the help of some objective function. And the objective function will give you the goodness measure. And if the method, your approach, searching approach, found that the goodness measure is the excellent one, no other better goodness value is found, then for that particular subset, for which the goodness function is the best one, that subset will be selected. And that selected subset will be used by some pattern recognition or machine learning model. Okay, so why feature selection is important? It is important because it enables the machine learning algorithm to train faster. I don't know whether you are aware about the training process or not for machine learning. Probably you have learned what is training. Training means you have developed one mathematical model. Machine learning means machine itself, although many of we think that machine means something hardware components. No, actually it is a Turing machine type of concept. It's a mathematical model. So the mathematical model can gain some valuable information in the time of training with the help of a large number of training data. And if you provide sufficient number of training data to that particular model, that is a mathematical model basically, and that model will learn something from that given data, training data, and it will keep some knowledge. The model will remember some knowledge mathematically, and that knowledge will be used at the time of testing. And that part, when model gains some knowledge at the time of training, you can evaluate the model, you can test the model by giving some test data. And at the time of testing data, the model will compute its level. Model will classify something, model will predict future. And if the prediction or classification is good, then you can say that model has gained sufficient knowledge, model is accurate. That way you can validate. Okay, the most important thing is that the sufficient amount of valuable or meaningful data you have to provide to the machine learning model. That is most important. That's why I have till now I have discussed so many things that means related to your feature extraction, feature selection, how to get network data. Only because of to classify the or analyze the network traffic by machine learning model in a good way, in an acceptable way. So it reduces the next complexity of the model. That means instead of using a large number of features, instead of using 80 numbers of features, if you can select only 5 features, those are the most informative features, then automatically your model complexity will be reduced. Time complexity will also be reduced. Analysis time complexity will be reduced significantly. And most importantly, if you can select the most informative features from the network or from any data, it will definitely improve the performance of the model. Okay, so definitely it will increase the accuracy of the model if the right subset is identified, right subset of features is identified. And third thing is that it reduces overfitting. Overfitting in the sense, if you are using a large number of features at the time of training, okay, fine. At the time of training, model is fitted to your training data with so many features perfectly. But at the time of testing, your model performance may be degraded due to some bias variance trade-off. Okay, that way overfitting will create some problems. So basically, filter method, wrapper method, embedded method, this type of methods are used for feature selection. So in filter method means, very quickly I'm going these things because I have to show you how to extract, how to select the features by using a very good tool. Okay, let me take that tool. Suppose filter method means you are filtering. Suppose you have 80 features or n numbers of features, you are just filtering the most informative features one by one. That is called filter method. So for filter method, you have to use some objective function. With the help of the objective function or the search function, you are computing the importance of that particular features. And if you found that score is important, score is very high, then that features will be selected. In wrapper method, Wrapper means some machine learning model will be used. As you have seen here, the learning model will be used along with the subset of features. That means out of 80 features, suppose you have selected 20 features. Now, whether that collection of 20 features will be good or not, that will be decided by the learning algorithm. One machine learning algorithm you can use to evaluate the subset of selected features. If the subset is not good, you select another subset of features, again you evaluate. So that way you are evaluating the subset of selected features with the help of a machine learning model. But this wrapper method takes significant amount of time as compared to the filter method. But accuracy you will get high in case of wrapper method, because already one evaluation algorithm, learning algorithm is used to evaluate the performance of the selected subset of features. Okay, third method is embedded method. Embedded method means at the time of training itself, it selects some features. That is called embedded method. Now, I will show you another tool by which you can select features. After extraction, you can select features. That tool is called Weka. Weka tool, W-E-K-A. You can install. This is a very widely used, very popular, very old tool for machine learning. For your experimental purpose, this is the best tool I can say. Why it is best tool? Because it provides GUI. You need to only click and you perform operation and you will get a result. So this tool is one of the best tools. So just install Weka and open the Weka. This is the GUI. Then you can go to Explorer. Once you click on the Explorer, then pre-process. You will get pre-process. Only pre-process is activated. And classify, cluster, associated, these are all deactivated now. Why? As I have mentioned, because this tool contains so many machine learning models. But you cannot apply the machine learning model directly on the raw data. You have to pre-process. Okay, so for pre-processing, you can open files. Already you have some data, you just open the data. And remember, one important point I have to mention here, this Weka tool supports only .arff file. Attribute relation file format it supports, .arff. Okay, so you have to convert your data set to ARFF only. Okay, so suppose this is my .arff file. I have uploaded that file. Okay, that means what I am telling, you can convert. See, recently I have somewhere I have stored the CSV file. No, this is your CSV file. So this CSV file you can convert it to ARFF. Just see in the web how to convert the CSV file to ARFF. It's very simple. These are the data portion. These are data portion. Okay, you just keep the data as it is, and whatever the feature, you have to mention the feature name and its data type. It may be categorical, it may be numerical, it may be real, so or boolean, whatever may be. You just mention before the data part. You just mention the type of the attributes. That's all, and you just save that file as a .arff. Okay. Now, once you upload that means once you upload the file to the Weka toolbox, then you can go for pre-processing or feature selection. Okay. So choose here, filter, correlation, current relation, attributes. Those things are given. Come to choose. Okay. Oh, sorry. Come to select attributes. Here, see, once you have loaded the file, classify, cluster, associate, select attribute, everything is activated now. So you can go to select attribute. Select attribute means select feature. Feature is also called attribute. Okay. So once you click on the select attribute, then you can choose what type of method you are going to use. I have already mentioned filter method, wrapper method. Okay. Then embedded method. So you can use suppose CFS subset evaluate this function, this feature selection method. It uses base first search method. I have already mentioned that there will be some searching method. That search method is suppose base first. Then you can use full training set. Then start. Okay. It's taking a little bit time. See here, the selected attributes 1, 2, 3. 3 attributes it has selected. Okay. So now it select the attributes based on some ranking. First feature is rank 1, second feature is rank 2, third feature is rank 3. I'm uploading a very simple smaller file having 3 features. That's why it is showing as 1, 2, 3. If you upload a very large file, your ordering may be different. Similarly, you can choose suppose relief F. So once you select the feature selection method as relief F, the search method will be sense. It will be rank. It will rank the features, and then you start. So it will 1, 2, 3. That way it is ranked. Rank 0 attribute. That means first feature is rank value 0.7869. Second feature attribute rank is 0.60. That way it is ranked. Then you can go for classify. You go to the click on the classify. Then you can choose classifier. So many classifiers are available. Suppose name-based classifier, base classifiers, name-based. You can choose name-based. Okay, choose name-based. Then cross-validation. I don't know whether you know cross-validation or not, but suppose I am using cross-validation, suppose 5 or 10, whatever you say. Then you start. You start classifying. So you see here, once you apply the name-based classifier, the accuracy, everything, confusion matrix, accuracy, everything is shown here. True positive rate, false positive rate, precision, recall, F-measure, Matthew correlation coefficient. Yesterday, Monwar sir has already mentioned these things: precision, recall, F-measure, MCC, Matthew correlation coefficient, ROC curve, everything you will get here. So what is the accuracy? Accuracy is 99.9057. This is the accuracy. Correctly classified instances out of 2118, it is classified 99 with accuracy 99.9057. Incorrectly, only 0.0943. This is for classifying. So all these machine learning models are available here. You can use net-based multinomial or any other. Then function, lazy function you can use, or meta function you can use. This decision tree you can use, tree-based method, random forest you can use. All right. So this tool is very simple to use. Only thing is that this tool requires structured data, or that data set should be in .arff format. You can take any data, any network data, pre-process it, and use that data, structured data in this tool, and apply any machine learning algorithm, any feature selection algorithm, any clustering algorithm, whatever you like, you can do it. Okay, so how to select features using Weka? I have already mentioned. Apart from Weka, you can use some Python toolbox packages also. Scikit-learn, one of the best tool for machine learning. You can use this scikit-learn package also, or MRMR package. MRMR is a very popular feature selection method. You can use MRMR package, or feature width. This is also an important package by which you can apply. You can select some features, or you can write your own method. Okay. Then feature selection using Weka. I have already shown you the demonstration. So here, pre-process in the pre-process tag of the Weka, go to the pre-process, then open file, select attributes, attribute evaluator, then search method. You have to click only on these buttons. Then apply machine learning model. So once you are opening the Weka toolbox, you can see classify, under classify toolbox, so many machine learning classifiers are available, so you can use any one. So machine learning classifiers available here: nearest neighbor, decision tree, support vector machine, random forest, naive bayes, Some neural networks-based methods are also available. Ensemble methods are available. Okay, so these are the things. Then you can evaluate the model. So for model evaluation, you can use cross-validation, K-fold cross-validation, precision, recall, F-measure, ROC. I am just quickly giving an overview. It's already 2:28. So very quickly, I'm giving you an overview. Okay, so model evaluation is in cross-validation. Cross-validation means, what do you mean by cross-validation? Let me explain that very quickly. Suppose you have a data set. Suppose this is your training data set. Okay, this is your training data. So if you apply 5-fold cross-validation, 5-fold cross-validation means you are dividing the whole data into 5 folds: 1-fold, 2-fold, 3-fold, 4-fold, 5. This is fold 1, fold 2, fold 3, fold 4, fold 5. And you have to perform the iteration for 5 times, 5 iteration. So iteration number 1, in iteration number 1, you suppose this is not training data set, suppose it is only data set. Okay, so in iteration number 1, your training data is from fold number 1 to fold number 4. 4 folds are used for training, and testing is only fold 5. Okay, next, training is from fold number 2 to fold number 5. 2, 3, 4, 5, 4. Then testing will be which fold? Fold number 1. Then suppose in iteration 3, training is suppose F3, F4, F5, F2. Then what will be testing? Testing will be, suppose F1. This will be F2. Then in 4, iteration number 4, training will be what is F4, F5, F3, F2, F1. Then testing will be F3. So that way, in each iteration, you are using this many folds as for training, and this is for testing. So the beauty of this thing is that all the folds will be used at least for one training and one testing, and there should not be any bias. So that is called training test cross-validation. Okay, so some research issues. Classification of network traffic in real time is very difficult. Already real-time analysis is a bit difficult, so you have to use some high performance computing. Then development of intrusion detection system to identify malicious traffic at the source end is another issue. Yesterday also it is mentioned, because collateral damages may be there, so it is very difficult to analyze network traffic in the source end. Then distributed machine learning model for network traffic is important. So if you can develop distributed or federated learning model for network traffic analysis, then that's good. Then real-time analysis of encrypted network traffic, because nowadays people are sending only encrypted network traffic. So if it is encrypted, then it is very difficult. Okay, so thank you so much. Let me take the question quickly. Does this attacking tool a part of operation of penetration testing? Yeah, you can say it's a penetration testing you can use, no problem. What is the meaning of overfitting? I have already mentioned overfitting means if your training, in the training data, if you are using so many features, then the machine learning model will get sufficient features. That means so many features. That's why its learning is perfect, or model is fitted perfectly. There is no any error, you can say training error, no training error. But at the time of testing, its performance is degraded because there is some high variance in the data, and for that variance, it cannot predict the levels correctly at the time of testing. How does Wireshark analyze network traffic? What is NSL KDD? So see, how does Wireshark analyze network traffic? There is some Go options. Okay, I cannot show you right now because time is over. There is some go option. You can go, you can click on that go option, and there will be some, that means statistical analysis or iograph based analysis is there. So you just simply click on go button, then go to statistical analysis or IO based analysis, input IO based analysis. In that option, you will see how traffics are flowing in a graphically you can observe. So the NSL KDD is one variance of KDD cup dataset that is used for only for 10 or 15% data is used from the original KDD cup dataset, and that is marked as NSL. Sir, is PCA a wrapper method? See, principal component analysis is a feature extraction method. It's not a wrapper method, it's a feature extraction method. It is basically used to reduce the dimensionality. Okay, you can use PCA for dimensionality reduction only. Okay, it's not related to your wrapper method or filter methods. You cannot say it's basically it's a dimensionality reduction thing. Which set of parameters are useful for attack classification packet or flow? Which set of parameters are useful? See, it's a good question, but what type of attacks you are going? See, if I want to attack, identify DDoS attack, then for DDoS attack, it may be only number of packets per flow, or IP variation, or entropy of IP. Only 4 or 5 features may be sufficient. So no one can say exactly what will be the important parameters or features for analyzing that type of attack. Okay, you have to experiment, you have to analyze all the features that you have extracted, and from that features you can select the informative one, and those informative features you can use for classification of packet. Is there such tool for feature extraction and selection for 2-dimensional data also? Yeah, you can get some to feature extraction. Even in the from image also you can extract features. Okay, there are some tools available. I can't remember, I don't know exactly what the name of those tools, but you can get so many tools by which you can get extracted features from 2-dimensional data sets. So I'm very sorry, very quickly I have answered the questions. I don't know whether you will be satisfied or not, so I have stopped here. And over to you, Jamal sir.
Thank you, Dr. Nazrul Haq, for such a nice, very excellent lecture, I will say, because you started from network traffic capturing, and you discussed about the details of the network traffic. Can you hear me?
Yes, sir. Yes.
Yeah. So I think if someone is really trying to take up any research work, particularly in networking field, it will be really nice to start with that the way you have shown that how data can be generated in different ways, and then analysis using machine learning. So different type of applications like anomaly detection and all, as he has rightly mentioned. So as a whole, I find that it was, although it was from the very basic, but I found it very interesting, and particularly for the newcomers who are coming into this research in this particular field, it will be really helpful. Thank you so much. And you have really addressed all the queries what the audiences have. If there is no more question, then we can thank Dr. Nazrul for such a wonderful talk. And we hope that in future you will deliver some more lectures for the audiences through some other platforms as well. Thank you.
Thank you so much for your nice words and giving me this opportunity to deliver my experience here in this good platform. Thank you all. Thank you, my dear participants.
Thank you. And for the participants, there is an announcement. Due to some unavoidable circumstances, the lecture scheduled at 2:30 is cancelled, and in due time it will be scheduled and it will be notified.
But let me tell you one thing, that tomorrow's class, which is scheduled at 10:30, will remain as it is scheduled. And the today's class, which is could not be held from 2:30, it will be scheduled sometime later, maybe tomorrow or day after. And in due time, it will be notified. Thank you so much.
Development manager as a research and development manager at Front Media Singapore division. Prior to that, he was associated with National University of Singapore as a research fellow from 2017 to 2021, and as a data scientist in COVID Research Lab, India, in the year 2017. He is a PhD graduate from Indian Institute of Technology, Guwahati. He was one of the organizers of the special sessions on the attacker's perspective on automatic speaker verification, Far Field Speaker Verification Challenge 2020, in Interspeech 2020, and the Voice Conversion Challenge 2020. He served as publication chair of IEEE Automatic Speech Recognition Understanding Workshop 2019, and one of the chairs of joint workshop for Blizzard Challenge and Voice Conversion Challenge 2020. He has published around 100 research papers in top-tier peer-reviewed journals and conferences. He is a senior member of IEEE, a member of ISCA and APSI-PA. His research interests are speech, audio signal processing, speaker verification, anti-spoofing, social signal processing, and various applications of deep learning. Ladies and gentlemen, the topic for today's lecture is speaker verification, the quest for voice print technologies. So with these words, I welcome Dr. Rohan Kumar Das and thank him for sparing his valuable time to interact with the participants. Dr. Rohan Kumar Das, please.
Okay, sure.
The floor is yours.
Hello, everyone. First of all, I would like to thank Professor Jamal and Professor Iftikhar. I don't know, like he's here. I don't see him in the panelist, maybe in the attendee list, for inviting me to deliver a talk in this FTP course on data analytics and machine learning. So let me share my screen and then we can go ahead with our with my talk. So I hope, sorry, let me share the sound as well, actually. Are you able to view my screen?
Yes, yes.
Okay, sure. Okay. So aligning to the theme of the FDP course, which is on means analytics and machine learning. So my topic of the talk will align towards it, means in terms of speech analytics. And in more detail, the title of the talk is Speaker Verification, the Quest for Voice Print Technologies. So I have planned my talk in this way. So first I will give a brief introduction, and then I will explain what is voice print. And then we'll look ahead to know what is speaker recognition and its classification. And then what are the various kinds of applications of it. And later we will know more details from the technical point of view to see the historical means evaluation of this technology research. And then we will also have a brief overview on the spoofing attacks and the countermeasures with respect to the voice biometric technology. And then towards the end, we will also view some related research directions which are quite correlated to the voice biometric. And finally, we'll move ahead to the summary and discussion. So this is how I have planned my talk. So let's go ahead with it. So given a speech signal, so this is a speech signal, suppose, or rather a part of speech. So we can infer many kinds of things from it. So speech is one of the most common form of signal that we use for human-human communication as well as human-machine interaction. So from a given speech, we can infer many things. So let us view what we can infer from a given speech. first of all, we can infer what is the message of the speech, right? What is being said, one can understand it. So that is most important. Then another aspect is what is the language of the speech. So one can know in what language the speech is spoken. Then one can also know the gender of the speaker. Similarly, one can also find out who is the speaker. Likewise, one can also try to estimate the age of a speaker, like not the exact age, but at least one can try to estimate the age range or something like that, whether it's a voice of a child or whether it's a voice of an like old age person or something like that. In the same time, one can also know the emotional state of that person as well, whether the person is happy, angry, or sad. So these kinds of things also one can infer from a given speech. Likewise, one can also know about the cognitive load or the stress level, whether the speaker is in quite stress or he is quite free mind or something. So these things also one can infer. And there are like a lot of aspects that one can infer from a speech signal itself. So basically, although speech is like one signal, we have like a lot of things that we can infer from the speech signal itself. So in today's talk, we will only focus on one direction out of it. And as we go ahead through the slides, you will come to know more. So then coming to what is a voice print? So in today's technology crazy world, so in our day-to-day life, we are using a lot of biometrics. So the most common is like thumb impression, or we use fingerprints even to like unlock our smartphones. Nowadays, like we have on the back side of the smartphone, there is a like fingerprint reader on the top side as well. So we use it often, our biometrics, to unlock our phone. Likewise, the human eyes, the eyes also have two kinds of aspects actually. So the one is the retina, where it captures, where it shows the like vein pattern of the user, and another is the iris pattern. So these two kinds of aspects can be modeled as a biometrics for that user. And like for a lot of like biometric IDs in like many countries, or even for like many countries visa application or so these kinds of biometrics are used as well. Then the face ID or like face recognition is also can be used as a like biometric measure for a user, because the face of a human is also unique, right? Like this, all these biometric exists. Similarly, the voice of a user also has unique speaker characteristics. That's why the voice can be also used for biometrics. And the unique characteristics of a user with respect to his or her voice is called as the voice print of that user. Then going ahead, voice print recognition by humans. So let us look at it for a while. So what we find that humans can recognize the known voices quite well. Like suppose we know our relatives, we know our friends, or like our like known people voice, which suppose we hear them often. So only by hearing the voices we can find out the who is the user. But for unknown voice, it is a bit hard. So just to illustrate that, I'll play like few sounds, and I hope like some of you will be able to recognize a few, and some you may not. So I have 3 sounds with me. So let me play them for a while.
Now, even as we speak, there are those who are preparing to divide us. The spin masters, the negative ad peddlers, who embrace the politics of anything goes. Well, I say to them tonight, there is not a liberal America and a conservative America. There is the United States of America.
So that is the first sound that I have played. I hope all of you are able to hear it. Then the next sound, let me play for a
For
while.
President of the United States, we need a leader that wrote The Art of the Deal. I will be the greatest jobs president that God ever created. Free trade.
And then let me play the last sound.
After April 1775, the whole question of independence, I think, was essentially a matter of timing and of tactical considerations.
So I have just played 3 different sounds or like other speech from 3 unique identities. And I hope most of you are able to recognize the first 2 voices because they are quite well known and we have heard them many times. And the third one may be hard for you. I think if I'm correct, I think almost all of you are able to recognize the first voice, which is of Barack Obama, and the next voice, who is of like Donald Trump. And the third voice, you might have some ambiguity, like who is that? Because you don't know that. So the third voice is from a professor called Jack Rakove. So he is a professor in Stanford, but suppose you have not heard him, so you could not recognize him. But other 2, you know them, so you are able to recognize them well by hearing their voice. So coming to like automatic recognition of voice print, why we need, right? So the first thing is that as opposed to the humans, machine do not have limitation to recognize speakers for a speaker population. Means suppose humans have a limitation. Suppose one can remember or like one can learn like 100 voice characteristics, or like I can remember voice of a like 100%, or maybe like one can remember 1,000 or 10,000 at the most or something. But as opposed to humans, machines do not have limitation of such numbers. So for machines, it's unlimited. Like machine can remember voices of millions, trillions, or like as much it can. So that is one thing why the automatic recognition of voice print is needed. And another thing is that like we want to use it as a biometric measure to access some service. So for that also, we need to develop this automatic recognition of voice print. Likewise, one can also use this kind of technology to find out the closest match of some unknown voice. Suppose in some forensic investigation or something, one want to use some like voice of a like means intruder or something to find out who is he or her, something like that. So that's why this automatic recognition of voice print is required. Then coming to the automatic speaker recognition technology, what it should do. So given a framework which can recognize a user by his or her voice, anyone who claims as that identity, then the framework should recognize that yes, he is, or like she is, if it's a like true person, and if it's wrong, some other one, so then one should reject the claim. Suppose here in this image, it shows the Einstein is claiming that I am Einstein. So the voice biometric framework should say, yes, you are. Suppose I claim as I am Einstein. So then ideally the framework should say, no, you are not Einstein, something like that. So that is the ideal way one framework of like automatic speaker recognition should work. Then let us go to the classification of this automatic speaker recognition. As we have seen, automatic speaker recognition, what it does, it tries to recognize speakers automatically using their voice samples. So broadly, the speaker recognition area, it can classify it into 2. The first one is speaker identification, and the next one is called as speaker verification. So the name itself tells like what is it, but I'll still explain. So coming to speaker identification, so it basically happens in the non-cooperative scenario. So where there is a test speech, and that test speech has to be matched with some existing voice database to find out the closest match. So some kinds of applications may be some forensic investigations, like we have some test speech. We want to identify what is the voice, like which criminal's voice it may be, or like suppose like we have some like call recording of some terrorist or someone. So we want to find out whose voice it is. So that is called as identification. And coming to the next category, which is speaker verification. So it is more applicable in cooperative scenario. So it's more application oriented. So what it happens, suppose with thumb impression or something, we want to unlock the phone. So here also with voice, we want to access some service. So here always with a test speech, there will be a claim identity. Suppose I can claim as myself for a like genuine trial, or suppose if I want to make a false claim, I will try to claim as another to like have unauthorized access, but ideally it should be rejected. And then its applications are seen in like attendance marking or something, or in even banking applications also it is seen. Then this automatic speaker verification, which we means shortly called as ASV. I will use this term more often from now, so please try to note this term ASV. So based on the lexical information or the lexical content, means the message, it can be also classified into two. So what are these? So one is called as text dependent and another is text independent. So here also the names itself are showing like what it is, but I will go through them. So in text dependent, what happens? So there are fixed passphrases used for enrollment session as well as testing session. Means to enroll a model for the user, so the same phrase has to be used for enrollment by that user, and during testing or to like claim for some like accessing some service, the user have to use that same phrase. Like suppose when we like open one bank account, so we first register the bank account by having our handwritten signs, right? So likewise the same signature we have to use when we like have to draw a check or something. So it's like that. So like same phrase have to be used during the enrollment to like creation of the speaker models, and then same phrase have to be repeated during the each testing session for like having access. So by this framework, it puts a lexical constraint on the user that the user is bound to speak that fixed text itself. And as here there is a like lexical constraint, so the duration of enrollment or test segments are quite short. Normally like phrase, like suppose I can use a phrase like my name is Rohan or something like that. So it typically is of the order of like 2 to 3 seconds only. So it's quite short duration utterance for even enrollment as well as testing. While when we have this text independent, the name itself says like the user is free to speak anything during the enrollment as well as testing. So there is no restriction like the text dependent that we have just seen now. So during enrollment, the user can read like text or something, or like speak whatever in his or her mind or something. And during testing also, user is quite free to speak anything to like claim against this identity. But since there is no lexical constraint on the user, so the duration of these kinds of framework, which is called as text independent, so the duration for enrollment or test is slightly larger than what we had during the text dependent. Like because the model while one it creates, it wants to like have a definite set of like acoustic speech coverage from that user. So normally the enrollment duration it's a bit longer, like 1 to 2 minutes it can be for each user, but enrollment is only for one time to create the model. And during testing it can vary, it can be of 10 seconds or something, but a duration of test segment here matters. Suppose if the duration is more, so then the like it's likely that the system will do well, while we have a very short segment, so then there may be chances that it may not be able to recognize. So these are some of the like limitations in terms of like text independent over text dependent, but there is advantage that there is no constraint on the user in terms of what to be spoken. So these are like about the categories of speaker verification based on the lexical content information. Then let us view some of this application. So as I have said, like it can be used for access control application. So there are already some banks which use the voice pattern to authenticate the customers over phone. Normally, suppose when we do a kind of like internet, suppose phone banking by calling to a phone number for our bank account, normally the customer care tries to like authenticate by asking some of the like credentials, like what's your date of birth or some other things and all. So here some of the banks even started to like record the voice itself, and with the voice itself to like authenticate the users while having the conversation for the phone banking applications. And even like there are like remote person authentication applications as well over phone, where one can remotely authenticate to access some application using his or her phone with some app. And there are some attendance applications seen as well using voice. Then like for understanding, so I'll play a short demo video how like we can observe one application. This is taken from this YouTube link itself, so I have mentioned the link here so that there is not any copyright issue. So I'll just play this small clip. So I hope you understood what I wanted to show. So this guy, I think like he is a student in some laboratory or something. So what they have in their like laboratory room to have the access. So like one have to give the voice over that phone, and then like it will recognize the voice, and based on that only like user will be given access to enter the room. So this is one application that I found which might be interesting for you to show. So that's why I just showed it. So likewise, some applications exist to have like access control with voice. Then let's move ahead. So yeah, on a lighter note even, so I found the blog even like which lists all the Hollywood movies, so like which uses different kinds of biometrics in their sci-fi movies. So we can observe that voice biometric is even quite popular in terms of sci-fi movies as well. So we can see like occurrences of various biometrics in sci-fi movies, and we can find the voice ID and the face recognition are most commonly used in the like movies as well. So it shows it's not only like application oriented, but for like even sci-fi movies also, like it's quite interesting. So like some of you might have come across these movies like iRobot or Dread, like which use voice ID like as some application in their movies. And then let's go to the main like technology part now. So first I would like to give a brief overview of the ASV system. So given a speech signal, the first thing is to like extract the features from the speech. Like we remember like humans based on their like facial characteristics or by some unique characteristics. So first we want to extract the unique characteristics from the speech signal itself. So the first step always is to extract the features. And then given some models, suppose we already have some enrolled models of some users. So what it does, it tries to match the extracted features with the existing models by various means, and then make a classification task to yield a score, and based on the score, a decision has to be taken to accept the claim or not. So this is the basic overview of the ASV system. And then this entire framework we can part into two. First one is the front end part, where extracting the features and all, and then the remaining part is called as backend, like modeling and then like scoring, etc. So this is just a very generic thing, but there are many intermediate modules also which are used. So I will show here in this diagram itself. So one can do some kinds of pre-processing itself, like before extracting the features. Suppose the speech is quite noisy, so one can do like some kinds of like speech enhancement to suppress the noise part and to enhance the speech part, or one can do some speech non-speech detection itself. Then also one can normalize the features after extraction, which also helps. Then on the modeling part also, one can do some kinds of speaker adaptation, or one can try to model the channel session information, or rather try to compensate them later as well. And then after having a score also, one can try to normalize like before having a decision, something like that. So these are again some parts which can be used, like means in between, to like improve the framework itself. Then now we will go through like one of the things, like first we will go through the front end, then we will go through the modeling part, and then we will go through the backend technology part. So coming to the front end, so as I just now said, so some kinds of pre-processing can be also done. So one kind of common pre-processing is called as voice activity detection. What it does, it tries to find out the speech and non-speech regions of a speech signal. So like when we speak, we also take some pauses in between, right? So mainly the user characteristics are only during the speech region. In the non-speech region, it doesn't contain any user's characteristics. That's why first some automatic ways can be applied to find out the speech and non-speech region from a given conversation or a speech, and then only the speech regions can be retained to process it further. Like, because if we extract features from non-speech regions also, so it may rather create some confusions later while creating the user's model. So there are like various kinds of methods to do this. The most common one is like energy-based voice activity detection. So let me also tell you here. So speech is in general a non-stationary signal, unlike image or something. So so what one have to do, so one have to do some kinds of short-term processing in speech. So the entire speech signal is divided into some small blocks in terms of a short, very short duration, like 10 millisecond or 20 millisecond size, under which it is assumed that the speech signal remain stationary in that part. And then that block-wise processing is done. So for energy-based voice activity detection, what it does, so one can extract energy of the speech in terms of each of these frames, and then compute and like average energy, and based on the some threshold, like which is a function of this average energy, every frame's energy can be checked, and if that frame's energy is higher than the threshold, then one can consider it as a speech frame. Otherwise, one will take it as a non-speech frame and then do the rest of the things. So this is voice activity detection, which is a critical part in this voice biometric kind of application. Then coming to feature extraction. So there are a lot of ways to do it. So I will show a few out of them. So one of the most common way is to like short-term spectral features. So these are obtained by short-term processing of speech signal. As I have said just now, the speech is processed in terms of some small blocks called as frames, which is of the order of like 10 millisecond or 20 millisecond or so, under which it is assumed as like stationary. So various kinds of spectral features are used. So some of the well-known features with respect to speech applications are MFCC, which is Mel frequency capsule coefficients. So it is widely used almost across all the speech-based applications. There are other features as well, which is LFCC. This is called as like linear frequency capsule coefficients, and there are many more. So these are some common short-term spectral features that are used in the domain of speech analytics. Then there are voice source features as well. So what it does, it represents the excitation source information. So let me tell a few things like before explaining this. So the speech of like humans is produced by involvement of two things. So everyone have a glottis or like source, and then we have a like vocal tract which ends at our lips. So the speech is produced by convolution of these two, and normally the spectral features like MFCC or LFCC, so these mainly capture the vocal tract information rather than the excitation source. But it is also found that the excitation source or the glottis information is also quite unique to each individual. So that's why the voice source features are another representations that can be used for voice biometric kind of application. So it can capture the glottal flow shape, size, and all. And then there are some kinds of features like that are based on the prosodic information. These are called as prosodic features. So what it captures, it tries to capture the speech, pitch of that user. Suppose pitch is also having unique characteristics. Grossly, suppose the children pitch is quite high, about 400 hertz. Then the female's pitch is about like 200 hertz, and then male pitch is about 100 hertz. But then every individual's pitch is also not the like same. So the pitch can be also taken as a like unique characteristics apart from the other information that we have talked about. And the duration also, how one takes some pauses or something, or even the speaking rate information as well. So those can be also taken as some characteristics of each user for their modeling. Then we have some high level features as well. So these are mainly based on some idiolectal information. Like suppose every user will not use the same set of words while explaining some topic, right? So everyone's vocabulary is not the same. So these kinds of high level information can be also used apart from this set of things. But like high level thing is is not used often, but like these things can be also used. So I just wanted to highlight this as well. And then in the recent years, the spectrogram representation. So it's like a 2D representation of speech, like time frequency. Actually, it's 3D. That means intensity is also there in terms of some color. So the image representation of speech is also used as a characteristics to train the model. So these are various kinds of representations from the speech signal that one can like extract and then use in their voice biometric framework. Then let us go to few more things. There is like spectrotemporal information as well, which is found to be quite useful. Let us see what is it. So it tries to capture the spectrotemporal dynamics of adjacent speech frames by first and second order time derivatives. As I have said, like speech is divided into frames, then suppose for every frame we extract some feature, suppose like MFCC, we extract it. So MFCC is suppose like 13 dimension or something. So suppose we have a speech signal of suppose 100 frames, so it will be like 100 cross 13 size. And then it's found that the spectrotemporal information is also important. To do that, for each frame, the adjacent frames information are also taken into account, and their first and second order time derivatives are like computed. And they are commonly known as, the first derivative is called as delta, and the other one is called as delta delta. So suppose originally the dimension was 13 and the frame size was 100. So if one extracts the delta delta, so the original 100 cross 13 dimension representation based speech will come into like 100 cross 39, including the delta delta coefficients. So these coefficients capture the spectrotemporal dynamics. And then there are ways to do feature normalization as well. So it is done by normalizing the feature factors by taking the mean only, or at times using variance, or by taking both. So they are commonly known as, suppose if one takes mean, so it's known as like Capstrel mean normalization. If only takes variance, it's said as like Capstrel variance normalization. And if one takes both, it's called as Capstrel mean variance normalization. So it normally tries to normalize some offset value that can be there due to some channel information or background noise information. So those kinds of means information it tries to nullify to some extent. And these kinds of normalization are also found to be quite useful for improving the results under voice biometry. So this is also one of the aspects in the front end. Then let us look ahead in the like advancements in speaker modeling. So speaker modeling is the core part of this technology. So it is like the heart of the entire architecture. So I will explain many things in this slide. So what I have made, so I have made a time axis. So it lists some of the key years where some breakthroughs have happened. And I will try to give some brief overview of each of these methods in this slide. So coming to the modeling, so earliest attempts were made by using some methods like factor quantization, or some kinds of spectral or template matching. So in VQ, what it does, given a set of features, some kind of like mean vectors are learned. So it's like a code book representation kind of thing, where features are assigned to some of the mean vectors. So it is like hard assignment of mean vector. And then some kinds of like spectral or template matching techniques like dynamic time warping also are also like used in the means initial days, like about 30-40 years back. Then as the technology evolved and the research in these directions were happening, so in 1995 around, so the Gaussian mixture model was first applied under this voice biometric based modeling. So that was a breakthrough in that time. Unlike VQ based methods where it was having a hard assignments of features into the mean vectors, in GMM, as like many of us we know that in GMM we have a mixture of quotients, and a model is represented by three things: weights, means, and variance. And here what it happens, unlike VQ where it was a hard assignment of each features to a mean vector, here for each feature there is a like non-zero probability of coming from any of the quotients. So this GMM framework was a breakthrough in that time. Then as the years went through, around 2000, a new method called GMM with universal background model. It's called as GMM UBM. So it was proposed that time. So what was happening with GMM? So like at times for text independent framework, so there were not much amount of data from the users, and suppose the enrollment and the test session has many kinds of mismatch in terms of channel or the like environment or something. On those cases, the results were not that good. So in this GMM UBM framework, what it happens, a UBM is a large size of GMM itself, so which is learned using like 1,000 hours of data and from like various kinds of user to represent one average speaker information. And given the features from like one speaker, means adaptation is done from the UBM to like create the adapted models, and then these adapted models are used for the later stages for like having a claim later, so it will be like matched with the adapted models as well as the UBM. So this was a breakthrough around that time. Then like many of you have heard about SVM, which is support vector machines. So like it was applied in other applications like image, etc. as well. At the same time, it was also explored in the domain of speech. So like, so what it was that, so like the GMM mean super vectors, so like GMM mean vectors, so like using that some large super vectors were created, and then those were used in the framework of SVM to make further advancements in it, which was also quite useful for this research area. Then as the time went on, some more mathematical models came around 2007. So a new method called as like joint factor analysis, or like JFA. So what it does, so it takes the large GMM mean supervector and then like decomposed into two kinds of spaces. One is called as like channel space and one is called as like speaker space, and then try to obtain the low component variant of the speaker space, and then tries to use that factor in the framework for modeling. So this was again a breakthrough during that time of introduction of that model. And then by the same group in the year 2010, another breakthrough happened to propose a new method called I-vector, which represents identity vector in short in terms of I here. So it is an advanced version of the joint factor analysis. So in joint factor analysis, so there were two components. One is like channel and one was like speaker components. In I-vector, what it happens, so here it merges all the variabilities, and instead of that there's a like total variability space which is learned, and using that total variability space, the large GMM supervectors are projected to a like low compact dimensional space, which is called as I-vector. And this I-vector is like used to capture the dominant characteristics of that user. And this I-vector is again means advanced by having some sort of like channel session compensation at the backend as well, by using some of the methods like linear discriminant analysis or even PLDA. So this I-vector remained as a standard for many years. Even now also it's one of the like strong technologies. Then with the emergence of deep learning era in last decade, I will say, so the deep learning applications also came into speech. So some advancements over the I-vector framework happened. So where in the traditional I-vector, the posterior probabilities were like derived using the GMM. So here it was used by taking a DNN network itself. So that was the advancement, and then it was termed as like DNN I-vector. And then some other kinds of D-vector, which is like a feed-forward DNN kind of framework, were also used. And in like last 3 years back or something, so the latest method, which is called as X-vector, so this took place, and current state of the art is X-vector. So the X-vector is a like neural speaker embedding, so which is learned using a time delay neural network using several thousand hours of data from many users in a discriminative way, and the embedding before the last layer is taken as an output to obtain the X factor. And in the recent days, like various versions of X factors are like used using the ResNet or like VGG-Fox, or even using some kinds of attention like ICAPA over like the time delay neural network. So these are the basic advancements that it happened. I may not be able to list all of the methods, but the key methods over the speaker modeling that has evolved over like last 30-40 years, I tried to like show in this one slide. And then by looking in this slide, we can like divide the time period into three. The first period can be termed as like classical model era, so where more traditional kind of models were used. Then the next era can be termed as like super vector or like factor analysis era, where this mathematical modeling kind of like JFA or I vectors were mostly like dominant. And then recent years, we can say like DNN or like deep speaker embedding era. So this way the technologies have evolved in the core speaker modeling part. So this is a brief overview on the like heart of the technology. Then coming to the like backend, as I have earlier illustrated in the block diagram. So backend is like the later part of the framework. So one can do some kinds of score normalization as well. So we have already studied the featured normalization. For score normalization, there are a lot of ways as well. So one is called as zero normalization, or in short, it's called as Z norm. Another is like test normalization, which is called as P norm. And another is like Hansen dependent normalization, which is called as H norm. So let's view one by one this. So normalization is done by two things, like as we have seen for the featured normalization case, by taking some mean and variance, but how they are taken. For let's like talk about each of these one by one. For zero normalization, what it happens, so some set of non-target trials are taken, and with respect to all the enrollment models, so these non-target trials are just tested to obtain scores from each of these, and from those non-target trials, which is not part of the main set, so some scores are obtained, and then mean and standard deviation out of them are taken for reference. And whenever there is a like a given test speech and it tests with some model, gets a score, that score is normalized with that mean and standard deviation. And for the test normalization, which is slightly different from the Z norm, how is different? So it's like on the fly. Instead of having taking some non-target trials, the test speech itself is tested with some like cohort speakers which are not the part of the original enrollment set, and how the test speech behaves with those like cohort speakers. So it's observed, and from those scores also again mean and standard deviation are taken, and that is used to normalize the final score. So that is like Z norm and T norm. In handset dependent normalization, so it was more in terms of like various kinds of handsets. Suppose if one wants to use voice biometric and so for some remote authentication, one can have various kinds of handset models, right? So so what one can do, one can have a set of scores from different handsets itself, and then have some like mean and standard deviation with respect to that, and then for a given test speech one can try to normalize with it, which is called as like Hansen dependent normalization. So this is on the like score normalization part, which is also found to be quite useful for improving the results of the voice biometric frameworks. Then one can also try for fusion of multiple systems. So fusion can be done at score level. So by various means, like one can have scores from like multiple system. Like just now I explained one can use one I vector based framework, one can use some X vector based framework. With respect to each of these framework, one can get like one score, and then they can combine this. So one can try some kinds of weighted fusion as well, or one can learn some logistic regression. But to do that, one should have a like development set or something to learn the weights and then apply on the like main test set. So these are some kinds of score fusion. And then fusion at feature level or decision level is doable as well. Like one can extract multiple features from the speech itself and try to like concatenate them while modeling. That can be also a direction. Or one can do even fusion at embedding level itself, or even one can try to like have a decision level fusion itself. So there are multiple ways, but the most important thing is that fusion of multiple systems, it tries to improve the overall results. So that is why these fusion aspects kinds of things are quite used in this domain. Yeah, so then while we evaluate, we also have to know what kind of measure we like report the results. Like suppose like whether it's accuracy or something. So like some of you may be curious to know. So here the most widely used measure is called as equal error rate. So let's see what is equal error rate. So equal error rate, it basically shows the location on the detection error trade-off curve, which is called as DET curve, where the false acceptance rate and the false rejection rate, these two error rates are equal. So let us view how a DET curve looks like. A DET curve looks like the like red line, and then the diagonal line, dotted line where it cuts there. So that is the equal error rate point there. So where both the errors, the false acceptance rate and the false rejection rate are equal. So you can see from here the false acceptance rate are plotted in the x-axis and the false rejection rate is plotted along the y-axis, and then the pattern of the equal error rate is obtained, and then the diagonal dotted line where it cuts it, so that is the equal error rate point where both FAR and FRR are equal. So here there are two things again. So if so equal error rate gives the optimal threshold point where these two errors are equal. Suppose one wants to have some voice biometric for very high security application, so one will try that there should not be any false acceptance rate, means any imposter should not have any access. In that case, the equal error rate threshold point can be changed towards the high security region. Likewise, if suppose one wants to have an application for high convenience, so one can like make the threshold towards other side, so that like most of the users are not facing rejections, but there will be some false acceptance as well. So to illustrate this, like I have got a plot here just to show. So suppose here there are two curves, right? You can observe. So suppose one is the distribution of the target trial scores, and one shows the distribution of the non-target trial scores. Suppose here like there is a mark for the threshold. Suppose if that is the threshold, then the light gray area shows the miss probability region, and the dark gray area shows the false alarm region. Suppose if one tries to move the threshold, I'm not sure I am moving my cursor. Suppose here, suppose if one fixes a threshold towards here, suppose -5 or something like that in the score scale, then thing is that there will not be any miss probability, right? But there will be false alarm, means it will be a user convenience kind of framework. But suppose if one tries to fix a threshold at about like 6 or something towards here, so then what will happen? It will not allow any like imposters to pass through the framework, but some of the like target users may also face some consequences. So this is just some plot I just showed. So it's not that means original distribution is like this. So with current advancements, we get quite a good equal error rate as well. Yeah. So this is just for understanding. I just wanted to show. Then next, we would like to know also like what are the like how these results have to be like benchmarked. Like suppose when you do some research experiments, right? So one have to benchmark on some standard data sets. So what are these? Or like there are various global competitions organized for this. So we'll view through this. So mainly the standard data sets are required for benchmarking the performance of the developed systems, because if we do not have some standard data and some standard trial set, one cannot compare the results of one work to the other work, right? So that's why these standard data sets create like make a very like important role while benchmarking the results for other applications also, like means image classification or some other tasks. So always there are standard data sets to perform the task. So in this like speaker verification domain, so there are many global challenges or competitions which releases the standard datasets. So the most like predominant one is the NIST speaker recognition evaluation. So NIST stands for National Institutes for Standards and Technology. So it's in US. So they are organizing this competition from the year 1996. So about 25 years back onwards. So they started this competition, and the latest one was held last year, just ended last year. So they organized this competition almost biannually, or at times like they organize yearly also. In last 3 years they organized yearly. So like if any of you are interested to know about this, so you can look ahead for these evaluations as well. There are some other competitions as well, like Speakers in the Wild Challenge. So coming to NIST SRE, so the competitions are always addressing some sort of issues every year. So it's not the same kind of data that you get from 1996 to 2021. So it means around initial days, it was more like telephone channel data. So then they moved it to like wideband data, like microphone data. And then some other kinds of research issues were also tried to address, like short utterances, how one can have a robust speaker verification framework with a short amount of enrollment or test data. Then even some language mismatch based issues were also studied around the years 2016, 2018, something like that. And in the latest challenges, they have also included audio visual person authentication module, where the voice is used as one of the modalities with like face recognition. So all these advancements are ongoing as the challenges are held every year or in a biannual manner. Then the Speakers in the Wild Challenge, so they also created some data which is like more realistic in terms of wild environment, means the conversations in like restaurants or something where there are a lot of background noises and all. So it was held in the year 2016. There was again Red Dots Challenge. So this was like text dependent data created in the year 2016 by a collaborative way by several research institutes across the globe. And the data was collected for a time more than a year, and then was released for a challenge. And then there is like Vox Celeb Speaker Recognition Challenge as well, which tried to create a huge amount of data from the YouTube videos of celebrity interviews. So these challenges were held like 2019 to 2021. Then there was like Voices from a Distant Challenge as well, which was held 2019, where for some smart home applications, means suppose from a distant the user is there, how the still the voice biometric can work. So these kinds of like application were studied. Then there was Powerful Speaker Verification Challenge as well, which was held in 2020. I was also a part of the organizers for this challenge. So here we tried to create a huge database where we studied the multi-channel microphone array data for voice biometric and a lot of other issues. And there is like short duration speaker verification challenge, which was held last 2 years for like text dependent framework. it was not only in English, so there was some other language used as well apart from English. Yeah, so these are various challenges or competitions which one might look ahead for, like exploring this field. Then I have shown like few of the applications of speaker verification to you, like for attendance or even like for banking applications. But it has been found that these ASB systems are quite vulnerable to spoofing attacks as well. Spoofing attacks means some imposter tries to pretend as the target users. Okay, so there are various newses reported as well. So for HSBC, so they reported some kind of news. Then like it was shown that like Adobe photo voice causes a concern as well. Then there were some other kinds of news which tries to like mimic one's voice within 1 minute, and there are some other reportings as well. So all this shows that there lies threat from the spoofing attacks to quite some extent. So like that's so like let's view like what are the like broad kinds of spoofing attacks that can be there as well when we go for a like real world like application of a like speaker verification. So there are broadly 4 categories of it. The first one is the impersonation. This is the most common kind of spoofing attacks that one will try to imitate by like by mimicking as some other's voice. So that is quite common, like this impersonation attack. Then another is like replay attack. One can try to capture the voice from the target speaker in some recording device and try to replay it back to like claim as that identity, false claim as the identity. So that is called a replay attack. Then there are ways of voice conversion as well. So voice conversion is a technology which aims to convert one speaker's voice to another speaker's voice, but it's more in terms of like perceptual closeness. But still these kinds of voice conversion based speech can be also tried to use to create some spoofing attacks. Then there is like text to speech applications as well. So many of you might have used text to speech applications in your smartphones or any other platforms where you type a text and it will generate a like message in terms of some voice. But normally these voice are in terms of some means average user voice. But still there is scope to do some kind of adaptation to some like target speaker's voice, and then that can be used as a like spoofing threat. So these are some common kinds of like spoofing attacks that exist in the domain of voice biometric. Then what are their impacts? So coming to impersonation or like mimicry attacks that we have just talked over, so it shows a very less threat as reported in like many of these works. So this is a like review work on this like mimicry attack, because in these kinds of attacks, speakers mainly try to mimic some kinds of like accent or pronunciation, or like mimic the like how much pause one takes, all these things. And these are by mimicking or like replicating those things, perceptually it may look close, but like when like we extract the spectral information or any other kinds of features, so the machines can well recognize it. So mimicry attack, it doesn't show a high threat, so they show quite less threat. Then coming to voice conversion or text to speech based attacks, because they are optimized for speaker similarity and quality, whether it's perceptual closeness still, so they show some high threat. Especially the voice conversion based attacks can be a like relevant concern, because it tries to modify the speech as if it's like spoken by the target user. So like one have to be careful for these kinds of attacks. And then the modern voice conversion or the text to speech attacks, like it produce very high quality of speech, and they show quite a threat due to the kind of speaker adaptation or use of some kinds of embedding in the training network itself. And then replay attacks also show a threat because they contain the voice of the original target user only, but thing is that it's the recorded speech. So the means if one wants to stop that kind of attack, so one have to have some countermeasures which can find out the replay attacks. And suppose for text dependent kind of framework, the attacker has to record the exact speech or the lexical information from the target user so that it can try to attack. Otherwise, for text independent means any kinds of speech of the target user can be recorded and one can try to attack. So these are some kinds of impact that the spoofing attacks have on the automatic speaker verification. Due to this, the research on the spoofing countermeasures emerged in the last 1 or 2 decades to prevent such attacks as well. So even many companies which already have their voice biometric application, they tried to develop spoofing countermeasure. As this news says, Nuance have developed their anti-spoofing or spoofing countermeasure method to detect the synthetic speech attacks, means the attacks derived from the voice conversion or the text-to-speech methods. And then there is a community-driven effort which is called as ASB Spoof Challenge, Automatic Speaker Verification and Spoofing Countermeasure Challenge. So this is the website details, and this challenge is held from 2015 year, means every biannually it's being held. 2021 was the 4th edition held last year. So this challenge tries to spearhead the field on spoofing countermeasures to prevent various kinds of spoofing attacks, like from voice conversion, text to speech, or replay attacks. So I'll not go through much details of the spoofing countermeasures because it's again a large field to be discussed, which may not be doable within the scope of this talk. But I will give a brief how it can be done. So spoofing countermeasures are generally used in tandem with the ASV. So how they are used? So there can be a spoofing countermeasure first. So for a given speech, so the countermeasure can be first invoked to assess whether the speech is a real speech or a fake speech. Fake speech means some created using voice conversion, text to speech, or replay attacks kind of speech. So if the countermeasure aim is to that, it should only pass the real speech and then it should pass that to the ASV framework to do the next set of voice biometric authentication. And the countermeasure should reject the other kinds of fake speech. So that's why this illustration shows here. It's in tandem. So first it happens that the countermeasure will either accept or reject in terms of real fake assessment. And if it's a real speech, then only it will go to the ASV for the voice biometric application for accepting or rejecting the claim. And if anyone wants to know more details about the spoofing countermeasures, please go through this work. It's a good review work which details about what are the spoofing attacks to voice biometrics and what are the countermeasures. And there are lot of advancements as well. So recent state of the art has been evolved to build robust countermeasures which can stop multiple kinds of spoofing attacks. Then now we are almost towards the end of the talk. I would like to also highlight some of the other related research directions with respect to voice biometric. So one of the direction is speaker diarization. So speaker diarization, what it does, it tries to find out who spoke when. So suppose there is a meeting is ongoing, there are 10 people conversing one after another, or suppose there is no regular way something, but who spoke when, apart from doing the authentication, the time instance who spoke when, that to be find out. So it is done by the speaker diarization, and it's also a very relevant research area which is used for many applications like meeting recording. Suppose automatic speech recognition is one thing, that suppose it obtains the transcripts, then suppose one has the speaker diarization methods also, so one can align the transcripts in terms of each of the users of that meetings, so that the minutes of the meetings may be also made in some automatic way in terms of like each of the users. So this is also a very emerging field, and it has been explored means over the globe. And there is voice conversion, which I have already said, to convert one speaker's identity to another speaker, and like this is used in many kind of applications as well. Like there are audiobooks where these kinds of voice conversion is used, and even like movie dubbing or something, dubbing industry. Suppose the actual actor's voice will be there, but his pronunciation may not be that well in the other language, so some other speaker will do the real dubbing, but then to retain the voice characteristics of that actual actor, so this voice conversion methods can be used to do like transfer of the voice characteristics onto that like dubbing voice. So this is some kinds of applications of voice conversion. And then speaker anonymization is another thing. So in the like recent years, the privacy of users have become a high concern for everyone. Like face, like our images or snaps are also of privacy. The voice should be also of our privacy concern. So there are methods which aims to anonymize the voice. Suppose now I am delivering a talk, but suppose most important is what the message of the talk, not my voice characteristics. So what it can be done, suppose one can try to anonymize my voice characteristics by converting it into some average user voice kind of thing, so that my user characteristics or my voice characteristics are not revealed to anyone for my own privacy. So these kinds of research directions also exist, and it's quite useful as well. And then yeah, there are kinds of, apart from the like traditional spoofing attacks that I have talked, so there are even kinds of like adversarial attacks kinds of things, which can be which are quite popular in the domain of image for speech or voice biometric. It has not been explored to that extent, but in recent years they are emerging. So attacks can be also performed by having some kinds of black box, gray box, or white box kinds of methods which show eminent threat. And there are always, when there is some bad guys, so there are always good guys, right? So likewise, there are like defense mechanisms to like prevent these kinds of adversarial attacks based threats as well. So these are some other directions. And then the multimodal authentication. So like the voice can be used as like one of the modality as well, like with face or other recognition, so that the two modalities are used to recognize the accuser. So nowadays, like in many countries, if you like travel, so they use like face or like thumb impression altogether to have this immigration access. Yeah, so like multimodal authentication is also widely used, and even some like I have seen, like I have experienced some of the hotels like which where you have to like enroll your face and some thumb impression, and then you can have the access of the rooms. So like this multimodal authentication is also like trending like research direction, and it's already used in many applications. Yeah, so these are some of the research directions that are related to voice biometrics that I tried to cover here. And coming to the discussion and summary, so like what should be our take-home message? So we found that the speaker verification is a useful biometric measure for access control and forensic application. Then we found that this research area has advanced over past several decades, as we have already seen. For the front end, there are many kind of representation. For the core modeling part, we have seen from VQ, then GMM, UBM, then SVM, joint vector analysis, I vector, X vector. All these things are like emerging from like one time period to another. So it has like advanced a lot in last few decades. Then we also found the practical ASV systems are vulnerable to some kinds of spoofing attacks as well. And that's why we need some kind of like spoofing countermeasures to prevent such kind of attacks for practical applications. And then lastly, we found the knowledge of automatic speaker verification can be used beyond the voice print technologies for other applications as we can view like multimodal authentication or speaker diarization. So these kinds of applications also, these kinds of technologies or modules of these technologies can be used to have some other kinds of application. Then lastly, I would like to share some of the implementation resources if anyone would like to like explore this field more for their like PhD research or even like post PhD research for some project grants or something. There are tools available to start off. So one tool is called as Elise. So it is slightly like it's about 10 years back or something maybe, but like it still has implementation of like GMM, UBM, or even iVector. So one can view this from this link. And there is like Kaldi. So this is one of the quite popular tool. So here the link is given here. So the Kaldi tool was mainly developed for the automatic speech recognition applications, but like later, like various kinds of other applications, including the like speaker verification recipes are also included. So it was, I think, released in the year 2011 around. So this has a lot of like speech analytics based application. I'm sure if anyone wanted to interest, like once you explore, like you will like this tool. And recently, last year, a new tool called Speech Brain. So this is like released. So this is done on a like large collaborative effort. So like it also has various kinds of new recipes, including voice biometrics, speaker diarization, automatic speech recognition. So a lot of speech applications. So it is quite new tool if you want to use. So it's even not even 1 year also. I think last year April around it was released. So you can have a look if you are interested from this link. And then coming to the database, as I have said, the databases are quite important if you want to do some research work. So like but thing is that databases, some are licensed, which you have to purchase it with a large amount of like money. Some of the licensed databases are the necessary databases, which is in the text independent modality. Then the switchboard databases, which is again text independent. Then there is like RSR 2015 database, text dependent databases. So these are licensed database where like purchase is required. And there are like publicly available databases as well. So recently these are more like about 5-6 years back, these were not many, but now with like a lot of groups starting this research and like means expanding the technologies. So these databases are also more. So I'll list some of these as well. Like so like one of them are like Voxelab 1 and Voxelab 2 databases. So these are in the text independent modality, where this database is collected from the YouTube videos. Then there is like Speakers in the Wild database, SITW, and for text dependent there is like Red Dots. So if one wants to use the free databases, so you can explore these kinds of database to try out hands-on in this field with the like some of the tools that I have said now, like Elise, Kaldi, or even the Speech Brain. So these kinds of tools can be used over these databases to get a hand on, and then like you can explore from your own research ideas as well. Yeah, in this field. So lastly, I'll share a few relevant overview papers which you can read, which are related to this field. Some are in like late 90s and rest are recent. So these will give you like more details of the speaker verification in terms of like text dependent or text independent, or some kinds of like applications in terms of short utterance, or even the spoofing countermeasures, and what are the kinds of attacks, and even the kinds of adversarial attacks. Yeah, so these are some of the relevant works you can go through. yeah, I mean, to learn more about this field. Yeah. So lastly, I will just share my contact. This is my email address. I have a like website. So that's all. Thank you. I hope like you could know some of the things from this talk. Yeah. Thank you.
Thank you so much. Thank you so much, Dr. Rohan, for this wonderful presentation. And I could see it's an account of development in last few decades. And of course, you have given a lot of new directions to the participants. I hope it will benefit all. And we have few questions in the Q&A. Let us take one by one.
Okay. Let me see the tab. Okay, so first someone asks which tools are used to extract voice features. Okay, so there are some tools as well to extract voice feature, or one can write their own codes as well to extract MFCC. So if you search for MFCC, I think there will be a number of like repositories you will find out. So I think I already shared some of the tools towards the end of my talk, like Kaldi, Elise, or SpeechBrain, all this. So all these tools will have feature extraction part as well. So you can try to use these tools to extract this. And then apart from that, there are some tools itself which are used to extract features only. So there is a tool called OpenSmile. So this OpenSmile tool is used to extract like 1,000 set of like features. You can see like pitch and all these things are also there. Yeah, so that is also another tool. But like if you want to work on some application, then you can directly use the tools that I have told. Those can be used as well. Then the next question is that is spectrogram slow pitch frequency harmonic? Is spectrogram show pitch frequency harmonic content? Yeah, so spectrogram is a like 2D representation. It's a like time frequency analysis. So one axis will be time, x-axis, and then y-axis will be the frequency. Means I'm sorry, I did not included any image, but I think I should have shown one so that it would have been more clear. But yeah, I think you can make a search. You can find out. So it will show all the harmonic components as well. Then the next question is how does GMM UBM speaker verification system perform based on different amount of data collection for true speaker mode? I don't understand the true speaker mode. What do you want to say? But like suppose in GMM UBM, as I have explained, so first one aims to learn a UBM, which is called as like universal background model. So UBM is a large GMM actually, which is like learned using like 1,000 hours of data, or like from many users, like 100 speakers, 200 speakers, so that lot of variabilities of speakers are covered. Not only the speakers variability, but also various channels through which the recordings are done, various sessions where these recordings are done. Then like after creating the UBM, which will be like represented in terms of the weights, mean, and variance. So given the features of a user, means irrespective of the amount of data, whether it's like 10 seconds or 20 seconds or like 1 minute. So what it will do, so it will, according to the feature distribution of that speaker's features, it will try to adapt the GMM. Suppose if one wants to try only the mean adaptation, so the means of the GMM will be changed. Other parts will be the same, something like that. So that's how it is done. Can Capstrum act as a spectrum? Actually, Capstrum is the opposite. If you can see, this Capstrum word is derived. If you see spectrum, SPEC, so caps is derived in the opposite way, CEPS, Capstrum. So it's on the capstral domain. So it's derived using some kind of inverse transform. So if you read details more about MFCC or something, so then you will try to come to know about this. So someone have asked how to identify a singer from a song in Indian context. if there is any Indian data sets exist apart from niche speech data set. Okay, so like for Singer actually, so there is another like specific field which is called as Singer identification. I have done one work on this. I can share you the link of that work. So I did it in the year 2019. So there is a database called Artist 20 database. So these are not means Indian singers data, of course, but like these are some renowned like worldwide singers data, which is a standard database. So to identify a singer, suppose if it's a like polyphonic song, which suppose where the singer's voice will be also there, and apart from that, suppose the music is also there, then it has more challenges. So then one have to do some kind of like source separation to take only the voice part of that singer and then try to model. And for like in terms of features, one can try with MFCCs or something for sure, but for those kinds of applications, there one can try some other kinds of representations which are like chroma features or something as well that I know. So one can try. If there is any Indian dataset exists for niche speech and niche speech, yeah, of course, yeah, I have not listed. So while I was doing PhD in IIT Guwahati, so like we created like two sets of data sets in the last like 10 years back around. So I can share you some link on that. So those are freely available. So like you can obtain by requesting them. So like one was the like multi-variability speech database in Indian like recordings, and another was like multimodal database. I can share some links. And then one question is that what are the deep learning models used in verification? Why deep learning better for this application? Okay, deep learning, I think already I explained while I explained the modeling part. So till I vector, it was like more mathematical. Then it came the DNN I vector, where the posteriors were used from the DNN models, and then the recent state of the art, which I explained, the X vector. So this is a deep learning model itself. So this is the like time delay neural network model where the embedding is taken from the layer to the last layer. Yeah. So that is a like deep learning model. And why you ask like why DL does better? Yeah. So so like deep learning models, it is more robust to like noise, or like when it's like more uncontrolled environment. When it's clean environment, so then suppose I vector kind of model can also work well to some extent. But like these deep learning models are more like robust to like noise or like changes in environment and all these things, like because these models are learned itself in a like discriminative manner, whereas other like GMM or iVector, like these are more like generative model. Yeah, so that's why. So I hope only this set of questions, and I can maybe post some of the database link. I don't know like till when this chat will be available. Yeah. Or like you can I think go to my website. There are some links of the database that like we have created. Yeah.
Dr. Rohan, thank you so much. You responded all the queries. Yeah. But I have a simple query, sure. Like, you know, all these devices, as you explained, can be compromised, right? There are a lot of different types of attacks also.
Yes, yes, yes.
So in practice, what is done? You know, is it like is there any hybrid model where, you know, multiple biometric can be used, or?
Oh yes. So as I have shown towards the end of my slides, so it depends. Suppose if one wants to use voice only, one can use voice. But it depends like what kind of application. Like it may be like low security, like suppose attendance. So for attendance, suppose it may not be like high threat. Suppose if any imposter is also there, right? So there one can try to have only voice as means authentication. But in order to stop like various kinds of like spoofing attacks that I have talked towards the end of my talk, so there should be a module just before the main voice biometrics technology, which is a spoofing countermeasure. So the countermeasures work should be first to assess whether a given speech is a like real speech or a fake speech, And then only if the countermeasure recognizes that it's like real speech, then only it will go to the main like voice biometrics module, and it will do the task of it. And for multimodal, yeah, it's used already. I have experienced multimodal biometrics in some hotel rooms or something recently, where like first one have to enroll with the voice and face and to access. And in some of the labs when I earlier worked in like National University of Singapore, so there like we had one lab called like AI speech lab. So there we had to enroll there with our face, and like we had to like enter with our face. So that was means another application of face, but like voice can be also used. And like we have also developed some kind of like attendance application like while like I was in IIT Guwahati. So there are some works as well with respect to that. Yeah.
Yeah. Okay, thank you so much once again, Dr. Rohan. And I hope the participants who are interested can further collaborate and communicate with Dr. Rohan. And we look forward to future collaboration. And of course, we invite whenever you have time and, we visit Assam. Do visit Mizoram also.
Yeah, sure.
Okay, then thank you so much.
Thank you so much to all of you as well. Yeah.
I have a small announcement for our participants. Actually, the next session that is to be scheduled at 2:30 has to be preponed by half an hour. That means today's second session will start from 2 p.m. Actually, our speaker, Dr. Asif Iqbal, he has some other assignment. So he requested to prepone a little bit by half an hour. So I think after lunch, we will start sharp 2 p.m. Okay. Thank you all. Thank you, Dr. Rohan.
Thank you. Thank you so much, all of you.
Yeah.
See you.
Okay, then. Bye-bye. We can log out now. So, dear participants, ladies and gentlemen, I have the privilege to introduce one of the distinguished speakers for today, Dr. Asif Iqbal. He is currently an associate professor in the Department of Computer Science and Engineering, IIT Patna. He has authored around 200 papers in top-tier conferences like ACL, EM, NLP, Calling, NAACL, and journals like SCM Transactions, IEEE Transactions, PLOS ONE, etc. Dr. Asif has been involved in several sponsored research projects funded by the different private agencies such as Elsevier, Accenture, EZDI, LG, SkyMap, Samsung Research, Wipro, Flipkart, and government agencies such as METI, Government of India, MHRD, Government of India, and SERB, Government of India, etc. He has been serving as an area chair, PC member, and a reviewer to several well-known conferences. Area chair, ESCL 2021, NAACL 2019, area chair on QA, senior PC member of IJACL 2019-2020, PC and review committee of conferences like ACL, EM, NLP, then CNLL, IJCNLP, Calling, NAACL, AAAI, AJCAI, etc. He has the associate. He is the associate editor of Sadhana, Springer Nature, Computer Science, Springer, and Machine Transaction Springer. His name is listed in the top 2% scientists published by the Stanford University findings in Elsevier. He is an awardee of Best Innovative Project Award from Indian National Academy of Engineering, Government of India, JSPS Invitation Fellowship from Government of Japan, and Young Faculty Research Fellowship Award of the Government of India. Dr. Asif Asif's publication faced 5,783 Google Scholars citations with H-index 39 and I-10 index 159. And today he is going to speak on deep learning for natural language processing. We are very fortunate that such a distinguished speaker is amongst us today. I hope all the participants will benefit, and I appeal to all the participants to concentrate and put their queries in the Q&A section. With these words, I welcome Dr. Asif. Dr. Asif, please go ahead. Floor is yours. Yeah, your screen is visible.
Oh, sorry, there was a call, urgent call. So, okay, thank you very much, Professor Jamal, and for this introduction. And I am really grateful that we have this opportunity to speak in front of all of you. I have selected my topic as deep learning. So, am I audible? Can you hear me? Hello. So, Professor Jamal, can you hear me? Hello? Hello? Anyone? Okay, so I'll talk about deep learning for natural language processing, and this is what the outline is. So I'll briefly introduce you the area of artificial intelligence, natural language processing, and machine learning. Then I have taken two very popular area of natural language processing. One is that sentiment analysis, the other one is the conversational AI. I cannot talk in much details, but I'll try to show you that what we have been doing, what are the current state of the art research, and also the another interesting topic, if the time permits. I will just show you that the machine translation. So there are three specific areas. One is the sentiment analysis, one is that conversational AI, and the third one is the machine translations. So if you see that the AI, artificial intelligence, and its various components, then you can see that AI has different components, like in the central part, this particular circle, if you see, there are three important components. One is the search, then you have the knowledge representation and reasoning, and the third one is the machine learning. So, and in the outer periphery, you can see several application areas like natural language processing, computer vision, robotics, planning, expert systems, etc. Well, now, when we want to build any AI systems, so we have seen that search plays a very important role. Now, the search can be both, either search can be an uninformed search, or it can be an informed search, or it can be a local search. Like, for example, breadth first search, depth first search, etc. All are the uninformed search. Okay, because when you do the searching, we only take care of what you have seen. Okay, in the previously. That means, let's say, if you represent the whole search as a graph, then given a particular point in uninformed search, we always focus that what has been the best path to reach to that particular node. we never see that what will be the future cost. Future cost, that means, let's say, if you take certain steps, okay, in a particular directions, whether that path will be more expensive, or if you take another alternative path, path 2, that will be more expensive. So that means you have a desired goal. We want to reach to the goal. And in our life also, we always do that. So for example, if you go back to how you have reached up to this level, and then you can do some kind of, let's say, optimizations, okay, that to decide that what has been your journey so far. Now, if you have a very well-defined goal in your career, in your future, and you have multiple options to reach there, we always estimate that what will be the best way to reach to my goal, right? So that inherently in our cognitions in the human, we always do. So that means the humans have a natural intelligence by which you can estimate something about your future. You cannot accurately predict about your future because that is impossible. But if your goal is well defined, then at least you can design your, let's say, steps, design your path in such a way that will ultimately help you to reach to your destinations easily. So these kind of search techniques are has a component which is the heuristics, we call, and you have to combine these heuristics plus the backward cost, like the uninformed search, to make a search process, to build a efficient search process, which is famously known in artificial intelligence as the A-star search. Okay. Then we have also local search. If you have a huge search space, how can you introduce randomness into the search process? Okay, so like hill climbing, simulated tunneling, etc. All these are the local search process. Then machine learning has the ability to quickly adapt to the new applications, to the new domain. So for example, like human, we learn from our experiences, whether machine can learn from the experience, from the data. Okay, that is what is the machine learning. And all these three components, that search, machine learning, and the third, the other one is the knowledge representation and reasoning, which is the very classical way of solving a artificial intelligence problem. Okay, so what do you mean by the classical way? So you can think that every thing will be represented by a symbol, and there will be some kind of relationships between the symbols. These will be stored into a kind of knowledge base, and there will be a kind of a reasoning process or the inference process. And the task of the inference process will be to operate over these knowledge bases and do the inferencing. Okay, so like in programming language, you do that if then else kind of situation. So knowledge representation and reasoning, you can also think that it is a kind of stored knowledge base. You have an inference process. The inference process will run over it and then will help you to derive a very effective, you can say, that conclusions. That is the reasoning process. So for example, if you say that, okay, every man is mortal, so then let's say Confucius is a man, so Confucius is mortal. So you see that how can we represent these three different facts into the logical notations, like predicate logic formula, propositional logic formula. So you have to represent everything as a symbol. You have to store them into as an implication operations into a knowledge base, and then you can do the kind of inferencing. Okay. So this is what is the classical way of solving the AI problem. But these days mostly are populated, or you can see that we are more these days, if you see most of the research, most of the development that is happening, mostly are based on the machine learning. Okay. And whether you are solving a natural language processing problem, or a computer vision problem, or a robotics problem, or a planning problem, or expert system problem, So you need the search process, you need either machine learning, you need either a logical systems. Okay, so because these three components, because of that reasons, are staying in the central part, and based upon that, you can build different solutions. So in my talk, mainly I will discuss about these two different aspects, that is natural language processing, which is an applications that makes use of the search, that may be based on the knowledge representation is reasoning, but my discussion mainly will be based on this machine learning. So how this machine learning and NLP interact with each other, okay, to build a robust systems, that actually we'll discuss. So now let's see that what is this natural language processing. So you can say typically natural language processing means you have to process the language, you have to build the systems that can accept your spoken language as an input. The machine should be able to do some kind of understanding, and then it should be able to derive a conclusions out of that. Okay, so to give you a desired output. So that means you want to build a systems that can understand the human language, which is a very more difficult problem. Because if you historically, if you see that Alan Turing test, okay, in 1950, the Alan Turing test was also based on that natural language question answering test. There were a set of questions which were asked to a machines, and these were asked to another human. Now the responses received from the human and the responses received from the machines were actually analyzed by another human expert. But human experts were not told which responses are coming from the machines and which responses have come from the human. That the third party is not told. So let's say you are responding, a computer system is responding. Then I give both the responses to another person and ask them to, can you discriminate these two things, that which is coming from the machine, which is coming from the human? Now, if the third person, who is a human expert, an intelligent person, if that person is not able to discriminate these two responses, that what is coming from a human, what is coming from the machine, then you can say that the way your machine has responded is almost like the human being, because another human expert is not able to distinguish it. So that was the task of, let's say, the Alan Turing test. And one of the very fundamental problems that it was identified at that point in time is how to solve it. Okay, so how to solve that problem. And this processing of language was one of the tasks. Okay, that how it was thought that if the machine can understand the human spoken language, then the machine will be intelligent. Now the question is how machine can understand this human language, okay, the spoken language, because you cannot talk. If you talk mathematically with another person, or when we let's say when you are engaging in yourself into a conversations with your friend, with your family member, we don't discuss in a mathematical way. We don't talk in a mathematical notations, but the computer system understands the mathematical notations, right? So everything is encoded in terms of bits of information. But as a human, we understand the spoken language, the language that where we are more comfortable in. So there was a necessity historically to build the models, to build the systems that will understand this language very well. And there is the beginning of natural language processing, you can say, because the natural language processing deals with building the computer systems or the systems that will enable the human to communicate with the machine in their own language. So there will be a science part to that. Science part is basically how the language phenomena happens. So for example, how a particular sentence is constructed, how a word is constructed in a language, what kind of grammatical category a particular word in the language has, what is noun phrase, what is verb phrase, how can you do the parsing of the input sentence, then what is the meaning of a particular word, So these will be all the cases of, let's say, natural language processing. So you have to understand, so as you can see in the left part, so these are the different layers that you have to perform. You have to do the morphological analysis. Now, what is morphological analysis? You have to know that how a particular word is constructed. Okay, so for example, if you say it is computers, then you have to know that computers is a word which is originated from the word computer, and computers is the plural form. Now it is noun. Okay, so this kind of information, so you have to get through the morphological analysis, then part of a speech tagging. That means every word will have a grammatical category. Chunking is basically designing the phrase. That means combining more than one words together. For example, noun phrase if you say, verb phrase if you say. So noun phrase is basically adjective followed by a noun, verb followed by let's say auxiliary verb followed by a main verb is a verb phrase. Then the parsing, for example, once you had identified the noun phrase, verb phrase, etc. So what kind of syntax you are following? How can you build a kind of parts tree? Like in formal language you have seen, so you have to build a kind of parts tree. Then the semantics is coming, that what is the meaning of your word? That is very important. Let's say if you say bank, bank is a word. Now the word bank can have multiple meanings. It can be a bank of the river. It can be a financial institutions or organizations from where you can draw some money. Now, which is bank, which is, let's say, which one is the financial institutions, and which one is the river bank, that depends on the particular context where this has been used. Then the discourse and the coreference, which is a more higher level task. Okay, and as you can see that this complexity of processing will keep on increasing as you move from this lower level to the upper level. Okay. So this has a lot of similarity with how a compiler actually works. Compiler, if you want to build a compiler for a language, compiler also works in a layered fashion, starting from lexical analysis, then syntax, then semantics, then pragmatics, then intermediate code generation, then code optimizations, then finally the code generation. So these are the different steps that we follow in compiler. In NLP pipeline, you also follow the quite similar steps, okay? And as you proceed from the lower level tasks to the higher level tasks, the complexity increases. Now this whole territory of NLP can be represented by these three-dimensional problem. So you can say that, okay, in one dimension, you have the different languages like Hindi, Marathi, English, etc. In one dimension, you have the different problems like morphology, part of speech tagging, parsing, semantics. In another dimension, you have the algorithms, the way how you can solve these problems. Like, for example, hidden Markov model is a efficient algorithm, maximum entropy Markov model, conditional random field, recurrent neural network. So these are all the different models, okay, that you can use, okay, to solve a problem of parsing, okay, to solve a particular problem of parsing, let's say in Hindi, let's say in Marathi, let's say in English, let's say in French. So that means you can choose a problem, NLP problem, for any language. And then you have to come up with a suitable algorithms to solve that. Algorithm can be a rule-based algorithm. Algorithm can be a machine learning based algorithms. Okay. So now, why this is important, the natural language processing in India? If you see that India is multilingual, we have many languages, spoken languages in India, and they are derived from most of the major language families like Indo-European, Dravidian, Sino-Tibetan, Austroasiatic, etc. And some of these languages are ranked within top 20. For example, Hindi, Bangla, Marathi, etc. there are large number of populations in the world. So this is some of the statistics. So we have 22 official languages in India and 122 major languages, approximately 1,600 other regional languages, 13 scripts we have, 720 dialects, 13 languages are spoken by more than 1 million native speakers. And there are 122 languages which are spoken by more than 10,000 people. But unfortunately, only 20% of them can understand English and 80% cannot. Now, what is the solutions? So how can you say that the Digital India, for example, will be successful until without giving access to these 80% of the people, all kinds of informations? A farmer from the very rural area, they have their own Android phone because these days these are very less cost effective and everybody can afford for that. But what is the problem with this? Where the people can use it with their greatest comfort. And if you want to ensure that they should be able to make use of it, then language is the barrier. The person, let's say a farmer, if he may want to know the weather conditions, he may want to know the market conditions, the prices, okay, of pesticides, etc. So how that person will come to know about all these informations through his, let's say, Android services? Most of the information are available in English. So now, if he wants to get it in his own language, then only it is possible if we can enable these services in non-English languages, in the language that the farmer understands. Okay. So this is very important. And there, the natural language processing will play an important role, because natural language processing will allow you to develop the models, develop the systems where the people can communicate, can access their desired informations in their own language. Okay. So this is what is the necessity of natural language processing. Apart from that, also, you have seen that there are phenomenal growth in the number of internet users these days. So, from the Facebook, from the Twitter, from different other e-commerce portal, huge number of contents are being generated every day. Okay. And there also that if you want to make this available to the people in their own language, then NLP, natural language processing, will be important. Now, if you see these three areas, that AI, natural language processing, and machine learning, that how this field has actually progressed. Some of the applications you might have witnessing these days, like for example, Google's powerful search engine, where you can give a query and you can get the relevant informations. Then let's say Alexa chatbot. Okay. Translation services of Google. You can input any particular content. Let's say if you are traveling to Japan, if you are traveling to China, if you are traveling to Europe, many languages you don't know. So how to translate those informations? Google provides a service of machine translation that can actually help. Fake news, misinformation detection is important. Mental health assessment, processing social media text. So all these are very important applications. Now, in terms of algorithms, if you see that earlier, most of the algorithms were based on shallow machine learning algorithms, where the features used to play an important role, like hidden Markov model, maximum entropy, conditional random field, support vector machine, logistic regressions, etc. But these are very time consuming, because the person who is developing the model, the person will have to sit, will have to understand the problem very well, will have to understand the features very well, and then only the person will have to input them into the models. Okay, so Now, in case of today's machine learning, if you see, so it is dominated by deep learning. So you don't need to do any kind of feature engineering. You don't have to worry about what are the important features to solve a particular problem. Rather, you can, if you have lots of data about that particular problem in that particular, to solve that particular problem, then the issue will be how can you represent that data following different ways. For example, distributional semantics representations, okay, is one of the very effective way to represent each and every word of a particular NLP sentence, every document. So these distributed representations will play an important role. And there are a lot of advancement has happened. For example, Word2Vec, Glove, Elmo, BART, etc. So this kind of distributed representations are these days available, which are very important for solving the NLP problems, to represent the NLP text, the words of the text. Okay, there are a lot of advancements that happened in terms of algorithms like convolutional neural network, recurrent neural network, recursive neural network, transformer, reinforcement learning, etc. And also there is a necessity to combine that deep learning as well as the memory-based techniques. Now, all these growth of deep learning, on the one hand, has facilitated in developing many important solutions, okay, in less time without much effort. But the problem of deep learning is that the interpretability, the explainability, because you don't know that how good is the model. Okay, what is the if you get a very good result, and if you want to understand why the good result is coming, so what are the intermediate features that are responsible for this, then this interpretability, this explainability is very difficult to get. Okay, so because of that reason, there has been a recent trend in artificial intelligence in the form of explainable AI that majorly focuses on the explanation part of a particular system, a particular model. Then there has been the other areas of AI. For example, mostly the AI solutions these days are the narrow AI. So that means mostly it can do, in most of the cases, it can solve the single task at a time. So now if you think in terms of the human intelligence, which is, you can say it's an artificial general intelligence, as a human, you can do multiple tasks at the same time, right? Whether a machine can do the multiple tasks at the same time. Can we exhibit that kind of behavior into the systems? Can the machine exactly can mimic the human intelligence? Okay, in terms of solving the problem, in terms of solving the problem, more than one problem simultaneously. So these are all the issues of artificial general intelligence. Then also the AI researchers are thinking about artificial superintelligence, where in many aspects, this may even surpasses the human intelligence. Okay, that let's say in science fiction movie, you might have seen a very supernatural power that can probably destroy the whole world, that can do everything for you. If you give some kind of, let's say, some instructions to a robot, to a machine, and if the robot can do everything for you, whatever you want, that you cannot probably do, then we can say that the machine has become more intelligent than the human. Okay, so can we achieve to that particular level of, let's say, level of wisdom, level of intelligence? So that actually is very important. So whether the machine can create, so whether it like human, so does it have the creativity? So for example, like human can solve very complex mathematical problem, whether the machine can solve it. Even machine can, let's say, can you create a story? Can you create a poem from the machines? Okay, through artificial intelligence. So these are all the very exciting problems of natural language processing, artificial intelligence. Okay. Now, there has been, for example, a lot of modern AI because of the pioneering research. These 3 persons, Bengio, Hinton, and Likan, were given the Turing Prize, which is the highest prize in highest coveted award in computer science in 2018 for their modern artificial intelligence, which is mainly dominated by the deep learning and the neural network. Okay. So let us move to this discussion to the 3 topics that I mentioned that that I'll give you some ideas about the 3 important problems of sentiment analysis, conversational AI, and the machine translation. So now in sentiment analysis, typically what you want is that it deals with identifying the orientation of opinion mentioned in a piece of text. Okay, that means if you know that a piece of text is, let's say, if you have a reviews written, okay, about a particular product, okay, then you express your own opinion, right? That means whether you have liked the product or not, which features you have liked, which features you have not liked. So those kind of discussions we write in the review. Then political party, let's say Twitter, if you see that which particular party to vote. So again, it is based on some kind of opinion. So you see that this opinion, so of our opinion plays an important role while we take different decisions in our life. Okay, and this is not very new because this has been an important piece of information for a long time. Okay. For example, as I mentioned, if you go back to our previous generations, your father, your parents, or their parents maybe, how they used to take decisions. They also used to take a lot of decisions. They used to go to the school, they used to go to the college, they used to go to the universities, they used to buy, let's say, a lot of products like televisions, cars, etc. Okay, they used to watch a movie, they used to vote for the political party, but how they were influenced by the different opinions. So at that point in time, there was not much popularity of the internet. Okay, so they used to communicate or take the opinions of their parents, guardians, teachers, or their friends who already have availed the services. Let's say if they wanted to buy television, they used to ask that, okay, to their friend or to their seniors or to their some other person who already have that kind of televisions, that, okay, about its features, about its longevity, about its different, let's say, other attributes. So, but these days, what do? We merely ask. Okay, so let's say if you want to go to a university, you have a lot of information available about that university, about its strength, about its weakness, about the particular department. You already know. If you want to watch a movie, you don't ask to your friends. So you have plenty of reviews available about that movie. And that actually influences us to decide whether to watch that movie or not. You want to, let's say, vote for a political party, lot of advertisement, lot of, let's say, tweets, etc. You can see, and that actually can influence you to vote for a particular party. You want to buy something, you search it in the web, you'll find plenty of reviews written. Now, based on that review, you can decide, you can form your own opinion. right? So you see that these days we don't really do the physical interaction. Rather, we have all kinds of information available before us, and we can get it easily from the internet. And based on that, we actually decide. But now what can be the problem in today's world? The problem will be like we have lots of informations. Now, which information is genuine, which is not genuine? That decision you have to make. Then you have to also see that which information to take and which information to ignore. Because you have, let's say, for example, in this case, you can see that a particular person needs to buy a phone. He was browsing Amazon.in and found 1,000 reviews for a particular phone. Now let us assume this particular scenario in the left part, where you can see that there are 850 negative, 100 positive, and 50 neutral reviews. Okay, so out of 1,000. Now overall you see that 850 are negative. So what we can say? We can say that in this scenario, the overall sentiment is negative. Okay, but on the right side, you see in the second scenario, there are 420 negative, 480 positive, and 100 neutral reviews. Okay, so now in this case, what will happen? In this case, you can see that, but in this case, let's say in the left part, out of this 850 negative, 100 positive, and 50 neutral review, when the user reads these reviews, okay, let's say as an end user, as a customer, you are reading these reviews. And if you see these reviews are written one after other, and at the beginning, if you find that all these 850 negative reviews are appearing at the beginning. So as a user, what you will do? So you will read the first review, you will see that, okay, it is negative. Second review, again negative. Third review, again negative. Fourth, again negative. So likewise, maybe you will read 100 reviews. And then you will see that, okay, out of these 100 reviews, all are negative. Then you will form your opinion that, okay, I have read 100 reviews. And let's say for this, all this positive one, if this positive one are appearing, then you see that, okay, I have read this 100 positive reviews at the beginning, and most of them are positive. So I form my opinion as positive. But that is not true, because after this 100 review, if you have the time to read the remaining reviews, you see that 850 are negative. Now this 850 are negative means what? So 850 are negative means, you see here that this we are missing, because as a customer, you don't have time to read all these 1,000 reviews. So you have read only this 100 positive reviews that appear at the beginning, and you have formed your own opinion. Okay, and you have missed the 850 remaining negative reviews. Okay, then you can form your own opinion as negative. So sentiment as negative. Okay, in the second scenario, you can see that there are 420 negative, 480 positive, and 100 neutral reviews. Now in this case, that overall that 480 are positive. So we can say that overall the product will be positive. Now what will happen in the situations if you find that, okay, out of these 480 positive reviews, if 100 of them are not genuine, so they were written intentionally, okay, they are actually fake, they are actually biased, then what is going to happen with these 100 reviews? So that means out of this 480, 100 are fake. So if you take them out, eventually you have only 380 positive reviews, which is lesser than these negative reviews, number of negative reviews. So you can see here now that there are the ways where this information we are missing because 100 are actually biased, and we have missed for that. We have missed those particular information because we don't have any way to judge that those 100 are actually biased or the fake. Okay, so this is the reason why you have seen that there's plenty of informations when we have before us that also is causing a problem in forming our own opinion. Okay, so now think about, let's say, rather than reading them manually, if you have an automated system, a system where you can pass all these 1,000 review, and in a second the model can tell you that, okay, out of this 1,000, 100 are positive, 50 are neutral, and 850 are negative. So as a user now, I don't have to read them manually. Rather, immediately I'll get the informations that out of 1,000, 100 are actually positive, 850 are actually negative, and 50 are actually neutral. Okay. So then this kind of situations will not arise, that you have read the 100 reviews, you have not read the rest, and so whatever decisions you have taken is wrong. So that questions will not arise. So this is the reason why a sentiment analysis system need to be developed that actually will help you in solving or giving you an output very quickly about the positivity, the quantum of positivity, the quantum of negativity, or the neutrality expressed in a written content. Now let us see that how can we build it, and what are the, when we try to build a model using machine learning, using natural language processing, what are the challenges before us? The challenges are like this. For example, we can have similar lexical features but different sentiments. For example, if you see this movie is not good, no movie can be better than this. So now in this case, what will happen? You see that the first sentence and the second sentence, both of them are very much similar in terms of the words that are present there. For example, movie is a word which is common, not, no is common, good, better are very much common. This is very common. Okay, so you see that there are a lot of similarities between these two different sentences. Okay, although the first one is negative and the second one is positive. Right? So how do you get, how the models will identify that? Because structurally they are similar, content wise they are very same, but their sentiment values are different. Now you can have the different styles of writing, but with the same sentiment. For example, if it is mentioned that it is an extremely useless phone, I have wasted my money on this phone, I could have bought iPhone instead of these. So you see that each of them is negative, but they have been written in different ways. How the model will capture this? The third problem is that even when we write about the product name, we write it in different forms. For example, sometimes we write G phone, Google phone, etc. So G phone here, Google phone here are same. But when you give it to a machine, how the machine, what kind of features, what kind of whether how it will identify that everything that is written for G phone and everything that is written for Google phone are same. Now, the very obvious solution that you can think of, that probably you can have a lexicon of all the words, which may not be sufficient for sentiment analysis. For example, the food is very cheap versus the service is very cheap. Now here the word cheap in the first case is used in the positive sense, where in the second case it is used in a negative sense. So in the first case, why? Because in our scenario, if the food is cheap, then we think it is good. But if we say the service is very cheap, then this is not good. So that means what? If you store all the words that can have some kind of polarity information, that may not solve your problem, because the meaning of a word can change depending upon where that particular word has been used. That means depending upon the context, its meaning can change. And the other problem that we had seen, that reviews which are written, that may not be genuine also. Okay. So this sentiment analysis has been done in many different ways for the different levels, like coarse grained, for different languages you can have, for different domains you can have, for different techniques, like mostly it can have feature engineering technique, deep learning technique. Application wise, it has immense application in e-commerce, politics, security, etc. And there are many sub problems. Okay? The first sub problem is that how do you know that which particular textual content are subjective in nature? There can be objective text, there can be subjective text. Now, objective text is basically that has a definite outcome. So for example, if you say that the sun rises in the east, so this states a fact. Okay, that does not have any subjective informations. It is a very purely objective information. Thwarting is another problem, interesting problem. As you can see, that impressive story, good acting, however, it did not meet my expectations. So at the end, you can see that initially there are a lot of positive sentiment, impressive, good, but at the end, you are just reversing your sentiment. It becomes negative. Sarcasm is a very interesting problem, very difficult problem. If you say that this movie is awesome to put you to sleep. Now, awesome is a very positive word. Now, awesome to put you to sleep is basically, although this is a positive word, that but it has been used in a negative connotations. Humble bragging. So for example, my life is miserable. I have to sign 300 autographs per day. So you see here, the miserable is a very negative word. Okay. But here the person, when the person is saying that my life is miserable, I have to sign 300 autographs per day. So this is basically the person is taking a credit, okay, drawing an attention. So although there is a negative word here, so the person is not saying that in a negative sense. Okay, so how the model will detect this kind of scenario. Discourse plays an important role. So for example, the movie is a classic, although I did not like. This although is actually reversing the sentiment. Sense is important. For example, if you say that Sen 1 is a deadly spinner, the campus has deadly snakes. So now deadly, both are different. Okay. So when you are using deadly spinner, it is positive sense, deadly snakes, it is in the negative sense. Now, sentiment intensity also is very important, that only saying positive, negative is not enough, but it is important to know how much positive, how much negative you are. Okay. So, and this is important in many decision-making process. So for example, if you say movie was okay, this is positive, but this positivity is very weak. Now, if you your friend is saying that movie was good, then you are more tempted to watch that particular movie. Okay, because now the positivity is more. Then if you say that movie was excellent, okay, then you're positive, then or marvelous, for example, then you see that your now the positivity expression is the highest. Okay, so you see that telling only positive stating only negative may not be enough. But how much positive you are, how much negative you are, that will also play an important role. Okay. So movie was awesome. For example, here you can see there is a very strong positive sentiment. Movie was good. You see here that mild positive sentiment. Movie was okay. The weak positive sentiment. So knowing these also will play an important role. So how to do this? Detect this intensity of the sentiment. Now, in terms of granularity of sentiment, so there are two kinds. One is that coarse-grained sentiment, where you can give the sentence or the document as an input, that you can detect whether it is positive or negative. The other one is the fine-grained sentiment, like which is the aspect-based sentiment analysis. Okay, where you have to detect the sentiments towards an aspect or opinion. So for example, its battery is awesome, but the camera is poor. Now, here you can see that the person has stated positive about the battery of this particular, this is a laptop review, but negative about its camera. So now if you do the sentence level sentiment analysis, what will happen that the whole sentence you will give is an input. And then you have to decide whether it is positive or negative or neutral. So you see that there is a positive word awesome, there is a negative word very poor. So you can very typically, if it is a +1 and -1, so it will be 0 ultimately. So 0 means neutral, which is not giving us the required informations. Let's say I am a person, I want to buy a laptop which has good battery. I am not interested about the camera. Then I will buy this product because the battery is very good. But that information is missing if you do the sentence level analysis. Now another person who is more interested in camera rather than battery, the person will not buy because camera is very poor. Okay. So you see that in aspect-based sentiment analysis, we have two different steps. The first step is aspect term extractions, and the second step is the aspect, the polarity identifications. Now in aspect term identification, what happens? So if you have a set of sentences, as you can see, okay, with predefined entities. Okay, so at first you have to know that what are the aspects of the attributes, and in sentiment analysis you have to know what are the sentiment expressed towards that particular aspect. So for example, I like the service and the staff, but not the food. This is the review for a restaurant. So there are three aspects mentioned over here. One is the service, then staff, then food. The second one is ambience and music, funky, which I enjoy. So ambience and music are the two different aspects. Sometimes it can be more than one word also, like for example, form factor and battery life. So form factor and battery life are the aspect. And once you know these are the aspects, now you have to tell whether which aspect is positive, which aspect is negative. For example, service, you can say it is positive. The staff, you can say it is positive. Food is negative. I did add a SSD drive and memory. SSD drive is neutral. Memory is neutral. The RAM memory is good, but should have plugged for 8 MB instead of 4 MB. So now here, you can see that this is a conflict of opinion. So at first you say the RAM memory is good, but it had been better if it is 8 MB instead of 4 MB. So now we have a conflict in opinion. Okay. So now in aspect base, you see that there are coarse grained versus fine grained distinction. So this kind of, if you have this review, and if you do this sentence level sentiment analysis of this whole review, then we have a kind of rating of around 3 to 3.5. in the scale of 5, which is not very high. On the other hand, if you, let's say, if you do this, now let's say I'm a customer, I see this output of rating of product X, and then I may not be very much tempted to buy it. Now, if you, let's say, if you have this aspect level sentiment analysis, like is shown over here, like price, zoom, picture quality, battery, display, etc. So now in this case, you can see that for the price, you have, let's say 4.5 in the scale of 5, because you say that, okay, the great value for the price. Zoom is excellent. So zoom wise, very good. Picture quality is amazing, 4.5, but the battery is drained pretty quickly. So battery are very low. Display are very low. Display is also very low. So you see here that in case of aspect level sentiment analysis, with respect to each and every aspect, we have a kind of a rating that is available. And being a customer, if I am looking for a product with good picture quality, having good zoom, but does not want to pay much, then probably I will not go for this particular product. But let's say if I want to see that, okay, another person who is interested, more, I will definitely buy this product if I don't want to pay much, good zoom, good picture quality are my requirement. But the person whose requirement is battery or display, that particular person will not definitely buy this product, because in terms of battery and display, this product is not good, because its rating is 1.5 and 1. So now see that because the users' requirement vary from one user to the other user, and such kind of very fine-grained informations we are not able to get through a course grade sentiment analysis system. So we need for that a fine-grained sentiment analysis. So instead of this, whatever is available to this left part, if this is available, okay, then the decisions will be more accurate, because the preferences, okay, of the customers are different, and based on their preferences, they can decide whether to buy the product or not to buy. Okay. So now let's see that when we talk about the traditional machine learning and the deep learning based models, so then how we actually can solve these. Okay, so we have this document or the sentence, we can do feature engineering, then we have these classifications, algorithms, and finally you do these predictions, let's say positive, negative, neutral, and conflict. Now feature engineering can be either the n-grams, like the actual words we are considering, certain keywords. Keywords means, let's say, some positive words, some negative words, etc. And then we have some kind of supervised machine learning algorithm like support vector machine, decision tree you can use. Now, if you have a kind of deep learning based method, then you don't need this feature engineering. Rather, if you have a good representation, which you call as an embedding of this document, you can use this CNN or LSTMs or any other kind of deep neural network, followed by multi-layer perceptron model, and then finally you can do the predictions. Okay. CNN we had used for solving a lot of problems in sentiment analysis. This is one of the work that we had done in 2016 for to solve a variety of sentiment analysis problems. And typically how it works, if you see that this part is the deep neural network part, okay, so up to this softmax. And this is CNN based. We have that input training input layer, a set of hidden layers. And then we follow all the steps of convolutions. And finally, the softmax does the classifications. That is how the typically CNN does. So CNN finds out the good feature representations and abstract representations, which are passed through a softmax classifier to classify into to build a multi-class classification systems. Now, what you observed is that if we can replace this traditional softmax with a support vector machines, whether that will be more effective or not. And why this can be more effective? It can be more effective because traditionally the support vector machine is a more stronger machine learning algorithm compared to the softmax. So what we have done here, whatever representations we are getting from the final CNN layer, that instead of passing through a softmax, we pass through a support, we give it as an input to the support vector machine, and then support vector machine does the classifications. We also had seen that, okay, can we combine this CNN-based deep learning with a classical machine learning algorithm? So what we had done, we had built a feature selection algorithms. Like, so for example, here is a multi-objective GA-based optimizations algorithms. Okay, so I'm not going into details of that. So what multi-objective optimization, what it does is that it takes the, it optimizes a model that has multiple competing objectives. Okay, in our case, we build a feature selection algorithm. So, so what are the multiple conflicting objectives here? We want to build a feature selection algorithms that will identify the important set of features. That means its first goal will be to reduce the number of features. So feature reduction is one objective. And the second objective is to maximize the classification accuracy. So one objective is the minimizations problem. The other objective is the maximization problem. So this is a feature, a wrapper-based feature selection algorithm. That means it has a classifier, and the classifier is support vector machines. We have a multi-objective optimization process that optimizes the support vector machines, and it to select the important features for solving the problem of sentiment analysis. So you see that here from the staining set, we extracted the number of features. We optimized these number of features through the support vector machines. And whatever features we have learned, we have found to be useful, those features, along with whatever we have learned from the CNN, have been combined together. And then they have been passed through the support vector machine. So these are the two different changes we had made. And then we had done a lot of experiments on two languages. One is Hindi and the English. For Hindi, we have done sentence level sentiment analysis, then the aspect level sentiment analysis. For English, we have the data from tweets, from product reviews, etc. It also contains the generic tweet as well as the sarcastic tweets. And we had done a lot of experiment to show that this algorithm actually helps. Now, this can also be used for, let's say, you can solve using recurrent neural network. Okay, so traditionally, how the sentiment classification is done through an RNN. So let's say this is your input, the zoom and display are awesome. So each of these individual words will be represented as a vector. And these vectors will be passed through a layer, recurrent layer. And these recurrent layers, you can see that is passing the informations from one unit to the next. Okay, it is propagating these informations from left to the right. So at this point then, here when you arrive, it actually captures the, all the information that it has seen. That means at this point, the abstract representations is the consolidated representation of this entire input. And then you pass through a softmax, do the classifications, and then you decide whether it is positive or negative or neutral. So we have also, I'm not going into details, but there are a lot of works have happened. Another area of sentiment is that whether multimodal sentiment and emotions are help. Multimodal means what? So let's say if you have this kind of expressions. Okay, so if you say that thanks for putting me on hold, I have all the time in the world. Now, if this textual written content is presented before you, then whether your model will be able to decide that what the model should actually tell. The model will tell that it's positive because thanks is a positive word. But here, actually, the person, when he had spoken in a negative sense. But how the model will learn that from this textual utterance, it is very hard because there is a positive word, but the underlying meaning is negative. But let's say if the visual expression is made available before you, the gesture of the person, the movement of the person, eye movement of the person when he was writing these, if these are made available, if the acoustic information is made available, like the intensity information, the pitch information, the tone, the variation of the tone, the variation of the pitch, if all these are made available, then not only for text, but along with these additional component, visual component, the speech component, your model can tell that, okay, look, although there is a positive word thanks, but the person eye movement says a different thing. His gesture is different. If the audio when he has spoken is made available, the variation of the tone will give you that kind of clue that maybe the person is actually negative. Second case also, let's say another problem of sentiment is the emotions. So emotion analysis is more fine-grained, and sentiment, you can say it is only positive, negative, and neutral. Now the emotion can be more fine-grained in the form of, let's say, anger, fear, disgust, sad, happy, surprise, etc. So now these two problems are very much interlinked because there are certain emotions categories that can map to a specific sentiment category like negative. Then happy and surprise are the emotions that can be mapped to a sentiment like positive. Okay. So now in the second example, you can see that if the utterance says that I am fine, then fine is a positive word. So here the emotion is should be actually positive, but actually this is negative, sad. But how the person, how do you know that it is sad? Fine is a positive word. When the person has written it, again from its facial expressions, because a conversation was going on, the person was not in happier mood and his friend was trying to console him. And then he is saying, okay, I am fine. But this fine was not said due to the joy, but rather the person was sad actually. And then he said, okay, don't be worried, I am fine. So from the text only, you cannot identify this. You can only identify if the other information is made available for you. The visual information, the acoustic, the speech related information is available. Then only you can understand it. So there is the necessity of this multimodal sentiment and emotion analysis. Then we have built very sophisticated models for based on the deep neural network. So maybe if you are interested, you can go through it. So I can skip this part because time is short. So very, very quickly, I'll give you some ideas that in conversational AI, what do you mean by this? Conversational AI, you can say that typically is a kind of computer systems that can communicate with you. Okay, preferably in the language that you know very well. You might have seen, for example, there are a lot of personal assistant like Siri, Cortana, Google Now, etc. If you want to talk to your car, communicating with the robots, clinical uses for mental health, chatting for fun, etc. But the most simplest form of conversational system is the chatbot. And why it is important? Because if you see the chatbot market size has grown from $2.6 billion in 2019 to $9.4 billion by 2024 at a compound annual growth rate of 29.7%. Okay. So it shows that this conversational system in the form of chatbot is extremely useful service in today's world. Okay, and it has a huge potential. But historically, if you see that the very first chatbot was named as Elijah, which was developed at MIT in 1960. But now today chatbot is very different from those years chatbot. So those kind of chatbots were capable of performing a very limited set of activities. For example, booking an appointment, selecting one of the songs, etc. But now, today's chatbot, conversational agent, is different. Okay, because today's conversational agent, it deals with identifying, understanding the human emotions. It is not merely booking a flight ticket or booking a movie ticket. Rather, when you speak to a chatbot, whether the chatbot can understand your underlying mood, your emotions, your sentiment, and whether it can converse accordingly. So that will actually be very important. So that means the chatbot will have to understand the dynamics of human conversations. Okay, but this is very hard problem. This is not an easy problem. How can you achieve that? Okay. Facebook AI has identified 5 different problems. For example, consistency is one of the problems. Specificity is another problem, empathy, knowledgeability, and multimodal understanding. So these are the features. If a bot can acquire all these features, then it can behave almost like a human. Now the consistency means the bot cannot contradict whatever it has already said earlier. Okay, specificity is very important. So if you want a service from a bot, the bot should deliver that service first to you. So it has to be very specific information to you that actually you need. It should be empathetic. It should have the capability of sentiment awareness, emotion awareness, courteousness understanding, etc. Knowledgeability, it should be knowledgeable. That means it should understand the external knowledge and the facts. If you say why 2nd October is important in India. Now, the 2nd October is important in India because it is the birth anniversary of Mahatma Gandhi. How do you know that? Why 1947, 15th August is important in India? Okay, so you see that to respond, if you ask these questions to a bot, the bot may not answer to these kind of questions. It may be able to answer only if it has the capability to incorporate the outside knowledge. Let's say 1947, 15th August, why it is important, that history the bot should know. As a human, you can do that if you are knowledgeable. But if you ask to a very child, okay, who is not aware about all these things, so they may not be able to respond to this kind of queries. The other one is that the input can be multimodal in nature. So it is not necessary that input always will be text to text. Input can be in the form of image. Input can be in the form of audio. Input can be in the form of video. Whether the model understands this, whether the bot understands this. So if the bot is able to take all these kinds of input then you can see that bot is capable in understanding the multimodal inputs. So these are all the features that any model should have. And typically we have, if you want to build a chatbot, so these are the typical steps that you have to perform. So you have this audio, let's say the automatic speech recognitions. Then from audio to text conversion will happen. The text will go into this natural language understanding. Okay, so this is a very important steps. Okay, that does these intent detections, then slot filling. There are many steps. I am not going into details. There is an important concept of dialogue management that controls that the flow of the dialogue, in which directions to move. Then there is a natural language generation module that will generate the final response before you. And that particular response in text that has to be converted into a speech, and it should be returned to the speaker. This is typical, is the cycle of any chatbot if the chatbot is enabled with the speech-to-speech input. So now if it is a textual input only, then probably this part is fine. Only natural language understanding, dialogue management, and natural language generation should be sufficient. Now, what do you mean by this empathetic conversational AI? So the kind of research that we have been doing at IIT Patna. So I'll explain with you more example. Let's say this person is saying that I finally got promoted today at work to a bot. Now, if the bot responds like this, that why would anyone promote you? Then the speaker will not feel good, right? This person will not feel good because the bot is not appreciating his achievement. And that also is very true in our human-to-human conversations. When you talk to your friend and say that, okay, you have got a very good job, and if your friend is not acknowledging that, then you don't feel good, and this relationship may not sustain for a long time. You may not like to engage into a very long term conversation with such kind of persons. So rather than saying that, if the bot replies like this, the congrats, that is great, then you see that this person, now this person will feel good because the person or this bot here has understood the achievement of this particular person, and these interactions will continue for a long time. Now, by empathetic conversational AI, we want to enable the machine or the chatbot to understand the human's feeling like this. And the bot, when will generate the response, should be capable of generating the response in this particular manner. There can be a lot of other things. For example, when we talk, the speaker can have multiple emotions like surprise, joy, are the two emotions, anger, acceptance, sadness, fear, etc. And you can see here that these two are basically two different emotions with their different intensity level. Okay, here the surprise is less, the joy is more. In the second case, anger is more, acceptance is less. In the third case, sadness is more, fear is very less. Okay, so now we can see here that how the model will behave when it generates a response that will encounter this kind of multiple emotions and their intensities. So we have discussed all these details in our recently published paper in AAAI 2020-21. Then, as I mentioned, that all this knowledge grounding, external knowledge, understanding the intent of the speaker, the context and the mood will make it more aware and relatable. The other problem is that we have done is that how can you make a bot polite, to behave in a polite manner? And this politeness is very important in our, again, in our human-to-human conversations. If you are talking to your senior, you have to be more polite. If you are talking to the teachers, if you're talking to your parents, if you are, you see that you have to be more polite, but when you are talking to your friend, you may not be so much polite. So you see that politeness is affected in our social life, and this plays an important role, particularly in a customer care situations. Let's say if you are taking a service, a mobile connections, and you have frequent problem in getting that particular service, frequent call drop, etc. And if you reach out to a particular, let's say, the service center, and if the service center agent is telling you that, okay, how can you help? How can I help? Then the response may seem to be very mechanical to you. But rather than saying that, if the agent is saying that, okay, we are sorry to see you are having trouble, help has arrived, how can I help? Then you see here that the person, okay, who was having this trouble will feel more satisfied because the customer care agent has understood, okay, the trouble that the customer was facing. And because of these apologetic natures, the customer will feel good, even he has a lot of problems. Then the other one is that, can you send us a screenshot? So rather than saying that, if you add these colored part, it makes more engaging, more polite. So in our many situations, this politeness or courteousness will also play an important role. And in many situations, it depends on the, it can vary from one person to the other person, because it depends on the various factors. The politeness may depend on the gender. Let's say whether you are talking to a female or male, then your politeness level will be different. Age, elder people, younger people, the level of politeness is different. Geographic location is important. Talking to a person in Japan, talking to a person in US, the level of politeness will be different. So you see that this kind of, whether the bot can automatically adapt to a situation. So let's say talking to a US people, so talking to a Japanese people, can it automatically adapt to this kind of situations and can drive the conversations in a way, in a directions that will be more engaging. Okay, that is very important. And then we have done several things. So probably I can skip these. If you have interest, you can go through our published papers. Okay. The other one is the translation, so that we have been doing for a long time, which is very important for building a multilingual society. Okay, that it translates from one language to the other language. And there are plenty of translation services you have seen: Google Translate, Microsoft Bing, Facebook, Yandex, etc. There are other translations like Sistran, Lingua, Webelfish, etc. Again, there are 4 kinds of techniques. We have been doing a lot of activities in machine translations, and there are rule-based machine translation, example-based machine translation, statistical machine translation, neural machine translations. I don't have time so much, but I can take some questions if you have, because translation, I don't think I will be able to talk much now. Okay. So if you have any questions from any of these parts, okay, so you can ask me. So I'll be happy to respond to.
Dr. Asif, there are a few questions in the question answer section. Asked by Venkata Subramanian. How sentiment analysis take the expression like emoji tracker as positive or negative or neutral?
Emoji, actually, you are saying?
Yeah, emoji tracker, yeah.
So in the chat, I can see the questions where it is.
Yeah, you can see Q&A section is there, Q&A down there.
Right.
Yeah. So there are 3 questions on there.
So one is that emoji, right? So can you repeat this? I don't know. I cannot see it. So,
how sentiment analysis take the expression like emoji tracker as a positive, negative, or neutral?
Yeah, so emoji has a very good connections with the underlying sentiment. Okay, whether it is positive, whether it is negative, it has relations with the specific emoji. So if you have a predefined set of emojis, then mapping that with the sentiment is not a problem. Okay, because you know that which emoji corresponds to what is that meaning, then what kind of sentiment it expresses. Okay, the problem will happen that if you create a new emoji, okay, then the idea will be that can we interpret this particular emoji? Okay, it's one of the with respect to the sentiment. Okay, so we have been doing some research on this, that finding the interactions between emoji, sentiment, and the emotions, particularly emoji and the sentiment, to build a models that can do both emoji predictions. Okay, emoji prediction, that means there are certain set of emojis. We have grouped them into different clusters, different groups. So the model will be able to identify the group, the type of that emoji, and at the same time the model will decide whether that emoji has any influence on the final sentiment values. That means given an emoji, how much it influences on the final sentiment values of that particular input. So it is a kind of multitask system that can do emoji predictions, and also it can decide that how emoji helps in sentiment predictions. Okay, so that actually is possible. You can build a kind of multitasking system to understand the interaction between these two, between emoji and the possible sentiment values.
Okay, next question is, can you tell us some free sentiment analysis software for academic research purposes?
Yeah, so there are quite a few. For example, Stanford has one, IBM has one sentiment analysis systems. Then at IIT Patna, our own website, if you see, we have several codes, we have several resources and codes we have made available for sentiment analysis. Okay, so so these are all. What about sentiment analysis system? Stanford one is quite good. Okay, then you can use it. But for the Indian language and the aspect level sentiment analysis that I was talking about, let's say not only the sentence level sentiment, but very specific attribute level sentiment. If you say that, okay, I like the camera, but did not like its battery. So now what kind of sentiment analysis system you have? So you can see our AI NLP machine learning group, okay, web page, and then you can get some more. There are some resources and tools we have also made available.
Dr. Asif, the last question will take, I think. Can you please tell us the current state of art in machine translation?
Yes, so machine translation, state of the art, yes. So mostly you can see that these days is dominated by neural machine translation. Okay, so there are 4 paradigms. So one is that historically earlier it was rule-based, then example-based machine translation, then the probabilistic machine translation, like phrase-based machine translation, which was until 2012-13, it was very popular. But mostly these days are the neural machine translation. Okay, and in neural machine translation means based on the deep neural network. Now, neural machine translation is good for the fluency, that syntactically it can generate good sentences, but adequacy is a problem. If you have plenty of data, let's say millions of parallel sentences, that NMT is better. But if you don't have such millions of parallel corpus, then probably the SMT can be better because you can incorporate a lot of linguistic features into SMT. So now if you are planning to see that use NMT for low resource languages like the Indian settings, then a lot of linguistic knowledge you have to incorporate because you don't have a lot of parallel corpus. Linguistic knowledge means, for example, morphological properties, part of speech tagging for syntactic information, some kind of semantic information. So these informations you have to incorporate into a NMT model, okay, to deal with this low resource scenario. The other technique obviously is the domain adaptations, okay, that how can you quickly adapt the model of machine translation from one domain, one language to the other language. That means transfer learning, domain adaptation is one popular concept that is very useful. Then the other one is that noise handling, okay, that lots of data can, social media data particularly, it is noisy, informally they are written. So how the translation system can be built to handle such noisy data. In low resource, another problem is that code mixing. Okay, the code mixing means that if the language is mixed with more than one language, then how can you translate that kind of language, okay, that mixed language into another target language. So code mix machine translations can be important, noisy machine translation, domain adaptation, good transfer learning techniques. Then data augmentation is important, that under low resource scenario, synthetic data augmentations, how can you incorporate? That can be important. Linguistic factors incorporations into NMT can be good. Combining SMT plus NMT together, that can be another interesting area to work on. In our research also, we have seen that if you combine the SMT and NMT together in an intelligent way, that actually improves the overall performance. So these combinations is very much required in order to achieve good performance level. Then there are a lot of other challenges for practical applications. For example, speech-to-speech machine translation these days is very important. India, if you see that new education policy, okay, so all the educational lectures will have to be made available in the Indian language. So how can you do that? So you need a good model. Then let's say a lot of other application in health information, then the legal domain, lot of judiciary documents. Okay, so I did not have time to show you. We were developing a system. You can also see the demo from our website. The idea was to build the model that can translate all the legal document from one language to the other language. And why it is important? Because in the lower level court in India, all the decisions are taken in the regional language. But when it moves to the High Court or the Supreme Court, everything is in English. So there is a requirement to translate it. Okay. Again, in the Supreme Court, all the decisions are in English. Now, when it goes back to the, let's say, appellant, okay, so who does not know about the does not know English, but wants to know about about the verdict, about the decisions taken in the court, how those informations will be disseminated to those kind of people. So there is a necessity to translate both ways, that decisions taken into the local languages in the lower level court, in the district level court, in the subdivisional level court, to a common language like English, and again from English to the local languages. So this judiciary domain translation is important. Education is another domain. E-commerce, they are very much interested, like Facebook, Amazon, Flipkart. Even Flipkart, I do a project with Flipkart. Their main goal is to make all the reviews that users are writing in the Flipkart portals to translate them automatically into the regional languages, so that everybody knows. A person who wants to take a service for Flipkart and wants to, let's say, to know about the quality of a product, the person should read it, should understand it in its own language. Okay. Then multilingual bot development is very important, that how a bot can be developed that can interact with the users. Okay, chatbot, for example. And whenever the multilinguality comes, the translations will also come in. So e-commerce, then this conversation translation, dialogue translation, specialized domain like education, like judiciary, health. Okay. So these are all the important sectors, okay, so where the translations can play an important role. But in terms of the technique, as I mentioned, that transfer learning, domain adaptations, combinations of, let's say, data augmentation technique, noise handling, then you have that combination of SMT and MT, linguistic factor incorporations, okay. These are the possible way forward for in terms of translations, machine translation, and also speech-to-speech machine translation in terms of application and building the practical systems is another area. Okay.
So, Dr. Asif, another question is there, but that is not very relevant. If you want to take it, it says, how can the DNA or RNA sequences can be used as data set for machine learning for disease classification?
Okay, disease classifications, right? Okay, so RNA sequences, DNA sequences, yes, there are works also, I think, in the disease classification. But anyway, so these are ultimately so grossly. So if it is a supervised setting, so then you know the types of the disease, right? So now you are talking about the features, okay? DNA sequences, RNA sequences, etc. Those are the features. Now, if you are using a deep learning based model, as I mentioned, that identifying the important features, okay, or to solve the problem is not your concerns. Rather, how can you represent these sequences, okay, in terms of the vectors as an input to the deep learning model? That is more important. Now, which RNA sequence is influencing your disease identification, which DNA sequences is influencing your decisions. So that interpretations, that explainability, that explanations in deep learning models is difficult. But if you are doing it, let's say in a traditional sequence labeling problem, like algorithm like hidden Markov model, maximum entropy Markov model, this kind of sequence learning algorithm, or any kind of traditional classical machine learning algorithms, then probably you can identify that which particular DNA sequence is actually influencing more. In deep neural network, ultimately through attention, you can get some ideas, right? So attention will tell you that which particular portions in the input, okay, which particular features is influencing most. Okay, you can get some ideas through the attention mechanisms in deep learning. Okay.
Yes. Thank you so much, Dr. Asif, for sparing your valuable time from your tight schedule. And I'm sure all the participants, they got benefited. And in future, you know, if they want to collaborate and if they want to learn further, can, I think, communicate with you. And we look forward to future collaboration. And I think it was an excellent presentation, and you know, details of the NLP and so many areas you touched. I think the participants can see a lot of scopes are there for further study. Yeah. So thank you so much for introducing all these problems. You know, that multi-model and then, you know, conversational AI, all this really interesting, and a lot of applications that you have mentioned. So I think a lot of scope the researchers can try and contribute.
Yes, sure. Okay, thank you once again. So if anyone has any questions, or if you want to connect me, you can write to me. So I'll try my best to respond. Okay.
Yes.
Okay, surely.
So yeah, thank you so much then, once again.
Thank you.
See you.
Bye. See you. Bye.
Yes. Bye. Yeah. For participants, I have a some announcement to make. I think tomorrow we'll have the last session, last day, and we'll have valedictory just after the sessions. And there may be little changes in the schedule. So we'll post in the group and let you know. So till then, see you tomorrow around 10:30. Okay, then we can leave, I think. And feedback link will be shared in the group.
Dear participants, the panelists, we have two very renowned personalities among us today. They are very closely associated with IEEE. I'm proud to introduce them. I'll introduce one by one. I will request Professor Celia ma'am first to deliver her speech, and after that I'll go to Professor Sheikh Fattah sir. Now I would like to introduce Professor Celia. She is IEEE Women in Engineering Committee Chair elect of 2022. She is member of various committees of IEEE. Professor Celia Shahnaz is a senior member of IEEE Fellow of Institution of Engineers, Bangladesh. She received PhD degree from Concordia University, Canada. Currently is a professor in the Department of Electrical and Electronic Engineering, Buet, Bangladesh since 2015. She has published more than 150 international journal and conference papers, a recipient of the Canadian Commonwealth Scholarship Fellowship and Bangladesh Academy of Science Gold Medal for her contribution in science and technology. Her papers have received Best Paper Awards in IEEE Basit Con 2019, Biomedical Engineering Treks 10Con 2017, IEEE WIE Con EC 2016, and Humanitarian Challenge Trek R10 HTC 2017. She was the member of first and second prize winning projects in IEEE IAS CMD contest, Robotic and Humanitarian in 2017 to 2019, USA, the supervisor of 4th, 5th rank winning teams in SPCUP and VIPCUP competitions, ICA SSP 2020 Spain, 2015 Australia, ICIP 2020 UAE. She has 21 plus years of experience, 21 years as an IEEE volunteer of leading impactful technical, professional, educational, industrial, women empowerment, and humanitarian technology projects at national and international levels. So with this, I welcome Professor Celia Shahnaz. Floor is yours, and you can start your presentation now.
Thank you for your humble introduction. Dr. Iftikhar, you wanted to introduce Professor Fattah, and then I start my presentation.
Okay, I can do that. I thought you will finish your presentation. After that, I'll do. Anyway, so let me introduce Professor Sheikh Anwarul Fattah. He is also very closely associated with IEEE. So Professor Fattah received PhD degree in Electronics and Communication Engineering from Concordia University, Canada, and later he was a visiting postdoctoral fellow in Princeton University, USA. He received BSc and MSc degrees from Buet, Bangladesh, where he is currently serving as a professor in the Department of Electrical and Electronic Engineering. His research interests include signal processing, machine learning, and biomedical engineering. He published more than 215 international journal and conference papers and delivered more than 80 keynote or invited talks in many countries. Dr. Fattah is the chair of IEEE SPS Bangladesh chapter and vice chair of IEEE RAS, EMBC, PES, and SSIT BDCs. He was the vice chair of IAS BDC. He served as the IEEE Bangladesh section chair during 2015 and 16. He is the chair of IEEE PES HSC, member of IEEE Public Visibility Committee, IEEE PES Long Range Planning Committee, and IEEE Smart Village Education Committee. He served IEEE HSC 2018 to 20 Education Chair, various committees of IEEE Region 10, IEEE EAB, and IEEE Site. He served key positions in many international conferences, such as the General Chair of IEEE R10 HTC 2017 and TPC Chair of IEEE 10 CP 2020. Dr. Fattah received several awards. For example, Concordia University's Distinguished Doctoral Dissertation Prize in 2009, 2007 URSI Canadian Young Scientist Award, Dr. Rashid Gold Medal in MSc, BAS TWAS Young Scientist Prize in 2014, 2016 IEEE MGA Achievement Award, 2017 IEEE R10 HTA Outstanding Volunteer Award, and 2018 IEEE R10 Outstanding Volunteer Award. He is the editorial board member of IEEE Access, IEEE Potentials, and Biomed Research International, editor of JEE, IEB, and editor-in-chief of IEEE PES eNews. He is a senior member of IEEE and a fellow of Institution of Engineers, Bangladesh. So they will be talking about deep learning for biomedical and healthcare applications. So I welcome Dr. Sheikh Fattah sir as well. So with this, may I request to proceed, to both of you to proceed with your presentation.
Thank you, Dr. Iftikhar and Dr. Jamal Hussain, for your effort in organizing this FDP and give me an opportunity to share my research with you. Let me share my screen very quickly. Hope my screen is visible to all of you.
Yes, ma'am, it's visible.
Yeah, thank you very much. I will be talking about deep learning, that artificial intelligence, machine learning, and deep learning is an emerging area and tool of research. And I will be focusing on applications related to biomedical and healthcare. By the way, I want to express my sincere gratitude to supporting me directly and indirectly for my successful election as 2022 IEEE Women in Engineering Committee Chair-elect. I will be chairing Women in Engineering for 2023-2024. Women in Engineering is not for women. Anybody, any body can be IEEE Women in Engineering member. However, for graduate students and undergraduate students, Women in Engineering membership fee is free. It's a great honor to get the opportunity to serve you. This is just a brief bio. Dr. Iftikhar has humbly introduced. Actually, I fervently request you to visit my website, www.celiashahnaz.com, to know about me, to know about my activities, to know about my research, and let me know how I can collaborate with you and how I can contribute to your research. The most importantly, I'm the founder of 4 Technical Society chapter in Bangladesh: Signal Processing Society, Robotics and Automation Society, Industrial Application Society, Society on Social Implications and Technology. Apart from it, my research is related to Engineering, Medicine and Biology Society, Computer Society, Power and Energy Society. So this is very important, and I have the opportunity to work as a member of IEEE History Committee. I'm working with IEEE Milestone. Apart from it, I am also chairing IEEE Signal Processing Global Society Women in Signal Processing, and also serving IEEE Educational Activity Board and IEEE New Initiative Committee. I request you to visit those websites and please let me know what help you need from me. And I also fervently request you to visit my Google Scholar citations to really know that despite the pandemic, despite a lot of limitations of computational facilities, less number of PhD students, because our students are basically going for PhD for United States of America, in Princeton University, in Berkeley, in Stanford, in Texas A&M, College Station, in Austin, like that. So, and also we have limitations of funding opportunity. Despite all limitations, how in the pandemic, I, along with my students, worked very hard to choose emerging topics and publish in impactful journals and conferences. Not only that, those research papers are cited by others. That's a very positive thing for myself, my team, and all of you who are young students and young faculty and facing challenges for continuing your research. That's a good example. And I hope you will be encouraged, and you can reach out to me for possible collaboration, possible co-authoring of papers or co-writing a book or book chapters. And I hope it will be a very great example of commitment of researchers beyond borders. So, musculoskeletal radiographs, and there are a lot of abnormalities. When I started talking about it, my students have told, why musculoskeletal radiographs? I told them, 1.7 billion people are suffering from the abnormality in musculoskeletal radiographs. So to make it automatic, to make a bridge between engineers, signal processing researchers, and doctors, they have developed a completely new network called capsule network. And we want to also see the ability of the capsule network and whether capsule network can outperform the convolutional neural network. And for that, the basic is first that we have to do some pre-processing and resize the image from 224 to 224 pixel size. Why, I will really explain you later. And you see the visual observations of different sizes of image, like 64 cross 264, 128 cross 128, 224 cross 224. You can see in the third picture in the rightmost corner, the more features are included. That means if we down the sampling, then image quality is degraded. And if we increase the pixel size, features are better preserved. However, I do not encourage the researchers to depend on the visual observation, subjective evaluation only. We strongly suggest to use the objective matrices such as training accuracy and validation accuracy. If you see, look in the first table, for different sizes, you can see that for 224 plus 224, both training accuracy and validation accuracy increases. And also we have shown BRIC score and NIC score. BRIC is blind image spatial quality evaluator. NIC is naturalness image quality evaluator score. And lower the scores are better the image quality. And also we have seen that for 224 plus 224, both the scores are lower. That means we lose less features after resizing. That gives us a rationale that what will be our pre-processed image size before moving to this block diagram. This is just a schematic diagram of our application or our algorithm. After pre-processing, we send it to the convolutional layer and primary capsule layers, and an optimization happens before going to the class capsule to give the final output. Okay. If we see that the proposed structure, the convolutional one has 256 9 cross 9 convolutional kernels with stride of 1, and ReLU is used for activation function. And then we move to convolutional capsule layer, 32 channels of convolutional 8-2 capsules. Primary capsule has 32 cross 104 cross 104 capsule output, and And then the class capsule includes 2 capsules, and each capsule has a dimension of 2. These are different blocks of how you are designing the architecture. If you look at this, you will get a better idea about the different sizes and different blocks, how this architecture works. And before going to the class capsule, we do routing by agreement algorithm. And what is routing by agreement algorithm? We will see later. So by the way, this work has been done by my undergraduate thesis students, and it has been published in IEEE Access. If you read that paper, that's available in my Google Scholar citation, you can see these are the functions and vectors we have used to describe the methodology, to describe the whole structure. Hope you will know better when you read the papers. I strongly recommend you to read the paper. And whenever you are handling in biomedical data, the first question is what type of data, what is the validity of the data, authenticity of the data. We are using a data set, mirror data set that contains a big data, 14,656 images, is among them 8,941 images are normal and 5,715 images are abnormal. The good thing is that we don't have data imbalance. What happens to data imbalance, I will show you in later example. You know, I was talking about routing by agreement. It's an iterative process where a routing algorithm acts like an orientation popularity filter. That means input from lower level capsule will send to the higher level capsule that agrees with its input. And we can see while plotting the training and validation accuracy by black and red for different types of images in the database, such as finger, elbow, hand, humerus, forearm, shoulder, and wrist. We can find that number of routing affects the accuracy. As the number of routing is increased, accuracy gets better. So it's a very good thing, but in some cases, overfitting problem happens. You can see it from the figure E and F. So to avoid overfitting, we have decided to take 4 routing. You know, and not only that, people will ask you that whether the proposed architecture is random or really appropriate. So for this, we have utilized a statistical measure, Cohen-Kappa static score. The first table is Kappa static score for NORA dataset using CAPSNet. And second table is the Kappa static score using the same dataset using the conventional DenseNet. You can see from this bar graph that Kappa score for different images are 10% better for CAPSNet architectures, while using 50% less training data while comparing with DenseNet. So that's a very lucrative claim for any architecture, because if we can have a better confidence, you know, with less training data, that is always hopeful. And it is also for a young researcher, it is important to compare your result with some standard state-of-the-art methods. And also it is important to use standard evaluation matrices, as we have used training accuracy and testing accuracy for different types of images. And this is the abnormality detection results for our method. If you observe the table, that we are providing better training and testing accuracy compared to the conventional DenseNet method as shown in the table. And finally, it is very important for all of us to really give the authors confidence about the accuracy of our model. That's why we have proposed and we have shown the accuracy versus loss graphs for different types of images. The red one is the accuracy for us, for our proposed CAPSNet, black one, the loss, and the blue one is the accuracy of the conventional DenseNet, where the purple one is the loss of DenseNet. We can see by the red one that CAPSNet is providing better, higher accuracy with lower loss, whereas DenseNet is providing a lower accuracy with higher loss. So with that said, we want to say that we have outperformed the standard technique with better results, with a new architecture. So these are important claims, and we are hopeful about making collaboration with the doctors to make the decision process faster and automatic. I will focus on another research topic that is also very interesting, like tuberculosis detection using chest radiographs. Here, we have exploited the cascaded ensemble of features for the detection of tuberculosis. If you look at this diagram, we are taking X-ray images of the chest, and in the lower block you can see we have taken ensemble of different deep learning architecture: DenseNet 169, ResNet 50, Inception V3. In the upper block, we have also taken ensemble of hand-engineered feature set. I will mention you what are those features. And finally, we have concatenated the probability score of both the ensembles so that we can have a better decision. And for pre-processing, we did rotation invariant augmentation. And there is a element-wise power, Gaussian filtering, sharing we did. And among the handcrafted feature that you have seen in this block diagram, we have found the following features very useful, like histogram of oriented gradients, binary pattern of phase congruency, improve Weber binary code, curvature descriptor histogram, shape descriptor histogram, local arc pattern, local transitional pattern, and median binary pattern. Okay, so before evaluating the result with hand-crafted feature, we really wanted to know the quality of the features based on two matrices like Voltage area distance, BD, and geometric separability index, GSI. You can see in the table for different hand-engineered features. And you can see in both the cases, BC and GCI are low. It indicates a very good inter-class separability and intra-class compactness of hand-engineered features in terms of BC and GCI. So we have evaluated the hand-engineered feature performance based on two databases publicly available, MC and Shenzhen. And our evaluation matrices are accuracy, area under the curve, sensitivity, and specificity. You can see that while we are ensembling the hand-engineered features, of course, all the matrices are showing better performance compared to the individual hand-engineered feature. That gives us a motivation that we are moving in the right direction. And it is important to really ensemble different hand engineer features. And before moving to the deep neural network architecture, it is important to know whether we are going to focus on all the layers of architecture, or rather we want to focus on particular layers. And for Inception v3, dense 169 and ResNet 50, for different layers, we found the most effective layer, and we showed it by bold font, and we evaluated based on accuracy, area under the curve, sensitivity, and specificity. We can see that for Inception v3, batch normalization 93 gives the highest highest performance. And for DisNet 169, convolutional block 5 block, convolutional 5 block 32 concatenated part gives the best one. And for ResNet 50, convolutional 5 block 3 concatenation gives the best result. This is just an analysis to give you a confidence that you will focus on which layer, so give the output from that layer. And also we wanted to motivate the researcher that we should go for ensembling different deep neural networks. So for that, we have shown the performance for two datasets, MC and Shenzhen, under different evaluation matrices. We also have shown that while doing pre-training, the results are improved. And not only that, with pre-training and with augmentation, the result improves much better. So this is very important proposal for us, that we will do deep neural network ensemble with pre-training and with augmentation. Okay, and then once the features from deep neural network are extracted, they are sent to the classifiers like logistic regression, support vector machine, artificial neural network, k-nearest neighborhood, and random decision forest. And you can see the results in different performance matrices. We can see that logistic regression classifier is showing better result for hand engineers and deep neural network ensemble technique. It is also very important for us to compare our result to standard state-of-the-art techniques. Our proposed method is the concatenation of hand engineered features and deep neural network features. So compared to that, we are really doing very good in terms of accuracy, area under the curve, sensitivity, and specificity for both the data set for MC and Shenzhen is a very detailed evaluation, validation by biomedical data before really convincing people about your method of ensembling, and that really the ensembling works. This is a GradCam visualization of 3 neural networks. You can see the second column is the DisNet 169, Inception v3, and ResNet 50. The first picture is for MC database, second picture for Shenzhen database, and we can see the also gray X-ray images, but we don't want to do this. The first row is from normal, second row for TB. You can see that there is a visible detection of tuberculosis, but we really didn't want to detect it visually. We wanted to do it by the deep learning and machine learning approach to really emphasize the accuracy of the decision that can be done by the doctors or by the engineers based on such visualization. Finally, I will focus on a very interesting topic, that is distortion classification in laparoscopic videos using DisNet network. This DisNet network is proposed by my students. This is the first skeleton. We will take the input image from the videos and detect the different types of distortion present in the laparoscopic videos. Motivation is that if there is distortion, then there may be surgical error can happen. So it is very important to detect this errors or distortions so that mitigation plans can be taken and surgery can be done without error and without fatal problem. So from input images, the distortion types are detected and their corresponding features are extracted. This is a picture of white Gaussian noise. Noise variance is a key factor to characterize an image as a polluted frame by white Gaussian noise. And this is a smoky frames. Smoky frames tend to have less median value. This is an important feature that can be obtained by histogram analysis. And these are a few frames where surely there is an uneven illumination. And ratio of luminance mean to range is a great indicator for this change to understand, to identify the frames as the frames with uneven illumination level. And these are frames which are really blurred due to camera hardware issues. A blur image will show low variance and less edges. Once based on such features, such distortions are identified, those features are sent to DisNet network. You can see the DisNet network, our proposal is introducing a sequential self-attention layer to really give a proper attention to particular distortion present in the input image. Then, since it is a two-dimensional image, we found that once after the self-attention block, if we add a LSTM block before the dense layer, then it gives a better motivation of finding the classified images from the 2D images. Like this is the importance of introducing LSTM. Now you see the model performance, model accuracy for training and validation with iteration and increases in the right picture. Eventually the losses are decreases. So this is the table. In the training and validation, we have very high accuracy and low loss. And we have also shown that we have a very less Cohen-Kappa score. We have evaluated our performance based on the unseen data also. We have exposed ourselves with more challenges. And we see that our accuracy and Cohen-Kappa score did not decrease much. Finally, actually, this was a competition launched in Global Signal Processing Society flagship conference, ICIP. I encourage you to contribute your papers there. And you see among all the teams that participated in the competition of ICIP 2020 in October, we can see that our accuracy is third ranked. But the good news is that average time per frame is lowest for us. That's a very good achievement because we want to take this decision very fast to have a mitigation plan to help the doctors so that the surgery is smooth. I'm a strong advocate of women for many years. I think that since I understand, I become a grown-up. But I found that many of our women are suffering from skin diseases, but they're shy to evaluate it. They are shy to do diagnosis about it. But these are the digital images, color images of the skin cancer. We are now working on and trying to develop an appropriate architecture to detect the skin disease and cancer directly by deep neural network. So I strongly suggest you to participate in signal processing cup competition co-located with ICAST. That's a flagship conference of Signal Processing Society, and also VIP Cup competition that is co-located with ICIP. And I'm participating as a supervisor since 2015. You know, my team was 2015 was ranked 5th, and they were they're very upset. I told that, you know, nothing can go in vain. Knowledge is such a thing, and we come up with 3 journal papers, and that has given opportunity to my students to get PhD admission in Princeton University, Ivy League, and another is University of California, Riverside. And in 2020, when everything was in lockdown, my student again worked very hard, new set of students, and in SP Cup competition, they are ranked 4th. And also in that October VIP Cup competition, my students again ranked 5th, another set of students. So importance of attending such competitions to expose yourself to the emerging areas of research that can be applied to your local community to help the community. And these are some of my hours. You can find it when you visit to my website. I was 2013 Women in Engineering Professional Volunteer Award from whole region 10, Asia Pacific, IEEE. 2015 Women in Engineering Inspiring Member Award from the whole Global Women in Engineering. And 2016 Member and Geographic Activities Leadership Award among all male and female members, 160 countries, that time 330 sections in the whole world. 2019 Region 10 Humanitarian Activities Outstanding Volunteer Award. That time Region 10 has 58 sections, and now it has 60 sections. And 2021 has been amazing. 2021 IEEE MG Achievement Award, and now in IEEE we had 160 countries, more than 342 sections. So it's a great honor to receive it for my technical professional contribution to the community, for the country, for the region, and for the globe. And it's a great honor to listen to your present, to give a lecture to you. This is, I like to introduce you to ICAS, where we did Women in Signal Processing panel, where Susan Cathy Land was invited to a speaker who was IEEE President 2021. And also in ICIP, another flagship, we have done Women in Signal Processing and connected with other societies so that we can share the good practices. And in 2022, we celebrated International Women's Day by signal processing researcher, communication expert, and an entrepreneur. And we talked about unlocking the potential of smart applications using AI and robotics. It is important to really know what our robotics experts are telling. That's why we have invited Dr. Vande Pharma from NASA, and also from Engineering Medicine Biology Society expert Carolyn, because we wanted to do interdisciplinary research and inspire our students to be part of signal processing. Has only $1 student fee. So please do not wait anymore and embrace the technology, know the diversity and inclusion, and what promotion and what initiatives we are taking to really promote diversity and inclusion in technical activities. With that said, I really want to say I change the world because I'm an engineer. And by working together, we can do it. Hope to collaborate with you in future, hope to interact with you future. If you have any questions, feel free to ask me. And I request you to visit my papers, to read them, and please tell me how our network can be implemented to your work, and we can easily come up with a joint collaboration. So thank you, and I wish all the best for this FDP, and I am grateful that you have participated in these lectures. Thank you. Over to you.
Thank you, ma'am, for your excellent speech. We have 3 questions in the question and answer section, Q&A. If you want me to read, I can read the questions, and if you kindly take those. So the first question is from RN Begum. Please describe the architecture of the CAPSNet in details.
In the architecture, I showed the architecture, right? If you remember. So if you visit the recordings, what I should say, and that at first the convolutional wall layer, and then the capsule layer, and then the decision layer. And before going to the decision layer, there's a routing by agreement algorithm. To know better, so I have really requested you to visit my paper. You go to my Google Scholar citation, you write the title, capsule network, then you can get the detail. But while I was lecturing, I have really showed you the architectures, 3 major blocks that are very important for the capsule network. Thank you very much.
Thank you. The next question is from Venkata Subramanian. He asks, can we use capsule neural network for interventional cardiovascular disorders?
You know, I was working with ECG data for cardiovascular disease detection. You know, since ECG signals are one-dimensional data, so such deep capsule network may not be needed there based on my research, but you can really made it a shallow network. So you can really work on how you can shallow the network. Then a modified version of the capsule network will be more effective for one-dimensional ECG signals that are used conventionally for cardiovascular disease detection. Thank you.
Thank you, ma'am. The last question is again from Venkata Subramanian. He asks that in case of stem cell technology process, which one is the best suited, CNN or capsule neural network?
You know, I'm not expert of stem cell, but I can read about it, you know, because my mother did stem cell research. My mother had a stem cell operation for her knee. So I really don't know that whether you are meaning the biochemical research for knee or stem cell. But if you tell me that, after doing the stem cell, if you want to take an X-ray of the knee, again, it will be a 2-dimensional image. And if capsule network is applicable to the musculoskeletal radiographs, of course, in that case, that capsule network will be useful because it can then make a difference between the abnormality and the improved version. So I think I could re-articulate your questions. You wanted to mean the images collected after stem cell research and before stem cell research. I think capsule network will be a potential application for that. Thank you.
Thank you, ma'am, for sharing your knowledge and experiences with us. I'm sure that the participants have been really motivated. You have talked about machine learning techniques for detecting health issues automatically from the medical data. So you have discussed about various machine learning models, in the different healthcare applications. So it was really wonderful to attend your sessions. And I really thank you from the bottom of my heart, because in spite of your very busy schedule, you could find some time for us. We'll be looking forward for future associations further. Thank you, ma'am.
Sure, it's a great honor. Don't hesitate to knock me. I will juggle and I will try to reach there. Thank you.
Thank you. Thank you. Now, may I request Professor Sheikh Anwarul Fattah sir to kindly take on the dais and start your speech. Thank you.
Thank you. Thank you for your patience, and I hope I can share some of my recent research works, which may help you in the area of deep learning based medical data analysis. Let me share my screen. I have the screen is visible.
Yes, it is.
Thank you. So it's about automatic disease detection from medical data using multi-perspective deep learning networks. So thank you for giving me the opportunity. This is an international FDP, thanks to Mizoram University and Northeastern Hill University for inviting me. So yeah, you have already given my biography. So please feel free if you're interested in participating different IEEE relevant works. So feel free to contact with me. So I'm serving different IEEE global committees as well as local committees. So I will try my best to include you in those committees. The awards, yes, it is also, you have mentioned about different awards. Just a second. Okay, so I know, like, whenever I am just dealing this type of FDP talk, so one major thing is like not all of you are exactly working on the same area what I'm presenting. So machine learning is a very big area, and we are especially today, I'll be focusing deep learning based networks. So just in 5 minutes, I'll give you fundamentals, because that you can relate all of my works with that basic concept. If you understand that, the rest of the part of the talk will be very useful for you. So first of all, in case of machine learning, what's happening whenever you are giving an image or medical data or input, basically what we are trying to extract some features, and then based on that feature, we use traditional machine learning algorithms, train them, and finally we have to also test them. But in case of, we call it end-to-end deep learning network, you give the input, the network itself will learn and extract features, and finally it will do the job, I mean the classification. So that's the advantage. You don't have to rely on handcrafted feature extraction, because which features will be good, how many features will be good, that's a big concern. In that case, in deep learning based methods, if you are able to design a very efficient network, and then the job is done. Yes, there are one concern, like you need to train the network, so you need enough data. But nowadays also we are working on a one-shot learning or minimum training set. Also, that's a different area. So in that case, when you are doing this training, you have the data. So this is a representation of your network. So you have to build this network. So forward path, backward path. So finally, you'll have to have an error function that you have to minimize. So I give first the example of artificial neural network. It's a very, very old network, but this is the fundamental network. In that case, in this artificial neural network, you can see if your data samples are X1, X2, X3 like that, you need a decision based on this X1, X2 data. And you have a label for the data. So what you can do, you can build an objective function. For example, y is a function of x. Depending on your x, you get a value y. Just imagine if you have two classes, class 1 and class 2, and just imagine if all these combinations of x1, x2, x3, x4, if you can get a value of y which is close to 1, in another case, the values are different, x1, x2, you get a value close to 2, then your life will be very easier. Just combination of your input data, if they give you a close value to a class level, say 1, another one giving you 2 all the time, then it's easily separable. But the life is not like that. That's the challenge. That's the objective. These given data points, you have to make a combination of them by using some weights. You can use like this right side, you can see this input multiplied by some weight and find out an output, so that for one class, this output will be given to a value, let's say close to 1, and the other class, due to this input data, you set your weights in such a way you get another type of class, which is class 2. That's the objective. So if you want to do that, yes, you can do by the use of artificial neural network. There your job will be to find out these weights. You can use this combination. You see here from 5 to 3 and then 1. You can add more and more layers. You will be having more and more flexibility to reach to that particular value. These are called hidden layers. That means from 5, when you reach here, one hidden point, you can use a lot of weight combinations, weighted sum. But in case of now what we are using, it's the convolutional neural network. The concept is same or similar. From one point, you are moving towards next. In between, you add a filter, which we call convolutional filter. So the left side, you see, this is your input. You have the, let's see, it's a 2D representation, you have pixels. So you 3 cross 3, you take and do the convolution and get an output. The question is, in previous case, you were supposed to find out these weights, multiplication weights, and now you are supposed to find out these filter coefficients. For example, this is your input, 1, 6, 9, this is your input. You have to find out a suitable filter so that you get this type of output. You may ask me, what if I use 2 filters, 10 filters, and why should I use this type of filter? What will be the benefit of this convolutional neural network? Believe me, by selecting these special filters, sometimes I'm giving an image example. For some images, these filters are capable of capturing vertical edges. In some cases, choice of this filter will give you horizontal edges, circles, darker part, brighter part, shadow part, changing part. So this is the flexibility. You never know. You can add a lot of filters. Each filter will be capable of capturing different types of characteristics hidden in your image. So the concept is same. You are trying to extract some sort of features from your image, but now the technique is you are using some convolutional filters These filter coefficients are your unknown. So if you are not aware of this deep learning, believe me, this is the fundamental. You will be given an input and your machine, that means the machine learning or deep learning, basically will learn these filter coefficients. That's it. Your job is to learn these filter coefficients efficiently so that you can have a better class separation. So here, few other steps are there. For example, if I give you this type of left side, you see yellow 30002, which one is most important? 30 is most important. So you just use the max pooling. This is called max pooling. Or you can take the average, because from long distance, if you look at 30002, what will be captured in your mind? 30. That's the natural. The actual max pooling is very common. Yeah, you can take an average 30 plus 2, 32. You can take divided by 4, 8. You can take an average. Even you can take an average of the whole. You see, the green one is average is 5. The blue one, I'm talking about the down. You see, this is called global average pooling. And one last is the flattening. Okay, the blue, you see, I have just flattened them, -1, 1. And the orange one I flattened. Why? Because at some stage when you have done the convolutions, finally you need a feature vector. That's this flattening will give you the feature vector. Once you are done with this feature vector, let's see x1, x2, I have already told you, that's the fully connected layer, or ANN, artificial neural network. That's the dense layer. So believe me why I spend time, because this is the fundamental structure that will be used in almost all cases. So you need some sort of convolutional network followed by some sort of pooling, max pooling or average pooling. You can repeat them several times. Again, I'm telling convolution, max pooling, convolution, max pooling. Once you are done, satisfied, you use the flatten to get the feature vector, and finally you use the classifier. So that's the dense layer. So now I'll be giving you 1D or 2D, 3D different biomedical signals. Their classifications may not be possible to explain details. You need to check those corresponding papers, but I'm sure you can get the idea. For example, first I'm giving you an example of ECG signal analysis using our own network. We call it DeeperNet. This is built by ourselves. It's classifying different types of cardiac abnormalities that you can find out from ECG signal, atrial fibrillation or ventricular tachycardia, different types of ECG arrhythmia we call. So this is our proposed DeeperNet architecture. Now I'll show you that this is nothing new, very common, but I will also tell you what's our innovation. The structure you see, you are given ECG data, and this is common pre-processing, signal processing. So you need to have some denoising, ECG peak detection, beat extraction, data augmentation. So these are very common. This is not about the deep learning. So once you have this ECG data, it's your job to find out these peaks, peak to peak distance, R peaks. So these you can do, the beat extraction. So this is a pre-processing part. I'm not focusing on that. That's not my objective today. This is our architecture, DeeperNet architecture. So if you look at our DeeperNet architecture, it's the same. You have the input, you have the DeeperNet convolutional block, then you would do the average pooling, global average pooling, and then you do some sort of flattening and dense layer, the same structure. So you may ask me, where is your contribution? The contribution is here, the DeeperNet architecture, the convolutional blocks that you have to propose or design an efficient architecture. For example, here, the concept here we used is pointwise convolution followed by a parallel path with a lot of temporal convolution. So you can see here input, and then, I mean, if you are familiar, these are common terms like you used, this is a 1D data. So the kernel size used 1 sample. Later you see kernel size 3 means 1 cross 3, 3 samples. So input data, stride means if you are leaving any points, that is called stride. Inside kernel is 1, using stride equal to 1. and the filter length, you are using 2C. It's very common. Like if you are using, I described you earlier, you remember, you see, if you are using 2 filters, then there will be 2 outputs like this. So if you are using here 2C number of, here, if you use here 2C, if you use here 2C number of filters, your output will be 2C. You see, F equal to 2C, the output is 2C. So those who are interested, you can follow these architectures. These are very interesting. And here we are using, this is our own architecture. I will say the advantage of building them instead of using other conventional architecture. So another thing, you need to extract features from multi-perspective. That's why you need a lot of blocks. You see, if you are using kernel 1, then every sample you're considering in 1D data. If you use kernel 3, at a time 3 samples you take and do the convolution. You move, then 3 next samples and do the convolution. So while you are taking 3 samples and do the convolution, and while you are taking 9 samples and do the convolutions, the concept is like that. You are accumulating information, considering more and more this temporal data together, because you don't know exact what is happening in the biosignal. So you need to vary them. So if you are looking for their correlation, their inherent similarity structure, you don't know whether it's hidden behind 3 or 9. That's why we varied the kernel. We varied also the stride, and we do depth-wise and point-wise. So depth-wise means, and point-wise means, like you do the temporal correlation, as well as you can also select a point and do the convolution in different channels. The back end are the channels. So as I said, I'll not be able to explain all details. You can listen. I'm not sure whether it's public. Recently, I have given a talk in IEEE Global Signal Processing Society. They have a school, signal processing school. So there I have a detailed, almost 2 hours talk on this deep learning. So you can check that. So what's happening here? This proposed network, you can see the accuracy is enormously high, 99% in comparison to the conventional other deep learning techniques. I give you another concept just to think. You'll be enjoying that. It's published in IEEE Sensor Journals last year. So you can consider about changing or manipulating your input. Not necessarily you always give the input directly whatever you have. So why don't you explore existing transforms? Different transforms are already proven to be able to extract different types of features. For example, this age detection or different types of time frequency analysis, wavelet is very popular. So why don't you use them? So before you apply this deep learning architecture, one of my suggestions, you can consider parallelly different representations of the signal. So you take the signal and you can transform even 1D signal into 2D. If you have multi-channels, then it's very easy. So that's what I'm telling you. You can check these papers. It's a very good idea. Now I'll give you some examples on image data. So recently we published a couple of papers. So I'm just picking up few of them for you, which you feel interesting because it's about COVID-19 and chest X-ray. And in particular, the first paper, this has already been cited 212 times within a year and a half. So you can see it's very high citation within 1.5 years. So this is the paper. I'll give you a brief why people are liking this. So this is the image data. If you are not well aware about this COVID-19 is a type of viral pneumonia. So it's a normal, viral, bacterial pneumonia, different types of pneumonia, and COVID is there. So once your chest X-ray is given, so your task is to classify them and identify whether it is a COVID or not. So in that case, the problem is data. As I said earlier, for deep learning, if you want to train your network properly, there is no way. I mean, if you have a lot of data, the machine will learn well. So we had a scarcity of COVID-19 data because it's medical data. It has to properly collect it. Ethical issues, medical issues are there, as well as it has to be properly labeled data. Labeling is important. It's COVID, it's bacterial, viral, normal. So here at first what we did, yes, I understand COVID chest X-ray data, we don't have enough. But what we have that we can use, we build our own CovXNet. It's not any conventional network. It's totally built by our own hand. This is the CovXNet. I'll show you. Then as we didn't have COVID-19 data, so what we did, we have a lot of normal chest X-ray data, viral pneumonia data, bacterial pneumonia data. So we use them for training. So there is no harm, because at least your network will be able to learn human chest X-ray. That means it will be gathering knowledge, because your COVID X-ray will be very similar to that. Let your network learn this. Rather than learning flower or fruits, learning this X-ray will definitely be a positive thing. So once your network is learned with this data, apart from this COVID-19 data, so what do you mean by learning? Learning means your network unknown weights are learned. Those convolutional filter weights are learned. So this learning will help you. You see the next step, middle one, will help you here. So this type of learning is called transfer learning. So you are now transferring your learn model to the middle part. You see the left, the middle box, I have written pre-trained weights and fine-tuning layers. What do you mean by pre-trained weights? Pre-trained weight means what you have learned at the first stage. Then in the next, this is the middle one I am talking about now. So you use now your COVID-19 data along with normal viral and bacterial data. But this time, the data size will be less. For example, 300, 400 samples, 300 images for COVID, 300 images for those non-COVID. But previously, you can, when you have abundant data, you can use 3,000, 4,000. So this is the next step. So once you use this pre-trained weight, now you train your rest of the part of your CovXNet with this balanced data. So it will be more efficient now. And finally, you do your classification. That's the simple idea. Now the concept is like, what's the story behind the success? Yes, one is this multi-stage transfer learning. Another one is the architecture itself. Again, I can show you, this is a very simple fundamental structure. You have convolutional block, you see, conv2d, residual unit, shifter unit. These are fundamental convolutional blocks, but we propose this yellow and pink one. It's our proposal. And then what I said, once you're done, you are satisfied with a lot of convolutional blocks, then you do the Glovage averaging and DenseNet for classification. That's it. So the thing here, you have to do residual unit. And this is about, you see, the pre-train. Once you do the COVID part, next stage training, you keep it frozen. this part. One part keep frozen, and the rest of the part you leave it open so that it can learn. Not necessarily you have to learn with a smaller data set all those stages. So this is our residual block and shift block. You see the very similar concept what I have shown you earlier. That's why I have picked up few of my publications so that you can relate. It's not very difficult. My objective is to tell you it's not very difficult. You just have to be innovative in this part. Here we have used depth-wise convolution. One thing we added, dilation. So when you are using the convolution here, you see the dilation rate 1 means it's compact 3 by 3 pixels. But when you use dilation rate 2, that means you can leave one samples. That is much better because you are now in a broader space, not necessarily all small pixels. They are always helpful to you. Why don't you dilated box you take and collect the information? It doesn't mean that we are ignoring that. We are using all of them. You see the dilation rate 1, see what's happening, what information you can collect. Dilation rate 2, dilation rate 3. You can change the dilation, that as well as depth-wise and temporal convolution. That will be our nice trick. And this is called meta learner. Also, not necessarily the given image size you have to be always kept as it is. Why don't you change it? The resolution will be changed. This is also a kind of, you can say downsampling. So if you are using this reshaping and do the similar work on reshaped image, you will not be expecting the same results, because once you are downsampled, it's a different, yes, I understand some information losing, but sometimes from when you are looking from far something, in your mind, you don't actually differentiate between two pictures or two class by looking at every pixel. Even for human being, you sometimes actually try to capitalize the gross shape. In that case, this is a good way because your job is not to segmentation, your job is classification. Then it's fine. So each path will give you a result, and you can use meta learner that will learn based on during the training phase. Input is same one image, but different path will give you different results. And you know the class is, let's say this is level 1, class 1. So you can understand this pattern and learn, okay, if the result comes 1, 1, 1, 1, then it is class 1. Sometimes for class 2, the result could be 2, 1, 2, 2. Still it is class 2. So in this way you can learn. This is called meta learner. This is the output you can see. And I mean, this is GradCam images. So the red one means this part, these pixels, these there, your network gave highest amount of weights. Weights were higher. So these GradCam images sometimes help to region detection. It's also helpful. So if you are if you see our results, it's also very impressive. As my time is, I guess, almost, yeah, I have maybe 5 minutes. So I can show you one example from chest CT. It's not the X-ray. You can find our paper in Transaction on Industrial Informatics. It's a very high impact journal, 9.1 factor. You can also find of the CT work in IEEE Transactions on Artificial Intelligence. I can give you one of them, which is a fantastic work. This is called COVTA-net, Try Attention Net. This COVTA-net can be used in other purposes also. So here we are proposing first time the Try Attention unit for chest CT X-ray. So the job here is very multifarious, I should say. Here, your task is to, from a given chest CT, you know the CT, chest CT images, they are basically a volumetric image. So from each chest CT image, you have to give us 3 types of decision. First of all, you have to tell whether this image belongs to COVID-19 or not. Then you have to give us the lesion. That means which regions are affected. Thirdly, you have to also give us the severity prediction. You see, these 3 tasks you have to perform. So when you are doing this, our fundamental is that we will be using segmentation. You see the left side red loss function corresponds to segmentation. Right side, you have this COVID-19 detection, and bottom here, the severity prediction. So 3 loss functions are there. So let me tell about this attention mechanism, which we are now using a lot, because sometimes when you do this deep learning network from a spatial image, it's not necessarily every pixel will be very much important, or every channel is always very important. You have to have the ability to know the region of interest or the interested channels. That's very important. That's why we used tri-attention unit. So here you can see channel attention. That means if you have 10 channels, 20 channels, which channel you should give more attention. Spatial attention or spatial attention, where you can see your spatial image, which pixels need to be give more attention. And pixel attention. So you call it voxel. You take a pixel and looks around and give me decision whether it's important or not. So the attention unit, the job is very easy. You have to create an attention mask and multiply. Definitely, this attention mask will have weights, different weights. For example, if you're talking about behind 10 channels, and if you multiply those channels by different weights, so definitely few channels will be getting higher weights. That means they, in your task, you are giving more attention to them. So this is a simple unit block. So if you are not familiar, then you can check. This is a simple unit block. The green blocks are the unit architecture. So here, the idea here, if you give an input with some mask, okay, this is my important region. So unit can eventually identify those regions. This is called segmentation. But yellow, these yellow box are not common in conventional unit. The green 16 and the right side decoder 16. In between, we implemented our tri-attention unit here. Also, the output of here and the output of decoder, we also use the tri-attention unit here. As a result, you can see because of this tri-attention unit, the results drastically improved. You see the 88% instead of 82, 81 conventional networks. That's what I'm telling. It's a very, very effective unit. So you can use them and see the results. So conventional unit segmentation, if there's some red, this red indicates error. You see the proposed, there is no red, all green. So we don't have any mistakes, very less mistakes. You can see the conventional unit, powerful multi-res unit, infinite net. So you can even compare the performance by looking at these region detections. So that's the beauty of this tri-attention net, COFTA net. We also worked on ultrasound. I'll not be explaining the ultrasound image-based COVID-19 detection. Only one thing I add, sometimes signal processing may help you, because in this case, we have shown this Speckman DL. You can check our paper on ultrasound. So the Speckman DL, you can see, you do a small spectral mask. The right side, you see this block, mask. If you use that mask, we have shown this mask-based processed image. If you used, then you get this color map. You can see the mask. This is the mask. So use of mask gave us drastical improvement in the deep learning network. Sometimes deep learning when you are in your input, you may process and use deep learning, and that may always, sometimes you may get better results. So that's the multi-perspective idea. Your idea is to enrich your network by different attention blocks or different input or different types of convolutions. You can also use transfer learning. And one thing is the joint optimization that we did in COFTANET, because we have several tasks. So rather than doing the 3 tasks separately, you can always do them jointly. The network may be complex, but that will give you better results. Thank you for your patience. Thank you.
Hello. Thank you so much, Professor Fatah, for your very excellent and informative presentation. I think we have a few questions for you. Let me read out, Professor.
Yeah, sure.
First one from Balaram Singh. He says, which one is better, max pooling or average pooling?
Yeah, there is no direct answer. It depends on your data. As I said, if you look for very far, sometimes max pooling may be a good one. There is no exact solution which one will be better. Most of the cases people use max pooling.
Okay, let us take the next one from Venkata Subramanian. He asks, in case of CT scan and MRI scan, is same logic followed?
Yes, that's a good question. Like CT and MRI, we are both of them. So I give you one very easy idea, like CT and MRI, you will be getting the data in volumetric data. So slice by slice, let's say 128 slices. So 128 images. MRI, they have 4 different modes. So you will be getting 4 volume. Each volume will be having slice by slice. So it's up to you. We have some papers where we have done, this is called volumetric processing. Volumetric processing, computationally expensive, but that will give you very nice idea, because you will not consider a pixel, you will consider a voxel, filtering of the voxel. So that's a part, you can do that. Or if you want to make your life easier, CT, MRI, you just extract the images from the volume and operate images slice by slice. Finally, combine your decision, because finally, for example, in brain tumor from MRI, you have to give the volume of the brain tumor. You cannot give me one slice results. You have to combine them and give me the results. So the question is good. Both of them input is volume. You can work slice by slice if you are beginner. Or later, you can also work on volumetric image processing. Thank you.
I think Professor Jamal Hussain is probably offline or what? I think, sir, there are few more questions if you kindly take.
Sure.
Give some
Another
examples
question
of,
is,
yeah.
Oh, you will read?
Yeah, you can take up, no problem, sir.
Yeah, some examples of popular CNN architecture often used in transfer learning for CNR, chest X-ray detection and segmentation DNN models. Yes, that's very good. I mean, when you are asking these questions, I'm very happy. So if you, from your institution, you can also arrange something, because I'm also working in different platform. So this is the question actually people will be asking, we know. So we can give you, now I can give you some name. but then we can show you why this is better. For example, if you are telling me about the architectures for this image analysis, this CNN, there are VGG16, VGG19, InceptionNet. So ChestXNet itself is there, GoogleNet, AlexNet, ResNet. In ResNet, you have ResNet 50. So a lot of architectures are there. And if you tell me, yes, they are very powerful, very, very powerful. And you can always see the Kaggle computation platform where for the larger data sets, recent models they will be given. So that's what I'm telling. It's very difficult. Which one is the best? These are some different networks, and your segmentation. Yeah, segmentation is UNet is the most popular. So interesting. Whatever name I have told you, and also for our CovexNet or our networks, these codes are free. These Python codes are free. You can use them. And for segmentation, UNet, UNet++, ResUNet. So there are different architectures. And the last one is, thank you, sir, for an insightful session. Please explain how image augmentation is used to generate more samples. What could be the minimum number of images? What could be the minimum number of images to use convolutional neural network with the help of image augmentation? Yeah, this is a very, very good question, because you are asking signal processing and deep learning. So augmentation is a very big word. So if you feel, the question is when you have to use the augmentation. When your data is small, only then? No. When your data is imbalanced, also you need to try to incorporate more data for the less populated class. Say you have 3 classes, one class has 3,000, next class has 3,000, one class has only 5 samples. Can you do that classification? Never, you'll fail. We are doing this work for skin disease classification, dangerously unbiased, unbalanced data set. So you need to augment more and more data, create more and more data. So you can use GAN, so that generates more augmented data. Apart from that, what we prefer, we are always generate data by using different morphology. You'll see there are more than 10, 20 morphology by using, squeezing, expanding, scaling, so some sort of sharing your data. So these are the different name of augmentation. I suggest you just Google, you will get the name of those augmentation data. So these are, if you share the image, so it's distorted. So your objective, please remember, while you are creating your augmented data, if you do the redundancy, the same thing you use 1 million, there will be no benefit. Try to innovate more new types of data. While you are creating, you have to face the real life challenge where you don't know what type of distorted data will be appearing, and you will face the problem. So that case, you use different type of morphology, different types of noise you can add, not only additive noise, also you can use homomorphic noise, convolutional noise. So these are different types of creating your augmentation data. Yeah, minimum number of images, there is no minimum number of images. As I said, it depends on other classes, which class has how many samples. That is very important. So there is one very interesting research we call one-shot learning or minimum shot learning. There in the test, you will be given very few, only 2 samples to learn. So that's a different area. Thank you. I think these are the questions.
Yeah.
This is last question, role of ML on healthcare, overview requested. Yeah, so this is a fantastic question, because before you are planning to step into this area, ML for healthcare, you have to understand the role. Because now you see, because of digitization in your hospitals, digital data are available. And in our subcontinent, patients are not very, I mean, they will be not creating problem to allow you to use the data without declaring their identity. So once you have the digital data, then for healthcare sector, this is very important. If you have these automated disease detection tools, what we say for telemedicine or various other applications, your doctors, specialist doctors may not be available there. So the tool can give you preliminary idea. For example, nowadays, you don't go to the doctor for your blood pressure checking. You rely on your machine. And days will come, believe me, you have your X-ray from the diagnostic center. They will send you your digital X-ray, and you can use American tools or Indian tools or Chinese tools, European tools, and you can also detect your own analysis and have an idea what type of disease you have. That's the goal. So medical, this healthcare sector, if you can give these automatic disease detection things, apart from I'm talking about this health analytics, where you can manage patient, that's a different area. Drug delivery, that's a different area. Every sector machine learning is used. Drug delivery, patient management, and also we are working on automatic disease detection, automation. That's a future, I should say. People are now using cell phone for every purpose. Whether there will be a rainfall or not, they don't rely on this weather side. They use their Google and they find that whether there will be a rainfall or not. Similarly, for disease prediction, if you have this ML, your cell phone can always tell you, okay, whether there is a chance of this disease or not. And especially these heart diseases can save a lot of people's life. Thank you.
Thank you so much, Professor Fatah, for your time and sparing time for us. And I must mention it's an excellent presentation, and thank you for sharing your ideas and your experiences. I'm sure all the participants have benefited, and those who want, can reach out to Madam Celia and Professor Fatah also. And we look forward to future association and collaboration with both of you, sir. Thank you so much once again on behalf of the organizing committee and on behalf of all the participants. Thank you so much, both of you.
Thank you very much.
Thank you.
And dear participants, ladies and gentlemen, welcome back to this, in fact, third session today. We had to organize this to compensate earlier cancellation of the same lecture. Because of unavoidable circumstances, we could not hold it. So I'm happy that Dr. Bora agreed and he's here now with us. So let me introduce, it's my proud privilege to introduce Dr. Surajit Bora. He is a data scientist at Huawei Technologies, Bangalore. He is a PhD from Tezpur University in Electronics and Communication Engineering in 2006. He received Commonwealth Split-Side Scholarship in the year 2004-05 and did PhD research at Warwick University, UK. Before joining Huawei, Dr. Surajit Bora was working at few other organizations like Tyco, Johnson Controls, and Siri Tech, etc. He has spent most of his industrial career into research and innovation in the fields of image processing, CV, AI, ML, DL. Dr. Bora is one of the inventors of 10 USA granted patents. Today, Dr. Surajit Bora will talk on practical applications of AI, ML in digital ads industry. During his talk, he will mainly cover that CA, AI, ML aspects and few examples of ads industry. Dear participants, actually we wanted to have a balance between academia and industry. So I'm happy that from industry we could get Dr. Bora here with us. He has vast experience, and I hope we'll get new insight and into AI and ML and deep learning as well. So with these words, I welcome Dr. Bora. And Dr. Bora, you can start your presentation, and floor is yours.
Thank you. Thank you, Professor Hussain. Thanks a lot for this lovely introduction. And it's my privilege, like, I'm really happy that, I got this invitation to talk in front of you. Even though it is virtual, but I feel like, it is even more convenient for the presenters and participants to have this kind of sessions. As as introduced, means I was earlier, I was in academia and I did my PhD research as well. But last 16, 17 years, I have been working in industry and different industries, and currently I'm working in Huawei. That's a Chinese giant, of course, in telecommunications. But my field of work is basically into AI/ML, deep learning, machine learning, and computer vision. And our domain is basically into advertisement domains. I will today talk on different applications of AI/ML. Of course, I'll just touch upon kind of little high level, and then I'll show you some of the prospect of research into this kind of field. And I think I hope this will motivate most of you even to pursue some of your research into that direction. So having said that, let me share my screen, and then I will take you through some of the slides. Just give me one minute. Yeah, I hope you can see my screen.
Yes, it is visible. Please go ahead.
Yeah. So I'll just talk about a little bit on advertisement before I'm going through my slides. So every day, each and every day, probably all of us come across lots of advertisements. We at least we can see a lot of advertisement in newspaper, or maybe if you're on the TV set, or if you read something in our laptop, mobile phone, we can see a lot of advertisement, right? So somewhere these advertisements are generated, and somehow it came in front of us. If it is maybe a newspaper, definitely it is a broadcast. It is fixed, and there are some slots available in the newspaper, and the advertisements are pasted on top of that, and we all of us see that. But if it is your mobile phone, or if it is your laptop, or if it is maybe you are watching some YouTube videos, or then probably it is little bit of customized towards your interest. Probably you have already observed that particular aspect. Maybe if you're interested with something, maybe you have already watched some of the advertisements, then maybe a similar kind of advertisement you keep seeing in most of the time. Of course, some of the things may be completely opposite, but still you feel, okay, this is some of the advertisement which probably you might have interest, right? So having said that, somebody is behind the scene, definitely, who is coordinating all this stuff, definitely, right? So, and if you talk about this kind of things, that it is customized to you, or maybe how those advertisements are created by someone, definitely lots of technologies, maybe AI/ML, deep learning, computer vision, these kind of technologies are involved there, because all of these things are involved with image, videos, a lot of different types of text involved. So that is why it's a very huge field for the industries. I'll show you some of the big giants who are actually investing money to create platform to create the advertisement, and how actually those big organizations are kind of delivering advertisements, and what sort of technologies are involved, and what sort of prospects are there
I'll talk on those things like little briefly today. So if you, this is the digital ad ecosystem. So if you see like big players like for example Google ad, again like Facebook. Okay, and if you see some of the amount of money involved in this kind of domains, for example, these are $134 billion. So you can imagine how much revenue probably they can generate based on that domain itself. Facebook is also similarly almost 69. I'm giving some figure in terms of money just to show you that people big giant organizations are investing money or generating revenue through the advertisement domain. That's what my clear message to you. And secondly, some second tier organizations are also involved, maybe Amazon or maybe TikTok or maybe Alimama, and similarly Alibaba, and some third third tier. These are other organizations. You probably don't see Huawei here, but anyway, we are somewhere, of course, but we are not showing it here as a slide. But we are also one player in the advertisement domain. So these many different organizations are working in ad domain, and they are delivering ad, and they are arranging what to say, how to bid the ad, and how exactly it comes to you as a personal advertisement. There are a lot of things are happening in in behind the scene. So I'll go through some of those things today. And this is basically a digital ads ecosystem landscape. Okay, so if you look at the left-hand side, there are some advertisers. Okay, anyway, at any point of time, if you have any questions, probably you can stop me and ask the question. I'll be very happy to answer if I can answer your questions. Okay, now at the left-hand side, you can see there are some advertisers. Advertisers are who basically who creates product as a company. Maybe they create product and they want to do the advertisement of their product. Okay, they may have their own people who actually create the advertisement, and they can go into the market. But otherwise, there are lots of ad agencies also. They can rely on those agencies, and they will do they will say, okay, we want to advertise this particular product, and please go ahead and advertise for us. Then either this advertiser or the ad agency, they will go to the ad server. So ad servers are those maybe created by either Google, Facebook, Huawei, or any whatever I had shown in my previous slide. Yeah, any of them maybe having some ad server. So what is ad server? Basically, this is the actual place where we create the advertisements. When I said advertisements, it could be either in terms of banner, or it could be maybe the video advertisement, or anything, or having music, or mostly these two, banner and video, you can say. Okay, and then once kind of advertisements is created, then they will kind of go to the DSP. DSP is what demand side platform. Demand side platform. This DSP actually not the other DSP, digital signal processing. No, this is a demand side platform in language of digital ad domain. So this DSP, and DSP is nothing but they know what should be their customer of that particular product. Okay, and they know how much money they can spend, and they know where exactly they want to show their advertisement. Okay, then if you look at the right hand side, there are some publishers. So publishers are who? So they basically publish some advertisement. They are they don't know what is the advertisement. Based on something they have some what to say, they have they know what are the segment of some of the customers. Maybe you see, they know who are using mobile phone and who are using laptop, and what sort of interest they have, who are watching what sort of movies, or who are watching what technology. Maybe they are seeing YouTube most of the time. They are seeing some technology tutorials and all. they know everything. And this is like an SSP, as SSP is supply side platform. So basically they know everything, and they know, like, okay, this is my minimum price. If I get this much price, then only I will show advertisement. So in between, like, there is a ad exchange. So this ad exchange is nothing but like some of the bidding. Okay, so basically, okay, if there is only one particular advertisement, and like, they have to show, like, an SSP has to show some advertisement, then probably it is a very simple thing. But there are a lot of players in the lot of advertisements are coming to the ad exchange, and there are like a lot of even SSP also, publishers. There are a lot of publishers also. That's why, like, this ad exchange, they have to, like, rely on some of the machine learning algorithms or so. They cannot just straightforward, like, show some images. They know, like, they have to analyze the data, and based on that, they have to publish the advertisement into, like, each and every mobile phone or maybe whatever. Okay. So having said that, this is again a very broad field I just talked about, just to show, like, in this place also we need to apply machine learning, deep learning, means whatever AI, ML we are talking about. Okay. But I personally work only here. Okay, so because in Huawei itself, maybe like out of 100 people, 100 data scientists, maybe like, some of them are working in this side, some of them are working in this side. I am maybe like, a member of a team of size 10 or around 10, 15 people, and who are actually working only here. So today, and this particular one ad server, this is actually generating the advertisement. So this is basically some technologies like the computer vision, deep learning, machine learning we daily use. So that is what, like, I'm going to talk today. I'm not going to talk anything about a DSP. I'm not going to talk anything about a SSP. I'm not going to talk anything about the ad exchange. But if you are interested, even like, this is also a huge field, kind of ad exchange. Definitely, like, you can go ahead and, like, explore what exactly digital advertising, what is actual ad exchange, and what is, like, in digital marketing, what are those things, and what sort of prospects are there of research you can definitely explore. Having, like, that thing in mind, I just showed this a broad picture of this, and yeah. So then I'll, from now, like, I'll go ahead and talk only about the ad server. Any questions so far?
I think as of now, there is no question, Dr. Bora. You can go ahead. They will ask in Q&A section. Q&A.
Sorry, I didn't hear the last part. Can you?
In Q&A down there, it will be visible if there is a question. Yeah.
Your voice is very low, actually. Am I audible properly?
Yes, you are audible. Yes.
Okay. Okay.
Please go ahead.
Sure. Any questions? Like, you can just stop me and ask. No problem. Anytime I can stop and answer any question.
Yes.
Okay. So I'll give you some background. So as I said, like, I work only in the ad server. So ad server is nothing but, like, creation of the ads. Okay. So I'm giving, like, I'm trying to create some context of ad server. So you see, there are 7 advertisements. Just I downloaded from the internet, and I have pasted here in this slide. So these are some banner advertisement. Okay, so you see, this is an advertisement of an university. So go to BSU, go beyond, basically, like, in a Bridgewater State University. So there is some picture in here. Here also, like, there is a picture, of course, different picture. And again, this is again an advertisement of an university. But they are, instead of, like, something, some building, and they are just showing some playground here. So what is the message here? On-campus benefits. Okay, so I'll not go through all the advertisement, but have a look in all the advertisement. And one thing probably you have already noticed, like, they are trying to use some catchy sentence, right? Go beyond. Here also, on-campus benefits. Here also, like, what's life-changing stories unfold. Okay, so these are, like, some catchy sentence. I'll come to that. Before that, I'll tell you another thing. You see, there are different sizes, dimensions of those each and every advertisements, right? So who defines what sort of size it has to be? Basically, this is defined by, okay, if you just think about a newspaper, there will be a placeholder for the advertisement, like, and that particular place will have a particular dimension, right? Maybe this may be like 3 inch by 3 inch. Okay, the advertiser knows, okay, I have a place 3 inch by 3 inch. I have to create an advertisement of that dimension, and they'll create an advertisement and send it to the newspaper, and they will publish it. Similarly, like in a mobile phone also, if you keep watching something, there will be some slots specified, and in those slots only some advertisement will come, right? So it could be either like in a squares type, it could be horizontal, it could be vertical. The different dimension of the advertisements, right? And each and every advertisement you might see like there is a image involved, there are text involved, there are logo involved, lot of things. And you see like these are designed so that like it is aesthetically pleasant most of the time, right? So there are a lot of things actually you have to take care when you try to create an advertisement. There are a lot of things you have to take care. For example, where you will put the image, and where you will put the text, and where you will put the logo. All this stuff you have to take care, and you have to take care automatically. Ultimately, like it has to be aesthetically pleasing, and at least like whatever message the advertiser wanted to broadcast, it has to go out. So that is the intention of the advertisers. So now, as I talked about, there are some catchy some catchy sentences. So who writes these sentences? Basically, there are some copywriters in each and every organizers. Basically, not now very what to say. Nowadays also copywriters are there. But my point, what I'm trying to say, a particular person, how many different types of this kind of catchy sentences he can write daily. So definitely, like these people, copywriters, are very that particular job is like a very well paid job, because based on him only like a lot of what to say, success of that particular product will lie most of the time, right? So there are like some trends started kind of using AI. Even we can write, we can start writing copyright. So this sentence itself is called copyright. Okay, so this copyright we can write like using our using maybe some NLP type, not NLP exactly, but type of NLP. So what we can do, we can just talk about, we can write something about the university. We can not university, any product maybe. Because like I'm showing some university advertisement, that's why I'm saying university. We can write something about a university, and finally our algorithm will say, okay, this could be like best copyright for you to use in the advertisement. So that is one. Okay, so you already came to know like there is a prospect of creation of the copyright in the advertisement. And then another thing is that this particular image, where I'll fit the image. You see, if now it is a vertical, but if my slot is available which is horizontal, then how can I fit this particular image? So definitely I have to do something. Either I have to squeeze it, or maybe like I have to crop the image. Which part I will crop? Means which one is the like important piece of information which probably I can crop, and if I put in the advertisement, it will serve its purpose. So definitely that is again another type of research we have to do. We have basically like we have to crop the image, or yeah. So at least like the useful information will never cut. Okay, this kind of things we have to do in the advertisement. And finally, the template, I mean to say, you see the organization of the things, all the things. So whether should I put this image on top, or put the logo down, put the logo in the right hand side, left hand side, what? Means there are a lot of things we have to take care when like we have to create one advertisement. So these are different types of research involved in creation of the banner type of advertisement. Okay, so I'll come like some of them maybe in my later slides, but just to like trying to start the context, like I just wanted to explain all this stuff upfront. Okay, so here what sort of things we saw? Copyright, maybe like image cropping, or maybe like the layout design, everything. And these all things have to be done automatically. It is not something like, somebody is going to intervene something. Maybe like, the advertiser will just explain something about the university or something about the product, and they'll give some image, and they will like, put the logo, and you will get maybe 100 of different types of advertisement, and they will say like, this is the rank 1, this is rank 2, this is rank 3, whatever you want, like, go ahead and use as your advertisement. So this is what actually done by the ad server, and we basically like, work behind the scene in that particular kind of work. Okay. So this again, like, this is one video advertisement. What happened? Okay, here also there is one video is playing. Some of the text are coming. This is very simple advertisement, of course. And here also another one maybe have to use. Yeah, things look very simple, but at the same time, somebody has to create this kind of things. That's what like a message I wanted to tell you. So for that also, there are a lot of things, a lot of research or like implementation you have to do. Then only like it will come as this kind of advertisement. Okay. So far like we have talked about banner advertisement and video advertisement, and I will basically like stick into this two kind of different advertisement and what are the technology involved. I will just talk about in some of the later slides. So again, this is same thing what I have spoken. So the ad platform, the products advertisers, ad creation, digital ads inventory platform, ads delivery. So these are basically like, there are millions of product kind of available in the market, right? So the ad server, like, we create the advertisement, and then those like, whatever I talked about, kind of the SSP side and all, and they require like an AI ML, and finally like, it comes to you and you can see the advertisement. And whenever like, you keep watching something like, in YouTube or so, some advertisement comes, and most of the time, even that is my personal experience, like, I'll wait till like, the skip ad comes. Whenever it comes, I click skip ad and I keep watching my video. But there, like, success is not involved for the advertiser in that. If the customer doesn't click skip ad, then only like, success of the advertisers. It is that is why like, you have to create your advertisement in such a way that like, most of the time user doesn't click on skip ad. I'm talking about the video ads, right? So even like, for other advertisement also, banner advertisement also, if you maybe have something in your mobile phone, you see some advertisement, how many times you click on the advertisement to go to the product and see the what sort of product it is and how much price? There also maybe like, success of the advertisers will not lie. But if, for example, seeing an advertisement, somebody click on it and like, go to the like, e-commerce website and buy that product, then only like, success of the advertiser. Okay, then the advertisers say, okay, yes, I'm successful now because like, this many people have bought my product. So to create this kind of advertisement, and most of the time you can see in your personal life itself, based on the advertisement itself, you buy maybe a lot of products. Not kind of, if there is an unknown product, probably you can think of, oh, what sort of product this is. I have never heard about this. Whenever you heard about the one particular product, then only you can think of, okay, yeah, I have seen this advertisement. Okay, go ahead and buy, right? So this is what like, the background of advertisement. And now I'll talk on, yeah, hype cycle. So what is hype cycle basically, like, in the digital advertising? You see, this is like, 2020. I didn't see anything came out in 2021, at least like, for the digital advertising. So whenever like, you have to start on some new technologies, definitely like, it is always better you just go with the hype cycle in most of the time, right? even in research also, it is same for educational institute, it's same for the maybe for the organizations, for anybody. So the hype is kind of always it should be an influencing thing, that okay, I have to these are the very high trend research topic, maybe most of the people are working on, and there is a chance 2-year chance down the line, maybe this will be productized. So definitely we need some breakthrough, and this is again a very good initiation of your research project as well, so that even you'll be able to publish a lot of papers also, because there'll be a lot of competition here. And if it is definitely if you have a breakthrough, definitely those things will be going to somewhere, and it will be productized, and you will be definitely get benefit, or yeah, maybe to go to the next research, right? So one of the things in this one of the hype is the generative AI. So basically GAN, right? So, and similarly in some other thing what is that advanced supply side bidding, what I talked about ad exchange and all, right? So these are at one point of time 2020, maybe these are already here. Now it is 2022. So it was started in 2020, okay, but GAN could be one very important technology for advertisement domain. So that hype was there at that point of time itself in 2020, and people have started working towards that. And even we also in Huawei, we have this kind of technology. We work on this kind of technology. We kind of sponsor some project to the outside universities, so that some professor will sponsor, and they are also working for us. Not only GAN, I'm just saying talking on example, but different technologies, different organizations are working for us. Working for us means we sponsor, and they work on for us. And we work as as an insider also in Huawei. We do research on different technologies, and all are based on, not all I'm saying, but most of them are based on this hype cycle. So I think this hype cycle is a very important thing, and we can start initiate our research, and whatever survival of fittest, definitely it will be productized at one point of time. Some of them maybe some technologies may not be suitable for productization, or maybe it will fail in the kind of when it was when people were doing research, maybe it's fail, and it is not suitable for productization, and those will fail, and whatever is successful, maybe will be productized, and organizations are benefited by that, right? So same thing, in the left hand side also I mentioned about the same thing. GAN is one of the important thing. Again, multimodal summarization, story generation, as I mentioned about the copyright, maybe GPT-3 is one of the useful techniques for the even copyright generation as well, or maybe storytelling. Basically these are something NLP side, and maybe in the GAN also, style GAN, these things are there. And in computer vision, definitely object detection, extraction, deep image matting, super resolution. These are the different technologies also part of our advertisement. I'm just giving some examples only, but there are a lot of even I can tell you most of the technologies which are as of now available in publicly available. Most of them are actually involved in ad domain. That is what I can tell you very proudly. So it may not be true maybe for other domain, but in ad domain, because we are generating something, right? So that is why all sort of things are very important in ad domain. Okay, this is what hype cycle. Now after that I'll go to some of, just to talk about some of the techniques we use. I'll show you one picture here. Okay, just I have downloaded this picture just to explain something. So you see a lot of stuffs are there in the picture, right? So I'll just have a blank screen now. Again, I will show the picture. So did you see any difference between previous picture and current picture? Any one of you can unmute and tell me if you have seen any difference between the previous picture and current picture. Of course, the same picture, but there could be some difference. Okay, in previous picture, like, you can see there are, like, some shadow of, like, in the water, the reflection of the building was there. But in this picture, that particular part was, like, erased, right? So that is the only difference I can tell you. But point is here, I'm not going to tell about that, but point is, like, you see in an image, there are some salient objects. Okay, so not all the like, part of the image are important for the viewers. So this is even true for advertisement also. Okay, and even, like, for any image, that is true always. Kind of whenever you see something like, a big banner or something, not all the part you will see, just slightly somewhere, like, you will see, and that is enough, right? So that's what I'm trying to say. In an image, like, not all the part of the image is important. I mean to say, it is not kind of it's not catching our eyes. Okay, that is, like, not intentional, it is unintentionally, that is true most of the time. That is what, like, the saliency talks about. So similarly, in advertisement also, as I said, like, I want to use some part of the image, maybe, like, a salient part of the image only we can put in our advertisement. And then previously I talked about, like, okay, we'll crop the image. Maybe based on a saliency also we can crop the image. Okay, these are the salient part of the image, and I will use this part only image as a product, like, as an image part in the advertisement. Okay, so to talk about, like, this part, I am going to talk, okay, how to use the saliency in advertisement. Okay, so assume, like, this is a picture. So earlier, like, before deep learning started, maybe then also some saliency map means we were able to generate some saliency map of the image, right? And this is what maybe the output of the saliency map, right? Now maybe, like, after deep learning started in 2012 or 2011, then since then, like, things are going towards something. Maybe now, if we talk about salient object detection, maybe, like, we can get output like this. And this is, like, a result of one very popular recent paper. This is U²net. Okay, this is the output of salient object detection of U²net. I'll talk about that paper also. But what I'm trying to say here, okay, so what are the use cases, maybe, like, from the saliency we can get out of? Okay, I'll talk about that. So it is, as I said, maybe, like, I want to blur, like, most of the, like, background, but not the rhino in this image. I can use this particular, I can have this mask, and, like, I can untouch this one and, like, do blurring of the rest of the part. So definitely, yes, right, in advertisement you can see this kind of thing. So definitely this particular deep learning algorithm definitely useful for doing this kind of work, right? So if you, like, want to work on some sort of salient object detection algorithms, there are a lot of prospects, I'll tell you. I'll show you some of the examples maybe where this kind of deep learning techniques doesn't work. So what is the improvement, like, proposal for that? So would you like to do research on that, like, so that it works in a generic manner for all sort of objects? You see, some maybe, like, some of the salient object detection algorithm works maybe, like, for the human picture, or maybe some animals, or maybe, like, some birds, but it doesn't work maybe, like, for the products where, like, it is a straight boundaries and all. And some deep learning techniques are something like that, like, it works better with like, the product images and all, but it doesn't work with the human portrait image, or maybe, like, an animal image, bird image, something like that, or natural images like that, maybe indoor image, outdoor image. But do you have any algorithm which works for all? So this kind of questions, like, we have to answer, like, based on our research. So here I can show you, this is the what U²net architecture I was talking about. And this is again, like, in a previous version of the U²net. This is of the same author. This is called BASNet. And even, like, recently one paper came out that is again called Tracer. And even, like, transformer is also come into, like, vision transformer. So visual saliency transformer is also there. I can see, like, the result of all these new technologies, new algorithms are almost identical. But again, as I said, that's again a question mark, of course. again, because like, it is based on what sort of data you use for your training, and what sort of use case you are looking for. It depends on all this stuff. But definitely, I'm saying like, it is maybe only 95% successful. What about the 5%? Can you like, start doing research on those things? How we improve the result, so that like, whatever we see, maybe like in the previous picture, it is good, right? It is good, but is it working for other object? So that is the question. So here in this particular architecture, you can see. Sorry, yeah. So here you can see this is a encoder decoder architecture itself, like inside, and sorry. So again, like another encoder decoder architecture. Okay, these are even like connected, and finally like again it is a U structure, and finally like it will give you the mask, right? That's how like you train this kind of. Here also it is similar almost, but in a different architecture. This the cascaded encoder architecture was not there here, but I can say you like from this to this, it is slight improvement, but you see the like a difference in the architecture. So what new architecture you can think of which will even kind of improve results, like in a generic way? This kind of research you can like if you want to pursue research, maybe like you can start with some in-depth survey papers. There are a lot of survey papers in this salient object detection, and based on that, like you can start doing research on that. So another aspect is like image matching. So what is image matching? You see, even in salient object detection, you will give some rough about the object, right? But if you want to have the fine boundaries, then like what? How can you achieve that? Okay, and that's what like refinement is talked about by the image matching. Okay, so it is image matching. Maybe I'll come to the other part also. If you look at the like formula behind that, you see this is the formula for one particular pixel. So if there is a alpha, assume like RGB image, and there is a alpha channel as well. If you add one alpha channel, assume like that alpha channel is a mask. Okay, and if you consider just only one pixel, then the alpha into the foreground and 1 minus alpha the background. Okay, one particular pixel, how much that particular pixel belong to foreground and how much that particular pixel belong to background. So this is what like that formula says. Okay, so that means, as we talked in salient object detection, where it is like completely binary mask. Okay, that is what like a completely binary mask. But here it is not a binary. Maybe some portion, maybe 70% of that particular pixel belong to foreground, and 30% belong to background. So that is what this particular formula says. Again, how many? If it is an RGB image, so how many equation you can think of? There are only 3 equations. Okay, and if you look at the like how many unknowns here, there will be 7 unknowns. So 3 equations, 7 unknowns. How can it be like possible to solve that equation, right? So definitely like we have to rely on training, that deep learning and training. That's how like we try to kind of calculate some of the this 7 unknown values. So how do you do that? So in 2017, like Adobe came up with a paper, deep learning paper. Of course, like previously also, it was not a new research. In even like 2000 also, when like when even I didn't start my PhD research, that time also like people talked about alpha matching. Okay, this is called alpha matching anyway. Alpha matching, like the Poisson matching was there. Some other matching techniques were there. Those are classical things. But when like deep learning started, people started thinking about, can deep learning can solve this image matching as well? As I said, like in 2017, Adobe came up with a proposal. Okay, this is the paper. Okay, I will go to the paper later on. Maybe I'll show you that. But before that, again, I will show you this particular one. So how exactly the image matting, what is the result of the image matting? So you see, if this is an input image, and assume like this is okay. In this particular case, we know this is completely a background, and this is a foreground. But there are some ambiguity here. I don't know precisely, like okay, I know somewhere it is background, but in the boundary I cannot say precisely this is the foreground. Okay, and if you are completely inside one leaf here, then okay, I can say okay, this is the foreground, right? But basically, like there is a confusing region here, right? So that is what, like they are talking about. Okay, I am confused with this particular regions, because anyway I cannot go pixel by pixel. So I'll say okay, I am confused with this. Similarly, like all other. So if I like process these two together, our deep learning algorithm will say okay, this is your mask. Okay, assume there is a deep learning algorithm used to process these two images. One like an input image, one is like with saying like this is called trimap, and where like there are ambiguity, will say okay, I'm confused with this sort of pixels. You please like deep learning method, you tell me like what should I do, and deep learning method will tell okay, this is what like your mask is. And this particular mask is, as I said, like not binary, and that is what like this histogram talks about. Okay, this histogram is nothing but like a histogram of this. So you see, like there are all sort of pixels involved, not like either 0 and 1. Even I didn't even draw the 0 and 1 here, just to show you like the distribution of the different pixel values. Okay, the same thing here also. And finally, like if you do the alpha blending, we can get this kind of cleanly cropped cut out image from this. Okay, this is the like example of that what 2017 paper I was talking about. This is the output, but it's very good output, right? I mean to say, if I want to extract the the pot image with the leaf, and how like best result I can achieve. This is the almost best result I can achieve, right? And I can use this one, and I can put it some other picture, and I can composite it on another picture, and we can create some other image, right? So this is what the another prospect of research, like we can do research, because you see the creation of this trimap itself is a very difficult job. It is not. I want like some deep learning techniques where I'll input only this image. I don't know. I don't want to like do anything like manual work here. I want to get this kind of result. Okay. Once I get this result, I definitely like, and this is again like the alpha blending, nothing more than that. My only intention is to get this mask, but that too like without using this. People are doing research in this, and in most of the cases, people are successful also. People are doing this like research. So these are like a different prospect, and this has to work like in a generic manner. Any object, any image you put, it should give this kind of like clean output image. So this is what the paper I was talking about in 2007 came up. Okay, here they train the network. Again, this is like encoder decoder architecture. Kind of they use the original image and this manually created trimap, and they use both of them as an input to the architecture as a training data set, and it is getting trained, and the loss function they will like with the backpropagation they adjust the weights. Of course, there is like another fine tuning kind of architecture also. Here there are 4 stages again. Of course, there is no downsampling over here. But how do they train? They first like train this, not this part, only train this one. Once it is converges, they stop it. All the weights they freeze it, and then like they train this part. Once this also converges, they like do a whole complete training process, and that's how like finally like they come up with the weights. Okay, so and it was good actually, but only drawback here like this creation of the trimap. So later on, people talked about okay, I'll not create the trimap by myself. I'll let the network create the trimap by its own. Yeah, that is also possible. Maybe what you can do, if you go back to this salient object detection, okay, so if you somehow like get the salient object from the image, assume like this is my input image, and internally like it will do some sort of salient object detection, and I get this one. Okay, I know this is not the image matching, this is not the perfect alpha met, because this is a binary, but I want like I want to know this particular pixels, where how much of this particular pixel belong to foreground, how much this particular pixel belong to background. Okay, those sort of things I need, right? So in this case, maybe like that kind of architecture is also involved, and internally they will create that what to say, that trimap internally. Once you get the mask, like they will know like okay, this is my boundary, and I this is my unknown like ambiguity region, and here only I will focus more. They can create an attention mechanism there. Okay, and that's how like they train the network, and they can get the result like alpha match without manually creating the trimap. So, but anyway, internally they will create the trimap, that is for sure. But when like I don't have to create my trimap, I'm happy. So people are actually doing research towards that. How to like anyway. So far, I'll tell you that using trimap is the state of the art. That is the best result we can achieve. If we have an image, if you create okay, these are my ambiguity region. If they can mark it. If they process that those images, input images, and they'll get the best result. This like without trimap, definitely so far like it is not the state of the art, but people are working, and it is almost close to that, right? So this is another like direction of research in ad domain. So another paper I saw in CVPR 2021. So they are what they are doing like they same thing like some mask they want, some segmentation mask they want, maybe either salient object detection or anything like any semantic segmentation mask they have, or they can create a like mask also. Assume like I want to met this particular girl from the image, then I can draw like something on top of her, and I can create this one, and I process both of them. And finally, like you see, I can get this kind of fine like mask over the like hair portion of the girl. Okay, that's what this is. Another 20. I actually experimented with this paper also, but I didn't get the proper results so far. But maybe like some sort of improvement is still required in this kind of techniques also. This is nothing but like they talked about. This is what is that? Where? Yeah, mask guided mapping via progressive refinement network. They talked about this particular network is a progressive refinement network. So again, like encoder architecture, the huge structure is there, but based on this kind of side thing, they are like refine the output basically. Refine the output, and they try to find out this the fine regions in the image. Okay. So this is all about like what I talked about, like salient object detection. Of course, firstly, yeah, salient object detection, and then image mapping. And these two things are like really important, and in advertisement domain in different aspects. I'll show you some of the use cases, of course. But here, some of the examples where it doesn't work. The state of the art algorithm also doesn't work. Okay. So here you see this is it looks like this is working fine. Okay. But in this particular case, you see like this still is opaque, right? It is not still, there are some gaps here, but I'm not getting those gaps here as an output. Okay, I want like only the earrings, okay, from the image, but I'm not getting. So these are like drawbacks of the algorithms. Here also you see some of the floor portions are also involved in this, right? Of course, like most of the things are segment like matted properly, but not all the portion. Here you see some portion of the wall also came here. And if you look at the peacock image, it is really tough image to mat. So this is the the result. So it is not something like yeah, a lot of progress happened in the deep learning towards this kind of techniques, but still like there are a lot of work pending. Okay, how to improve the network to achieve because as a human eye we know okay, this is a peacock image, and we know where the background is, but our algorithm cannot detect that where the background and where is the foreground. These kind of cases. So these are complex images, and so these are the complex images, and then difficulties are there in these kind of images. Okay. So reason behind talking about all these techniques, showing all these pictures, is that the prospect of research and nothing more than that, and that too in advertisement domain. Okay. So yeah, as I said, one of the use case, maybe I mentioned earlier also, if we know this is the portion of the car, maybe we can blur this could be used in advertisement, of course, right? So keeping the car object sharp, rest of the things we can blur it, so then focus of the people go there only, not the background. So basically we create the saliency out of the saliency. Basically, create more salient saliency into the image. Okay. So here another if you can cut out one image, then we can probably use it in some other background. So this is we crop that image from this background. Sorry, we made the object from this background and put in a different background. So that maybe this is the contrast is not proper. Then we can create more better contrast image, so that again same thing the saliency of the object will become more. I mean to say focus of the people will go there mostly, instead of going towards something else. Here also same this is method like this and putting in some different background. All the examples are same. Okay, so another thing is image compositing. So definitely in our advertisement we have to composite image. We can so far we have talked about salient object detection, then image matting, and now we have different images and we composite all the images into single image, so that that image looks good. So if I say this is of course a manually created image, and I have created this image not I, maybe even Adobe, if you go through some Adobe website, you can see this image and they tell you how they can create this image. Of course, a lot of image processing algorithms they have used it, but our intention is that is it possible by any algorithm, so that we can create this kind of image. Okay, if I tell you what are the components used to create this image, so these are the components actually. Okay, so this is one image, this is another image, this is one image, and you see all sort of components are present here. This part is this one, this part is again here. So these are also used as a even kind of water itself. The cloud became water here, of course, and these birds are also there. This yacht is also there here somewhere, right? All components are there. And it is not just you just copy that image and paste it here. No, it is a lot of image processing algorithms you are using here. So can our deep learning techniques also can be involved here, so that I'll input all these images. Okay, I'll define, of course, maybe some layout I may define. Okay, that layout also defined by the algorithm itself, and I need this kind of output. Is it possible? This is another prospect of research. Of course, this is very complex image I'm talking about. Kind of maybe output may not be here, but to some extent similar direction. I'll give you some other example. Maybe you can see this particular image. This particular image created from these two images. Again, these are I copied from Adobe website only. Just to explain you what is composite image, and yeah, there are some prospect in creation of this object. Oh, sorry, yeah, composite the images, right? So here, this girl was maybe swimming in the ocean or somewhere, but finally I have shown you, okay, she is actually swimming in the roadside. That is a good effect, right? And this kind of images people can use in the advertisement. Just I'm giving some example. This is another example. Okay, so this particular lemur was actually sitting on a tree. I have cut out the object and I put him inside in a beach. Okay, so this is a beach image. Of course, this is I'm not doing any composite, just I am pasting it. But this is different again. You see, I want to put this particular image into this image. Okay, if I do this way, maybe it will be odd looking and people will think, okay, this is maybe pasted on top of that, similar to this. But no, if I do some processing over there, it looks as if it's a part of the original image. So success of composite image is lies there. So how can you do this one? So these are also different algorithms, deep learning algorithms may be involved, where we can even yeah, you probably worked on style transfer and all. There also they talked about that, one a style of one image can be transferred to some other image in kind of using deep learning techniques. Okay, so again, a composite, maybe you see here I am even changing the color, right? So based on what I'll change that color, and where I am going to change the color. All this stuff will be decided by the deep learning. So this is one of the architecture. Of course, I just for a completion purpose only I put it. I didn't go through the complete architecture here. I'll not be able to explain this one, but just to show you okay, people are doing research on image composite as well and getting success. And these all kind of things are required by the ad domain in the advertisement domain, and people organization Google, Facebook, whatever, Alibaba, Alibaba, TikTok, all people are working in this kind of technologies, and they are delivering their advertisement. Okay, so initially I mentioned about cropping. Okay, right? So it seems cropping is what is there, just crop the image, right? Yes, that is true. Crop the image, just have some dimension and then crop the image. But when we crop the image, so which part of the image I'll crop? Should I crop kind of some portion? And if I crop okay, I'll tell you something, some weird dimension I'll tell you. It's a 1080 by 170. So 1080 will be in this width side and 170 in the height side. So if you crop from the top, maybe I'll crop the image from top, right? So will it make any sense? No. So if maybe I crop the image here somewhere, then only it will make sense. At least somebody's face will be visible in the cropped image, right? So who will decide on that? Okay, if I manually crop it, okay, fine, I can do it. But my algorithm can do it. So that's the question. So image cropping also, there are a lot of algorithms, in deep learning algorithms are coming up, so that people are using them to even crop the image into different kind of to get the proper image. I'll tell you, aesthetic, image aesthetic, right? Even in camera also nowadays, some cameras has a feature kind of, you just click on some DSLR image camera, just click some image, or maybe in a mobile phone itself, click some image, then you can auto crop the image so that the final output is aesthetically correct. You see, in this particular image also, of course, this looks like a very aesthetically correct image only, because even though these two persons are sitting towards right side, but they are looking towards this side, their face orientation is towards this side. That's how the balance in that image is there. So those are things aesthetic. People talked about aesthetically pleasing image, right? So after you crop the image, that image also should be aesthetically pleasing. I'll show you some example. Okay, before that, I'll tell you how exactly that can be done. So what you can do, you can have lots of crop. Okay, assume like you have to do one dimension, first dimension only, 1832. Okay, so basically that is what 1920. Okay, so okay, 1080 and 1920. For example, this is the aspect ratio is 18/32. Okay, so now you can have that particular aspect ratio of many crop you can have. Now you can do like you can send those input. Consider those like each and every crop. How many crops you can do? Many crops you can have, right? You can have many crops from the same image, and then you can process all the images through a deep learning network, and it will return you the best aesthetically and informative image to you. Okay, for that also you have to train your network so that it is always pleasing. So NIMA is one thing that Google, I think, Facebook came up with, and that is also talking about the quality of that image. But this particular example I am talking about from the anchor based image cropping. I'll explain you a little bit more into that. So basically what they do, as I told you, just have some grids from the image, and those grids you just process through some backbone architecture. Maybe you can use, in this case you can select MobileNet V2, because this is a little lightweight, and it will serve the purpose what they are trying to do. Or maybe you can use the ShuffleNet as well. So then if you remember in mass Carsian and what we do, the ROI align, right? Instead of ROI pulling, they in mass Carsian and they do ROI align, right? So this is a floating point version of the ROI pulling. Okay, the feature extraction basically once the features are given by this one. So this is again, these features are in a different dimension, right? When we process the image, it is processed with a very low dimension. Now we need all the pixels in the higher dimension. So how will implement those features? So that is what ROI align can be used as mass Carsian. Here also we can do the same thing. And then once we get those features, then we see how these features are can be trained and get the most aesthetically pleasing image out of that. Which are the features which are the images, portion of the images always giving a high score, so that okay, here again our score may be 1, 2, 3, 4, 5. Okay, 5 is the best, 1 is the worst. So these features okay, have the crop of the image, use MobileNet, do the ROI align, and then calculate some score. Okay, this score is 4.5 maybe. Some other score maybe 3.5. Definitely 4.5 will the winner, right? So that's how we say, okay, this is what the best images. So this is nothing but the same thing I pictorially representing. So the MobileNet, and then there are some ROI align and ROD align. ROD align is nothing but the same thing, but you see in some cases not only the foreground, but also they are processing the background. How they do it? Just if this is the foreground, and then we can blacken it up and use the background also through the same this particular architecture. And then I'm talking about the ROI align. Okay, and then finally we create the opinion score, what I said 1, 2, 3, 4, 5, and based on that they can say, okay, this is the best image. So a simple expectation image cropping, there also we can use deep learning techniques, and of course these are very useful because we need the kind of it has to be accurate, right? Aesthetically, that's why we need that. Again, that slot I was talking about. Okay, my slot is this, dimension is this, but my advertiser is big. So again, there also I have to crop the image, and that cropped image also should contain entire information and aesthetically correct. So there also we can use the image cropping algorithm, the deep learning algorithm, to crop the image. Yeah, this is the same thing as I gave you them an example of digital camera, DSLR. Maybe you can click any image, but it will finally give the aesthetically correct image. Okay, this may not be good looking image, You see, if you are like a photographer, definitely you can say maybe, oh no, this you could have that taken it this way, that way. If you click an image and show some photographer, they will say like, you could have gone little back and like, to take this this side or that side. A lot of things like, they explain it, right? They talk all the perspective of the aesthetic looking of the image. So maybe like, this particular image is having less complaint than this. So these are like, some of the use cases of image cropping. Of course, like, in digital advertisement also, these cropped images are used extensively. That's why like, this is also important. Yeah, these are like some of the examples of the same image. I crop into different dimensions, and all of them are like, aesthetically pleasing, I can tell you. Even like, this dimension also, you see the face of the people are visible here, right? Here also, everywhere. Another thing is the image super resolution. I'm sure like, I'll exceed the time, so but anyway, I'll stop another maybe 5 to 7 minutes. I'll try to conclude so that like, we can have some more question and answer session. I'll go very fast now. So super resolution, and definitely like, we cannot use any image which is like, as it is. That's what, if it is a very low quality image, definitely advertisement will never succeed if you use like, low resolution, low quality image. So super resolution is also required. So a lot of like, research are going on in super resolution. So even CAN domain itself, like, super resolutions are happening. So a lot of research prospects are there in super resolution. Okay. So again, some of the these are like, some of the what to say. Yeah, this is the SR GAN only. So I'll not go through them. Yeah, some of the use cases may be where we, of course, like, as creative generation, definitely super resolution is being used in the multimedia, astronomy, microscopy, medical imaging, satellite imaging, all everywhere super resolution is there. And I mentioned about this creative generation as well. Creative generation is nothing but like ad generation. So super resolution. So this is a different prospect of researching for the ad domain. I talked about many times like an aesthetic. So along with the aesthetics, like, quality. So I mentioned kind of you just as a advertiser, you can provide the input image, you can provide some description about the product, you can provide the logo of the image, and finally, like, it comes up with like, our ad server will come up with a lot of banner advertisement or maybe video advertisement, whatever you want, right? So quality wise, like, what sort of different qualities you can think of there. One is aesthetically, of course, but it has to be sharp also, and it has to be like, what to say. There is a point called memorability. So do you remember like, some advertisement what you watched in your childhood? I still remember some of the advertisement. Maybe that is called like, memorability. So if you see some advertisement, how long you will memorize it? But that you don't have to like, do it intentionally or so. It has to come automatically to you. There are a lot of things like, we memorize, right? So there is a like, research on that direction as well. So which other pictures are like, having memorability, or which are like, not? You don't know, but our deep learning algorithm can say, okay, if you use this image, maybe like, it will stick into people's mind and it will like, at least last for some time, or maybe last for a long time, maybe last for like, forever, like that. So again, like, there are some other contrast thing is there, some lot of things like, if you talk about the quality, like, image quality, you can think of all the things. And I told you, like, ranking, right? So it can create a lot of different images, maybe 100 images, 100 advertisements. Out of that, like, there will be only one image which is ranked 1, and another image will be ranked 2, like that. Maybe another image like, rank 3, 4, 5. Okay, maybe like, in 3 itself, maybe there are 5 images. Okay, these all 3 images are 5 images are ranked 3. Similarly, like, 3 images are in rank 1. It could happen based on, because like, these are based on some scores, right? To get the scores, even you have to go ahead and like, find out different object in that image, maybe like, where the product is, where is the logo is, where is the text is. and is that like, everything is correct, color combination is correct, sharpness is correct, brightness is correct, aesthetic is correct, all sort of things are correct or not. And finally, like, maybe you can process everything in a graphical neural network and find out the, like, the rank score. Okay, but that rank score, even like, even it should be visible also. If you say like, this is rank 1, but if you it doesn't come to people's mind, then maybe your like deep learning algorithms failure. So that's what, like, even this is also a very huge resource prospect. So that, like, every time you get, you don't have to worry, like, you just put the inputs, get the image, use it as, like, in the advertisement, and that should be successful. As a, like, ad server, success is there only. So that, like, the advertiser doesn't have to think anything about, like, what sort of advertisement goes to the market. Okay, so that way. This is again, like, I just wanted to tell you some, like, Mima. Okay, this is again a quality I am saying. So this is what, like, the layout also can be generated. You see, I showed you some advertisement there, like, you saw some places for the image, some places for the text, some places for the logo. So this could be, like, some fixed template. But apart from that, these layouts also can be generated based on the inputs, based on the, like, dimension of the inputs. This like, layout could be different, right? Again, of course, like, you can crop into this particular dimension. That is also one thing, but it will be always like, static template. But rather than that, like, you can see different types of layout, like, different types of advertisement most of the time, right? So definitely, like, some layout generation algorithms also could be very useful to use in this kind of advertisement, like, in ad domain. Again, I talked about the copywriting at the beginning itself. You can see, like, some of the old copyrights. For example, this is, like, I liked it very much. Yeah, it is not talking about anything about the car, but at the same time, like, yeah, it gave the information about the car. You see, at 60 miles an hour, the loudest noise in this new Rolls-Royce comes from the electric clock. Okay, of course, they mentioned about the Rolls-Royce, but they are talking about the loudest noise, right? So this kind of, like, that when they say loudest noise, definitely, like, this is a copyright example. Okay. You see, good copywriting can be used to enhance the consumer's memory of the product. Definitely, yes. So that is why, as I said, like, copywriters, as a human being, like, as an employee in an organization, copywriters are, like, very highly paid job. But now, like, that copywriters are, like, replaced by, not replaced, but what to say, like, helped by the deep learning algorithms. So copywriters also, like, nowadays use deep learning technologies to generate different types of copyrights to use in the advertisements. These are, like, generation of some human face. Now even celebrities images can be also, like, discarded. Okay, I'll not pay you this much, like, I'll create some face image, some celebrities by myself, and I'll use it in my advertisement. So that is also a possibility. Yeah, these are, like, these people are, like, not exist in the world. They are, like, generated by the GAN networks, right? And of course, like, I'm sure, like, these if we can use these images in advertisement, definitely, why not? We can use it. And finally, like, the attribution. You see, how do you measure our success of our advertisement? Those are, like, maybe click-through rate. I told you earlier, like, if someone, it comes to me, for example, as a consumer, if I click and buy the product, then okay, that is called maybe, like, click-through rate. Okay, so do I click? Did the customer click? If it is yes, yeah, that will be captured somewhere. So like that, in that, that is also one thing. Like, how you will, how can you say, like, okay, your advertisement is successful, at least, like, in selling the product. So here also there are a lot of research going on, like CVR, CTR, CVR. Okay, so yeah, this here also like a lot of AI/ML techniques can be used. I think I am done with my setup presentation. Yeah, this is some of the architecture of that attribution I talked about, like in CTR, CVR. Okay. Any question?
Thank you, Dr. Bora, for such a nice presentation. It has been really elaborative. I think there are 2 questions in the Q&A section. Did you try to take this?
Okay, I have to see.
So if you kindly check it and. Could you get it? Otherwise, I can.
Yeah. I have seen like what is new in Gartner's hype cycle for AI 2021. Of course, I didn't see that 2020. I saw it, but I don't remember 2021. What are the hype they mentioned? But anyway, my point is simple. So to start a new research, definitely, like if you go through the hype cycle first, and okay, if you are like maybe I'm not sure where you invest your time and research, then definitely hype cycle is one of the best starting point for anything. So as I say, in advertisement domain, I am sure the GAN is one of the kind of the hype, definitely Gartner's talked about. And I as I said, I don't remember what is there in 2021, but as I said, this is a good starting point for any to start a research anywhere. I think not completely, but maybe I tried to answer the question a little bit.
Did you try to take the other questions? Particularly, new question has come up in 351 at 351. So in Q&A section, shall I read it for you or?
You can. I can also see in front of me only. It is the U2net a 2-level nested U structure, which image does not support alpha met channel. Yeah, U2net is a 2-level nested U structure. Yes, that is true. And second part is which image does not support alpha met channel. I didn't get that question even. Which image doesn't support alpha met channel? Can you, who is asking this question? Can you explain what exactly you are talking in the second part? Okay, maybe you can ask me even later point of time also. What is trimap in image matting? Okay, trimap, as I mentioned in the when I was talking about image matting. So trimap is nothing but you have to manually create some mask where there is an ambiguity, means you are not sure whether okay, anyway you cannot go to the pixel level, right? So definitely you will broadly create something, some mask, right? Maybe using some brush paint and all, and where the boundary definitely be there. So that is called a trimap.
And waiting for you.
Sorry.
Sorry.
Sorry. Yeah. So so that trimap and the image itself will be processed together. So that is what the trimap is. The next question is there any algorithm to detect a fake image and real image? Definitely there. Fake image and real image. Spoofing, some spoofing algorithms are definitely there. But even nowadays, the images look so real. Even spoofing algorithms also maybe sometimes a little bit of failure, not kind of. But again, it is not something to like, in ad domain, definitely it is not to detect a fake image or so. But anyway, I'm just telling in a little lighter way. But to generate like, more realistic image is the like, key for us. But as I said, like, spoofing algorithm is definitely there. A lot of algorithms having, maybe like, you see in biometrics, I'll tell you in biometrics, definitely like, the question will be like, more relevant there. You see, you want like, a face recognition algorithm for maybe like, the door access. So you can, instead of you, maybe you can show your somebody's picture and get access, right? So they are definitely, this spoofing algorithm is much more useful. So algorithms are there, definitely there. I cannot name some of them as of now, but it is there. Alphamet file format. Alphamet file format can be any RGB or maybe like, the one channel. It could be RGB also, it doesn't matter. But anyway, finally you have to create, you have to like, generate 0 to, maybe it comes as a like, in terms of 0 to 1, but you have to create like 0 to 255. So that like, it will be spread at, in the range of 0 to 255, and you can use as a like an alpha channel. Of course, you have to do like blending for the cutout image. Yeah, going back to the like, the second question, which image does not support AlphaMet? I didn't understand the question itself. Please, can you help me?
Maybe the question looks incomplete. Maybe what type of image might be, because what image?
Okay.
Maybe it is incomplete question, I suppose.
Which image does not support AlphaMet? Anyway, my point is again, I think whatever, maybe I can guess like in that question, maybe a little bit. You see, there are a lot of problems in kind of salient object detection. So problems are like, if the complex background is very complex, for example, and in some cases, maybe boundary of the object is very complex, maybe like hair. That's a complex, right? And sometimes what happens, like background color and the foreground color, object color and the background color are also similar. So these are the like, typical examples where any salient object detection algorithm might fail. Okay. So the research purpose of the research is nothing but like, how to overcome those difficulties, how to like, get proper boundaries, proper like, the to hair level fine like, salient object in that image. So as I said, now even like, if you evaluate some of the algorithms, maybe it doesn't cross 95% now. So can we do some like, extend our research so that like, it crosses 95%? Oh, it is 100% definitely well and good, right? So if it works, again, some of the algorithm doesn't work for different types of objects. For example, it works very fine. I mentioned about during my talk, the kind of portrait image, it works, but it doesn't work for some product image. Some algorithms are there, it works for product image. Even though you train with all sort of images, it doesn't work for the other portrait image, maybe animal image, maybe bird image. So research towards like, by having a generic model which works for all is like, maybe key. Any more question?
So I do not think there is more question. So thank you so much for accepting our invitation and delivering such a wonderful speech. In fact, you have presented the inside out of the creative industry, starting from that how we can make the advertisements. We can customize it actually rather. So many things starting from NLP, image processing, this mix of all these things you have told us. And definitely the participants will be benefited from this. And we look forward actually to get input from the industries in particular, what is going on in industry and what we are doing in academics. So there should be some tandem actually, we should work in tandem. So I have found it really interesting, the thing what you have presented. Thank you so much for accepting our request and presenting.
Welcome. Yeah, thank you.
Please bear with us, Dr. Surojit Bora, and we'll be starting our validity session within 5 minutes.
Okay, should I stay in this one or I have to log in once again?
No, 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 please stay here. Please
stay here only. Okay.
Yes,
okay.
you should be in the panel.
Yeah, sure.
So I request all the participants to bear with us maybe for 2-3 minutes. Let us set the stage for the valedictory function. Thank you. Okay, thank you. Thank you, Professor Jamal Hussain. Honorable Dr. Laltla Moana, Joint Secretary cum Chief Informatics Officer, Government of Mizoram, India, the chief guest of this valedictory function, the guest of honors, Dr. Surojit Bora from Huawei Technologies, Bangalore, India, Professor Gautam Saha, Northeastern Hill University, Shillong, Professor Jamal Hussain, the coordinator of this faculty development program. I suppose Professor Dibakar Tiwari is not there. So Dr. Sarat S. Singh, Department of Mathematics and Computer Science, Mizoram University. We have come to the end of this week-long international faculty development program on data analytics and machine learning. It has been attended by a large gathering, large number of participants covering not only different states, but also from different countries. So in fact, about 1,000 people registered for this, out of which we have constantly seen 100 to 200 participants throughout. We got resource persons from different reputed institutions, universities, out of which 4 were from abroad, 2 were from reputed industries. The persons from abroad are from the countries like USA, Sweden, Singapore, and Bangladesh. There have been some very nice talks which we have come across. The topics which were covered, particularly the machine learning applications in various domains of computer science, like natural language processing, speech processing, healthcare, network and security, and finally in advertising areas. So they have touched upon various fields. I'm sure all the participants have been benefited immensely from here. So as a joint coordinator of this faculty development program, it has been a great experience to work with Mizoram University and particularly with Professor Jamal Hussain. I, on behalf of the organizing committee, would like to formally welcome the chief guest of this valedictory function, Dr. Laltla Moana. And I also would like to welcome Dr. Surojit Bora from Huawei Technologies and Professor Gautam Saha from Northeastern Hill University, who are the guest of honor of this program. I would like to welcome Dr. S. Singh from Department of Mathematics and Computer Science, Mizoram University, and other guests and the participants. So now with this, may I request Professor Jamal to proceed with presenting a report on the faculty development program. Thank you.
Thank you so much, Dr. Iftikhar. Let me read out a short report on the week-long faculty development program. It's as mentioned, it is an international faculty development program on data analytics and machine learning, being organized by Mizoram University, Aizawl, and Northeastern Hill University, Shillong. It is from 21st to 25th of this month. And it is sponsored by Department of Information and Communication Technology, Government of Mizoram. And it is headed by our chief guest today, Pu Moana. And as our joint coordinator already expressed, there are participants from various countries. The inaugural function was held on 21st at 10 a.m. local time. And in the inaugural session, chief guest was our Honorable Vice Chancellor, Mizoram University, Professor K.R.S. Sambasiva Rao. I'll read out their messages they sent that day. Professor K.R.S. Sambasiva Rao, Vice Chancellor, Mizoram University, congratulated the Department of Mathematics and Computer Science for organizing this important event, which is relevant to present-day scenario. He mentioned the importance to learn how to process and protect voluminous data that is being generated nowadays. He highlighted the importance of data analytics, artificial intelligence, machine learning, and their applications in various fields, including healthcare and applications of blockchain technology in banking sector. He asked the teachers to continuously update and improve their knowledge and in turn cater to the needs of the students. He expressed his happiness to know that participants from many countries have shown interest and registered for this program. Then guest of honor, Professor Samanto M. Hazarika, expressed his happiness to be part of this program and for the opportunity to interact with young people working on machine learning. He mentioned that traditional data analytics platform would typically involve technical team members, whereas machine learning analytics is an entirely different process. It automates entire data analysis workflow to provide deeper, faster, and more comprehensive insights. Then another guest of honor, the Registrar of Northeastern Hill University, Dr. J.N. Nayak. He expressed his happiness about the collaboration and joint event between Mizoram University and Northeastern Hill University. He hoped that such kind of programs would help all the scientists, industrialists, educationists to come forward to have meaningful deliberations and to learn how to make use of this kind of technologies for the betterment of human being with proper results. Then the chairman of the organizing committee, Professor Diwakar Tiwari, Dean, School of Physical Sciences, Mizoram University, in his speech expressed great satisfaction and congratulated the organizers for the joint event. He was happy about the collaboration of Mizoram University, Northeastern Hill University, and Indian Institute of Technology, Guwahati. He congratulated the department for bringing experts from academia and industry from different parts of the world and wished grand success of this program. And about the daily events, every day we plan 2 lectures, either lecture or hands-on. And the first day, that is on 21st March, the first technical session started with a lecture on machine learning overview, trends and prospects by Professor Samanto M. Hazarika, Department of Mechanical Engineering, Indian Institute of Technology, Guwahati. The second session was hands-on training on application of machine learning, deep learning by Mr. Banlal Ruata. He is a research scholar in the Department of Mathematics and Computer Science, Mizoram University. On second day, the first lecture was role of artificial intelligence, machine learning in next generation communication networks. And it was delivered by Dr. Noor Jaman Ahmed, Dartmouth College, USA. The second session was a lecture on deep learning based cyber attacks, behavior analysis for cloud systems. And the speaker was Dr. Manwar H. Bhuya, Umeå University, Sweden. Then on 23rd, actually, due to unavoidable circumstances, we could not held this second session. So the second session is moved to third session in the form of third session today. So on 23rd, we had one lecture which is on network traffic analysis using machine learning by Dr. Noor Nazrul Haq, Manipur University, and it was hands-on. Then on 24th March, the first lecture was on speaker verification, the quest for voice print technologies, delivered by Dr. Rohan Kumar Das, R&D manager at Front Media, Singapore. The second session was on deep learning for natural language processing by Dr. Asif Iqbal, Indian Institute of Technology, Patna. And the final day, that is today, there were actually, as I mentioned, 3 sessions. The first session was on application of machine learning in healthcare by 2 distinguished professors from Bangladesh, Bangladesh University of Engineering and Technology. They were Celia Shehnaz and Professor Sheikh Anwarul Fatah, and they talked about application in healthcare. The second session was hands-on machine learning, and it was by machine learning in healthcare, I think hands-on, and it was delivered by Mr. Kishore Medhi. He is also a research scholar in Department of Information Technology, Northeastern Hill University, Shillong. The third session just concluded was on practical applications of artificial intelligence, machine learning in digital ads industry by none other than one of our guest of honor today, Dr. Surajit Bora, Huawei Technologies, Bangalore. So with these words, I conclude this reporting session, and then we'll move to our next speaker. Was supposed to be our Dean, Professor Diwakar Tiwari, but he earlier mentioned also his prior engagement, so he could not join. So we'll move to address by our guest of honor, Dr. Surajit Bora, Huawei Technologies, Bangalore, India. Dr. Surajit Bora, please.
So I should go ahead, right?
Please go ahead.
Your voice was a little low. That is why I could not hear properly. Means I should go ahead, right?
Yes, yes, please.
Okay, okay. Am I audible properly?
Yes, yes.
Okay. So yeah, just very briefly, I'll mention. Anyway, means during my session, I talked about the hype cycle. I'll try to reiterate the same thing. To start research, definitely, like if you are not very keen what technologies maybe you want to pursue, like having seeing the hype cycle is like most important, and it could be like in any domain. As I showed you, like in the ad domain, maybe it will be in marketing domain, it could be in medical domain, it could be in automotive domain. What is the hype going on? Definitely, like some of the hype will go ahead and like will be productized at later point of time, and that will actually I feel like help the researcher even to publish paper, even to like submit some patents and all, because like you see, I'll give you one example. Actually, not recently, last year I attended CBPR 2021. Of course, that is again a virtual conference. As you know, like that is the #1 conference in computer vision and pattern recognition. And there, what is my experience was kind of from India. Actually, participants are very less. I mean to say, like paper submissions were really less. Maybe like from all the organizations, maybe 100 papers were submitted, and out of that, maybe I don't know how many were accepted in CBPR 2021. But in comparison to that, like if you look at the other countries, some countries even like submitted maybe almost 4,000 papers. In comparison to 100, 4,000 is a huge number, and it is like seen there. Those paper, most of the papers are like maybe in the like from the hype cycle itself. Basically, like those technologies only, and even a slight improvement itself is a like a good paper, because like no one is a foolproof solution so far, and all are like improving in their research. Like maybe today it is like maybe some percentage of accurate. Tomorrow maybe like some fraction of a percentage is like more accurate. That's how like the research are evolving. And at one point of time, like if you feel okay, this is the trade-off, and we can like think of the productization of this one. Maybe some industries will come and grab that technology and go ahead with the product. So that is why I try to again reiterate the hype cycle is the most important thing, and this will help even to like start your research. and and if you are doing some other research, maybe if you want to switch to other research, then definitely go ahead with the hype cycle and start doing research. And I think that is what I wanted to say.
Okay, thank you so much, Dr. Suradin. Thank you so much for your time. And we'll move to the next speaker. We have our guest of honor, Professor Gautam Saha. He is head of the Department of Information Technology, Northeastern Hill University, Shillong. Sir. Professor Saha. Am I audible, Iftika?
Yes, sir, audible. I think he is busy looking something else.
Maybe there is some internet issue.
I am audible.
Yeah, there is some internet issue because his photograph is static now.
Oh,
yes.
Right. Maybe he can switch off video.
Is it okay?
Yes, come, I think, yeah. Sir, please.
Professor Saha, just switch off your video. I think then it... please go ahead, sir.
Okay. Am I clearly?
Yes.
Am I audible now?
Yes.
Yes. Am I audible?
Yes. Please go ahead.
Yeah. Thank you very much. I am very happy that one of our colleagues, Dr. Iftikhar Hussain, has in collaboration with you, has done such a beautiful job, and international faculty development program data and dynamics and this machine learning. So, and the international participants has participated into it. That is great. And also the lectures and the knowledge sharing between the international experts and our students. Our students means the teachers who have converted themselves into students over here in another role. Okay. Of course, teachers are the definition of teacher is that he should be an excellent student. This is the definition of student, a teacher, a good teacher. So here they are enlightened because teachers not only has to perform the class load as to take the class teaching, but he has to go for research also. And nowadays we are also emphasizing on startups, and startups requires much more defined knowledge and experience. So in a particular setup, beautiful setup has been made by inviting, and I think students are benefited already there. Benefits and the teachers also. It would have been much more, apart from the students could have discussed their own research problems and others while doing their research or doing something. They could have discussed with them and they could have enlightened, they could have new ideas.
I think there is some network issue. Yes, Professor Saha, please go ahead if you can hear. Dr. Iftikhar, what to do?
I think the Saha sir is the on mute.
Now mute, yeah.
Yeah, can you hear
Yes.
me now?
Yes, please.
Yes. Was previously whatever I've said, was it audible?
Not much, but yeah, please.
Shall I start from the beginning or start anew after that?
Up to you, sir.
Continue. Okay, sir. So, actually, what I mean to say, type of interim benefit students and the definition of that student. So that means here the stars, international players, who these different topics, and these students will benefit both. And had this this thing, it would have been in that case, these the teachers who are doing researches in different fields definitely facing many problems. They could directly talk to get many ideas and new ideas out of that. Conferences, we only for getting that in the world. This is the big conferences are held at different, and government also encourages that in such type of everybody interacts, new ideas there, and because this is generally not possible enough. So I'm happy that my platform, everybody in a topic.
Okay. Adi, shall I proceed?
Sir, please unmute first. Unmute, sir. Gautam Shah, sir, please unmute.
Yeah, I'm unmute. Am I audible now?
Yes.
Am I audible now?
Yes.
Okay. So, yes, so I'm very happy that my colleague has done such a great job for Mizoram University, and he is organizing in 2022 in the month of October. So I'm grateful to him that to make some. I'm very sorry that I couldn't participate in it because of my preoccupations and academic. I have missed something. So I participated. I very much shared their experience. The teachers, the experts, who have shared their experience with the teachers. Thank you very much. Thank you, Dr. Ritika Rosen. Thank you, the organizers in the Mizoram University and other organizations who has participated in it. Thank you very much, sir. I'm sorry for the inconvenience it is caused because of the intermittent.
Yeah,
Yes,
it
thank
happens. Sometimes it happens, sir. Not an issue. Thank you so much, sir. Thank you for your time.
Thank you.
So now let me introduce and welcome our chief guest. Moana, can you hear me?
I can hear you.
I think he has to be unmute. So still
Moana, please unmute yourself. Moana, please unmute yourself and switch on your video. Yes.
Can I?
Yes. You are audible. Yes. So yeah, here is Lalkla Moana calling. the Joint Secretary cum Chief Informatics Officer, Department of Information and Communication Technology, Government of Mizoram. So I welcome Dr. Lalsa Moana. Please interact with the participant.
It give me thank you so much, sir.
Yes, welcome.
So I can talk.
Please go ahead, Moana.
Okay. It give me immense pleasure to invite me to have a valedictory speech in this webinar on International Faculty Development Program on Data Analytics and Machine Learning, organized jointly by MZU and NEHU. I'm really grateful to the organizing committee selecting this kind of topics like data analytics and machine learning, as it plays an important role in our day-to-day life and improving the governance. There are huge potential and opportunities in the field of data analytics and machine learning. And today, a large volume of data is being generated through e-governance application. Even in Mizoram, there are millions of transaction is taking place every year, even only in Mizoram. Thus pave the way of for data-driven governance, wherein with the use of data analytics tools, we can provide insight and facilitate better decision-making. And this machine learning, which is a subset of AI, can help various sectors of government to improve education, healthcare system, and law enforcement, customer services, and weather forecasting, and recruitment process, and intelligence surveillance and traffic control also. There are so many applications today. I hope this kind of seminar would help us improving our governance mechanism, for which I would like to request the organizing committee to focus of the application of emerging technology, other emerging technology also, like blockchain and IoT as well. Introducing this kind of emerging technology in our government system will definitely improve our public service delivery system and the mechanism. I hope this webinar would benefit all the participants in understanding the application of emerging technology for socioeconomic development and sustainability of the state. So I would request NEHU and MZU to continuously organizing this kind of technology, the application of the technology for the benefit of the people of Mizoram, not only Mizoram, for the benefit of the people of our country. Thank you so much.
Thank you so much, Dr. Lalsa Moana, for your time and accepting our invitation from you in this last part of March. Everybody is busy. So despite your tight schedule, you agreed. Thank you so much for your time, sir. Thank you.
Okay, thank you, thank you.
Yeah, over to Dr. Sarath S. Singh, our colleague in the Department of Mathematics and Computer Science. Post vote of thanks.
Thank you, sir. I think, am I audible?
Yes, very much.
Okay, okay, sir. Okay, sir. Respected chief guest of these valedictory functions, Dr. Lalthan Moana, Joint Secretary cum Chief Information Officer, Government of Mizoram, India. Respected guest of honor, Sujit Bora, Hawaii Technologies, Bangalore, India, and Professor Gautam Shah, Head of the Department of Information Technology, NEHU, India. Our most valued invited speakers, ladies and gentlemen, it is my privilege to have been asked to propose a vote of thanks on these occasions. Thanks to the coordinators, Professor Jamal Hussain, Mizoram University, and Dr. M.D. Iftikhar Hussain, on behalf of the International Faculty Development Program on Data Analytics and Machine Learning, which is organized jointly by Department of Mathematics and Computer Science, Mizoram University, and Department of Information Technology, Northeastern Hill University, all team member of the event, let me call it fraternity of the field, here together and on behalf of organizing committee, extend a very hearty vote of thanks to all the speakers and all the participants for their gracing their important works and sharing with us their experience, findings, and opinions in this event. The event is successful thanks to all the participants from different countries for their cooperations and the help to bring success of this program. Finally, I would like to thank the coordinator of this program, Professor Jamal Hussain and Dr. Iftikhar Hussain for their contributions and dedications for the success of this event. Thank you all. And at the end, so coordinators want to share a few words. Please carry on.
Thank you, Dr. Sir. Thank you so much. Actually, we are at the end of this program, week-long program. Thank you everyone for the support and your cooperation. What I want to mention is that this will not be a one-time exercise. I think in next year also and in the years to come, we'll keep organizing this, and I look forward to support and collaboration from NEHU as well. And yeah, now I request our joint coordinator from NEHU, Dr. Iftikhar, to say a few words.
Thank you. It has been a wonderful experience jointly organizing this international FDP with Mizoram University, and particularly having so many participants, more than 100 participants all the time I have seen. So it is really good, and people have interest towards it, and probably the quality of the program has been really nice, what I feel. And I would like to just announce one thing, as our head of the department, Professor Gautam Shah, has rightly mentioned, that the Department of IT, Northeastern University, is going to organize one international conference in the month of October. It is called I3CS, International Conference on Computing and Communication Systems. So we have been organizing since 2015. So this will be the 4th event of this conference. And we publish it with Springer. So it is Scopus Index. And we are also trying to publish the extended version of these papers in some reputed journals. Particularly, we are looking forward to UGC care listed journals or Scopus Index journals like that. So I would like to give this information to all of you, and looking forward to see you in I3CS. That's it from my side. Thank you so much.
Thank you, Dr. Iftikhar. And last few words for the participants. Thank you so much once again, all the participants, for your interest, for your time. And I hope you are benefited by these excellent lectures from different countries, different workplace, industry, and academia. And now that that feedback form, I think last lecture will post it soon after this meeting. And the certificates we are preparing, so not to worry about that. In due course, you will receive. Your details are with us, your email and all. So we'll send it soon, and you will receive in due course. So thank you once again, everyone, our guests, participants, and see you next time, probably next year. And look forward to your cooperation and collaboration and support. Thank you all. Can we leave now?
Okay, sir. Okay.
Yeah, thank you very much.
Yeah.
Thank you.
Sign
Thank
off.
you all.
Thank you, sir.